Oh, that is fucking hilarious. I'm fucking hilarious. No one will ever know it because I'll probably perish in a fiery pit of my own despair. But I am fucking hilarious. That was fun. Don't you pull that? Don't you pull that Chuck Berry shit with me, woman? Oh shit. And there's a junior league. Shout out to the junior league.
High school ball, high school baseball, there's college ball. College ball 5. I think it should just go 50. But anyway. I don't keep track of statistics like that. I keep track of statistics. Alright, so what kind of whiz was that? I guess we could just call up. Be like college ball. You could do it by color. Alright, so 0 is. What's a 0 in this field? What's before people? I guess T-ball. T-ball? Like Pee-wee league? You're in the paper. T-ball? Pee-wee league? Pee-wee league. Is it T-ball? Pee-wee league. Little league. High school baseball. College baseball. Triple A. Majors. It can show. What about the 0? What is a 0? I always say, how bad did he have to go to the red bathroom? I might 0 to play. Zero to softball. So when you're just chilling, it's just softball? Yeah, that's true. So there's softball. There's... Hey guys. on one axis, you have more hardware coming in. On the other hand, you have an explosion of innovation in AI. And so what happened with both TensorFlow and PyTorch, which is that the explosion of innovation in AI has led to, it's not just about matrix multiplication and convolution. These things have now like 2,000 different operators. And on the other hand, you have, I don't know how many pieces of hardware there are out there. It's a lot. Part of my thesis, part of my belief of where computing goes, if you look out 10 years from now, it's not going to get simpler. Physics isn't going back where we came from.
This guy is
It's
a
only
Python
going to get
guy.
weirder from here
I'm
on
a
out.
Python man,
Right?
baby.
And so to me, the exciting part about what we're building is it's about building that universal form, which world can continue to get weird. Again, I don't think it's avoidable. It's physics. But we can help lift people, scale, do things with it. We don't have to rewrite their code every time a new device comes out. And I think that's pretty cool.
The following is a conversation with Chris Ladler, his third time on his podcast. As I've said many times before, he's one of the most brilliant engineers in modern computing, having created LLM compiler infrastructure project, the Clang compiler, the Swift programming language, a lot of key contributions to TensorFlow and TPUs as part of Google. He served as vice president of autopilot software at Tesla, was a software innovator and leader at Apple, and now he co-created a new full-stack AI infrastructure for distributed training, inference, and deployment on all kinds of hardware called Modular, and a new programming language called Mojo that is a superset of Python, giving you all the usability of Python but with the performance of C, C++. In many cases, Mojo code has demonstrated over 30,000x speed up over Python. If you love machine learning, if you love Python, you should definitely give Mojo a try. This programming language, this new AI framework and infrastructure, and this conversation with Chris is mind-blowing. I love it. It gets pretty technical at times, so I hope you hang on the ride. This is the Let's Vision podcast. To support it, please check out our sponsors in the description. And now, dear friends, there's Chris Ladler.
It's been, I think, 2 years since we last talked. In that time, you somehow went and co-created a new programming called Mojo. So it's optimized for AI. It's a superset of Python. Let's look at the big picture. What is the vision for Mojo?
For Mojo, well, so I mean, I think you have to zoom out. So I've been working on a lot of related technologies for many, many years. So I've worked on LLM and a lot of things, and mobile and servers and things like this. But the world's changing. And what's happening with AI is we have new GPUs and new machine learning accelerators and other ASICs and things like that that make AI go real fast. At Google, we work on TPUs. It's one of the biggest, largest scale deployed systems that exist for AI. And really what you see is if you look across all of the things that are happening in the industry, there's this new compute platform. And it's not just about CPUs or GPUs or TPUs or NPUs or IPUs or whatever, all the PUs, right? It's about how do we program these things, right? And so for software folks like us, right, it doesn't do us any good if there's this amazing hardware that we can't use. And one of the things you find out really quick is that having the theoretical capability of programming something and then having the world's power and the innovation of all the smart people in the world get unleashed on something can be quite different. And so really where Mojo came from was starting from a problem of we need to be able to take machine learning, take the infrastructure underneath it, and make it way more accessible, way more usable, way more understandable by normal people and researchers and other folks that are not themselves like experts in GPUs and things like this. And then through that journey, we realized, hey, we need syntax tools. We need to do clear.
So one of the main features of the language, I say so fully in jest, is that it allows you to have the file extension to be an emoji or the fire emoji, which is one of the first emojis used as a file extension I've ever seen in my life. And you ask yourself the question, why in the 21st century are we not using Unicode for file extensions? Because I mean, it's an epic decision. I think clearly the most important decision you made. But you could also just use MOJO as file extension.
Well, so okay, so take a step back. I'm like, do you think that the world's ready for this? This is a big moment in the world, right?
We're releasing this onto the world.
This is innovation.
I mean, it really is kind of brilliant. Emojis are such a big part of our daily lives. Why isn't it not in programming?
Well, and like you take a step back and look at what file extensions are, right? They're basically metadata, right? And so why are we spending all the screen space on them, all this stuff? Also, you have them stacked with files and PDF files and whatever else. Like, if you're gonna do something cool, you want to stand out, right? Emojis are colorful, they're visual, they're beautiful, right?
What's been the response so far? From, is there support on like Windows on operating system in displaying like file explorer?
Yeah. The one problem I've seen is that Git doesn't escape it right. And so it thinks that the fire emoji is unprintable, and so it like prints out weird hex things if you use the command line Git tool. But everything else, as far as I'm aware, works fast. And I have faith that Git can be improved. So I'm not
GitHub is fine.
GitHub is fine. Yeah. GitHub is fine. Visual Studio Code, Windows, like all this stuff, totally ready, because people have internationalization in their normal part of their past. So this is just like the next step, right? Somewhere between, oh wow, that makes sense. Cool. I like new things. To, oh my god, you're killing my baby. Like, what are you talking about? This can never be, like, I can never handle this. How am I going to type this? Like, all these things. And so this is something where I think that the world will get there. We don't have to bet the whole farm on this. I think we can provide both paths, but I think it'll be great.
When can we have emojis as part of the plan?
Yeah, so I mean, lots of languages provide that. So I think that we have partial support for that. It's probably not fully done yet, but yeah, you can do that. For example, in Swift, you could do that for sure. So an example we gave at Apple was the dog cow. Yeah, so it's a classical Mac heritage thing. So you use the dog and the cow emoji together, and that's your variable name. But of course, the internet went and made pile of poop for everything. So, if you want to name your function pile of poop, then you can totally go to town and see how that gets through code review.
Okay, so let me just ask a bunch of random questions. So is Mojo primarily designed for AIs, or is it a general purpose program?
Yeah, good question. So it's AI first. And so AI is driving a lot of the requirements. And so Modular is building and designing and driving Mojo forward. And it's not because it's an interesting project theoretically to build, it's because we need it. And so at Modular, we're really tackling the AI infrastructure landscape and the big problems in AI, the reasons that it is so difficult to use and scale and adopt and deploy, and like all these big problems in AI. And so we're coming at it from that perspective. Now, when you do that, when you start tackling these problems, you realize that the solution to these problems isn't actually an AI-specific solution. And so what we're doing is we're building Mojo to be a fully general programming language. And that means that you can obviously tackle GPUs and CPUs and like these AI things, but it's also a really great way to build NumPy and other things like that. Or, just if you look at what many Python libraries are today, often they're a layer of Python for the API, and they end up being C and C++ code underneath them. That's very true in AI. That's true in lots of other domains as well. And so anytime you see this pattern, that's an opportunity for Mojo to help simplify the world and help people have one thing.
Optimize through simplification by having one thing. You mentioned Modular. Mojo is the programming language. Modular is the whole software stack.
So just over a year ago, we started this company called Modular. Yeah, what Modular is about taking AI and up-leveling it into the next generation. Right? And so if you take a step back, what's gone on in the last 5, 6, 7, 8 years is that we've had things like TensorFlow and PyTorch. These other systems come in. You've used them. You know this. And what's happened is these things have grown like crazy. You get tons of users. It's in production deployment scenarios. It's being used to power so many systems. I mean, AI is all around us now. It used to be controversial years ago, but now it's a thing. But the challenge with these systems is that they haven't always been thought out with current demands in mind. And so you think about it, where were LLMs 8 years ago? They didn't exist. Right? AI has changed so much, and a lot of what people are doing today are very different than when these systems were built. And meanwhile, the hardware side of this has gotten into a huge mess. There's tons of new chips and accelerators, and every big company is announcing a new chip every day, it feels like. And so between that, you have like this moving system on one side, moving system on the other side, and it just turns into this gigantic mess, which makes it very difficult for people to actually use AI, particularly in production deployment scenarios. And so what Modular's doing is we're helping build out that software stack to help solve some of those problems, so then people can be more productive and get more AI research in production. Now, what Mojo does is it's a really, really, really important piece of that. And so that is, part of that engine and part of the technology that allows us to solve these problems.
So Mojo is a programming language that allows you to do high-level programming, the low-level programming, to do all kinds of programming in that spectrum that gets you closer and closer to the hardware.
So take a step back. So, what do you love about Python?
Oh boy, where do I begin? What is love? What do I love about Python?
You're a guy who knows love. I know this.
Yes. How intuitive it is. How it feels like I'm writing natural language English. How when I can not just write but read other people's code, somehow I can understand it faster. It's more condensed than other languages, like the ones that I'm really familiar with, like C++ and C. There's a bunch of sexy little features. We'll probably talk about some of them, but list comprehensions and stuff like this.
Also, and don't forget the inherent ecosystem of all packages.
Oh yeah, there's probably huge.
Because there's always something. If you want to do anything, there's always a package.
Yeah, so it's not just the ecosystem of the packages and the ecosystem of the humans that do it. That's an interesting dynamic, because I think something about the usability and the ecosystem makes the thing viral, and it grows, and it's a virtuous cycle.
Well, and there's many things that went into that. So I think that ML was very good for Python, and so I think that TensorFlow and PyTorch and these systems embracing Python really took and helped Python grow. But I think that the major thing underlying it is that Python's like the universal connector. Right? It really helps bring together lots of different systems so you can compose them and build out larger systems without having to understand how it works. But then, what is the problem with Python?
Well, I guess you could say several things, but probably that it's slow.
I think that's usually what people complain about, right? And so other people complain about tabs and spaces versus curly braces or whatever, but I mean, those people are just wrong. It is actually just better to use indentation.
Wow, strong words. So actually, a small tangent. Let's actually take that. Let's take all kinds of tangents.
Oh, come on, Lex, you can push me. I can take
it. Sign. Listen, I've recently left Emacs for VS Code.
Okay.
The kind of hate mail I had to receive, because on the way to doing that, I also said I've considered Vim.
Yep.
And chose not to, and went with VS Code. And
just on deep religions, right?
Anyway, tabs is an interesting design decision, and so you've really written a new programming language here. Yes, it is a superset of Python, but you can make a bunch of different interesting decisions here.
Totally. Yeah.
And you chose actually to stick with Python as in terms of some of the syntax.
Well, so let me explain why. Right. So, you can explain this in many rational ways. I think that the indentation is beautiful, but that's not a rational explanation, right? So, but I can defend it rationally. Right? So, first of all, Python 1 has millions of programmers.
Yeah.
It is huge. It's everywhere. It owns machine learning. Right? So, factually, it is the thing. Second of all, if you look at it, C code, C++ code, Java, whatever, Swift, curly brace languages also run through formatting tools and get indented. And so if they're not indented correctly, first of all, we'll twist your brain around. It can lead to bugs. There's notorious bugs that have happened across time where the indentation was wrong and misleading and it wasn't formatted right, and so it turned into an issue, right? And so what ends up happening in modern large-scale code bases is people run automatic formatting. So now what you end up with is indentation and curly braces. If you're going to have the notion of grouping, why not have one thing? Right? And get rid of all the clutter and have a more beautiful thing. Right? Also, you look at many of these languages, it's like, okay, well, you can have curly braces, or you can omit them if there's one statement, or you just enter this entire world of complicated design space that objectively you don't need if you have Python style indentation. So,
yeah, let's actually see statistics on errors made because of indentation. Like how many errors are made in Python versus in C++ that have to do with basic formatting, all that kind of stuff. I would love to see.
I think it's probably pretty minor, because once you get like you use VS Code, I do too. So if you get VS Code set up, it does the indentation for you, right? And so you don't, it's actually really nice to not have to fight it. And then what you can see is the editor is telling you how your code will work by indenting, which I think is pretty cool.
I honestly don't think I don't remember having an error in Python because I indented stuff.
So I think that there's, again, this is a religious thing, and so I can joke about it, and I love to kind of, I realize that this is such a polarizing thing, and everyone wants to argue about it. So I like poking at the bear a little bit, right? But frankly, like, come back to the first point, Python 1. Like, it's huge. It's an AI. It's the right thing for us. Like, we see Mojo as being an incredible part of the Python ecosystem. We're not looking to break Python or change it or quote unquote fix it. We love Python for what it is. Our view is that Python is just not done yet. And so if you look at, you mentioned Python being slow. Well, there's a couple of different things that go into that, which we can talk about if you want. But one of them is that it just doesn't have those features that you would use to do the C-like programming. And so if you say, okay, well, I'm forced out of Python into C for certain use cases, well, then what we're doing is saying, okay, well, why is that? Can we just add those features that are missing from Python back up to Mojo, and then you can have everything that's great about Python, all the things you're talking about being well, plus not be forced out of it when you do something a little bit more computationally intense or weird or hardware or whatever it is you're doing.
Well, a million questions I want to ask this. High level again, is it compiled or is it an interpreted language? So Python is just in time compilation with Mojo.
So Mojo, the complicated answer, does all the things. So it's interpreted, it's JIT compiled, and it's statically compiled. And so this is for a variety of reasons. One of the things that makes Python beautiful is that it's very dynamic. And because it's dynamic, one of the things they added is that it has this powerful metaprogramming feature. And so if you look at something like PyTorch or TensorFlow or even a simple use case, like you find a class that has the plus method. You can overload the dunder methods, like dunder add, for example, and then the plus method works on your class. And so it has very nice and very expressive dynamic metaprogramming features. In Mojo, we want all those features to come in. Like, we don't want to break Python, we want it all to work. But the problem is you can't run those super dynamic features on an embedded processor or on a GPU, right? Or if you could, you probably don't want to just because of the performance. And so we entered this question saying, okay, how do you get the power of this dynamic metaprogramming into a language that has to be super efficient in specific cases? And so what we did was we said, okay, we'll take that interpreter. Python has an interpreter in it. Right? Take that interpreter and allow it to run at compile time. And so now what you get is you get compile time metaprogramming. And so this is super interesting, super powerful, because one of the big advantages you get is you get Python-style expressive APIs. You get the ability to have overload operators. And if you look at what happens inside of like PyTorch, for example, with automatic differentiation, and pure mode, like all these things, they're using these really dynamic and powerful features at runtime. But we can take those features and list them so that they run at compile time.
So your the C++ has metaprogramming with templates, but it's really messy.
It's super messy. It's always, it was accidentally, different people have different interpretations. My interpretation is that it was made accidentally powerful. It was not designed to be Turing complete, for example, but that was discovered kind of along the way, accidentally. And so there have been a number of languages in the space. And so they usually have templates, code instantiation, code copying features of various sorts. Some more modern languages, or some more newer languages, let's say, like, they're fairly unknown, like Zig, for example, says, okay, well, let's take all of those types that you can run, all those things you can do at runtime, and allow them to happen at compile time. And so one of the problems with C++, which is one of the problems with C++,
There we go.
is,
Don't worry. You're not offend everybody.
oh, it's okay. Everybody hates me for a variety of reasons anyways, I'm sure, right? I've written enough the way they show love. I've written enough C++ code to earn a little bit of grumpiness with C++. But one of the problems with it is that the metaprogramming system templates is just a completely different universe from the normal runtime programming. And so if you do metaprogramming and programming, it's just like a different universe, different syntax, different concepts, different stuff going on. And so, again, one of our goals of Mojo is to make things really easy to use, easy to learn, and so there's a natural stepping stone. And so as you do this, you say, okay, well, I have to do programming at runtime, I have to do programming at compile time. Why are these different things?
How hard is that to pull? Because that sounds, to me, as a fan of metaprogramming in C++, how hard is it to pull that off? That sounds really, really exciting because you can do the same style programming at compile time and at runtime. That's really
Yep. And so, I mean, in terms of the compiler implementation details, it's hard. I won't be shy about that. It's super hard. It requires, I mean, what Mojo has underneath the covers is a completely new approach to the design of the compiler itself. And so it's built on these technologies like NLIR that you mentioned. It also includes other like hashing and other interpreters and JIT compilers and other stuff like that.
you have like an interpreter inside the
within the compiler. Yeah. And so it really takes the standard model of programming languages and kind of twists it and unifies it with the runtime model, which I think is really cool. And to me, the value of that is that, again, many of these languages have metaprogramming features, that they grow macros or something. Right? Look.
Fucking shit.
Right?
Go.
I know. Your roots, right? You know. And this is a powerful thing, right? And so, you know, if you go back to Lisp, one of the most powerful things about it is that the metaprogramming in the program.
Heard about this fucking programming language so many fucking times. Yeah.
On one axis, you have more hardware coming in. On the other hand, you have an explosion of innovation in AI. And so what happened with both TensorFlow and PyTorch is that the explosion of innovation in AI led to, it's not just about matrix multiplication and convolution. These things have now like 2,000 different operators. And on the other hand, you have, I don't know how many pieces of hardware there are out there. It's a lot. Part of my thesis, part of my belief of where computing goes, if you look out 10 years from now, it's not going to get simpler. Physics isn't going back to where we came from. It's only going to get weirder from here on out. Right. And so to me, the exciting part about what we're building is it's about building that universal platform, which will continue to get weird. Because again, I don't think it's avoidable, it's physics. But we can help lift people, scale, do things with it. They don't have to rewrite their code every time a new device comes out. And I think that's pretty cool.
The following is a conversation with Chris Ladner, his third time on his podcast. As I've said many times before, he's one of the most brilliant engineers in modern computing.
Weird.
The following is a conversation with Chris Ladner.
Oh, what the fuck is that shit? No wonder.
As I've said many times before, he's one of the most brilliant engineers in modern computing, having created LLM compiler infrastructure project, the Clang compiler, the Swift programming language. A lot of key contributions to TensorFlow.
Did you see that? I fucking did that on a Cinderblock, kids.
As vice president of autopilot software at Tesla.
Incredible.
Software innovator.
35 fucking minutes later. Worst stream
full stack AI
ever.
Infrastructure for distributed training, inference, and deployment on all kinds of hardware called Modular, and a new programming language called Mojo. It is a superset of Python, giving you all the usability of Python, but with the performance of C, C++. In many cases, Mojo code has demonstrated over 30,000x speed up over Python. If you love machine learning, if you love Python, you should definitely give Mojo a try. This programming language, this new AI framework,
Like that
and
fucking
infrastructure,
YouTube channel.
and this conversation with Chris
I've got
is
Mojo.
mind-blowing.
What is Mojo?
I love it.
Sex
It
appeal?
gets pretty technical at times, so I hope
gotta
you
take a
hang
whiz.
on to the ride.
What kind of whiz,
This
Rabbi?
is the Lex Freedom Podcast. Support it. Please check out our sponsors in the description. Now, dear friends, it's Chris.
What kind of,
It's been,
I don't know,
2 years
5'5"?
since we last talked, and in that time, you somehow went and co-created a new program.
It's an average piss, lady.
Mojo.
Mind your own
So
business.
it's
I don't ask you what your
optimized
piss
for
looks
AI.
like.
It's a superset of Python.
This one time,
Let's look at the
Oprah
big picture. What is the
had
vision
this thing.
for Mojo?
She like made me start thinking about piss
So
color
I've been
and like how
working on a lot of related
dehydrated you
technologies
can
for
be.
many, many years.
We're hydrated.
A lot of things and mobile
Should be like
servers and things like this.
a
But the world's
zero.
changing.
Zero should be you don't have to
AI,
do
so we have
anything.
new GPUs and new machine learning accelerators.
Oh wait,
and
pee
ASICs,
can be
things like that for
how
making AI
badly
go
you have to pee, and then the
fast.
color.
At Google, worked on TPUs. It's one of the biggest, largest scale
All right.
systems
We're
that
gonna-
exist for AI.
We're gonna have all this shit.
Really, what you see is
Standardized,
if you look
kids.
across all of the things that are happening in the industry, there's this new compute platform. And it's not just about
Some lady's gonna. Yeah.
CPUs or
I just
GPUs
had a
or
5.5.
TPUs or NPUs or IPUs or whatever, all the PUs, right? It's about how do we program these things. And
I gotta take a whiz.
software folks like us,
Whiz,
right,
kid.
doesn't do us any good if there's this amazing hardware that we can't use. And one of the things you find out really quick is that having the theoretical capability of programming something and then having the world's power and the innovation of all the smart people in the world get unleashed on something can be quite different. And so really where Mojo came from was starting from a problem of we need to be able to take machine learning, take the infrastructure underneath it and make it way more accessible, way more usable, way more understandable by normal people and researchers and other folks that are not themselves like experts in GPUs and things like this. And then through that journey, we realized, hey, we need syntax rules. We need to do programming.
So one of the main features of the language, I say so fully in jest, is that it allows you to have the file extension to be
Yeah, I think it's like a
the
5.5.
fire emoji, which is one of the first emojis used as a file extension I've ever seen in my life. And then you ask yourself the question, why in the 21st century are we not using Unicode for file extensions? Because I mean, it's an epic decision. I think clearly the most important decision we made was, but you could also just use emoji or
Also, okay, so take a step back. Do you think that the world's ready for this? This is a big moment in the world, right?
we released this onto the world.
This is innovation.
I mean, it really is kind of brilliant. Emojis are such a big part of our daily lives. Why is it not in programming?
Well, and like you take a step back and look at what file extensions are, right? They're basically metadata, right? And so why are we spending all the screen space on them, all this stuff? Also, you have them stacked with text files and PDF files and whatever else. Like, if you're gonna do something cool, you want to stand out, right? Emojis are colorful, they're visual, they're beautiful, right?
What's been the response so far? Is there support on like Windows on operating system in displaying like files for?
Yeah. The one problem I've seen is the Git doesn't escape it right. And so it thinks that the fire emoji is unprintable, and so it like prints out weird hex things if you use the command line Git tool. But everything else, as far as I'm aware, is fine. And I have faith that Git can be improved. So
Yeah, so
I'm not
Git
really-
is fine.
GitHub is fine. Yeah, GitHub is fine. Visual Studio Code, Windows, like all this stuff, totally ready. Because people have internationalization in their normal part of their paths. This is just like the next step, right? Somewhere between, oh wow, that makes sense. Cool. I like new things. To, oh my god, you're killing my baby. Like, what are you talking about? This can never be, like, I can never handle this. How am I going to type this? Like, all these things. And so this is something where I think that the world will get there. You don't have to bet the whole farm on this. I think we can provide both paths, but I think it'll be great.
When can we have emojis as part of it?
Yeah, so I mean, luckily we just provide that. So I think that we have partial support for that. It's probably not fully done yet, but yeah, we can do that. For example, in Swift, you could do that for sure. So an example we gave at Apple was the dog cow. Yeah, so it's a classical Mac heritage thing. So you use the dog and the cow emoji together next to your variable name. But of course, the internet went and made pile of poop for everything. So, if you want to name your function pile of poop, then you can totally go to town and see how that gets through code review.
Okay, so let me just ask a bunch of random questions. So is Mojo primarily designed for AI, or is it a general purpose program?
Good question. So it's AI first, and so AI is driving a lot of the requirements, and so Modular is building and designing and driving Mojo forward, and it's not because it's an interesting project theoretically to build, it's because we need it. And so at Modular, we're really tackling the AI infrastructure landscape and the big problems in AI, the reasons that it is so difficult to use and scale and adopt and deploy, and all these big problems in AI. And so we're coming at it from that perspective. Now, when you do that, when you start tackling these problems, you realize that the solution to these problems isn't actually an AI-specific solution. And so what we're doing is we're building Mojo to be a fully general programming language. And that means that you can obviously tackle GPUs and CPUs and like these AI things, but it's also a really great way to build NumPy and other things like that. Or, just if you look at what many Python libraries are today, often they're a layer of Python for the API, and they end up being C and C++ code underneath them. That's very true in AI. That's true in lots of other domains as well. And so anytime you see this pattern, that's an opportunity for Mojo to help simplify the world and help people have one thing.
Optimize through simplification by having one thing. You mentioned modular. Mojo is the programming language. Modular is the whole software stack.
So just over a year ago, we started something called Modular. Yeah, what Modular is about taking AI and up-leveling it into the next generation. Right? And so if you take a step back, what's gone on in the last 5, 6, 7, 8 years is that we've had things like TensorFlow, PyTorch, these other systems coming in. We've used them, you know this. And what's happened is these things have grown like crazy. We get tons of users. It's in production deployment scenarios. It's being used to power so many systems. And AI is all around us now. It used to be controversial years ago, and now it's a thing. But the challenge with these systems is that they haven't always been thought out with current demands in mind. So you think about it, where were LLMs 8 years ago? They didn't exist, right? AI has changed so much, and a lot of what people are doing today are very different than when these systems were built. And meanwhile, the hardware side of this has gotten into a huge mess. There's tons of new chips and accelerators, and every big company is announcing a new chip every day, it feels like. And so between that, you have like moving system on one side, moving system on the other side, and it just turns into this gigantic mess, which makes it very difficult for people to actually use AI, particularly in production deployment. That's what Modular's doing to help build out that software system, solve some of those problems, but then get more AI research. Now, what Mojo does is it's a really part of that engine and part of the technology that allows us to solve these problems.
So Mojo is the programming language that allows you to do high-level programming or low-level programming, and do all kinds of programming in that spectrum that gets you closer and closer to the hardware.
So take a step back. So like, what do you learn about Python?
Oh boy, where do I begin? What is love? What do I love about Python?
You're a guy who knows love.
Yes. How intuitive it is. How it feels like I'm learning natural language, English. How when I can not just write but read other people's code, somehow I can understand it faster. It's more condensed than other languages, like ones I'm really familiar with, like C++ and C. There's a bunch of sexy little features. We'll probably talk about some of them, but list comprehensions and stuff like this.
So and don't forget the inherent ecosystem of Python.
Oh yeah, there's probably huge.
There's always something. If you want to do anything, there's always a package.
Yeah, so it's not just the ecosystem of the packages and the ecosystem of the humans that do it. That's an interesting dynamic, because I think something about the usability and the ecosystem makes it viral and it grows, and it's a virtuous cycle.
Well, there's many things that went into that. Like, so I think that ML is very good for Python, and so I think that TensorFlow and PyTorch systems embracing Python really took and helped Python grow. But I think that the major thing underlying it is that Python's like a connector. And it really helps bring together lots of different systems so you can compose them and build out larger systems without having to understand how it works. But then, what is the problem with Python?
Well, I guess you could say several things, but probably very slow.
I think that's usually what people complain about, right? And so I mean, other people complain about tabs and spaces versus curly braces or whatever, but I mean, those people are just wrong. It is actually just better to use indentation.
Wow, strong words. So actually, a small tangent. Let's actually take that. Let's take all kinds of tangents.
Oh, come on, Mike, you can push me out. I can take it.
Sign. Listen, I've recently left Emacs for VS Code.
Okay.
For the kind of hate mail I had to receive. Because on the way to doing that, I also said I've considered Vim.
Yep.
And chose not to with VS Code.
Especially on deep religions, right?
Anyway, tabs is an interesting design decision, and so you've really written a new programming language here. Yes, it is a superset of Python, but you can make a bunch of different interesting decisions here. And you chose actually to stick with Python as in terms of some of the syntax.
Well, so let me explain that. Right, so, I mean, you can explain this in many rational ways. I think that the indentation is beautiful, but that's not a rational explanation, right? So, but I can defend it rationally. Right? So first of all,
Maybe I made it the way with me all the
it's used
time.
everywhere. It owns machine learning. And so,
Maybe I'm
actually,
afraid
it
of
is
the way I need you.
second of all, if you look at it, C code, C++ code, Java,
Maybe I'm
whatever,
afraid
so
of the way
curly brace
I'm
languages
missing my
also
song.
run through formatting.
Right me when I'm wrong.
And so if they're not indented
Maybe I'm
correctly,
amazed at the way I
first of all,
really
it's right.
need you.
it can lead to bugs. There's notorious bugs that happen across time, but the indentation is wrong and misleading, and it doesn't format right, and so it turns into an issue, right? And so what ends up happening in modern large-scale code bases is people run automatic formats. So now what you end up with is indentation and code. You're going to have the notion of grouping. Why not have one thing, right? And get rid of all the clutter and have a more beautiful thing, right? Also, you look at many of these languages, it's like, okay, well, you can have curly braces, or you can omit them if there's one statement, or you just like enter this entire world of complicated time space that objectively you don't need if you have something.
Yeah, we'll actually see statistics on errors made because of implementation. Like how many errors are made in Python versus in C++ that have to do with basic formatting.
I think it's probably pretty minor because once you get when you use VS Code, I do. So if you get VS Code set up, it does the annotation for you. Right? So you don't, it's actually really nice to not have to fight it. And then what you can see is the editor is telling you how your code will work by indenting, which I think is pretty cool.
I honestly don't think I don't remember having an error in Python because I indented stuff.
So I mean, I think that there's again, this is thing. So I can joke about it, and I love to kind of I realize this is such a polarizing thing, and everyone wants to argue about it. So I like
the way I really need you.
right? But frankly, right, come back to the first point. Like it's huge, it's an AI, it's the right thing. For us, like we see Mojo as being an incredible part of the Python ecosystem. We're not looking to break Python or change it or quote unquote fix it. We love Python for what it is. Our view is that Python is just not done yet. And so if you look at, you mentioned Python being slow. Well, there's a couple of different things to go into that, which we can talk about if you want. But one of them is it just doesn't have those features that you would use to do C-like programming. And so if you say, I'm forced out of Python into C in certain use cases, well, then what we're doing is we're saying, okay, well, why is it? You just add those features that are missing from Python back up to Mojo, and then you can have everything that's great about Python, all the things you're talking about as well, plus not be forced out of it when you do something a little bit more computationally intense or weird or hardware-y or whatever it is.
Well, a million questions I want to ask, but high level again, is it compiled or is it an interpreted language? So Python is just-in-time compilation with Mojo.
So Mojo, the complicated answer, does all the things. So it's interpreted, it's JIT compiled, and it's statically compiled. And so this is for a variety of reasons. One of the things that makes Python beautiful is that it's very dynamic. And because it's dynamic, one of the things they added is that it has this powerful metaprogramming feature. And so if you look at something like PyTorch or TensorFlow or even a simple use case, like you find a class that has the plus method. So you can overload the dunder methods like dunder add, for example, and then the plus method works on your class. And so it has very nice and very expressive dynamic metaprogramming features. In Mojo, we want all those features to come in. Like, we don't want to break that down, we want all the work. The problem is you can't run those super dynamic features on an embedded processor or on a GPU. Or if you could just because of performance. So we entered this question of saying, okay, how do you get the power of this dynamic metaprogramming into a language that has to be super efficient in specific cases? And so what we did was just like, okay, we'll take that interpreter. Python has an interpreter in it. Right? Take that interpreter and allow it to run it compile time. And so now what you get is compile time metaprogramming. So this is super interesting and powerful because one of the big advantages you get is you get Python-style expressive APIs. You get the ability to have load operators. And if you look at what happens inside of PyTorch, for example, with automatic differentiation, all these things, they're using really dynamic features that run. But we can take those features and lift them so they run up.
So you're just C++ of metaprogramming. Templates. But it's really
super messy. It's always accidentally. We'll have different interpretations. My interpretation is it was made accidentally powerful. Not designed to be for example, but that was discovered kind of along the way accidentally. And so there have been a number of languages
really good.
in space.
Psych, worst concert ever. No one liked it. I didn't even like it, and I was in it.
Some more modern languages or some more newer languages, let's say, like, they're fairly unknown, like Zig, for example, says, okay, well, let's take all of those types that you can run it, all those things you can do at runtime, and allow them to happen at compile time. And so one of the problems with C++, one of the problems with C++, here we go. Is okay. I mean, for a variety of reasons, anyways, I'm sure. Right? I've written enough the way they show love. I have written enough C++ code to earn a little bit of grumpiness of C++. But one of the problems with it is that the metaprogramming system templates is just a completely different universe from the normal runtime programming. And so if you do metaprogramming and programming, it's just like a different universe, different syntax, different concepts, different stuff going on. And so, again, one of our goals with Mojo is to make things really easy to use, easy to learn, and so there's a natural stepping stone. And so as you do this, you say, okay, well, I have to do programming at runtime. I have to do programming at compile time. Why are these different things?
How hard is that to pull on? Because that sounds, to me, as a fan of metaprogramming in C++, how hard is it to pull that off? That sounds really, really exciting because you can do the same style programming at compile time and at runtime. That's really, really exciting.
Yep. And so, I mean, in terms of the compiler implementation details, it's hard. I want to be shy about that. It's super hard. It requires, what Mojo has underneath the covers is a completely new approach to the design of the compiler itself. And so this builds on these technologies like NLIR that you mentioned. It also includes other caching, other interpreters and JIT compilers and other stuff like that.
So you have like an interpreter inside
within the compiler, yeah. And so it really takes the standard model of programming languages and kind of twists it and unifies it with the runtime model, which I think is really cool. And to me, the value of that is that, again, many of these languages have metaprogramming features, like they grow macros or something. I use Lisp, right? I know your roots, right? And this is a powerful thing, right? And so, if you go back to Lisp, one of the most powerful things about it is that it said that the metaprogramming and the programming are the same. right? And so that made it way simpler, way more consistent, way easier to understand, reason about, and it made it more composable. So if you go to the library, you can use it both at runtime and compile, which is pretty cool.
Yeah. And then for machine learning, I think metaprogramming, I think you could generally say is extremely useful. And so you features, I mean, I'll jump around, but there's the feature of auto tuning and adaptive compilation. Just blows my mind.
Yeah. Well, so okay, so let's come back to that.
Sure.
So,
All right.
So what is machine learning? Like what is a machine learning model? Like you take a PyTorch model, right? It's really interesting to me because what PyTorch and what TensorFlow and all these frameworks are kind of pushing compute into is they're pushing into like this abstract specification of a compute problem, which then gets mapped in a whole bunch of different ways. Right? And so this is why it became a metaprogramming problem. So you want to be able to say, cool, I have this neural net. Now run it with batch size 1,000, right? Do a mapping across batch, or okay, I want to take this problem now run it across 1,000 CPUs or GPUs, right? And so like this problem is like just describe the compute and then map it and do things and transform it, or like actually it's very profound, and that's one of the things that makes machine learning systems really special.
Maybe can you describe auto tuning and how do you pull off? I mean, I guess adaptive compilation is what we're talking about, metaprogramming.
Yeah.
How do you pull off auto tune? I mean, is that as profound as I think it is? It just seems like a really like we mentioned list comprehensions. To me, from a quick glance at Mojo, which by the way I have to absolutely like dive in. As I realize how amazing this is, I absolutely must dive in. That looks like just an incredible feature for machine learning people.
Yeah. Well, so what is auto tuning? So take a step back. Auto tuning is a feature in Mojo. It's not so very little of what we're doing is actually research. Like many of these ideas, it exists in other systems and other places, and so what we're doing is we're pulling together good ideas, remixing them, and making them into hopefully a beautiful system, right? And so auto tuning, the observation is that turns out hardware systems, algorithms are really complicated. Turns out maybe you don't actually want to know how the hardware works, right? A lot of people don't, right? And so there are lots of really smart hardware people, I know a lot of them, where they know everything about, okay, the cache size is this, and the number of registers is that, and if you use this length of vector, it's going to be super efficient because it maps directly onto what it can do, and like all this kind of stuff, or the GPU has SMs and it has a warp size of whatever, right? All the stuff that goes into these things, or the tile size of a TPU is 128, like these factoids, right? My belief is that most normal people, and I love hardware people also, I'm not trying to offend literally everybody on the internet, but most programmers actually don't want to know this stuff, right? And so if you come at it from the perspective of how do we allow people to build both more abstracted but also more portable code, because it could be that the vector length changes or the cache size changes, or it could be that the tile size of your matrix changes, or the number, an A100 versus an H100 versus a Volta versus a whatever GPU have different characteristics, right? A lot of the algorithms that you run are actually the same, but the parameters, these magic numbers you have to fill in, end up being really fiddly numbers that an expert has to go figure out. And so what auto-tuning does is says, okay, well, guess what? There's a lot of compute out there. Right? So instead of having humans go randomly try all the things, or do a grid search, or go search some complicated multi-dimensional space, how about we have computers do that? Right? And so what auto-tuning does is you can say, hey, here's my algorithm. If it's a matrix operation or something like that, you can say, okay, I'm going to carve it up into blocks. I'm going to do those blocks in parallel, and I want this with 128 things that I'm running on. I want to cut it this way or that way or whatever. And you can say, hey, go see which one's actually empirically better on the system.
And then the result of that, you cache for that system.
Yep.
You save it.
And so come back to twisting your compiler brain, right? So not only does the compiler have an interpreter,
what time is it in Manila?
That compiler, that interpreter,
no one
programming now has to actually take your code and go run it on a target machine. see which one it likes the best, and then stitch it in, and then keep going. Right?
So part of the compilation is machine specific.
5:11 p.m.
This is an optional feature, right? So you don't have to use it for everything. But yeah, if you're so one of the things that we're in the quest of is ultimate performance. Right, and ultimate performance is important for a couple of reasons, right? So if you're an enterprise, you're looking to save costs and compute and things like this. Ultimate performance translates to fewer servers. If you care about the environment, hey, better performance leads to more efficiency. Right? I mean, you could joke and say like, Python's bad for the environment, right? And so if
511
Mojo
right now,
is 10x better just out of the box and keep going, right? But performance is also interesting because it leads to better products. And so in the space of machine learning, right, if you reduce the latency of the model so that it runs faster, so every time you query the server running the model, it takes less time, well, then the product team can go and make the model bigger. So that actually makes it so you have a better experience as a customer. And so a lot of people care about that.
So for auto tuning, for like tile size, you mentioned 128 for TPU, you would specify like a bunch of options to try just in the code, simple statement, and then you can just set and forget and know, depending on wherever it compiles, it'll actually be the fastest.
And yeah, exactly. And the beauty of this is that it helps you in a whole bunch of different ways, right? So if you're building, so often what will happen is that you've written a bunch of software yourself, right? You wake up one day, you say, I have an idea, I'm going to go code up some code, I get to work, I forget about it, I move on with life, I come back 6 months or a year or 2 years or 3 years later, you dust it off and you go use it again in a new environment. And maybe your GPU is different. Maybe you're running on a server instead of a laptop, maybe whatever, right? And so the problem now is you say, okay, well, I mean, again, not everybody cares about performance, but if you do, you say, okay, well, I want to take advantage of all these new features. I don't want to break the old things though, right? And so the typical way of handling this kind of stuff before is talking about C++ templates, or you're talking about C with macros, you end up with if-defs, you get like all these weird things get layered in, make the code super complicated, and then how do you test it? Right? It becomes this crazy complexity, multi-dimensional space that you have to worry about. And, that just doesn't scale very well.
Actually, let me just jump around before I go to specific features. Like the increase in performance here that we're talking about can be just insane. You're right that Mojo can provide a 35,000x speed up over Python. How does it do that?
Yeah, so you can even do more, but we'll get to that. So first of all, when we say that, we're talking about what's called CPython. It's the default Python that everybody uses. When you type Python 3, that's like typically the one you use, right? CPython is an interpreter. And so interpreters, they have an extra layer of like bytecodes and things like this. They have to go read, parse, interpret, and make some kind of slow from that perspective. And so one of the first things we do is we move to a compiler. And so just moving to a compiler, getting the interpreter out of the loop is 2 to 5 to 10x speed up, depending on the code. So just out of the gate, just using more modern techniques. Right? Now, if you do that, one of the things you can do is you can start to look at how CPython started to lay out data. And so one of the things that CPython did, and this isn't part of the Python spec necessarily, but this is just a set of decisions, is that if you take an integer, for example, it'll put it in an object. So in Python, everything's an object. And so they do the very logical thing, keeping the memory representation of all objects the same. So all objects have a header, they have like payload data. And what this means is that every time you pass around an object, you're passing around a pointer to the data. Well, it turns out that modern computers don't like using pointers very much and things like this. It means that you have to allocate the data. It means you have to reference count it, which is another way that Python uses to keep track of memory. And so this has a lot of overhead. And so if you say, okay, let's try to get that out of the heap, out of a box, out of an indirection, and into the registers. That's another 10x.
So it adds up if you're reference counting every single thing you create, that adds up.
Yep. And if you look at, people complain about the Python GIL. This is one of the things that hurts parallelism. That's because of the reference count. So the GIL and reference counting are very tightly intertwined in Python. It's not the only thing, but it's very tightly intertwined. And so then you lean into this and you say, okay, cool. Well, modern computers, they can do more than one operation at a time. So they have vectors. What is a vector? Well, a vector allows you to take one, instead of taking one piece of data, doing an add or a multiply, and then pick up the next one, you can now do 4 or 8 or 16 or 32 at a time. Well, Python doesn't expose that because of reasons. And so now you can say, okay, well, you can adopt that. Now you have threads. You have like additional things, like you can control the memory hierarchy. And so what Mojo allows you to do is it allows you to start taking advantage of all these powerful things that have been built into the hardware over time. And the library gives very nice features. So you can say, just parallelize this, do this in parallel, right? So it's very, very powerful weapons against slowness, which is why people have been. And I think having fun, like just taking code and making it go fast, because it's just kind of an adrenaline rush to see like how fast you can get things.
Before I talk about some of the interesting stuff with parallelization and all that, let's first talk about like the basics. We talked indentation, right? So this thing looks like Python. It's sexy and beautiful like Python, as I mentioned.
Yep.
Is it a typed language? So what's the role of types?
Yeah, good question. So Python has types. It has strings, it has integers, it has dictionaries, and like all that stuff. But they all live at runtime, right? And so because all those types live at runtime in Python, you don't have to spell them. Python also has like this whole typing thing going on now, and a lot of people use it.
Yeah.
I'm not talking about that. That's kind of a different thing. We can go back to it. But typically the you just say I have a def, and my def takes two parameters. I'm going to call them A and B. I don't have to write type. Yeah. So that is great, but what that does is that forces what's called a consistent representation. So these things have to be a pointer to an object with the object header, and they all have to look the same. And then when you dispatch a method, you go through all the same different paths, no matter what the receiver, whatever that type is. So what Mojo does is it allows you to have more than one kind of type. And so what it does is allows you to say, okay, cool, I have an object, and objects behave like Python does. So it's fully dynamic, and that's all great. And for many things, classes, like that's all very powerful and very important. But if you want to say, hey, it's an integer, and it's 32 bits, or 64 bits, or whatever it is, or it's a floating point value, it's 64 bits, well, then the compiler can take that, and it can use that to do way better optimization. It turns out, again, getting rid of the interactions is huge. It means you can get better code completion because you have, because the compiler knows what the type is, and so it knows what operations work on it, and so that's actually pretty huge. And so what Mojo does is it allows you to progressively adopt types into your program. So you can start, again, it's compatible with Python, and so then you can add however many types you want, wherever you want them. And if you don't want to deal with it, you don't have to deal with it. And so one of our opinions on this is that it's not that types are the right thing or the wrong thing. It's that they're a useful thing.
Which is kind of optional. It's not strict typing. You don't have to specify type.
Exactly.
Okay, so starting from the thing that Python's kind of reaching towards right now with trying to inject types into it.
With a very different approach, but yes. Yeah.
What's the different approach? I'm actually one of the people that have not been using types very much in Python.
That's okay. Why did you sigh?
It's just, because I know the importance. It's like adults use strict typing. And so I refuse to grow up in that sense. It's a kind of rebellion. But I just know that it probably reduces the amount of errors, even just forget about performance improvements. It probably reduces errors if we need to strict type.
Yeah, so I mean, I think it's interesting if you look at that, right? And the reason I'm giving you a hard time is that there's this cultural norm, this pressure, this like there has to be a right way to do things. Like grown-ups only do it one way, and if you don't do that, you should feel bad.
Yes.
Right? Like some people feel like Python's a guilty pleasure or something, and it's like when it gets serious, I need to go rewrite it, right?
Yeah. Exactly.
Well, I mean, cool. I understand history and I understand kind of where this comes from, but I don't think it has to be a guilty pleasure.
Yeah.
Right. So if you look at that, you say, why do you have to rewrite it? Well, you have to rewrite it to deploy. Well, why do you want to deploy? Well, you care about performance, or you care about predictability, or you want a tiny thing on the server that has no dependencies, or you have objectives that you're trying to attain. So what if Python can achieve those objectives? So if you want types, well, maybe you want types because you want to make sure you're passing the right thing. Sure, you can add a type. If you don't care, you're prototyping some stuff, you're hacking some things out, you're like pulling some random code off the internet, it should just work, right? And you shouldn't be like pressured. You shouldn't feel bad about doing the right thing or the thing that feels good. Now, if you're in a team, right, you're working at some massive internet company and you have 400 million lines of Python code, well, they may have a house rule that you use types, right? Because it makes it easier for different humans to talk to each other and understand what's going on and bugs at scale, right? And so there are lots of good reasons why you might want to use types, but that doesn't mean that everybody should use them all the time. Right? So what Mojo does is it says, cool, well, allow people to use types. And if you use types, you get nice things out of it, right? You get better performance and things like this, right? But Mojo is a full compatible superset of Python. And so that means it has to work without types. It has to support all the dynamic things. It has to support all the packages. It has to support for comprehension, list comprehensions, and things like this, right? And so that starting point, I think, is really important. And I think that, again, you can look at why I care so much about this. There's many different aspects of that. One of which is the world went through a very challenging migration from Python 2 to Python 3. Right? This migration took many years, and it was very painful for many teams. Right? And there's a lot of things that went on in that. I'm not an expert in all the details. I honestly don't want to be. I don't want the world to have to go through that.
Yeah.
Right? And people can ignore Mojo, and if it's not their thing, that's cool. But if they want to use Mojo, I don't want them to have to rewrite all the code.
Yeah, I mean, the superset part is just, I mean, there's so much brilliant stuff here. That definitely is incredible. We'll talk about that.
Yeah.
First of all, how's the typing implemented differently in Python versus Mojo?
Yeah.
So this heterogeneous flexibility you said is differently implemented.
Yeah. So I'm not a full expert in the whole backstory on types in Python. So I'll give you that. I can give you my understanding. My understanding is basically, like many dynamic languages, the ecosystem went through a phase where people went from writing scripts to writing large-scale, huge code bases in Python, and at scale, it kind of helps to have types. People want to be able to reason about interfaces. What do you expect, string or an int, or like what these basic things, right? And so what the Python community started doing is it started saying, okay, let's have tools on the side, checker tools, right, that go and like enforce invariance, check for bugs, try to identify things. These are called static analysis tools generally. And so these tools run over your code and try to look for bugs. What ended up happening is there's so many of these things, so many different weird patterns and different approaches on specifying types and different things going on, that the Python community realized and recognized, hey, there's a thing here. And so what they started to do is they started to standardize the syntax for adding types to Python. Now, one of the challenges they had is that they're coming from kind of this fragmented world where there's lots of different tools, they have different trade-offs and interpretations, and the types mean different things. And so if you look at types in Python, according to the Python spec, the types are ignored. Right. So according to the Python spec, you can write pretty much anything in a type position. Okay. And you can write any expression. Okay. Now, that's beautiful because you can extend it, you can do cool things, you can build your own tools, you can build your own house linter or something like that, right? But it's also a problem because any existing Python program may be using different tools and they have different interpretations. And so if you adopt somebody's package into your ecosystem, try to run the tool you prefer, it may throw out tons of weird errors and warnings and problems just because it's incompatible with how these things work. Also because they're added late and they're not checked by a Python interpreter, it's always kind of more of a hint than it is a requirement. Also, the CPython implementation can't use them for performance, and so it's really
that's the big one, right? So you can't utilize for the compilation, for the just-in-time compilation.
Yep, exactly. And this all comes back to the design principle of they're kind of hints. They're kind of, the definition's a little bit murky. It's unclear exactly the interpretation in a bunch of cases, and so because of that, you can't actually
fucking brilliant.
Even if you want to, it's really difficult to use them to say like it is going to be an int, and if it's not, it's a problem, right? A lot of code would break if you did that. So in Mojo, right, so you can still use those kind of type annotations, it's fine, but in Mojo, if you declare a type and you use it, then it means it is going to be that type, and the compiler helps you check that and enforce it, and it's safe, and it's not a like best effort hint kind of a thing.
So if you try to shove a string type thing into an integer,
you get an error
from the compiler compile time.
Fuck.
Nice. Okay, what kind of basic types are there?
Yeah, so Mojo is pretty hardcore in terms of what it tries to do in the language, which is the philosophy there is that we, again, if you look at Python, right, Python's a beautiful language because it's so extensible, right? And so all of the different things in Python, like for loops and plus and like all these things, can be accessed through these underbar methods. Okay, so you have to say, okay, if I make something that is super fast, I can go all the way down to the metal. Why do I need to have integers built into the language? And so what Mojo does is it says, okay, well, we can have this notion of structs. So we have classes in Python. Now you can have structs. Classes are dynamic. Structs are static. Cool. We can get high performance. We can write C++ kind of code with structs if you want. These things mix and work beautifully together. But what that means is that you can go and implement strings and ints and floats and arrays and all that kind of stuff in the language, right? And so that's really cool because to me as a idealizing compiler language type of person, what I want to do is I want to get magic out of the compiler and put it in the libraries. Because if somebody can, if we can build an integer that's beautiful and it has an amazing API and it does all the things you'd expect an integer to do, if you don't like it, maybe you want a big integer, maybe you want a like sideways integer, I don't know, like what all the space of the integers are, then you can do that and it's not a second class citizen. And so if you look at certain other languages, like C++, one I also love and use a lot, int is hard-coded language, but complex is not. And so isn't it kind of weird that you have this std complex class, but you have int, and complex tries to look like a natural numeric type and things like this, but integers and floating point have these like special promotion rules and other things like that that are magic and they're packed into the compiler. Because of that, you can't actually make something that works like the built intended.
Is there something provided as a standard? Because because it's AI first, numerical types are so important here. So is there something like a nice standard implementation of integer and float?
Yeah, so we're still building all this stuff out. So we provide integers and floats and all that kind of stuff. We also provide like buffers and tensors and things like that you'd expect in an ML context. Honestly, we need to keep designing and redesigning and working with the community to build that out and make that better. That's not our strength right now. Give us 6 months or a year, and I think it'll be way better. But the power of putting it in the library means we can have teams of experts that aren't compiler engineers that can help us design and refine and drive this forward.
So one of the exciting things we should mention here is that this is new and fresh. This cake is unbaked. It's almost baked. You can tell it's delicious, but it's not fully ready to be consumed.
Yep, that's very fair. It is very useful, but it's very useful if you're a super low-level programmer right now. And what we're doing is we're working our way up the stack. And so the way I would look at Mojo today in May in 2023 is that it's like a 0.1. So I think that a year from now, it's going to be way more interesting to a variety of people. But what we're doing is we decided to release it early so that people can get access to it and play with it, and we can build it with the community. We have a big roadmap, fully published, being transparent about this, and a lot of people are involved in this stuff. And so what we're doing is we're really optimizing for building this thing the right way. And building it the right way is kind of interesting working with the community because everybody wants it yesterday. And so it's sometimes it's kind of, there's some dynamics there. But
yeah,
I think it's the right thing.
So there's a Discord also, so the dynamics is pretty interesting. Sometimes the community probably can be very chaotic and introduce a lot of stress. Guido famously quit over the stress of the walrus operator. I mean, that broke. Maybe that was broke the camel's back. Exactly. And so, like, it could be very stressful to develop. Can you just tangent upon a tangent? Is it stressful to work through the design of various features here, given that the community is so loosely involved?
Also, so I've been doing open development and community stuff for decades now. Somehow this has happened to me. So I've learned some tricks. But the thing that always gets me is I want to make people happy, right? And so this is maybe not all people all happy all the time, but generally I want people to be happy, right? And so the challenge is that, again, we're tapping into some deep-seated long tensions and pressures, both in the Python world, but also in the AI world, in the hardware world, and things like this. And so people just want us to move faster. And so, again, our decision was, let's release this early. Let's get people used to it or access to it and play with it, and let's build in the open, which we could have, had the language monk sitting in the cloister up on the hilltop, beavering away trying to build something. But in my experience, you get something that's way better if you work with the community. And so, yes, it can be frustrating, it can be challenging for lots of people involved. And if you mentioned our Discord, we have over 10,000 people on the Discord, 11,000 people or something. Keep in mind, we released Mojo 2 weeks ago. Yeah. So it's very cool. But what that means is that 10, 11,000 people all will want something different, right? And so what we've done is we've tried to say, okay, cool, here's our roadmap. Here, and the roadmap isn't completely arbitrary. It's based on, here's the logical order in which to build these features or add these capabilities and things like that. And what we've done is we've spun really fast on like bug fixes. So we actually have very few bugs, which is cool. I mean, actually for a project in the state, but then what we're doing is we're dropping in features very deliberately.
I mean, this is fun to watch because you got the two gigantic communities of like hardware, like systems engineers, and then you have the machine learning Python people that are like higher level.
Yeah.
And it's just two like army, like
they've been at war. Yeah, they've been at war, right? And so here's
like
the
a Tolkien novel or something. Okay.
Well, so here's the test. Again, like it's super funny for something that's only been out for
Son
2
of a
weeks,
bitch.
right? People are so impatient, right? But okay, cool. Let's fast forward a year. Like in a year's time, Mojo will be actually quite amazing and solve tons of problems. Will be very good. People still have these problems, right? And so you look at this and you say, and the way I look at this at least is to say, okay, well, we're solving big, long-standing problems. To me, again, working on many different problems, I want to make sure we do it right. Right? There's like a responsibility you feel because if you mess it up, right, there's very few opportunities to do projects like this and have them really have impact on the world. If we do it right, then maybe we can take those feuding armies and actually heal some of those wounds.
Yeah, this
Right?
is like this feels like a speech by George Washington or Abraham Lincoln or something.
And you look at this and it's like, okay, well, how different are we?
Yeah.
We all want beautiful things. We all want something that's nice. We all want to be able to work together. We all want our stuff to be used, right? And so if we can help heal that. Now, I'm not optimistic that all people will use Mojo and they'll stop using C++. Like, that's not my goal, right? But if we can heal some of that, I think that'd be pretty cool.
And we start by putting people like braces.
So there are proposals for adding braces to Mojo. We tell them no.
Okay. Politely. Yeah, anyway, so there's a lot of initiatives on the roadmap and those already implemented. It'd be awesome if I could just ask you a few things.
Yeah,
so,
go for it.
So the other performance improvement comes from immutability. So what's this bar and this thing that we got going on?
Well, so
what's immutability?
Yeah, so one of the things that is useful, and it's not always required, but useful, is knowing whether something can change out from underneath you. So in Python, you have a pointer to an array, right? And so you pass that pointer to an array around to things. You pass into a function, maybe take that and scroll it away in some other data structure. So you get your array back and you go to use it. Now somebody else is like putting stuff in your array. How do you reason about that? It gets to be very complicated and leads to lots of bugs. Right? And so one of the things that, again, this is not something Mojo forces on you, but something Mojo enables is a thing called value semantics. And what value semantics do is they take collections like arrays, like dictionaries, tensors and strings and things like this that are much higher level and make them behave like proper values. And so it makes it look like if you pass these things around, you get a logical copy of all the data. If I pass you an array, it's your array. You can go do what you want to do. You're not going to hurt my array. Now, that is an interesting and very powerful design principle. It defines away a ton of bugs. You have to be careful to implement it in an efficient way.
Is there a performance hit that's significant?
Generally not, if you implement it the right way, but it requires a lot of very low-level getting the language right bits.
I assume that'd be a huge performance hit because it's a really the benefit is really nice because you don't get into it.
Absolutely. Well, the trick is you can't do copies, so you have to provide the behavior of copying without doing the copy.
Yeah, how do you do that? How do you do that?
It's not magic. It's actually pretty cool. Well, so first, before we talk about how that works, let's talk about how it works in Python. Right? So in Python, you define a person class, or maybe person class is a bad idea. You define a database class, right? And a database class has an array of records, something like that, right? And so the problem is that if you pass in a record or a class instance into a database, it'll take hold of that object, and then it assumes it has it. And if you're passing an object in, you have to know that that database is going to take it, and therefore you shouldn't change it after you put it in the database, right? This is
just kind of have to know that.
You just have to kind of know that, right? And so you roll out version 1 of the database, you just kind of have to know that. Of course, Lex uses his own database, right? Yeah. Right? Because you built it. You understand how this works, right? Somebody else joins the team. They don't know this, right? And so now they suddenly get bugs. You're having to maintain the database. You shake your fist. You argue. the 10th time this happens, you're like, okay, we have to do something different, right? And so what you do is you go change your Python code, and you change your database class to copy the record every time you add it. And so what ends up happening is you say, okay, I will do what's called a defensive copy inside the database. And then that way, if somebody passes something in, I will have my own copy of it, and they can go do whatever, and they're not going to break my thing. Okay, this is usually the two design patterns. If you look in PyTorch, for example, this is cloning a tensor. There's a specific thing, and you have to know where to call it, and you have to call in the right place, you get bugs, and this is state of the art, right? So a different approach, so it's used in many languages, so I've worked with it in Swift, is you say, okay, well, let's provide value semantics. So we want to provide the view that you get a logically independent copy, but we want to do that lazily. And so what we do is we say, okay, if you pass something into a function, it doesn't actually make a copy. What it actually does is it just increments a reference to it. And if you pass it around, you stick it in your database, you can go in the database, you own it, and then you come back out of the stack, nobody's copied anything, you come back out of the stack, and then the caller lets go of it. Well, then you've just handed it off to the database, you've transferred it, and there's no copies made. Now, on the other hand, if your coworker goes and hands you a record and you pass it in, you stick it in the database, and then you go to town and you start modifying it, what happens is you get a copy lazily on demand. And so what this does is gives you copies only when you need them, and it also so it defines away the bugs, but it also generally reduces the number of copies in practice. And so
But the implementation details are tricky here.
Yeah. So this is
something with reference counting, but to make it performant across a number of different kinds of objects.
Yeah, well, so you need a couple of things. And so there's many. So this concept has existed in many different worlds, and so it's not novel research at all, right? The magic is getting the design right so that you can do this in a reasonable way, right? And so there's a number of components that go into this. One is when you're passing around. So we're talking about Python and reference counting at the expense of doing that. When you're passing values around, you don't want to do extra reference counting for no good reason, and so you have to make sure that you're efficient and you transfer ownership instead of duplicating references and things like that, which is a very low-level problem. You also have to adopt this, and you have to build these data structures. So you say, Mojo has to be compatible with Python, so of course the default list is a reference semantic list. It works the way you'd expect in Python, but then you have to design a value semantic list. So you just have to implement that, and then you implement the logic within. And so the language here is to provide all those low-level hooks that allow the author of the type to be able to express this behavior without forcing it into all cases or hard-coding this into the language itself.
But there's ownership, so you're constantly transferring, you're tracking who owns this thing.
Yes. So there's a whole system called ownership, and so this is related to work done in the Rust community. Also, the Swift community has done a bunch of work, and there's a bunch of different other languages that have all kind of. C++ actually has copy constructors and destructors and things like that, and so, C++ has everything. So it has move constructors and has like this whole world of things, and so this is a body of work that's kind of been developing for many, many years now. And so Mojo takes some of the best ideas out of all these systems and remixes it in a nice way, so that you get the power of something like the Rust programming language, but you don't have to deal with it when you don't want to, which is a major thing in terms of teaching and learning and being able to use and scale these systems.
How does that play with argument conventions? What are they? Why are they important? How does the value semantics, how does the transfer ownership work with the arguments when they're passing to
functions? So if you go deep into systems programming land, this isn't, again, it's not something for everybody, but if you go deep into systems programming land, what you encounter is you encounter these types that get weird. So if you're used to Python, you think about everything, I can just copy it around, I can go change it and mutate it and do these things, and it's all cool. If you get into systems programming land, you get into these things like I have an atomic number, or I have a mutex, or I have a uniquely owned database handle, things like that, right? So these types you can't necessarily copy. Sometimes you can't necessarily even move them to a different address. And so what Mojo allows you to do is it allows you to express, hey, I don't want to get a copy of this thing. I want to actually just get a reference to it. And by doing that, what you can say, okay, if I'm defining something weird, like a atomic number,
This is so athletic.
So an atomic number is an area in memory that multiple threads can access at a time without without locks.
Yeah, you never seen a
Right.
pimp
So,
like this.
And so, like, the definition of an atomic number is multiple different things have to be broken. Therefore, they have to agree on where it is. Right? And so you can't just like move it out from underneath one because it kind of breaks what it means. And so that's an example of a type that you can't copy, you can't move. It, like, once you create it, it has to be where it was. Right? Now, if you look at many other examples, like a database handle, right? So, okay, well, what happens? How do you copy a database handle? Do you copy the whole database? That's not something you necessarily want to do. There's a lot of types like that
Oh,
where you want to
motherfuckers.
be able to say that they are uniquely owned. So there's always
Where's the
one
thing?
of this thing, or if I create a thing, I don't copy it. And so what Mojo allows you to do is it allows you to say, hey, I want to pass around a reference to this thing without copying it.
Oh, man.
And so
Can't wait to learn
borrowed conventions.
about aliens.
You can use it, but you don't get to change it. You can pass it by mutable reference. And so if you do that, then you get a reference to it, but you can change it. And so it manages all that kind of stuff.
So it's just a really nice implementation of like C++ has, the reference kinds of pointers.
Yeah,
Smart, different kinds of implementations of smart pointers that you can explicitly define this allows. But you're saying that's more like the weird case versus the common case.
Well, it depends on where. I mean, I don't think I'm a normal person, so
Yes.
I mean, I'm not one to call other people weird.
Yeah.
But if you talk to a typical Python programmer, you're typically not thinking about this, right? This is a lower level of abstraction. Now, if you talk to a C++ programmer, certainly if you talk to a Rust programmer, again, they're not weird, they're delightful. Like these are all good people, right? Those folks will think about all the time, right? And so I look at this as there's a spectrum between very deep, low-level systems. I'm going to go poke the bits and care about how they're laid out in memory, all the way up to application and scripting and other things like this. And so it's not that anybody's right or wrong. It's about how do we build one system that scales.
By the way, the idea of
Maybe I'm gonna start you.
Number has been something that always brought me deep happiness, because the flip side of that, the idea that threads can just modify stuff asynchronously. Just the whole idea of concurrent programming is a source of infinite stress for me.
Well, so this is where you jump into, again, you zoom out and get out of programming languages or compilers and just look what the industry has done. My mind is constantly blown by this, right? And you look at what, Moore's Law. Moore's Law is this idea that like computers for a long time, single thread performance just got faster and faster and faster and faster for free. But then physics and other things intervened, and power consumption, like other things started to matter. And so what ended up happening is we went from single core computers to multi-core. Then we went to accelerators. Right? And this trend towards specialization of hardware is only going to continue. And so for years, us programming language nerds and compiler people have been saying, okay, well, how do we tackle multi-core? Right? For a while, it was like, multi-core is the future. We have to get on top of this thing. And then it was, multi-core is the default. What are we doing with this thing? And then it's like, there's hundreds of cores in them. what happened, right? Yeah. And so I'm super inspired by the fact that, in the face of this, those machine learning people invented this idea of a tensor. Right? And what is a tensor? A tensor is an arithmetic and algebraic concept. It's like an abstraction around a gigantic parallelizable data set, right? And because of that, and because of things like TensorFlow and PyTorch, we're able to say, okay, we'll express the math of the system. This enables you to do automatic differentiation. This enables you to do like all these cool things. And it's an abstract representation. And because you have that abstract representation, you can now map it onto these parallel machines without having to control, okay, put that by here, put that by there, put that by there. And this has enabled an explosion in terms of AI, compute, accelerators, like all this stuff. And so that's super, super exciting.
What about the deployment and the execution across multiple machines? Yeah. So you write that the modular compute platform dynamically partitions models with billions of parameters and distributes their execution across multiple machines, enabling unparalleled efficiency. By the way, the use of unparalleled in that sentence. Anyway, enabling unparalleled efficiency, scale, and reliability for the largest workloads. So how do you do this abstraction of distributed deployment of one?
Yeah, so one of the really interesting tensions, so there's a whole bunch of stuff that goes into that. I'll pick a random walkthrough. If you go back and replay the history of machine learning, the brief most recent history of machine learning, because this is, as you know, very deep. I knew Lex when he had an AI podcast. Right, yeah. So if you look at just TensorFlow and PyTorch, which is pretty recent history in the big picture, right? But TensorFlow is all about graphs. PyTorch, I think, pretty unarguably ended up winning. And why did it win? Mostly because of usability, right? And the usability of PyTorch is, I think, huge. And I think, again, that's a huge testament to the power of taking abstract, theoretical, technical concepts and bringing it to the masses, right? Now, the challenge with what the TensorFlow versus PyTorch design points was that TensorFlow is kind of difficult to use for researchers, but it was actually pretty good for deployment. PyTorch is really good for researchers. It kind of not super great for deployment, right? And so I think that we as an industry have been struggling. And if you look at what deploying a machine learning model today means, is that you'll have researchers who are, wicked smart, of course, but they're wicked smart at model architecture and data and calculus, and they're wicked smart in various domains. They don't want to know anything about the hardware or deployment or C++ or things like that, right? And so what's happened is you get people who train the model, they throw it over the fence, and then you have people that try to deploy the model. Well, every time you have a team A does X, they throw it over the fence, and team Y does something. Team B does Y, like you have a problem, because of course it never works the first time. And so you throw it over the fence, they figure out, okay, it's too slow, won't fit, doesn't use the right operator, the tool crashes, whatever the problem is, then they have to throw it back over the fence. And every time you throw a thing over a fence, it takes 3 weeks of project managers and meetings and things like this. And so what we've seen today is that getting models in production can take weeks or months. It's not atypical. I talk to lots of people, and you talk about like VP of software at some internet company trying to deploy a model, and they're like, why do I need a team of 45 people? It's so easy to train a model. Why can't I deploy it, right? And if you dig into this, every layer is problematic. So if you look at the language piece, this is tip of the iceberg. It's a very exciting tip of the iceberg for folks, but you've got Python on one side and C++ on the other side. Python doesn't really deploy. Can theoretically, technically in some cases, but often a lot of production teams will want to get things out of Python because they get their performance and control and whatever else. So Mojo can help with that. If you look at serving, we talk about gigantic models. Well, a gigantic model won't fit on one machine, right? And so now you have this model. It's written in Python. It has to be rewritten in C++. Now it also has to be carved up so that half of it runs on one machine, half of it runs on another machine, or maybe it runs on 10 machines. Well, so now suddenly the complexity is exploding, right? And the reason for this is that if you look into TensorFlow, PyTorch, these systems, they weren't really designed for this world, right? They were designed for, back in the day when we were starting and doing things, where it was a different, much simpler world. You want to run ResNet 50 or some ancient model architecture like this. It was a completely different world.
Trained on one GPU.
Exactly.
Doing
AlexNet. Yeah, AlexNet, right? The major breakthrough. And the world has changed, right? And so now the challenge is that TensorFlow, PyTorch, these systems, they weren't actually designed for LLMs. Like that was not a thing. And so where TensorFlow actually has amazing power in terms of scale and deployment and things like that. And I think Google is, maybe not unmatched, but they're like incredible in terms of their capabilities and gigantic scale. Many researchers using PyTorch, right? And so PyTorch doesn't have those same capabilities. And so what Modular can do is it can help with that. Now, if you take a step back and say, like, what is Modular doing? Right? So Modular has like a bitter enemy that we're fighting against in the industry. And it's one of these things where everybody knows it, but nobody is usually willing to talk about it.
The bitter enemy.
The bitter thing that we have to destroy, that we're all struggling with, and it's like all around, it's like fish can't see water, is complexity.
Yes. Complexity.
Right.
That was very close off of you. Very
So-
sad.
And so if you look at it, yes, it is on the hardware side.
Yes.
All these accelerators, all these software stacks that go with the accelerator, all these, like, there's massive complexity over there. You look at what's happening on the modeling side, massive amount of complexity. Like, things are changing all the time. People are inventing. Turns out the research is not done, right? And so people want to be able to move fast. Transformers are amazing, but there's a ton of diversity even within transformers. And what's the next transformer, right? And you look into serving, also huge amounts of complexity. It turns out that all the cloud providers, right, have all their very weird but very cool hardware for networking, all this kind of stuff, and it's all very complicated. People aren't using it. If you look at classical serving, right? So there's this whole world of people who know how to write high-performance servers with zero copy, all this fancy asynchronous I/O and
for
all
a
these
while.
fancy things. And
Maybe
serving
long
community.
if you.
Very little that has pervaded into the machine learning world, right? And why is that? Well, it's because, again, these systems have been built up over many years. They haven't been rethought. There hasn't been a first principles approach to this. And so what Modular's doing is we've built many of these things, right? So I've worked on TensorFlow and TPUs and things like that. Other folks on our team worked on PyTorch Core. We've worked on Onyx Runtime. We've worked on many of these other systems. And so built systems like the Apple accelerators and all that kind of stuff. Like, our team is quite amazing. And so one of the things that roughly everybody at Modular is grumpy about is that when you're working on one of these projects, you have a first order goal. Get the hardware to work. Get the system to enable one more model. Get this product out the door. Enable the specific workload, or make it solve this problem for this product team, right? And nobody's been given a chance to actually do that step back. And so we as an industry, we didn't take 2 steps forward. We took like 18 steps forward in terms of all this really cool technology across compilers and systems and runtimes and heterogeneous compute, like all this kind of stuff. And like all this technology has been, I wouldn't say beautifully designed, but it's been proven in different quadrants. You look at Google with GPUs, massive, huge exaflops of compute strapped together into machines that researchers are programming in Python in a notebook. That's huge. That's amazing. Right? It's incredible. And so you look at the technology that goes into that, and the algorithms are actually quite general. And so lots of other hardware out there and lots of other teams out there don't have the sophistication or maybe the years working on it or the budget or whatever that Google does, right? And so they should be getting access to the same algorithms, but they just don't have them. Right? That's what Modular's doing. So we're saying, cool, this is not researching. Like we've built auto tuning in many systems. We've built programming languages, right? And so like have implemented C++, have implemented Swift, have implemented many of these things. And so it's hard, but it's not research. And you look at accelerators. Well, we know there's a bunch of different weird kinds of accelerators, but they actually cluster together. Right? And you look at GPUs. Well, there's a couple of major vendors of GPUs, and they maybe don't always get along, but their architectures are very similar. You look at CPUs. CPUs are still super important for the deployment side of things. You see new architectures coming out from all the cloud providers and things like this, and they're all super important to the world, right? But they don't have the 30 years of development that the entrenched people do, right? And so what Modular can do is we're saying, okay, all this complexity, like it's not bad complexity, it's actually innovation, right? And so it's innovation that's happening, and it's for good reasons, but I have sympathy for the poor software people, right? I mean, again, I'm a generally software person too. I love hardware, but software people want to build applications and products and solutions that scale over many years. They don't want to build a solution for one generation of hardware with one vendor's tools. And because of this, they need something that scales with them. They need something that works on cloud and mobile, right? Because their product manager said, "Hey, I want it to have lower latency and better for personalization," or whatever they decide, right? Products evolve, and so the challenge with the machine learning technology and the infrastructure we have today in the industry is that it's all these point solutions. And because there are all these point solutions, it means that as your product evolves, you have to switch different technology stacks or switch to a different vendor. And what that does is that slows down progress.
So basically, a lot of the things we've developed in those little silos for machine learning tasks you want to make that the first-class citizen of a general-purpose programming language that can then be compiled across all these kinds of hardware.
Well, so it's not really about a programming language. I mean, programming language is a component of the mission, right? And the mission is, our not literal, but our joking mission is to save the world from terrible AI software.
Excellent.
Okay. So if you look at this mission, you need a syntax. So yes, you need programming, right? And like we wouldn't have to build the programming language if one existed, right? So if Python was already good enough, then cool, we would just used it. Right? We're not just doing very large scale, expensive engineering projects for the sake of it. Like it's to solve a problem, right? It's also about accelerators. It's also about exotic numerics and bfloat16 and matrix multiplications and convolutions and like this kind of stuff. Within the stack, there are things like kernel fusion. It's an esoteric but really important thing that leads to much better performance and much more general research hackability together. Right?
And that's enabled by the ASICs. That's enabled by certain hardware. So it's like, where's the dance between? There's several questions here. Like, how do you add a piece of hardware to the stack?
Yeah.
If you need a piece of, like, if I have this genius invention of a specialized accelerator, how do I add that to the modular framework? And also, how does modular as a standard start to define the kind of hardware that should be developed?
Yeah. So let me take a step back and talk about status quo. Okay.
Right.
And so if you go back to TensorFlow 1, PyTorch 1, this kind of time frame, and these have all evolved and gotten way more complicated. So let's go back to the glorious simple days, right? These things basically were CPUs and CUDA. And so what you do is you say, go do a dense layer, and a dense layer has a matrix multiplication in it, right? And so when you say that, you say, go do this big operation, matrix multiplication, and if it's on a GPU, kick off a CUDA kernel. If it's on a CPU, go do like an Intel algorithm or something like that with the Intel MKL. Okay. Now, that's really cool if you're either NVIDIA or Intel, right? But then more hardware comes in, right? And on one axis, you have more hardware coming in. On the other hand, you have an explosion of innovation in AI. And so what happened with both TensorFlow and PyTorch is that the explosion of innovation in AI has led to, it's not just about matrix multiplication and convolution. These things have now like 2,000 different operators. And on the other hand, you have, I don't know how many pieces of hardware there are out there. It's a lot. Okay, it's not even hundreds. It's probably thousands. Okay, and across all of Edge and across like all the different things
that are used at scale.
Yeah, exactly. I mean,
also, it's not just like
AI is everywhere. Yeah,
it's not a handful of GPU alternatives.
Correct.
It's
every phone, often with many different chips inside of it from different vendors. From like it's. AI is everywhere. It's a thing, right?
Why are they all making their own chips? Like, why is everybody making their own thing?
So because
is that a good thing? First of all,
so Chris's philosophy on hardware,
yeah,
right. So my philosophy is that there isn't one right solution, right? And so I think that again, we're at the end of Moore's law. Specialization happens.
Yeah.
If you're training GPT-5, you want some crazy supercomputer data center thingy. If you're making a smart camera that runs on batteries, you want something that looks very different. If you're building a phone, you want something that looks very different. If you have something like a laptop, you want something that looks maybe similar but a different scale, right? And so AI ends up touching all of our lives, robotics, right? And like lots of different things. And so as you look into this, these have different power envelopes. There's different trade-offs in terms of the algorithms. There's new innovations in sparsity and other data formats and things like that. And so hardware innovation, I think, is a really good thing. Right? And what I'm interested in is unlocking that innovation. There's also like analog and quantum and like all the really weird stuff, right? And so if somebody can come up with a chip that uses analog computing and it's 100x more power efficient, think what that would mean in terms of the daily impact on the products we use. That'd be huge. Now, if you're building an analog computer, you may not be a compiler specialist. Right? These are different skill sets, right? And so you can hire some compiler people if you're running a big company, maybe. But it turns out these are really like exotic new generation of compilers. Like this is a different thing, right? And so if you take a step back out and come back to what is the status quo? The status quo is that if you're Intel or you're NVIDIA, you keep up with the industry and you chase and okay, there's 1900 now, there's 2000 now, there's 2100, and you have a huge team of people that are like trying to keep up and tune and optimize. And even when one of the big guys comes out with a new generation of their chip, they have to go back and rewrite all these things, right? So really powered by having hundreds of people that are all like frantically trying to keep up. And what that does is that keeps out the little guys. And sometimes the not so little guys, the big guys are also just not in those dominant positions. And so what has been happening, and so a lot of, you talk about the rise of new exotic crazy accelerators, people have been trying to turn this from a let's go write lots of special kernels problem into a compiler problem. And so we, and I contributed to this as well, we as an industry went into it like, let's go make this compiler problem phase, let's call it. And much of the industry is still in this phase, by the way, so I wouldn't say this phase is over. And so the idea is to say, look, okay, what a compiler does is it provides a much more general, extensible, hackable interface for dealing with the general case, right? And so within machine learning algorithms, for example, people figured out that, hey, if I do a matrix multiplication and I do a ReLU, right, the classic activation function, it is way faster to do one pass over the data and then do the ReLU on the output where I'm writing out the data. Because ReLU is just a maximum operation, right? Maximum zero. And so it's an amazing optimization. Take matmul, ReLU, squish together in one operation. Now we have matmul ReLU. Well, wait a second. If I do that, now I just went from having 2 operations to 3. But now I figure out, okay, well, there's a lot of activation functions. Wiki ReLU, like a million things that are out there, right? And so as I start fusing these in, now I get permutations of all these algorithms. Right, and so what the compiler people said is they said, hey, well, cool, well, I will go enumerate all the algorithms, and I will enumerate all the pairs, and I will actually generate a kernel for you. And I think that this has been very, very useful for the industry. This is one of the things that powers Google GPUs. PyTorch 2's like rolling out really cool compiler stuff, like Triton, this other technology and things like this. And so the compiler people are kind of coming into their fore and saying like, awesome, this is a compiler problem, we'll compiler it. Here's the problem. Not everybody's a compiler person. I love compiler people, trust me, right? But not everybody can or should be a compiler person. It turns out that there are people that know analog computers really well. So they know some GPU internal architecture thing really well, or they know some crazy sparse numeric interesting algorithm that is the cusp of research, but they're not compiler people. And so one of the challenges with this new wave of technology trying to turn everything into compiler is, again, it's excluded a ton of people. And so you look at what does Mojo do? What does the modular stack do? This brings programmability back into this world. Like it enables, I wouldn't say normal people, but like a new, a different kind of delightful nerd that cares about numerics or cares about hardware or cares about things like this to be able to express that in the stack and extend the stack without having to actually go hack the compiler itself.
To extend the stack on the algorithm side, then on the hardware side.
Yeah. So again, go back to like the simplest example of int, right? And so what both Swift and Mojo and other things like this did is we said, okay, pull magic out of the compiler and put it in the standard library. Right? And so what Modular is doing with the engine that we're providing and like this very deep technology stack, right, which goes into heterogeneous runtimes and like a whole bunch of really cool things. This whole stack allows that stack to be extended and hacked and changed by researchers and by hardware innovators and by people who know things that we don't know. Because, Modular has some smart people, but we don't have all the smart people, it turns out.
What are heterogeneous runtimes?
Yeah, so what is heterogeneous, right? So heterogeneous just means many different kinds of things together. And so the simplest example you might come up with is a CPU and a GPU. And so it's a simple heterogeneous computer to say, I will run my data loading and pre-processing and other algorithms on the CPU. And then once I get it into the right shape, I shove it into the GPU. I do a lot of matrix multiplications and convolutions and things like this. And I get it back out and I do some reductions and summaries and I shove it across the wire across the network to another machine. And so you've got now what are effectively two computers, a CPU and a GPU, talking to each other, working together in a heterogeneous system. But that was okay. You look at like the modern cell phone. You've got CPUs and they're not just CPUs. There's like big dot little CPUs, and so there's multiple different kinds of CPUs that are kind of working together. They're multi-core. You've got GPUs. You've got neural network accelerators. You've got dedicated hardware blocks for media, so for video decode and JPEG decode and things like this. And so you've got this massively complicated system. This isn't just cell phones. Every laptop these days is doing the same thing. And all of these blocks can run at the same time and need to be choreographed, right? And so, again, one of the cool things about machine learning is it's moving things like data flow graphs and higher level abstractions and tensors and these things that it doesn't specify, here's how to do the algorithm. It gives the system a lot more flexibility in terms of how to translate or map it or compile it onto the system you have. And so what you need, the bottomest part of the layer there is a way for all these devices to talk to each other. And so this is one thing that I'm very passionate about. I'm a nerd, but all these machines and all these systems are effectively parallel computers running at the same time, sending messages to each other. And so they're all fully asynchronous. Well, this is actually a small version of the same problem you have in a data center. Right? In a data center, you now have multiple different machines, sometimes very specialized, sometimes with GPUs or TPUs in one node, and sometimes with disks in another node. And so you get a much larger scale heterogeneous computer. And so what ends up happening is you have this like multi-layer abstraction of hierarchical parallelism, hierarchical asynchronous communication, and making that, again, my enemy is complexity. By getting that away from being different specialized systems at every different part of the stack and having more consistency and uniformity, I think we can help lift the world and make it much simpler and actually get used.
But how do you leverage the strengths of the different specialized systems? So looking inside the smartphone, like there's what, I don't know, 5-6 computers essentially inside the smartphone. How do you, without trying to minimize the explicit, making it explicit which computer is supposed to be used for which operation?
Yeah, so there's a pretty well-known algorithm, and what you're doing is you're looking at two factors. You're looking at the factor of sending data from one thing to another, right? So it takes time to get it from that side of the chip to that side of the chip, and things like this. And then you're looking at what is the time it takes to do an operation on a particular block. So take CPUs. CPUs are fully general. They can do anything, right? But then you have a neural net accelerator that's really good at matrix multiplication. Okay? And so you say, okay, well, if my workload is all matrix multiplications, I start up, I send the data over to the neural net thing, it goes and does matrix multiplications. When it's done, it sends me back the result. All is good, right? And so the simplest thing is just saying, do matrix operations over there. Right? But then you realize you get a little bit more complicated because you can do matrix multiplications on a GPU, you can do it on a neural net accelerator, you can do it on CPU, and they'll have different trade-offs and costs. And it's not just matrix multiplication. And so what you actually look at is I have generally a graph of compute. I want to do a partitioning. I want to look at the communication, the bisection bandwidth, and like the overhead and the sending of all these different things, and build a model for this, and then decide, okay, it's an optimization problem. Where do I want to place this compute?
It's the old school theoretical computer science problem, scheduling. And then how does, presumably it's possible to somehow magically include auto-tune into this?
Absolutely. So, I mean, in my opinion, this is an opinion. This is not everybody would agree with this, but in my opinion, the world benefits from simple and predictable systems at the bottom you can control. But then once you have a predictable execution layer, you can build lots of different policies on top of it. Right? And so
look at this move, kids.
The human programmer says, do that here, do that here, do that here, do that here, and like fully manually controls everything. And the system should just do it, right? Then you quickly get in the mode of like, I don't want to have to tell it to do it.
Yeah.
And so the next logical step that people typically take is they write some terrible heuristic. Oh, if it's a matrix multiplication, do it over there. Or if it's floating point, do it on the GPU.
Yo, dog.
CPU, like something like
this shit sucks.
And then you then get into this mode of like people care more and more and more, and you say, okay, well, let's actually like make the heuristic better.
Let's see if that bitch is working.
Let's actually do.
What are the odds?
Search of the space.
0%.
Decide, well, what is actually better?
Right.
Well, then you get into this problem where you realize this is not a small space.
Really.
It's a many-dimensional, hyperdimensional space that you cannot exhaust your search.
It's the worst.
Do you know of any algorithms that are good at searching very complicated spaces for
Don't tell me you're going to turn this into a machine learning
005.
problem.
So then you turn it into a machine learning problem, and then you have a space of algorithms.
Give me that
reinforcement
005.
all these good
Can
queries.
Oh,
include
fuck
that into
you.
the stack, into the
This
the
is
module stack?
oh, it's live.
Yeah.
Where does it sit? Where does it live? Is it a separate thing or is
We
it
live, pimp.
So you start from
Can you
simple
hear it?
models. And
Yo.
so you can have full control, and you can have
Can you
full
hear it?
screen knobs that like nudge the system so you don't have to do this. But if you really care about getting the best, last
Sucks.
out of the problem, then you can use additional tools. And there, the cool thing is you don't want to do
This
this. every
is
time
the
you run a
worst.
Model. You want to figure out the right answer and then cache it.
Says it's
And once you do
live.
that, you can say, okay, cool. Well, I can get up and running very quickly. I can get good execution out of my
worst.
system. I can decide if something's important, and if it's important, I can go through a bunch of machines at it and do a big exhaustive search over the space using whatever technique I feel like it's related to the problem. And then when I get the right answer, cool, I can just start using it.
I don't hear anything.
And so you can get out of this this trade-off between, okay, am I going to like spend forever doing a thing, or do I get up and running quickly and get a quality result? Like these are actually not in contention with each other if the system's designed to scale.
You started and did a little bit of a whirlwind overview of how you get 35,000x speed up or more over Python. Jeremy Howard did a really great presentation about sort of the basic. Like, look at the code. Here's how you get the speed up. Like you said, that's something you could probably developers can do for their own code to see how you can get this gigantic speed up. But can you maybe speak
this
around
thing
machine learning
sucks.
tasks in general? How do you make some of these
working
code fast and specifics? Like what would you say is the main bottleneck?
Is it frozen?
For machine learning tasks. So are we talking about matrix multiplication? How do you make that fast?
So I mean, if you just look at the Python problem.
Yo,
right,
what is
say,
this?
How do I make Python faster?
Do it times
There's been a
2.
lot of people that have been working on the
This is
okay, how to make Python 2x faster, 10x faster, or something
Yo.
like that. Right? And there's been a ton of projects in that vein, right? Mojo started from
There's no sound.
what can the hardware do? Like, what is the limit of physics? What is the speed of light?
Yo, is this even fucking
how fast can
working?
this thing go? And then how do I express that?
It's just
Right, and so it wasn't anchored relatively on
it's just the
make
worst.
Python a little bit faster. It's saying, cool, I know what the hardware can do. Let's unlock it. Right now, when you
Oh, it's doing that
It is
shitty
how-
thing.
How gutsy that is to be in the meeting and as opposed to trying to see how do we get the improvement. It's like what can the physics do?
I mean, maybe I'm a special kind of nerd, but you look at that, what is the limit of physics? How fast can these things go, right?
This
When you're
is the
looking at that,
worst.
Typically, it ends up being a memory call.
Close this
So
bitch.
today,
It's terrible.
particularly with these
Terrible.
accelerators, the
Cerebral.
problem is that you can do a lot of math within them, but you get bottleneck sending data back and forth to memory, whether it be local memory or distant memory or disk or whatever it is. And that
YouTubers.
particularly as the training sizes get large, as you start doing tons of inferences all over the place, like that becomes a huge bottleneck for people, right?
No way is this new.
So again, what happened is
Gonna shit
we went through a
myself.
phase of many years where people took the special case and hand tuned it, tweaked it and tricked it out, and they knew exactly how the hardware worked, and they knew the model, and they knew
Dog.
that. Didn't generalize.
It's called.
And so you can make, less than 50 or some. Or
Are you fucking serious?
Like you can do that.
This is
right?
the worst.
Small,
This is the
right?
worst.
But as the models get
Kids.
bigger, more complicated, as the machines get more complicated,
I've never known
stuff
anything
works,
worse.
right? And so this is where
This
things like kernel fusion.
just
So what is kernel fusion? This is this idea of saying, let's avoid
dog.
going to memory, and let's do that by building
This
a
shit
hybrid kernel
is the
a numerical
worst.
algorithm that actually keeps things in the accelerator instead of having to write it all the way out to memory.
Amy,
What's happened with these accelerators? now
what
you
you
can
want
level
to
them.
do?
In a GPU, for example, you'll have global memory, and local memory, and like all these things. If you zoom way into how hardware works, the register file is actually memory. So the registers are like an L0 cache. And so a lot of taking advantage of
Make
the
cash,
hardware
homie.
ends up being fully utilizing the full power in all this
Straight
capability.
cash, homie.
And this has a number of problems, right? One of which
Interaction
is,
required.
again, the complexity of disaster, right? There's too much hardware. Even if you just say, let's look at the chips from one line of
Straight
defense,
cash,
Apple,
homie.
Intel, or whatever it is.
This is the
Each
worst.
version of the chip comes out with new features.
Hey
They
everybody.
change things, so that it
Oh,
all
my
kind of
ass.
time to do different things. and you can't rewrite all the software.
Project Looking
whenever
Glass.
you change
Oh,
it. Right. So this is where you need a much
No.
more scalable approach.
if it's a sponsored
What
podcast,
Mojo and what the modular stack
that's the
provides
fucking
provides
difference.
this
When
infrastructure,
YouTube was
system,
just like, hey, put
factoring
whatever
all
the fuck
complexity,
you, whatever you want
and
on
allowing
it,
people to express
you
algorithms.
used to get people be like,
Auto-tuning,
oh
for
man,
example,
I
express
think
algorithms
X, Y,
in a
and Z.
more portable
Now
way,
it's like, oh, this
so that
isn't
when
fucking
new shit
sponsored
comes out,
content.
you don't
Fuck
have to
you.
rewrite it all. So to me, like, I kind of joke, like, what is compiler? There's many ways to explain that. Convert from
Hey,
thing A to
me,
thing B, and you
what
the
you
source code,
wanna
machine code. Like,
do?
you can talk about many
I
things that
find
compilers do.
God gets
But to me,
tired
it's about
you.
a bag of tricks. It's about a system and a framework.
Dog,
that can
it's
hang
called Project
complexity.
Looking Glass.
It's a
This
system
shit,
that can then generalize and it
you
can
can
work
look
on
into the
problems that are
future
bigger
with
than
it.
fit in one human's head.
It was wild.
Right? And so what that means, what a good stack and what the modular
It's
stack
called
provides is
Project
the
Looking
ability
Glass,
to
dog.
walk up to it with a new problem.
No.
And generally work quite well.
No.
That's something that a lot of machine learning infrastructure and tools and technologies don't have. Typical state of the art today is you walk up, particularly if you're deploying, if you walk up with a new model, you try to push it through the converter crashes.
This
It's
is,
crazy. The state
dude,
of
none of this shit
ML
is
tooling today,
good
it's
anymore.
not anything that a C programmer
YouTube
ever
sucks.
accepts, right? And it's always been this kind of flaky set of tooling that's never been integrated well, and it's been never worked together, and because it's not designed together. It's built by different teams. It's built by different hardware vendors. It's built by different systems. It's built by different internet companies that are trying to solve their problems, right? And so that means that we get this fragmented, terrible mess of complexity.
So, I mean, the specifics,
This
and Jeremy showed this. There's
is
the
the
vectorized version,
worst
which I guess is
shit I've
built
ever
into
seen.
into Mojo,
This
Vectorized
is
shows
the
built into the
worst
library.
into the library. It's their library.
shit I've ever
Vectorized,
seen.
parallelized.
Dog, why is this
Vectorized
shit
is more
just
low
like,
level,
oh, here's
parallelized
12
is
minutes
high
of it.
level.
I want
There's the
14
tiling
fucking
thing,
hour
which is how it's
playlists of
demonstrated
this
through
shit. It's the
auto-tune,
worst.
I think.
So
Oh,
think
you want a
about this
Project
in
Looking Glass?
levels, hierarchical
Psych.
levels of abstraction.
Oh,
Right, so
all anytime?
At the very, if you zoom
How
all the way
about
into
by
your problem, you
time?
have one
Oh,
floating
fuck
point.
you.
Right, and so then you say, okay,
Douche.
I can do things one at a time in an interpreter.
I wonder if
It's pretty slow.
Google
right?
has
So I can
better
get
shit.
to doing
Google's the
one at a
worst.
time in a compiler.
Sundar. Hey, Sundar.
When I can get to
It's
doing
called
4 or 8 or
Project
16 at a time
Project.
with vectors. That's called
Looking
vectorization. And you
Glass.
can say, hey, I have a whole bunch
Why?
of different.
Because I need to know who's going to win the
what a
fucking game.
multi-core computer is basically a bunch of computers. Right, so they're
A
all independent
COVID-19
computers
decision
that can talk
support
to each other and
platform?
they share memory. And so now what Parallelize does is
No,
okay, run
that's
multiple
not what I
instances
want.
on
I want
computers. And now they can all work together. Right. And so what you're doing is you're saying, keep going out
Dog.
to the next level out. And as you do that,
Search
how do I take
tools.
advantage of this? So tiling
Duration
a memory
20
optimization.
minutes.
Right. It says, okay, let's make sure that we're keeping the data close to the compute part of the problem instead of sending it all back and forth through
like
memory
this guy.
every time I load a block.
And size of the block size is all. That's how you get through the auto tune. So
Talk
Right.
to me, baby.
Yeah. Well, so all of these, the details matter so much to get the performance. This is
Ooh.
another funny thing about machine learning and high performance
Yeah,
computing
his sound
that is
sucks,
very
though.
different than C
I
compilers
don't
we
know.
all
What's
grew
this guy
up
doing?
with, where if you get a new version of GCC or a new version of Clang or
Heard
something
me.
like that, maybe something will go 1%
No.
faster.
This isn't going to work.
Right? And so
What's
compilers
up,
are
babies?
really, really, really hard to get 0.5% out of your C code, something like that. But when you're talking
Who
about
the fuck is
an
the fucking
accelerator
dog?
or
You gotta
application, or you're talking about
wrap me in.
these kinds of algorithms,
Carrie
these are
Cassidy.
things people used to write Fortran, for example, right? If you get it wrong,
I've
it's not 5%
I've had
or
things like
1%.
this
It can be
for
2x or
15
10x.
years.
Right? If you think about it, you really want to make use of the full memory you have. The cache,
Really?
for example.
I just think she's smart. She's one of the only women in
in
these subjects. Name another one. Linda Moulton Howe, who I've always thought is really hot.
So this is where getting these magic
She's
numbers
beautiful.
right is really actually
Really?
you
Yeah.
mentioned that Mojo is a superset of Python. Can you run Python code as if it's Mojo code?
Yes. Yes. So and this has She said, so Mojo's not done yet. So I'll give you the disclaimer. Mojo's not done yet. But already we see people that take small pieces of Python code, move it over, they don't change it, and you can get 12x speed. Somebody was just tweeting about that yesterday, which is pretty cool. Yeah. And again, interpreters compatible.
Yeah,
so without changing any code,
it's so old.
Also, this is not Git compiling or doing anything fancy. It's just basic.
It's just too old.
Mojo will continue to grow
not
out,
that it's
and as
not
it grows out,
cool.
it will have more and more features. And our North Star is to be a full superset of Python, and so you can bring over
Doesn't anyone
basically arbitrary Python code and have it just work.
English?
And it may not always be 12x
Damn
faster,
burst, dude. I could
but,
come over this
but it
shit.
should be at least as fast and way
If you had to have
faster.
sex with one person from ufology, who would it be?
Now, it'll take time to do that.
Bubbles.
Python is a
Well,
complicated
if it had to be a
language. Not
dude,
just the obvious things,
if it had to be a
also
chick, Linda Moulton Hall.
non-obvious things that are
Actually, Linda Moulton
like
Hall
Python
over everybody.
packages
More than
comments,
anyone?
API. There's a bunch of
I mean,
You
yeah,
have
I
to,
think she's pretty hot.
just to make explicit the obvious, and not be so obvious until you think about it. It's like, to run Python code, that means you have to run all the Python packages and libraries.
Yeah.
So that means what? What's the relationship?
If you had to have sex with a
between
dude,
Mojo and C Python?
Bubbles, right? Well, leave George now.
Presumably would be tasked with getting those packages to work.
Yep. So in the fullness of time,
But
Mojo
Bubbles
will
are.
solve for all the problems and you'll be able to move Python packages
Goes like
over.
Bubbles are.
Without the C Python.
Without C Python.
Damn version is
Someday.
sneaking there.
Not today, but someday. And that'll be
Anybody
a beautiful
else?
day because then you'll get a whole bunch of
George
advantages
Mason,
and you'll
yeah.
get massive speed ups and everything.
Oh,
You can do
John
that one at
Lear.
a time, right? You can move packages.
Exactly. But we're not literally
Maybe
waiting for
Bubbles
that.
are than John Lear.
Python is too important. The ecosystem's too broad. We want to
John Lear might
build
be top.
Mojo out. We also want to do it the right way.
I had to have
without
sex with a
like,
dude
without intense
who
time
was
pressure
also
or obviously
ufology.
moving fast. But
How about that
and so
guy
what
from
we do is
Blink
we say, okay,
182?
well, let's make it so you can import an arbitrary existing package.
I mean, if I had to have sex with him, yeah, I guess.
Including
I really have
writing
sex
your
with
own
chicks,
unreleased
though.
disk.
But
Whatever,
the
it's
fact
not-
that
it's not like the same thing, like,
if I had to have sex with a dude of any dude,
import
I would
packages
rather
using
have them be a ufologist.
See, Python already runs on packages, right? And so what we do is
Really?
we built an integration layer where we
Yeah,
can
because
actually
maybe they
use CPython
they know something that they plug them with.
to actually just load
Tell me
in
about
packages as they are.
J-Rod.
The downside of that is you don't get the benefits of Mojo. So they run as fast
Really?
as they do in the traditional CPython.
I try to get more information out of them.
What that does is that gives you an incremental migration.
Yeah, actually, does J-Rod count? I'd rather have sex with J-Rod than anybody. Even one Linda Moulton House.
But there's certain things that are really
Yep,
important.
J-Rod's
So
at the top.
weather forecasting or something. Well,
Only with his
I want to be
consent.
a little
Only with any of his
and
people's
I have my
consent.
own crazy algorithm inside of it.
Are you done?
Normally I'd write that in C++. But when I
Maybe.
Mojo have one system that scales. Well, that's
This is
way
the
easier to
worst.
work with.
Is it hard to do that to have that layer that's running C Python? Because is there some communication back and forth?
Yes, it's complicated. I mean, this is what we do. So, I mean, we make it look easy, but it is complicated. But what we do is we use the CPython existing interpreter. So it's running its own bytecodes, and that's how it provides full compatibility. And then it gives us CPython objects, and we use those objects as is. And so that way, we're fully compatible with all the CPython objects and all the it's not just the Python part; it's also the C packages. The C libraries underneath them, because they're often hybrid. And so we can fully run and we're fully compatible with all that. And the way we do that is that we have to play by the rules. Right? So
Actually,
we keep
Dr.
objects in that
Janet
representation
Rosen, I think
when
her
they're
name
coming from
is.
that rule.
What's the representation that's being used?
Anyway, Dr. Rosen, she could get it.
How the CPython interpreter
Maybe
works.
Linda Moulton House.
Has, for example, reference counting, but also different rules on how to pass pointers around and things like this. Super low
Carrie
level fidelity, and it's
Cassidy,
not
Janet
like
Rosen,
Python, it's
something
like
like
how the interpreter works. Okay, and so that gets all.
There are like
out.
no
Different
women my
brackets,
age
different
into
rules.
UFOs who are like public.
What this means is you have to know not only C, which is a different rule from Python, obviously, not only Python, but the interpreter and the wrappers and the implementation details and the conventions, and it's just this really complicated mess. And when you do that, now suddenly you have a debugger that debugs Python, you can't step into C code.
This is Carrie
So
Cassidy
you
as
have this
well.
two-world problem, right? And so by pulling this all into Mojo, what you get is you get one world. You get the ability to say, cool, I have untyped, very dynamic, beautiful, simple code. Okay, I care about performance for whatever reason, right? There's lots of reasons you might care. And so then you add types, parallelize things, you can vectorize things, you can use these techniques, which are general techniques to solve a problem, and then you can do that by staying in the system. And if you have that one Python package that's really important to you, you can move to Mojo, you get massive performance benefits on that, and other advantages. If you like static types, it's nice that they're enforced. Some people like that, right? Rather than being hints, so there's other advantages too. And then you can do that incrementally as you go.
So one different perspective on this would be why Mojo instead of making CPython faster, redesigning CPython?
Yeah. Well, I mean, you could argue Mojo is redesigning CPython, right? But why not make CPython faster and better and other things like that? There's lots of people working on it. So actually, there's a team at Microsoft that is really improving. I think CPython 3.11 came out in October or something like that, and it was 15% faster, 20% faster across the board, which is pretty huge given how mature Python is and things like this. So that's awesome. I love it. It doesn't run on GPU. It doesn't do AI stuff, doesn't do vectors, doesn't do things. 20% is good, 35,000 times better, right? So they're definitely. I'm a huge fan of that work, by the way, and it composes well with what we're doing, and so it's not like we're fighting or anything like that. It's actually just general. It's goodness for the world, but it's just a different path. Right? And again, we're not working forward from making Python a little bit better. We're working backwards from what is the limit of physics.
What's the process of porting Python code to Mojo? Is there what's involved in that? Process? Is there tooling for that?
Not yet. So we're missing some basic features right now, and so we're continuing to drop out new features on a weekly basis. But at the fullness of time,
I was then taken to the location where
is it an automatable process?
So when we're ready, it'll be very automated.
Give a short recitation.
Is it automatable? Is it possible to automate in the general case the Python to Mojo conversion?
Yeah.
Well, you're saying it's possible.
Well, and this is why. One of the reasons why we use tabs.
Yes.
Right. So first of all, by being a superset,
yeah.
It's like C versus C++. Can you move C code to C++? Yeah, right. And you can move C code to C++, and then you can adopt classes. You can adopt templates. You can adopt other references or whatever C++ features you want after you move C code to C++. You can't use templates in C, right? And so if you leave it as C, fine, you can't use the cool features, but it still works, right? And C and C++ could work together, and so that's the analogy, right? Now, here, right, there's not a Python is bad and then Mojo is good. Right? Mojo just gives you superpowers, right? And so if you want to stay with Python, that's cool. But the tooling should be actually very beautiful and simple because we're doing the hard work of defining a superset.
Right, so you're right. So there's several things to say there, but also the conversion tooling should probably give you hints as to how you can improve the code.
And then exactly. Once you're in the new world, then you can build all kinds of cool tools to say hey, you adopt this feature, or and we haven't built those tools yet, but I fully expect those tools will exist, and you can quote unquote modernize your code or however you want to look at it, right? So, one of the things that I think is really interesting about Mojo is that there have been a lot of projects to improve Python over the years. Everything from getting Python run on the Java virtual machine, PyPy, which is a JIT compiler. There's tons of these projects out there that have been working on improving Python in various ways. They fall into one or two camps. So PyPy is a great example of a camp that is trying to be compatible with Python. Even there, not really. It doesn't work well with C packages and stuff like that. But they're trying to be compatible with Python. There's also another category of these things where they're saying, well, Python is too complicated, and I'm going to cheat on the edges, and it's integers in Python can be an arbitrary size image. You care about going fast in a register in a computer. That's really annoying. Right? And so you can choose two paths. Right? You can say, well, people don't really use big integers that often, therefore I'm going to just not do it and it'll be fine.
No, I haven't.
Not a Python superset. Or you can do the hard thing and say, okay, this is Python. You can't be a superset of Python without being a superset of Python. And that's a really hard technical problem, but it's, in my opinion, worth it. Right? And it's worth it because it's not about any one package and stuff, it's ecosystem. It's about what Python means to the world. And it also means we don't want to repeat the Python 2 to Python 3 transition. Like we want people to be able to adopt this stuff quickly. And so by doing that work, we can help with people.
Yeah, the challenge, it's really interesting, technical philosophical challenge of really making a language a superset of another language. Breaking my brain a little bit.
Well, it paints you in the corners. So, again, I'm very happy with Python. And so, all joking aside, I think that the indentation thing is not the actual important part of the problem, right? But the fact that Python has amazing dynamic metaprogramming features, and they translate to beautiful static metaprogramming features, I think it's profound. That's huge, right? And so Python, I've talked with people about this. It's like it was not designed to do what we're doing. That was not the reason they built it this way, but because they really cared and they were very thoughtful about how they designed the language. It scales very elegantly in this space. But if you look at other languages, for example, C and C++, right? If you're building a superset, you get stuck with the design decisions of the subset, right? And so, C++ is way more complicated because of C and the legacy than it would have been if they would have theoretically designed a from scratch thing. And there's lots of people right now that are trying to make C++ better and resyntax C++. It's going to be great. We'll just change all the syntax. But if you do that now, suddenly you have 0 patterns. You don't have to spend more.
So what are the, if you could just linger on that, what are the biggest challenges of keeping that superset status? What are the things you're struggling with? Is it all boiled down to having a bigger?
No, I mean it's
what are the other things?
usually it's the long tail of weird things. So let me give you a war story. Okay. So war story in the space is you go way back in time. The project I worked on is called Clang. Clang, what it is C++ parser, right? And when I started working on Clang, must have been like 2006 or something. It was 2007, 2006 when I first started working, right? It's funny how tough that is. I started that project, and I'm like, okay, well, I want to build a C parser, C++ parser for LLVM. It's going to be the world. GCC is yucky. This to me in earlier times. It's yucky, it's unprincipled, it has all these features, like all these bugs, like it's yucky, so I'm going to build a standard compliant C and C parser. It's going to be beautiful, amazing, well engineered, all the cool things that everyone wants to do. And so I started implementing, building out, and then I got to include standard IO.h. And all of the headers in the world use all GCC stuff. Okay. And so again, come back away from theory back to reality, right? I was at a fork in the road. I could have built an amazingly beautiful academic thing that nobody would ever use. Or I could say, well, it's yucky in various ways. All these design mistakes, accents of history, the legacy. At that point, GCC was like over 20 years old. By the way, now LLVM's over 20 years old. So it's funny how time catches up to you, right? And so you say, okay, well, what is easier, right? I mean, as an engineer, it's much easier for me to be able to implement long-tail compatibility weird features, even if they're distasteful, and just do the hard work and like figure it out, reverse engineer it, understand what it is, write a bunch of test cases, like try to understand behavior. It's way easier to do all that work as an engineer than it is to go talk to all C programmers and argue with them and try to get them to rewrite their code. Right? And
that breaks a lot more things.
Yeah. And you have realities like nobody actually even understands how this code works. This is written by the person who quit 10 years ago. Right? And so this software is kind of frustrating that way, but that's how the world works.
Yeah, unfortunately, you can never do this. Such a beautiful thing.
Well, there are occasions in which you get to build, like, you invent a new data structure or something like that. It was this beautiful algorithm that just like makes you super happy. I love that moment. But when you're working with people, you're working with code and just that code bases and things like this, right? It's not about what's theoretically beautiful, it's about what's practical, what's real, what people actually use. And I don't meet a lot of people that say, I want to rewrite all my code. Just for the sake of it.
By the way, there could be interesting possibilities, and we'll probably talk about it, where AI can help rewrite some code. That might be farther out future, but it's a really interesting one. How that could create more, be a tool in the battle against this monster of complexity that you mentioned.
Yeah.
And I said, you know, some strange thing happened.
You mentioned Guido, the benevolent dictator for life of Python. What does he think about Mojo? Have you talked to him much about it?
I have talked with him about it. He found it very interesting. We actually talked with Guido before it launched, so he was aware of it before it went public. I have a ton of respect for Guido for a bunch of different reasons. You talk about Walrus Operator, and like Guido is pretty amazing in terms of steering such a huge and diverse community and like driving it forward. And I think Python is what it is thanks to him. And so to me, it was really important starting to work on Mojo to get his feedback and get his input and get his eyes on it. Right now, a lot of what Guido was and is, I think, concerned about is how do we not fragment the community? We don't want a Python 2 to Python 3 thing. Like, that was really painful for everybody involved. And so we spent quite a bit of time talking about that and some of the tricks I learned from Swift, for example. So in the migration from Swift, we managed to not just convert Objective-C into a slightly prettier Objective-C, which we did. We then converted, not entirely, but almost an entire community to a completely different language. Right? And so there's a bunch of tricks that you learn along the way that are directly relevant to what we do. And so this is where, for example, you leverage CPython while bringing up the new thing. That approach is proven and comes from experience. And so Guido was very interested in, like, okay, cool. Like, I think that Python is really his legacy, his baby. I've come to respect that. Incidentally, I see Mojo as a member of the Python family. We're not trying to take Python away from Guido and from the Python family. And so, to me, it's really important that we're a good member of that community. So, yeah, I think that, again, you would have to ask Guido this, but I think that he's very interested in this notion of, like, cool, Python gets beaten up for being slow.
As I understand it, disappeared.
Maybe there's a path out of
There
it.
have been certain,
Right?
allocations
That,
that have been made.
the future is Python, right? I mean, look at the far outside based on this, right? And I'm not saying this is Guido's perspective, but there's this path of saying, like, okay, well, suddenly Python can suddenly go all the places it's never been able to go before. Right, and that means that Python can go even further and can have even more impact on the world.
So in some sense, Mojo could be seen as Python 4.0.
I would not say that. That would drive a lot of people really crazy.
Because of the PTSD of the 3.0 2.0.
I'm willing to annoy people with access to BIM,
Not that one.
versus spaces.
Not that one.
I don't know. That might be a little bit far even for me. Like my skin may not be that bad.
But the point is, the step to being superset and allowing all of these capabilities, I think, is the evolution of the language. It feels like an evolution of the language. So he's interested by the ideas that you're playing with, but also concerned about the fragmentation. So what are the ideas you've learned? What are you thinking about? How do you avoid fragmenting the community? Where the Pythonistas and
but it has been used since.
I don't know what to call the Mojo people. Magicians, I like it. Can coexist happily and share code and basically just have these big code bases that are using CPython and more moving towards Mojo.
Well, so again, these are lessons I learned from Swift, and here we face very similar problems, right? In Swift, you have Objective-C, super dynamic,
skewed and designated and
very different syntax, right? But you're talking to people who have large-scale code bases. I mean, Apple's got the largest scale code base of Objective-C code, right? And so, none of the companies, none of the iOS developers, none of the other developers want to rewrite everything all at once, and so you want to be able to adopt things piece at a time. And so a thing that I found that worked very well in the Swift community was saying, okay, cool. And this is when Swift is very young. And you say, okay, you have a million line of code Objective-C app. Don't rewrite it all. But when you implement in the feature, go implement that in your class using Swift. So now this turns out is a very wonderful thing for an app developer, but it's a huge challenge for the compiler team and the systems people that are implementing. Right? And this comes back to what is this trade-off between doing the hard thing that enables scale versus doing the theoretically pure and ideal thing, right? And so Swift had adopted and built a lot of different machinery to deeply integrate with Objective-C. And we're doing the same thing with Python. Now, what happened in the case of Swift is that Swift as a language got more and more mature over time, right? And incidentally, Mojo is a much simpler language than Swift in many ways, and so I think that Mojo will develop way faster than Swift for a variety of reasons. But as the language gets more mature, in parallel with that, you have new people starting new projects. Right? So when the language is mature and somebody's starting a new project, that's when they say, okay, cool, I'm not dealing with a million lines of code. I'll just start and use the new thing for my whole stack. Now the problem is, again, you come back to where communities and where people work together, you build a new subsystem or a new feature, a new thing in Swift, or you build a new thing in Mojo, then you want to be end up being used on the other side. Right? And so then you need to work on integration back the other way. So it's not just Mojo talking Python, it's also Python talking Mojo. Right? And so what I would love to see, I don't want to see this next month, right? But what I want to see over the course of time is I would love to see people that are building these packages, like NumPy or TensorFlow or these packages that are half Python, half C++. And if you say, okay, cool, I want to get out of this Python C++ world into a unified world, and so I can move to Mojo, but I can't give up all my Python clients. There's like these libraries are used by everybody, and they're not all going to switch all at once, and maybe never, right? Well, so the way we should do that is we should bend Python interfaces to the Mojo type. And that's what we did in Swift. It worked great. I mean, it was a huge implementation challenge for the compiler people, right? But there's only a dozen of those compiler people, and there are millions of users. And so it's a very expensive, capital-intensive, skill set intensive problem. But once you solve that problem, it really helps adoption. It really helps the community progressively adopt it. So I think that this approach will work quite well with the Python and the Mojo rules.
So for a package, port it to Mojo and then create a Python interface.
Yep.
So how do we so when you're on these packages, NumPy, PyTorch, TensorFlow, how do they play nicely together? So is Mojo supposed to be, let's talk about the machine learning one. Is Mojo kind of vision to replace PyTorch and TensorFlow, to incorporate it? What's the relationship?
All right, so take a step back. So I wear many hats. So you're angling in on the Mojo side. Mojo is a programming language, and so it can help solve the C, C++, Python, Vue
The fire emoji got me, I'm sorry. We should be talking modular,
yes. Okay, so the fire emoji is amazing. I love it. It's a big deal. The other side of this is the fire emojis in service of solving some big AI problems. Right? And so the big AI problems are, again, this fragmentation, this hardware nightmare, this explosion of new potential, but it's not getting felt by the industry. Right? And so when you look at how does the modular engine help TensorFlow and PyTorch, right? It's not replacing them. Right? In fact, when I talk to people, again, they don't have to rewrite all their code. You have people that are using a bunch of PyTorch, a bunch of TensorFlow. They have models that they've been building over the course of many years, right? And when I talk to them, there's a few exceptions, but generally they don't want to rewrite all their code. Right? And so what we're doing is we're saying, okay, well, you don't have to rewrite all your code. What happens is the modular engine goes in there and goes underneath TensorFlow and PyTorch. It's fully compatible. It just provides better performance, better predictability, better tooling. It's a better experience that helps lift TensorFlow and PyTorch and make them even better. I love Python, I love TensorFlow, I love PyTorch. Right? This is about making the world better because we need AI to go further.
But if I have a process to train the model and I have a process that performs inference on that model and I have the model itself, what should I do with that in the long arc of history. In terms of if I use PyTorch to train it, should I rewrite stuff in Mojo? Or that if I care about performance?
Oh, so I mean, again, it depends. So if you care about performance, then writing in Mojo is going to be way better than writing. But if you look at LLM companies, for example, if you look at OpenAI, Rumored, and you look at many of the other folks that are working on many of these LLMs and other like innovative machine learning models, on the one hand, they're innovating in the data collection and the model billions of parameters and the model architecture and the RLE, HF, and the like all the cool things people are talking about. But on the other hand, they're spending a lot of time writing CUDA kernels. Right? And so you say, wait a second, how much faster could all this progress go if they were not having to handwrite all these CUDA kernels? Right? And so there are a few technologies that are out there, and people have been working on this problem for a while, and they're trying to solve subsets of the problem, again, kind of fragmenting the space. And so what Mojo provides for these kinds of companies is the ability to say, cool, I can have a unifying theory. Right, and again, the better together unifying theory, the two-world problem, the three-world problem, the n-world problem, like this is the thing that is slowing people down. And so as we help solve this problem, I think it'll be very helpful for making this whole cycle go faster.
So obviously we talked about the transition from Objective-C to Swift to design this programming language, and we've also talked quite a bit about the use of Swift for machine learning context. Why have you decided to move away from maybe an intense focus on Swift in machine learning context versus sort of providing a new programming language that happens to be a superset?
It's a rational set of life choices I made.
I go to the desert. Did you medicate? Okay. All right. No, it was bold. It was bold and needed, and I think it's just bold. And sometimes to take those leaps is a difficult leap to take.
Yeah. Well, so okay. I mean, I think there's a couple of different things. So, actually, I left Apple back in 2017, January 2017. So it's been a number of years that I left Apple, and the reason I left Apple was to do AI. Okay, so, and again, I won't come on Apple and AI, but at the time, right, I wanted to get into and understand the technology, understand the applications and workloads, and so I'm going to go dive deep into applied and AI and then the technology underneath. Right? I found myself at Google.
And that was like the GPUs waking up.
Exactly. So I found myself at Google, and Jeff Dean, who's a rock star, as you know, right? And in 2017, TensorFlow was like really taking off and doing incredible things, and I was attracted to Google to help them with GPUs. Right? And GPUs are an innovative hardware accelerator platform. Have now, I think, proven massive scale and like done incredible things. Right? And so one of the things that this led into is a bunch of different projects, which I'll skip over, right? One of which was just Swift for TensorFlow Labs, right? And so that project was a research project. And so the idea of that is say, okay, well, let's look at innovative new programming models where we can get a fast programming language, we can get automatic differentiation into the language, let's push the boundaries of these things in the research setting. Right? Now, that project, I think, lasted 2-3 years. There's some really cool outcomes of that. So one of the things that's really interesting is I published a talk at an LLM conference in 2018. Seems like so long ago. Graph program abstraction, which is basically the thing that's in PyTorch 2. And so PyTorch 2 is all this DynamoRio thing. It's all about this graph program abstraction thing from Python bytecode. So a lot of the research that was done ended up pursuing and going out through the industry and influencing things, and I think it's super exciting and awesome to see that. But the Swift for TensorFlow project itself did not work out so well. And so there's a couple of different problems with that. One of which is that you may have noticed Swift is not Python. There's a few people that write Python code.
Yes.
And so it turns out that all of ML is pretty happy with Python.
It's actually a problem that other programming languages have as well, that they're not Python. We'll probably maybe briefly talk about Julia. It's a very interesting, beautiful programming language, but it's not Python.
Well, and so like if you're saying I'm going to solve a machine learning problem where all the programmers are Python programmers, and you say the first thing you have to do is switch to a different language. Well, your new thing may be good or bad or whatever, but if it's a new thing, the adoption barrier is massive.
It's still possible.
Still possible? Yeah, absolutely. The world changes and evolves, and there's definitely room for new and good ideas, but it just makes it so much harder. And so, lesson learned, Swift is not Python, and people are not always in search of like learning a new thing for the sake of learning a new thing. And if you want to be compatible with all the world's code, turns out, meet the world where it is. Second thing is that, a lesson learned is that Swift is a very fast and efficient language, kind of like Mojo, but a different take on it still. Really worked well with eager mode. And so eager mode is something that PyTorch does, and it does out really well, and it enables really expressive and dynamic and easy to debug programming. TensorFlow at the time was not set up for that. Let's say that was not.
Timing is also important.
Yeah, TensorFlow is a good thing and it has many strengths, but you could say Swift for TensorFlow is a good idea, except for the Swift and except for the TensorFlow part.
So because it's not Python and TensorFlow because it's not.
It wasn't set up for eager mode at the time. Yeah,
it was 1.0.
Exactly. And so one of the things about that is that in the context of it being a research project, I'm very happy with the fact that we built a lot of really cool technology. We learned a lot of things. I think the ideas went on to have influence in other systems like PyTorch. A few people use that right here, right? And so I think that's super cool. And for me personally, I learned so much from it. And I think a lot of the engineers that work on it also learned a tremendous amount. And so, I think that that's just really exciting to see. And I'm sorry that the project didn't work out. I wish it did, of course, right? But it's a research project, and so we're there to learn from it.
It's interesting to think about the evolution of programming as we come up with these whole new set of algorithms in machine learning and artificial intelligence, and what's going to win out. Because it could be a new programming language.
Yeah,
it could be. I just mentioned Julia. I think there's a lot of ideas behind Julia that Mojo shares. What are your thoughts about Julia in general?
So I will have to say that when we launched Mojo, one of the biggest things I didn't predict was the response from the Julia community, and so I was not. I mean, let me take a step back. I've known the Julia folks for a really long time. They're an adopter of LLVM a long time ago. They've been pushing state of the art in a bunch of different ways. Julia is a really cool system. I had always thought of Julia as being mostly a scientific computing focused environment, right? And I thought that was its focus. I neglected to understand that one of their missions is to help make Python work end to end. And so I think that was my error for not understanding that, and so I should have been maybe more sensitive to that. But there's major differences between what Mojo is doing and what Julia is doing. So as you say, Julia is not Python. Right? And so one of the things that a lot of the Julia people came out and said is okay, well, if we put a ton of more energy and a ton more money or engineering or whatever in Julia, maybe that would be better than starting Mojo. Maybe that's true, but it still wouldn't make Julia Python. So if you work backwards from the goal of let's build something for Python programmers without requiring them to relearn syntax, then Julia just isn't there. I mean, that's a different thing. And so if you anchor on I love Julia and I want Julia to go further, then you can look at it from a different lens. But the lens we were coming at was, hey, everybody is using Python. Python syntax isn't broken. Let's take what's great about Python and make it even better. And so it's just a starting point. So I think Julia's great. The community is a lovely community. They're doing really cool stuff, but it's just it's slightly different angle.
But it does seem that Python is quite sticky. Is there some philosophical almost thing you could say about why Python, by many measures, seems to be the most popular programming language?
Well, I can tell you things I love about it, and that's one way to answer the question, right? So, huge package ecosystem, super lightweight and easy to integrate. It has very low startup time.
So what startup time? You need a learning curve or what?
Yeah, so if you look at certain other languages, you say like Go, and it just takes like Java, for example, it takes a long time to compile all the things, and then the VM starts up and the garbage collector kicks in, and then it revs its engines, and then it can plow through a lot of internet stuff or whatever, right? Python is like scripting. It's good, right? Python has very low compile time, so you're not sitting there waiting. Python integrates into notebooks in a very elegant way that makes exploration super interactive, and it's awesome. Right? Python is also it's like the glue of computing because it has such a simple object representation. A lot of things plug into it. That dynamic metaprogramming thing we were talking about also enables really expressive and beautiful APIs. Right? So there's lots of reasons that you can look at technical things that Python has done and say like, okay, well, this is actually a pretty amazing thing. And any one of those you can neglect. People will all just talk about indentation and ignore like the fundamental things. But then we also look at the community side, right? So Python owns machine learning. Machine learning is pretty big.
Yeah, and it's growing.
And it's growing, right? And it's growing in importance, right?
And there's a reputation and prestige to machine learning to where, like, if you're a new programmer, you're thinking about, like, which programming language do I use? Well, I should probably care about machine learning, therefore, let me try Python. And
well,
kind of builds and builds and builds.
And even go back before that. Like, my kids learn Python. But not because I'm telling them to learn Python, but because
they were calling it
well, no, right. Well, they also learn Scratch, right, and things like this too. But it's because Python is taught everywhere, because it's easy to learn, right, and because it's pervasive. Right?
Back in my day, we learned Java and C++. Uphill both directions. But yes, I guess Python is the main language of teaching software engineering in schools now.
Yeah, well, if you look at this, there's these growth cycles. Right? If you look at what causes things to become popular and then gain in popularity, there's reinforcing feedback loops and things like this. And I think Python has done, again, the whole community has done a really good job of building those growth loops and help propel the ecosystem. And I think that, again, you look at what you can get done with just a few lines of code. It's amazing.
So this kind of self-building loop is interesting to understand, because when you look at Mojo, what it stands for, some of the features, it seems sort of clear that this is a good direction for programming languages to evolve in the machine learning community. But it's still not obvious that it will, because of this, whatever the engine of popularity, of virality. Is there something you can speak to, like how do you get people to switch?
Yeah, well, I mean, I think that the viral growth is to switch people to Unicode.
Yes.
I think the Unicode file extensions are what I'm betting on. I think that's going to be the thing.
Yeah. Tell the kids that you can use the fire emoji.
Exactly. Exactly. Well, in all seriousness, like, I mean, I think there's really, I'll give you two opposite answers. One is, I hope if it's useful, if it solves problems, and if people care about those problems being solved, they'll adopt the tech. Right, that's kind of the simple answer. And when you're looking to get tech adopted, the question is it solving an important problem people need solved? And is the adoption cost low enough that they're willing to make the switch and cut over and do the pain up front so that they can actually do it? Right? And so hopefully Mojo will be that for a bunch of people. And people building these hybrid packages are suffering. It's really painful, and so I think that we have a good shot of helping people. But the other side is like, it's okay if people don't use Mojo. Like, it's not my job to say like everybody should do this. Like, I'm not saying Python is bad. Like, Python, CPython, like all these implementations, because Python ecosystem is not just CPython, it's also a bunch of different implementations with different trade-offs. And this ecosystem is really powerful and exciting, as are other programming languages. So like TypeScript or something is going to go away, right? And so there's not a winner-take-all thing. And so I hope that Mojo is exciting and useful to people, but if it's not, that's also fine.
But I also wonder what the use case for why you should try Mojo would be. So practically speaking, it seems like there's entertainment, there's a dopamine hit of saying, holy shit, this is 10 times faster. This little piece of code is 10 times faster. Mojo.
Box before you get to 35 times.
Exactly. I mean, just even that, I mean, that's the dopamine hit that every programmer sort of dreams of. The optimization. It's also the drug that can pull you in and have you waste way too much of your life optimizing and over optimizing, right? But so what do you see would be like common? It's very hard to predict. If we look 10 years from now, Mojo's super successful, what do you think would be the thing where people like try it and then use it regularly and it kind of grows and grows and grows?
Well, so you talk about dopamine. So again, humans are not one thing, and some people love rewriting their code, learning things, and throwing themselves in deep dive and trying out new things. In my experience, most people don't. Like they're too busy. They have other things going on. By number, most people don't like this. I want to rewrite all my code. But even those people, the too busy people, the people that don't actually care about the language, they just care about getting stuff done, those people do like learning new things, right? And so you talk about the dopamine rush 10x faster. Wow, that's cool. I want to do that again. But it's also like, here's the thing I've heard about in this domain, and now I don't have to rewrite all my code. I can learn a new trick. Right? Well, that's called growth. You know? And so one thing that I think is cool about Mojo, and again, most will take a little bit of time for example, the blog posts and the books and like all that kind of stuff developed, and the language needs to get further along. So what we're doing, types, like you can say, look, you can start with the world you already know, and you can progressively learn new things and adopt them where it makes sense. If you never do that, if you get really excited about it, want to go all the way in the deep end and want to rewrite everything and like whatever, that's cool, right? But I think the middle path is actually the more likely one, where it's you come out with a new idea and you discover, wow, that makes my code way simpler, way more beautiful, way faster, way whatever, and I think that's what people do. Now, if you fast forward and you said like 10 years out, right? I can give you a very different answer on that, which is, I mean, if you go back and look at what computers looked like 20 years ago, every 18 months they got faster for free. Right? 2x faster every 18 months. It was like clockwork. It was free. Right? You go back 10 years ago, and we entered in this world where suddenly we had multi-core CPUs and we had GPUs. And if you squint and turn your head what a GPU is, it's just a many-core, very simple CPU thing, kind of, right? And so, and 10 years ago, it was CPUs and GPUs and graphics. Today, you have CPUs, GPUs, graphics, and AI, because it's so important, because the compute is so demanding, because of smart cameras and the watches and all the different places that AI needs to work in our lives. It's caused this explosion of hardware. And so part of my thesis, part of my belief of where computing goes, if you look out 10 years from now, it's not going to get simpler. Physically, going back where we came from, it's only going to get weirder from here on out. Right? And so to me, the exciting part about what we're building is it's about building that universal platform, which will continue to get weird. Again, I don't think it's avoidable, it's physics. But we can help lift people, scale, do things with it. You don't have to rewrite their code every time a new device comes out. And I think that's pretty cool. And so if Mojo can help with that problem, then I think that it will be hopefully quite interesting and quite useful to a wide range of people, because there's so much potential. Like there's so much, maybe analog computers will become a thing or something, right? And we need to be able to get into a mode where we can move this programming forward, but do so in a way where we're lifting people and growing them instead of forcing them to rewrite all their code and exploding them.
I think there'll be a few major libraries that go Mojo first.
Well, so I mean, modular engines are Mojo. So again, come back to like, we're not building Mojo because it's fun. We're building Mojo because we had to solve these accelerators.
That's the origin story. But I mean, ones that are currently in Python.
Yeah, so I think there are a number of these projects. So one of those things, again, this is just my best guess. Like each of the package maintainers also has, I'm sure, plenty of other things going on. People really don't like rewriting code just for the sake of rewriting code. But sometimes, like, people are excited about, like, adopting a new idea. Yeah. It turns out that while rewriting code is generally not people's first thing, it turns out that redesigning something while you rewrite it and using a rewrite as an excuse to redesign can lead to the 2.0 of your thing that's way better than the 1.0. And so I have no idea. I can't predict that. But there's a lot of these places where, again, if you have a package that is half C and half Python, right, it just solves the pain and make it easier to move, make it easier to bug and involve your tech. Adopting Mojo kind of makes sense to start with, and then it gives you this opportunity to rethink things.
So the two big gains are that there's a performance gain, and then there's the portability to all kinds of different devices.
And there's safety, right? So you talk about real types. And I'm not saying this is for everybody, but that's actually a pretty big step. Right?
Types are,
And so there's a bunch of different aspects of what value Mojo provides. And so, I mean, it's funny for me. Like, I've been working on these kinds of technologies and tools for too many years now. But you look at Swift, right? And we talked about Swift for TensorFlow, but Swift as a programming language, right? Swift's now 13 years old from when I started it. Yeah. So, because I started in 2010, and so that project, and I was involved with it for 12 years or something, right? That project has gone through its own really interesting story arc, right? And it's a mature, successful, used by millions of people system, right? Certainly not dead yet, right? But also going through that story arc, I learned a tremendous amount about building languages, about building compilers, about working with the community, and things like this. And so that experience, like I'm helping channel and bring directly to Mojo. You know, other systems, same thing. Like, apparently, I like building and iterating and evolving things. And so you look at this LLVM thing that I worked on 20 years ago. You look at MLIR, right? And so a lot of the lessons learned in LLVM got fed into MLIR, and I think that MLIR is a way better system than LLVM was. You know, Swift is a really good system, and it's amazing. But I hope that Mojo will take the next step forward in terms of design.
In terms of running Mojo, people can play with it. What's Mojo Playground?
Yeah,
and from the interface perspective and from the hardware perspective, what's this incredible thing running on?
Yeah, so right now, here we are 2 weeks after launch.
Yes.
We decided that, okay, we have this incredible set of technology that we think might be good, but we have not given it to lots of people yet. And so we were very conservative and said, let's put it in a workbook. So if it crashes, we can do something about it. We can monitor and track that. Right? So again, things are still super early, but we're having like one person a minute sign up with over 70,000 people 2 weeks in. It's kind of crazy.
So you can sign up with the playground and you can use it in the cloud.
Yeah,
in your browser.
And so what that's running on, that's running on cloud VMs, and so you share a machine with a bunch of other people. But it turns out there's a bunch of them now because there's a lot of people, and so what you're doing is you're getting free compute and you're getting to play with this thing in kind of a limited, controlled way, so that we can make sure that it doesn't totally crash and be embarrassing. Right? Yeah. So now a lot of the feedback we've gotten is people want to locally, so we're working on that right now, and so that's the goal, to be able to download locally. Yeah, that's what everybody expects. And so we're working on that right now, and so we just want to make sure that we do it right. And I think this is one of the lessons I learned from Swift. Also, by the way, is that when we launched Swift, gosh, it feels like forever ago. It was 2014, and it was super exciting. The team, had worked on Swift for a number of years in secrecy. Okay? And we, 4 years into this development, roughly, of working on this thing, at that point, about 250 people at Apple knew about it. Okay, so it was secret. Apple's good at secrecy, and it was a secret project. And so we launched this at WWDC, a bunch of hoopla and excitement, and said, developers are going to be able to develop and submit apps to the App Store in 3 months. Yeah. Well, several interesting things happened, right? So first of all, we learned that, it had a lot of bugs. It was not actually production quality, and it was extremely stressful in terms of like trying to get it working for a bunch of people. And so what happened is we went from 0 to, I don't know how many developers Apple had at the time, a lot of developers overnight, and they ran into a lot of bugs, and it was really embarrassing, and it was very stressful for everybody involved. Right? It was also very exciting because everybody was excited about that. The other thing I learned is that what happened roughly every software engineer they got the Italian allies and their head exploded when it was launched because they didn't know it was coming. And so they're like, wait, what is this? I signed up to work for Apple because I wanted to check and see why is there a new thing, right? And so now what that meant practically is that the push from launch to first of all the fall, but then to 2.0, 3.0, and like all the way forward was super painful for the engineering team. myself. It was very stressful. The developer community was very grumpy about it because they're like, okay, well, wait a second, you're changing and breaking my code, and like, you have to fix the bugs, and it was just like a lot of tension and friction on all sides. There's a lot of technical debt in the compiler because you have to run really fast, you have to implement the thing and unblock the use case and do the thing, and you know it's not right, but you never have time to go back and do it right. And I'm very proud of the Swift game because but they came so far and made so much progress over this time since launch. It's pretty incredible. This is a very, very good thing. I still want to do that again. Right? So
more iterate more through the development process.
And so what we're doing is we're not launching it when it's hopefully 0.9 in the testers. We're launching it and saying it's 0.1. Right? And so we're setting expectations and saying like, okay, well, don't use this for production. Right? If you're interested in what we're doing, we'll do it in a way, and we can do it together, but don't use it in production yet. Like, we'll get there, but let's do it the right way. And I'm also saying, we're not in the race. The thing that I want to do is build the world's best thing. Right? Because if you do it right and it lifts the industry, it doesn't matter if it takes 2 months. Like 2 months is worth waiting. And so doing it right and not being overwhelmed with that, yes, again, war wounds, lessons learned, whatever you want to say, I think is absolutely the right thing to do, even though right now people are very frustrated that you can't download it or it doesn't have feature X or something like this.
What have you learned in a little bit of time since it's been released into the wild that you've been complaining about feature X or Y or Z? What have they been complaining about? What they have been?
What do you think is the big difference?
Excited about, like almost like detailed things versus a big. I think everyone would be very excited about the big vision.
Yeah. So I mean, I've been very pleased. In fact, we've been massively overwhelmed. But I think which is a good problem to have. Kind of like a success disaster, in a sense, right?
First of all, childhood mortality.
So, what, I mean, if you go back in time, when we started launching, not yet a year and a half ago, it's still a pretty new company, new team, small but very good team of people. Like, we started with extreme conviction that there's a set of problems we need to solve, and if we solve it, then people will be interested in what we're doing. But again, you're building in basically
nowadays we think of that as
you're trying to figure it out. Creation's a messy process. You're having to go through different paths and understand what you want to do and how to explain it. Often when you're doing disruptive and new kind of things, just knowing how to explain it is super difficult, right? And so when we launched, we hoped people would be excited, but you know, I'm an optimist, but I'm also like don't want to get ahead of myself. And so when people find out about Mojo, I think they're happy to right? And you know, here's I think pretty credible team. There's still some tools before, and so they have some lessons learned and are tackling some of the deep problems in the Python ecosystem and giving it the love and attention that it should be getting. And I think people got very excited about that. And so if you look at that, I mean, I think people are excited about ownership and taking a step beyond Rust. I think people that are very excited about that. There's people that are excited about, you know,
for me,
like I made Game of Life go 400 times faster, right? And things like that. And that's really cool. There's people that are really excited about the, okay, I really hate
that give us those little glimpses into
Like
everyday
they're like
stuff
like
yeah. So that's
or just something that survives on a scrap of parchment that records a financial
but
transaction.
I get
And whenever I read some of those,
excitement
I'll have this
when people
moment
tweet,
of
yeah, I made this code, Game
feeling,
of Life,
I
or
know
whatever,
exactly how that
faster.
person felt.
You're like,
Here across 2,000 years
and also
of time,
like
completely different cultures.
well, I would also
have
say
this
that
spark
let
of
me
sympathy
cast
with someone
blame
from
out
antiquity.
to people
And I
who
think
deserve
as a
it.
historian, the way you
These
begin
terrible
to
people who
understand
convinced me to do
alien
some of this.
foreign culture, which is what
Jeremy
these
Howard,
cultures are, is
that
to look
guy,
for those little moments of
so he's
sympathy.
been pushing
But
for
on
this
the
kind
other
of
hand,
thing.
he's wanted this for years.
Yeah, he's wanted this for a long,
He's
long
wanted
time.
this for years.
For people who don't know
So you
Jeremy
also
Howard,
look
he's
for those
like
moments
one
where
of
you
the
just
most
think,
legit people
how
in
the
the
hell
community.
could these people have done that?
He's
I just don't
the
understand how they
grassroots.
could have thought or
He
acted
really
in this
teaches.
way.
He's an incredible
And it's
educator,
lining up
incredible
those
teacher,
moments
but
of
also legit.
sympathy, that kind of
A machine learning
disconnection
engineer himself.
that I think
Yeah,
is
he's
when you
been running
begin to start to
AI
understand a
and
foreign
looking at
culture
it
or an
for
ancient culture.
exactly
The idea of assembling
Exactly.
the big
So,
picture
and
from
so,
the details,
I mean,
little pieces, because
the
that is
first
the
time,
thing
so I
that
met
makes up
Jeremy
life.
pretty early
The
on,
big picture is nothing
but
without
the
the details.
first time I sat up
And those
and I'm like,
details would bring it to life.
this guy is
It's not
ridiculous.
the
Is when I
grand
was
sweep
at
of
Google
things. It's
and we were bringing
seeing those
CPUs and we had a
hopes and
whole team of
fears.
people.
Another
And
thing
we're-
that I think is a huge
there's this
difference between
competition called
the
Dawn
modern
Bench
world and the
of
ancient
who can train
is just
ImageNet
basically everybody's a farmer.
fastest.
Everybody's a small
And Jeremy
family
and
farmer.
one of his
They just get this.
researchers
I was just
crushed
writing a
Google.
lecture for
Yeah.
my next
Like,
great
not
course.
through sheer
course,
force
and I was
of the
writing about
amazing
farming
amount of
in ancient
compute and the number of GPUs and
And I
stuff
was
like
really thinking,
that he
if
just
we were to
decided
write a
that progressive imagery
realistic
sizing
textbook,
was the
let's say
right way to train the model and Fury
nine
epoch
out of
faster
10
and
chapters
make the
should
whole
be
thing go
details of what
with
it was like
room,
to be a
right?
small-time
And
family farmer.
I'm like,
Because
this
that's
guy's
what
incredible.
90% of the
So you
people
can
in
say,
the ancient world did.
anyways, come back to where's
Soldiers, they
Mojo
weren't
coming from.
priests, they weren't kings, they weren't authors, they weren't artists, they were small-town family
But there's a kind of
and they
very
lived in a little village. They never traveled
refreshing,
20 miles from that
pragmatic
village.
view
They
that he
were
has
born there. They
about
buried
machine
somebody
learning
from
that
there. They raised kids. They walked around
I don't know if
for a
it's
couple
like
decades,
this
and they died.
mix
They never
of
saw a battle. They
desire
never
for
saw a work of
efficiency,
art.
but
They never saw a
ultimately
philosopher.
grounded in
They
desire
never
to
took
make
part in any of the
machine
things we
learning more
define
accessible
as
to a
being
lot of people.
history.
I don't know what that is. I guess that's
So
coupled with
that's what
efficiency
life should be, and
and
that's
performance.
representative.
But it's not just
It is
obsessed
the
about
emperors and the
performance.
philosophers
So,
and the
so a lot of
artists
AI
and
and AI
the warriors
ends
of
up being
history.
that
And it is the
it has to go fast enough to get scale.
That's true.
So a lot of people don't actually care about
That's a good
performance, particularly on
reminder,
the
though,
research
if you want
side,
to truly
until it allows
empathize
them
and
to have more bigger
understand
data
what
sets,
life was like.
right? And so
You have to
suddenly now you care about
represent it
distributed
fully.
compute and like
And
all
I would
these
say let's
exotic
not
HPCs.
forget
Like you don't actually
So
want
let's
to know
not
about that. You
forget
just want
what life was
to
like
be able
for
to do more
89%
things
of the
faster
people
and
in
do
the
things
ancient
bigger
world, the
data
ones
sets,
we
right?
don't talk
And
about,
so
because
Jeremy
that's
has been
important too.
really pushing limits.
So the
And one of the
Roman
things I'll say
Empire
about Jeremy, and there's many
is
things I can
widely
say about
considered to
Jeremy,
be the most
I'm a fan.
powerful, influential,
What it is, but
impactful
he
empire in
it
human
fits in his
history.
head.
What are some
And
reasons
Jeremy
for that?
actually takes the time where many people
I mean,
don't to
Rome
really dive deep
has been hugely influential. I
why
think,
is the
just
beta
because of
parameter of the atom
the
optimizer
image.
equal
I
to
mean, there's all
this,
these practical
right?
ways.
And
I
he'll
mean,
go
the
survey
words I'm using to speak with you
and
today,
understand
30% are
what are all the
direct from Latin,
activation
another
functions
30%
and
are from
trade-offs, and
Latin
why is it
descended
that
languages.
everybody
Our
that
law
does,
codes, I mean, our
this
habits,
model
our
pick that thing,
holidays,
the
everything comes
why,
fairly
not just
directly
trying
from
to
the
figure
ancient
out,
world.
like really
But the
what is
image
going
of
on
Rome,
here.
right?
at least
And so
again,
as a
in
consequence
Western
of that, like he's
civilization, has
always,
really been the dominant
again, he
image
makes
of a
time, but
successful
he spends
empire.
time to understand things in
And I think
depth that a
that's
lot
what
of
gives it
people
a lot
don't.
of its
And as
fascination.
you say, he then
This
brings
idea
it
that
and teaches
Rome was
people,
this great,
and
powerful,
his
culturally
mission is
influential
to
empire.
help lift.
And there's a lot of other
Website
empires.
says
I mean, we could
making
talk
AI
about
uncool
ancient
again.
China,
Like it's about
which
forget
arguably
about the
was
hype.
just as
It's
big as
actually
Rome, just
practical
as
and
culturally
useful.
sophisticated, lasted about the same amount of
Now
time.
the problem Jeremy
But
struggled
at
with is
least
that
in
he's
Western
pushing the envelope.
civilization, Rome is the
Right?
paradigm.
Research isn't about doing the
But
thing
Rome
that
was a
is
little
staying on the happy
schizophrenic
path,
in that it's both
the well-paved road,
empire,
right?
when it was
And
ruled
so
by
a lot of the
emperors,
systems
which is
today
one
then
kind of model,
these really
and it's the
fragile,
Roman
fragmented things with
Republic,
special
when it
case
was
and
a
happy path. And if you fall off the happy path,
pseudo-democracy, which is a different
you get
model.
eaten by the
And
alligator.
it's interesting how some later
So
civilizations tend to either
what
focus on
about
one or the other
so
of those.
Python has
So,
this
you know, the
giant
United States,
ecosystem of
Revolutionary
packages,
France, they were very obsessed with the
package
Roman
repository.
Republic as
Do
a
you have
model.
ideas of how
But
to
other
do
people,
that well?
Mussolini,
Mojo?
Hitler, Napoleon,
Yeah,
how to
they
do
were
a
very
repository
obsessed with the
packages.
empire.
So that's another really
Britain,
interesting problem that
as a
I
model.
knew
So
about, but I
Rome
didn't
itself
understand
has
how big the
different
problem it
aspects.
was. Python
But what I think is
packaging,
actually another big difference between
a lot of people have very big
ancient
pain points and a
is
lot of
our
scars with
relationship
Python packaging.
with the
Oh, you mean
past.
so there's
So
several things.
one of
Building
the
and distributing,
keys to
managing
understanding
dependencies
all of
and
Roman history
versioning and all
is
this
to
stuff.
understand that
So
this
from the
was a people
perspective
who
of
were
what if
obsessed
you want
with
to
the
create
past
your own package,
and
Yes.
for whom
And then, or you want to build on top of a bunch of other people's packages.
not
and then
just
make
as
it
something
updated.
inspirational, but it
Now,
actually
I'm not an expert in this, so
dictated what
I
you would do in your
don't
daily life.
know the answer.
And today,
I think this is one
especially
of
in the
the
United
reasons
States,
why it's great
we
that we
don't
work as a
have
team.
much of a relationship
There's
with the
other
past.
really good
We see
inspirational
ourselves
ones.
as free agents, just floating
but
along,
one of my-
not tethered to what came
One of the
before.
things I've heard from
And
some
the
people who've
classical
done a lot
story
of
that
this
I
is
sometimes
that
tell my classes
the
to illustrate
packaging
this
becomes a
is,
huge disaster when you get the Python
Rome
and
started out
together.
as a monarchy.
And so if you have this problem where you have
kind of unhappy with their
code split
kings
between
around
Python and
5.
C, now not only do you have
BC,
to
they held a
package the C
revolution
code,
and they
you have to
kicked
build
out
the
the Kings, and one of the guys
He doesn't have a
who played
package
role in
manager.
this was a man named
Right?
Lucius
He doesn't have a
Julius
dependency versioning management system.
500
Right?
years
So
later,
I'm not
500
experienced in state of the
years
art
down
and
the road, the guy
all
comes
the
along
different
like
Python
Caesar,
package managers,
who
but
starts
my
to
understanding
act
is that's a
like a
massive
king.
part of the
So
problem.
if you have
And I
trouble
think
with
Mojo
kings
solves
of
that
Roman
part of the problem
society,
correctly.
who
Heads
you
up.
gonna call?
Now,
Somebody
one of the
named
things I think we'll
Brutus.
do with community,
Now, as it
which isn't
happens, there is a
again,
guy named
not
Brutus
solving
in
all
Roman
those
society
problems
at
at
this
once, we
time.
should
Was one
kind
of
of
Julius
focus
Caesar's
start with
best friends,
is that
Marcus
I think that
Junius
we will have
Brutus.
an opportunity to reevaluate packaging.
Before I go further with the story, and I
And
think
so I
you might
think
know
that we
where
can
it
come back
ends,
and say, okay, well, given the new tools and technologies and the cool things we have that we've built up, we have not just syntax, we have an entirely new compiler stack that works in a new way. Maybe there's other innovations that we can bring together, and maybe we can help solve that problem.
So almost a tangent to that question, from the user perspective of packages, it was always surprising to me that it was not easier to sort of explore and find packages.
And they hung these in a big
With
cabinet
pip
right inside
install,
the front door.
it
So every time
feels
you enter your
it's
house,
an incredible
you're literally
ecosystem.
staring
It's
at the faces of your ancestors.
interesting that it
And
wasn't
every
the
child
still,
in that
I think,
family
not made easier
would
to
have
discover packages to
obsessively
do
memorized
like
every accomplishment of every one of those ancestors.
search and
You would have known
discovery.
their career, offices they held,
Well, I mean,
battles they
it's
fought,
kind of
what
funny
they did.
because this is one of the challenges
When
of
somebody
these like
new in the family died, there would be a
intentionally
funeral,
decentralized
and they would talk
communities.
about all the
And
things
so I
their
don't know what the right
ancestors
answer is
did.
for Python.
The kids in
There
the
are
family
many
would
people
literally
who
take out those masks,
well, I
tie
don't
them
know the right
onto their
answer
own
for Mojo.
faces, and wear them in
Yeah,
the
so there are many people
So
that
you were like
would have
wearing
much more
the
informed
face of your
opinions, but
ancestors.
it's interesting
So
to look at
you
this,
as
right?
an
Open source
individual,
communities.
you were just the latest iteration
There's
of
Git.
that family.
Git is a fully
And there was
decentralized, and they
enormous
can do it any way they want.
huge
But then
weight
there's
to
GitHub,
live up to the
right? And
deeds of your
GitHub,
ancestors.
centralized,
So the Romans were
commercial in that
absolutely
case,
obsessed
right?
with the past,
Thing,
especially with their own
really
family.
help pull together and
Every
help
Roman
solve
kid
some
who was,
discovery
let's
problems
say,
and
an
help build
aristocratic family can
a
tell
more
you every one of his ancestors
consistent
back
community.
centuries.
And so maybe there's
I can't go
opportunities
beyond
for
my
something
grandparents.
like
I
a
don't know,
GitHub
but
for
that's,
yeah.
100
Although even
years. So
GitHub,
it's a
I might be
completely
wrong on
different
this,
attitude
but
towards
the search and
the
discovery
past.
for
And the level
GitHub
of
is not
celebration
that
that we have now of the
great.
ancestors,
I
even
guess they'll
with
use
names,
Google
not
search.
as intense as it
Yeah.
was
Well,
now.
I mean, maybe
It was
that's because
obsessive
GitHub
and
doesn't want to replace Google
impressive.
search.
Determined
I think there is room
because
for
there's that
specialized
weight for you to
solutions
act
for
like your
specific problems.
ancestors did.
Sure.
I don't know the right answer for GitHub either.
Less off the, do you think it was
They can go figure that
limiting
out.
to the way the
But
society
the point is to have an
develops, to be
interface that's usable and
as deeply
accessible to people of all
constrained
different
by
skills.
Well, and again, like,
limiting
what
it
are the
good way or
benefits of
bad,
standards,
do you think?
right? Standards allow you to build
Like
these
everything, it's a
next
little
level of
both, but the
ecosystem, next
So on
level
the
of
one hand, it gives them more
infrastructure, next
restraint,
level of
and it gives them
things.
this
And so,
enormous connection, it gives them
again,
guidance.
come back
But
to
the negatives, what's interesting, is it makes the
C++
Romans extremely
Python is
traditional-minded.
it makes everything more difficult to deal with.
And I mean conservative in the sense of
around,
resistant
work
to
with,
change.
all these things get more
So
complicated.
in the
So,
late Republic, which
I
we'll
mean,
probably
I'm
talk about
not an
later,
expert, but maybe Mojo can help a
desperately
little
needed
bit
to
by
change certain
helping
things.
reduce the amount
It
of
was
C
a
in the
society
ecosystem and make it
did
therefore
things
scale
the
it.
way
Any
the
kind of
ancestors
packages
did
that
it, and they did
hybrid in
make some
nature
obvious
would be a
changes, which
natural
might have
fit
saved
in
the Republic.
Which is a
So
lot of
that's
them.
the downside, is that it locks you into something
a lot of
you
them,
can't
especially
change.
they're doing some interesting
But
stuff.
to get us back to the Brutuses, so
Let me ask you about some
500 years
features.
after that first
Yeah.
Brutus got rid of
So
kings,
we talked
Julius
about
Caesar started acting like a king.
indentation
One of his
as the
best
type
friends is
language
Marcus Junius
or
Brutus.
optionally
And
typed
literally in the middle of the
language
night, people
that
go to
either
Brutus's
optionally or
house and they write
progressively or
graffiti on it that
I think
says,
so people have very strong opinions on the right word to use.
and another one is
I don't know.
I look forward to your letters. So there's the var versus let, but let is for constants. Var is an optional.
Yeah, var makes it beautiful.
Take daggers, stick them in Julius Caesar, and kill him.
Then there's
So the way I always pose this to my students is,
Oh, okay. Yeah.
how many of you,
I mean, there's a lot of source of happiness when you go function overloading. That's
because of what your
I guess is that for performance, or is that why does Python not have functionality?
That's the power of the past.
So I can speculate.
That's a
So,
society.
Python is a dynamic
isn't just
language. The way it
influential,
works
but it
is that
dictates what you do. And that concept
Python
is
and
very
Objective-C are
alien
actually
to us today. We
very
can't
similar
imagine murdering our
rules
best friend
if you
because
ignore
of some
syntax.
incredibly distant ancestor.
And so Objective-C is straight line derived from Smalltalk, a really venerable, interesting language that much of the world has forgotten about, but people that remember it love it generally. And the way that Smalltalk works is that every object has a dictionary in it. And the dictionary maps from the name of the function, the name of the value within an object, to its implementation. And so the way you call a method in Objective-C is you say, go look up, the way I call foo is I go look up foo, I get a pointer of the function back, and then I call it. Yeah. That's how Python works. Right. And so now the problem with that is that the dictionary within a Python object, all the keys are strings, and it's a dictionary, so you can only have one entry per name.
You think it's as simple as that?
I think it's as simple as that. And so now, why do they never fix this? Like, why do they not change it to not be a dictionary? Why not like do other things? Well, you don't really have to in Python because it's dynamic. So you can say, I get into the function. Now, if I got past an integer, do some dynamic tests for it. If it's a string, thing. There's another additional challenge, which is even if you did support overloading, saying, okay, well, here's a version of the function for integers and a function for strings. You'd have, even if you could put it in that dictionary, you'd have to have the caller do dispatch. So every time you call a function, you'd have to say, like, is it an integer or is it a string? And so you'd have to figure out where to do that test. And so in a dynamic language, overloading is something you don't have to have. So, but now you get into a type language, and in Python, if you subscript with an integer, then you get typically one element out of a collection. If you subscript with a range, you get a different thing out, right? And so often in type languages, you want to be able to express the fact that, cool, I have different behavior depending on what I actually pass into this thing. If you can model that, it can make it safer, more flexible, and faster, and all these things.
It somehow feels safer, yes, but also feels empowering. Like in terms of clarity, like you have to design for different functions.
Yeah, well, this is also one of the challenges with the existing Python typing systems, is that in practice, like you take subscript, like in practice, a lot of these functions, they don't have one signature. They actually have different behavior in different cases. And so this is why it's difficult to like retrofit this into existing Python code and make it play well with typing. You're gonna have to design for that.
Okay, so there's an interesting distinction that people that program Python might be interested in: is def versus fn. So it's two different ways to define a function, and fn is a stricter version of def. What's the coolness that comes from the strictness?
So here you get into what is the trade-off with a superset.
Yes.
Okay. So a superset, you have to, or you really want to be compatible. Like if you're doing a superset, you've decided compatibility with existing code is the important thing, even if some of the decisions they made were maybe not what you choose. Okay. So that means you put a lot of time into compatibility, and it means that you get locked into decisions in the past, even if they may not have been good. Now, systems programmers typically like to control things, right? They want to make sure that, not in all cases, of course, and even systems programmers are not one thing, right? But often you want predictability. And so one of the things that Python has, for example, is that if you define a variable, you just say x equals 4. I have a variable named x. Now I say some long name equals 17. Print out some long name. Oops, but I typoed it. Right. Well, the Python compiler doesn't know in all cases what you're defining, what you're using, and did you typo the use of it or the definition? Right. And so for people coming from type languages, again, I'm not saying they're right or wrong, but that drives them crazy because they want the compiler to tell them you typoed the name of this thing. Right. And so what FN does is it turns on, as you say, it's a strict mode. And so it says, okay, well, you have to actually intentionally declare your variables before you use them. That gives you more predictability, more error checking, things like this. But you don't have to use it. And this is a way that Mojo is both compatible, because defs work the same way that defs have always worked, but it provides a new alternative that gives you more control and allows certain kinds of people to have a different philosophy to be able to express that and get that.
But usually, if you're writing Mojo code from scratch, you'll be using fn.
It depends. Again, it depends on your mentality. Right? It's not that def is Python and fn is Mojo. Mojo has both, and it loves both. Right? It really depends on. Yeah, exactly. Are you playing around and scripting something out? Is it a one-off throwaway script? Cool. Python is great at that.
I will still be using it.
Well, it's okay. Okay, also
Control. Power.
You also like suffering, right?
Yes. Go hand in hand.
How many pull-ups?
I've lost count with this.
Yeah, exactly.
So
and that's cool. I love you for that.
Yeah.
And I love other people who like strict things, right? But I don't want to say that that's the right thing, because Python's also very beautiful for hacking around and doing stuff and research and these other cases where you may not want that.
Yeah, I just feel like maybe I'm wrong with that, but it feels like strictness leads to faster debugging in terms of going from, even on a small project, from zero to completion. It's just, I guess it depends how many bugs you generate.
Yeah. Well, so I mean, it's again lessons learned and looking at the ecosystem. It's really, I think it's, if you study some of these languages over time, like the Ruby community, for example, Ruby is pretty well developed, pretty established community, but along their path, they really invested in unit testing. And so I think that the Ruby community has really pushed forward state of the art of testing because they didn't have a type system that caught a lot of bugs in compile time, right? And so you can have the best of both worlds. You can have good testing and good types, right, and things like this. But I thought that was really interesting to see how certain challenges get solved. And in Python, for example, the interactive notebook kind of experiences and stuff like this are really amazing. And if you typo something, it doesn't matter. It just tells you that's fine, right? And so I think that the trade-offs are very different if you're building a large-scale production system versus you're building and exploring a notebook.
Speaking of control, hilariously, if you look at the code I write just for myself for fun, it's like littered with asserts everywhere.
Yeah.
It's a kind of
Yeah, you like that.
it's like basically saying in a dictatorial way, this should be true now, otherwise everything stops.
And that is a sign. I'm looking at that is a sign of somebody who likes control.
Yeah.
And so yes, I think that you'll like. I think you'll like Mojo.
Yes, I definitely will. Speaking of asserts, exceptions are called errors. Why is it called errors?
So we use the same. We're the same as Python, right? But we implemented very differently, right? And so if you look at other languages, like we'll pick on C++, our favorite, right? C++ has this thing called zero cost exception. Yeah. So this is, in my opinion, something to learn lessons from.
It's a nice polite way of saying it.
And so zero cost exception handling, the way it works is that it's called zero cost because if you don't throw an exception, there's supposed to be no overhead for the non-error code, and so it takes the error path out of the common path. It does this by making throwing an error extremely expensive. And so if you actually throw an error with a C++ compiler using exceptions, let's go look up in tables on the side and do all this stuff. And so throwing an error can be like 10,000 times more expensive than returning it. Also, it's called zero cost exceptions, but it's not zero cost by any stretch of imagination because it massively bloats out your code, your binary. It also adds a whole bunch of different paths because of structures and other things like that.
I'll just say that I'm extremely vehement with
Reduce
regard to my
the
objection
all these
to
effects.
being used.
And so this thing that was called zero cost
That
exceptions, it really ain't. Okay. Now, if you fast forward to newer languages and this includes Swift and Rust and Go and now Mojo. Well, in Python it's a little bit different because it's interpreted, and so like it's got a little bit of a different thing going on. But if you look at compiled languages, many newer languages say, okay, well, let's not do that zero cost exception handling thing. Let's actually treat throwing an error the same as returning a variant, returning either the normal result or an error. Now, programmers generally don't want to deal with all the typing machinery and like pushing around a variant. And so you use all the syntax that Python gives us. For example, try and catch, functions that raise and things like this. You can put a raises decorator on your function, stuff like this. And if you want to control that, and then the language can provide syntax for it. But under the hood, the way the computer executes it, throwing an error is basically as fast as returning something.
This is exactly the same
And so this is actually, it's a fairly nerdy thing, right? Which is why I love it. But this has a huge impact on the way you design your APIs. Right? So in C++, huge communities turn off exceptions because the cost is just so high, right? And so the zero cost is so high, right? And so that means you can't actually use exceptions in many libraries. And even for the people who do use it, well, okay, how and when do you want to pay the cost? If I try to open a file, if I throw an error, well, what if I'm probing around looking for something, right? And I'm looking it up in many different paths. Well, if it's really slow to do that, maybe I'll add another function that doesn't throw an error, returns an error code instead, and I have two different versions of the same thing, and so it causes you to fork your API. And so, one of the things I learned from Apple and I still love is the art of API design is actually really profound. I think this is something that Python's also done a pretty good job at in terms of building out this large scale package ecosystem is about having standards and things like this. And so, we wouldn't want to enter a mode where, there's this theoretical feature that exists in the language, but people don't use it in practice. Now, I'll also say one of the other really cool things about this implementation approach is that it can run on GPUs and it can run on accelerators and things like this. That standard zero-cost exception thing would never work on an accelerator. So this is also part of how Mojo can scale all the way down to like little embedded systems and running
greater access.
Can you actually say about
Intelligence about what
maybe is there some high-level way to describe the challenge of exceptions and how they work in code for compilation? It's just this idea of calculating up a thing, an error.
Yeah, so the way to think about it is, think about a function that doesn't return anything. Right? So you have function 1 calls function 2, calls function 3, calls function 4. Along that call stack, there are try blocks. And so if you have function 1 calls function 2 has a try block, and then within it, it calls function 3. Right? Well, what happens if function 3 throws? Well, actually, start simpler. What happens with return? Well, the return is supposed to go back out and continue executing and then fall off the bottom of the try block. That's good. If the function throws, you're supposed to exit the current function and then get into the exception class, right? And then do whatever code's there, and then follow on. And so the way that how Mojo works is that the call to that function, which happens in the exception block, calls the function, and then instead of returning nothing, it actually returns a variant between nothing and an error. And so if you return normally, at the bottom of your return, you return nothing. If you throw an error, you return the variant that is an error. Right? So when you get to the call, you say, okay, cool, I call the function. Hey, I know locally I'm in a try block. Right? So I call the function and then I check to see what it returns. Aha, if it's that error thing, jump to the exception.
And that's all done for you behind the scenes.
Exactly. And I mean, one of the things if you dig into how this stuff works in Python, because it's a little bit more complicated because you have finally blocks. Now you need to go into do some stuff. Those can also throw and return.
Wait, what?
Yeah, I didn't like the stuff matters for ability. Like there's nesting, there's with clauses, and so with clauses are kind of like finally blocks with some special stuff going on, and so there's
Nesting in general, nesting of anything, nesting of function should be illegal. It just feels like it adds a level of complexity.
Like I'm merely an implementer, and so this is again, one of the trade-offs you get when you decide to go superset is you get to implement a full fidelity implementation of the thing that you decided is good. And so, yeah, I mean we can complain about the reality of the world, we can shake our fists.
It always feels like you shouldn't be allowed to do that, like to declare function inside function. Inside function.
Wait. What happened to that?
No, I understand that, but this is what I used to do in college.
So now you've grown up.
Yeah, we've all done things in college.
Wait a second.
I love this.
Okay, I was gonna say you're afraid of me. You're taking whole
It worked as a joke in my head.
Yeah. So nested functions are, joking aside, actually really great for certain things, right? And so these are also called closures. Closures are pretty cool, and you can pass callbacks and a lot of good patterns. And
so speaking of which, I don't think you have nested functions implemented yet in Mojo.
We don't have lambda syntax, but we do have nested syntax.
So there's a few things on the roadmap that you have that would be cool to sort of just fly through because it's interesting to see, how many features there are in the language, small and big.
Yep.
You have to implement.
Yeah.
So first of all, there's tuple support, and that has to do with some very specific aspects of it, like the parentheses or not parentheses. That.
Yeah, this is just totally a syntactic
thing. Okay, it's cool still. So keyword arguments and functions.
Yeah, so this is where in Python you can say call a function x equals 4, and x is the name of the argument.
That's a nice sort of documenting, self-documenting feature.
Yeah, I mean, again, this isn't rocket science to implement. It's just the logic.
It's just on the list.
The bigger features are things like traits. So traits are when you want to define abstract. So when you get into typed languages, you need the ability to write generics. So you want to say, I want to write this function, and now I want to work on all things that are arithmetic-like. Well, what is arithmetic-like? Well, arithmetic-like is a categorization of a bunch of types. And so you can define it in different ways, and I'm not going to go into ring theory or something. But you can say it's arithmetic-like if you can add, subtract, multiply, divide it. And so what you're saying is there's a set of traits that apply to a broad variety of types. And so there are all these types of arithmetic-like, all these tensors, and floating point integer, and like there's this category of types. And then I can define on an orthogonal axis algorithms that then work against types that have those properties. And so this is it's a widely known thing in Swift and the rest of many languages, so it's not Haskell, which is where everybody learns their tricks from. But when you implement that, that'll enable a new level of expressivity.
So classes.
Yeah, classes are a big deal.
It's a big deal. Still to be implemented. Like you said, Lambda syntax. And there's like detailed stuff like call module import, support for top level code or file scope, and then global variables also. So being able to have variables outside of the top level.
Well, and so this goes back to the where Mojo came from and the fact it's 0.1. Right? And so we're building, so Mojo is building an AI stack. Right, and an AI stack has a bunch of problems working with hardware and writing high-performance kernels and doing this kernel fusion thing I was talking about and getting the most out of the hardware. And so we've really prioritized and built Mojo to solve Mojo's problem. Right now, our North Star is build out and support all the things, and so we're making incredible progress. By the way, Mojo's only like 7 months old, so it's another interesting thing.
I mean, part of the reason I wanted to mention some of these things is like there's a lot to do, and it's pretty cool how you kind of sometimes you take for granted how much there is in the programming language, how many cool features you kind of rely on, and this is kind of a nice reminder when you lay it as a to-do list.
Yeah, and so, I mean, but also you look into, it's amazing how much is also there. I mean, you take it for granted that a value, if you define it, it will get destroyed automatically. Like that little feature itself is actually really complicated, given the way the ownership system has to work. And the way that works within Mojo is a huge step forward from what Rust and Swift have done.
But can you say again, when value, when you define it, gets destroyed on
Yeah, so like say you have a string. So you define a string on the stack. Whatever that means, like in your local function. Right? And so you say, like, whether it be in a def, so you just say x equals hello world, right? Well, if your string type requires you to allocate memory, then when it's destroyed, you have to deallocate. So in Python and in Mojo, you define that with the del method. Right? Where does that get run? Well, it gets run sometime between the last use of the value and the end of the program. Like in this, you now get into garbage collection, you get into like all these long debated, you talk about religions and trade-offs and things like this. This is a hugely hotly contested world. If you look at C++, the way this works is that if you define a variable or a set of variables within a function, they get destroyed in a last in, first out order. So it's like nesting. Okay? This has a huge problem because if you have a big scope, you find a whole bunch of values at the top, and then you use them, and then you do a whole bunch of code that doesn't use them, they don't get destroyed until the very end of that scope. And so this also destroys tail calls, it's functional programming, right? This has a bunch of different impacts on, you talked about reference counting optimizations and things like this, a bunch of very low-level things. And so what Mojo does is it has a different approach on that from any language I'm familiar with. It destroys them as soon as possible. And by doing that, you get better memory use, you get better stability, you get tail calls that work, you get a bunch of other things, you get better ownership tracking. There's a bunch of these very simple things that are very fundamental, that are already built in Mojo today, that are the things that nobody talks about generally, but when they don't work right, you find out and complain about.
Is it trivial to know what's as soon as possible to delete a thing that's not going to be used again?
Yeah, well, I mean, it's generally trivial. It's after the last use. So if you find X is string, and then you have some use of X in like a code
Within that scope, I mean, within the scope that is acceptable?
yeah, exactly. So you can only use something within it. And so then it doesn't wait until the end of the scope to delete it, and it destroys it afterlife.
So there's kind of some very eager machine that's just sitting there and deleting.
Yeah, and it's all in the compiler, so it's not running. It's also, and so, yeah, and so what, and this is actually non-trivial because you have control flow. And so it gets complicated pretty quickly and stuff, but like getting this right was not.
Also, you have to insert delete like in a lot of places.
Potentially, yeah. Definitely. So the compiler has to reason about this. And this is where, again, it's experience building languages and not getting this right. So, again, you get another chance to do it, you get basic things like this right. But it's extremely powerful when you do that. Yeah. And so there's a bunch of things like that that can combine together. And this comes back to the, you get a chance to do it the right way, do it the right way, and make sure that every brick you put down is really good, so that when you put more bricks on top of it, they stack up to something that's beautiful.
But there's also, like, how many design discussions do there have to be about particular details, like implementation of a particular small feature? Because the features that seem small, I bet some of them might be like really require really big design.
Yeah. Well, so I mean, let me give you another example of this. Python has a feature called async await. So it's a new feature. I mean, in the long run history, it's an relatively new feature, right? That allows way more expressive asynchronous programming. Again, this is a Python's a beautiful thing, and they did things that are great for Mojo for completely different reasons. The reason that async await got added to Python, as far as I know, is because Python doesn't support threads. Okay, and so Python doesn't support threads, but you want to work with networking and other things like that that can block. I mean, Python does support threads; it's just not its strength. And so they added this feature called async await. It's also seen in other languages like Swift and JavaScript and many other things as well. Async await in Mojo is amazing. It has a high-performance heterogeneous compute runtime underneath the covers that then allows non-blocking I/O to get full use of your accelerator. That's huge, turns out. It's actually a really important part of fully utilizing the machine. You talk about design discussions. That took a lot of discussion, right? And it probably will require more iteration. And so my philosophy with Mojo is that we have a small team of really good people that are pushing forward, and they're very good at the extremely deep knowing how the compiler and runtime, like all the low-level stuff works together. They're not perfect. Same thing as the Swift team. Right? This is where one of the reasons we released Mojo much earlier is so we can get feedback. We've already renamed a keyword due to community feedback. We use an ampersand, and now it's named now. We're not renaming existing Python keywords. That breaks compatibility. Right? We're renaming things we're adding and making sure that they are designed well. We get usage experience. We iterate and work with the community because, again, if you scale something really fast and everybody writes all their code and start using it in production, then it's impossible to change. And so you want to learn from people, you want to iterate and work on that early on. This is where design discussion is actually quite important.
Could you incorporate an emoji into the language, into the main language?
I could.
Do
you have a favorite one?
Well, I really like just raw flow, whatever, rolling in the floor laughing. So that could be like what would that be? The use case for that, like an exception, throw an exception of some sort.
Fully file it.
It was actually the information about
Or maybe a hard one.
It has to be a hard one.
People told me that I'm insane, so this is. I'm liking this.
I'm gonna use the viral nature of the internet to actually get this past.
I mean, it's funny you come back to the flame emoji file extension, right? We have the option to use the flame emoji, which just even that concept goes, for example, to people who get up and say, now I've seen everything.
Yeah, there's something it kind of it's reinvigorating. It's like, oh, that's possible. That's really cool. For some reason, that makes everything else
I
seem
think
really
the
exciting.
world is ready for this stuff. And so, when we have a package manager, we'll clearly have to innovate by having the compiled package thing be the little box with the on it, right? I mean, it has to be done.
It has to be done. Is there some stuff on the roadmap that you're particularly stressed about or excited about that you're thinking about a lot?
I mean, as a today snapshot, which will be obsolete tomorrow, the lifetime stuff is really exciting. And so lifetimes give you safe references to memory without dangling pointers. And so this has been done in languages like Rust before, and so we have a new approach, which is really cool. I'm very excited about that. That'll be out to the community very soon. The traits feature is really a big deal, and so that's blocking a lot of API design, and so there's that. I think that's really exciting. A lot of it is these kind of table stakes features. One of the things that is, again, also lessons learned with Swift, is that programmers in general like to add syntactic sugar. And so it's like, oh, well, this annoying thing, like in Python, you just go under add, FNH plus, def plus, come on, why can't I just do that, right? And so, trivial bit of syntactic sugar, it makes sense, beautiful, it's obvious. We're trying not to do that. And so, for two different reasons, one of which is that, again, lesson learned with Swift has a lot of syntactic sugar. Maybe a good thing, maybe not, I don't know. But because it's such an easy and addictive thing to do, sugar, makes your blood get crazy, right? The community will really dig into that and want to do a lot of that, and I think it's very distracting from building core abstractions. Second is we want to be a good member of the Python community, right? And so we want to work with the broader Python community, and yeah, we're pushing forward a bunch of systems programming features, and we need to build them out to understand them. So once we get a long ways forward, I want to make sure that we go back to the Python community and say, okay, let's do some design reviews. Let's actually talk about this stuff. Let's figure out how we want this stuff all to work together. Syntactic sugar just makes all that more complicated.
And list comprehension, yes, it is implemented. And dictionaries.
Yeah, there's some basics. 0.1. Yeah, but nonetheless, it's actually still quite interesting and useful.
As you mentioned, modular is very new. Mojo is very new. It's a relatively small team.
Yeah.
It's building up this gigantic stack, this incredible stack that's going to perhaps define the future of development of our AI overlords.
We just hope it will be useful.
As do all of us. So what have you learned from this process of building up a team? Maybe one question is, how do you hire great programmers, great people that operate in this compiler, hardware, machine learning, software, interface design space?
Yeah,
I mean, they are a little bit fluid.
Yeah.
What they can do.
So
Language design.
So building a company is just as interesting in different ways as building a language. Different skill sets, different things, but super interesting. And I've built a lot of teams in a lot of different places. If you zoom in from the big problem into recruiting, well, so here's our problem. Okay. I'll be very straightforward about this. We started modular with a lot of conviction about we understand the problems, we understand the customer pain points. We need to work backwards from the suffering in the industry, and if we solve those problems, we can use our people. The problem is that people we need to hire, as you say, are all these super specialized people that have jobs at big tech corps, right? And I don't think we have product market fit in the way that a normal startup does, or we don't have product market fit challenges. Because right now everybody's using AI and so many of them are suffering and they want help. And so again, we started with strong conviction. Now, again, you have to hire and recruit the best, and that's all our jobs. And so what we've done is we said, okay, well, let's build an amazing culture. Start with that. That's usually not something a company starts with. Usually you hire a bunch of people and then you start fighting and gigantic mess, and then you try to figure out how to improve your culture later. My co-founder Tim in particular is super passionate about making sure that that's right, and we spend a lot of time early on to make sure that we can scale.
Can you comment, sorry, before we get to the second, what makes for a good culture?
So, I mean, there's many different cultures, and I've learned many things from
Hey,
many
you worked
different.
with several very unique, almost famously unique cultures.
And some of them I learned what to do, and some of them I learned what not to do. Okay? And so we want an inclusive culture. I believe in amazing people working together. And so I've seen cultures where you have amazing people and they're fighting each other. I see amazing people and they're told what to do. Like, thou shalt line up and do what I say. It doesn't matter if it's the right thing, do it. Right? And neither of these and I've seen people that have no direction, they're just kind of floating in different places. And they want to be amazing, they just don't know how. And so a lot of it starts with have a clear vision. So we have a clear vision of what we're doing. And so I kind of grew up at Apple in my engineering life, right? And so a lot of the Apple DNA rubbed off on me. My co-founder Tim also is like a strong product guy. And so what we learned is, I was taught at Apple that you don't work from building cool technology. You don't work from like come up with a cool product and think about the features you'll have in the big tech boxes and stuff like this. If you go talk to customers, they don't actually care about your product. They don't care about your technology. What they care about is their problem. Right? And if your product can help solve their problems, well, hey, they might be interested in that. Right? And so if you speak to them about their problems, if you understand and you have compassion, you understand what people are working with, then you can work backwards to building an amazing product.
So vision starts by finding problems.
And then you can work backwards in solving problems. And at Apple, like it's, I think, pretty famously said that, for every, there's 100 no's for every yes. I would refine that to say that there's 100 not yets for every yes. But famously, if you go back to the iPhone, for example, right, iPhone 1, many people laughed at it because it didn't have 3G, it didn't have copy and paste. And then a year later, okay, finally it has 3G, but it still doesn't have copy and paste. It's a joke. Nobody will ever use this product, blah, 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 right? Well, year 3, it had copy and paste, and people stopped talking about it, right? And so being laser focused and having conviction and understanding what the core problems are and giving the team the space to be able to build the right tech is really important. Also, you come back to recruiting, you pay well. Right, so we have to pay industry salaries, benefits, and things like this. That's a big piece. We're a remote first company, and so we have to. So remote first has a very strong set of pros and cons. On the one hand, you can hire people from wherever they are, and you can attract amazing talent even if they live in strange places or unusual places. On the other hand, you have time zones. On the other hand, you have everybody on the internet will fight if they don't understand each other, and so we've had to learn how to have a system where we actually fly people in. We get the whole company together periodically, and then we get work groups together.
There's an intimacy to the in-person brainstorming. I guess you lose, but maybe you don't. Maybe if you get to know each other well and you trust each other, maybe.
Well, so when the pandemic first hit, I'm curious about your experience too. The first thing I missed was having whiteboards. Right, those design discussions where I can high intensity work through things, get things done, work through the problem of the day, understand where you're on, figure out and solve the problem, and move forward. But we figured out ways to work around that now. All these screen sharing and other things like that we do. The thing I miss now is sitting down at a lunch table with the team. Spontaneous things like the coffee bar things and the bumping into each other and getting to know people outside of the transactional solve a problem over Zoom.
And I think there's just a lot of stuff that I'm not an expert at this. I don't know who is. Hopefully there's some people. There's stuff that somehow is missing on Zoom. Even with the whiteboard, if you look at that, if you have a room with one person at the whiteboard and there's 3 other people at a table, there's first of all, there's social aspect of that where you just shoot the shit a little bit, almost like
Yeah, as people are just kind of coming in and
that, but also while like it's a breakout discussion that happens for like seconds at a time, maybe an inside joke, it's like this interesting dynamic that happens. Like
you're bonding. Yeah.
You're bonding, but through that bonding, you get the excitement. There's certain ideas that are like complete bullshit, and you see that in the faces of others that you won't see necessarily on Zoom. Like something, it feels like that should be possible to do without being in person.
Well, I mean, being in person is a very different thing.
I don't.
It's worth it. It's like you can't always do it. And so again, we're still learning. We're all still learning. Like humanity as this new reality, right? But what we found is that getting people together, whether it be a team or a company or whatever, is worth the expense because people work together and are happier after. Like it just like there's a massive period of time where you're like, well, things start getting great, put people together, and then you realize that we're all working together, we see things the same way, we work through the disagreement or misunderstanding, we're talking across each other, and then we work much better together. So things like that I think are really quite important.
What about people that are kind of specializing in different aspects of the stack working together? What are some interesting challenges there?
Yeah, well, so I mean, there's lots of interesting people, as you can tell, and hard to deal with too. But
you're one of the most lovely people.
So there's different philosophies in building teams. For me, and so some people say hire 10x programmers, and that's the only thing, whatever that means, right? What I believe in is building well-balanced teams that have people that are different in them. If you have all generals and no troops, or all troops and no generals, or you have all people that think in one way and not the other way, what you get is a very biased and skewed and weird situation where people end up right now. And so what I like to do is I like to build teams of people where they're not all the same. We do have teams that are focused on kind of compiler, GPU, or accelerator, or whatever the specialty is. So people bring a different take and have a different perspective. And I look for people that complement each other. And particularly if you look at leadership teams and things like this, you don't want everybody thinking the same way. You want people bringing different perspectives and experiences. And so I think that's really important.
That's team, but what about building a company as ambitious as Market? What's some interesting questions there?
Oh, I mean, so many. One of the things I love about Modular's the first company I built from scratch. One of the first things that was profound was I'm not cleaning up somebody else's mess. Right, and so if you look at
that's liberating.
It's super liberating, and also many of the projects I've built in the past have not been core to the product of the company. Swift is not Apple's product. Right? LAR is not Google's revenue machine or whatever. Right? It's not. It's important, but it's like working on the accounting software for the retail channel or something. Right? It's like enabling infrastructure and technology. And so Modular, the tech we're building, is here to solve people's problems. Like it is directly the thing. And so this is a really big difference in what it means for me as a leader, but also for many of our engineers, is they're working on the thing that matters. And that's actually pretty, again, for higher people and things like that, that's usually not the case, right? And so that's also pretty exciting and quite nice. But one of the ways that this manifests is it makes it easier to make decisions. And so one of the challenges I've had in other worlds is it's like, okay, well, community matters somehow for the goodness of the world. Like, sure, open source matters theoretically, but I don't want to pay for a t-shirt. Right, or some swag. Like, well, t-shirts cost $10 each. You can have 100 t-shirts for $1,000. To a megacorp, $1,000 is uncountably, can't count that way. Right, but justifying it and getting a t-shirt. If you'd like a t-shirt,
I would 100% like a t-shirt. Are you joking?
Emoji t-shirt.
I will treasure this. I will pass it down to my grandchildren.
It's very liberating to be able to decide, I think that I should have a t-shirt. Right? And it becomes very simple. Lex.
This is awesome. So I have to ask you about
That's why I was so interested.
one of the interesting developments with large language models is that they're able to generate code recently really well.
When I was interacting with
Yes.
To a degree that maybe
because we were literally on
I don't know if you understand, but I struggle to understand because it forces me to ask questions about the nature of programming, of the nature of thought,
to alter the
because
outcome of the game.
the language models are able to predict the kind of code I was about to write so well that it makes me wonder like how unique my brain is and where the valuable ideas actually come from, like how much they contribute in terms of ingenuity, innovation to code I write or design and that kind of stuff. When you stand on the shoulders of giants, are you really doing anything? And what LLMs are helping you do is they help you stand on the shoulders of giants in your program. There's mistakes. They're interesting that you learn from, but I just would love to hear your opinion first, high level, of what you think about this impact of large language models when they do program synthesis, when they generate code.
Yeah. Well, so I don't know where it all goes.
Yeah.
I'm an optimist. I'm a human optimist. I think that things I've seen are that a lot of the LLMs are really good at crushing leak code projects, and they can reverse the linked list like crazy. Well, it turns out there's a lot of instances of that on the internet, and it's a pretty stock thing. And so if you want to see standard questions answered, LLMs can memorize all the answers, and that can be amazing. And also, they do generalize out from that, and so there's good work on that. But I think that in my experience building something like Mojo, where you talk about these things, we talk about building an applied solution to a problem. It's also people. It's about understanding the problem. What is the product you want to build? What are the use cases? What are the customers? You can't just go survey all the customers because they'll tell you that they want a faster horse. Maybe they need a car, right? And so a lot of it comes into, I don't feel like we have to compete with LLMs. I think they'll help automate a ton of the mechanical stuff out of the way. And just like, I think we all try to scale through delegation and things like this, delegating rote things to an LLM, I think is extremely valuable and approach that will help us all scale and be more productive.
But I think it's a fascinating companion.
But I'd say I don't think that means that we're going to be done with coding.
But there's power in it as a companion. And from there, I would love to zoom in onto Mojo a little bit. Do you think about that? Do you think about LLMs generating Mojo code and helping sort of like design your programming language? It almost seems like, man, it would be nice to sort of almost as a way to learn how I'm supposed to use this thing for them to be trained on some of the code.
So I do lead an AI company, so maybe there'll be a Mojo LLM at some point. But if your good question is like, how do we make a language to be suitable for LLMs? Yeah, I think that the cool thing about LLMs is you don't have to, right? And so if you look at what is English or any of these other terrible languages that these humans deal with on a continuous basis, they're never designed for machines. And yet they're the intermediate representation. They're the exchange format that we humans use to get stuff done, right? And so these programming languages, they're an intermediate representation between the human and the computer, like the human and the compiler, roughly, right? And so I think the LLMs will have no problem learning whatever keyword we pick.
Maybe the file emoji is gonna.
Maybe that's what break it. Doesn't tokenize.
No, reverse of that, it will actually enable it, because one of the issues I could see with being a superset Python is there would be confusion about the gray area. So it would be mixing stuff.
But I'm a human optimist and want to send LLM optimist. I think people solve that problem. But you look at that and you say, okay, well, reducing the rote thing, right? Turns out compilers are very particular, and they really want things. They really want the indentation to be right. They really want the colon to be there on your else, or else it'll complain, right? I mean, compilers could be better at this, but LLMs can totally help solve that problem. So I'm very happy about the new predictive coding and compiler type features and things like this, because I think it'll all just make us more productive.
It's still messy and fuzzy and uncertain, unpredictable. So, but is there a future you see, given how big of a leap GPT-4 was, where you start to see something like LLMs inside the compiler?
I mean, you could do that. Yeah, absolutely. I mean, I think that'd be interesting.
Otherwise,
Well, I mean, it would be very expensive. So compilers run fast and they're very efficient, and LLMs are currently very expensive. There's on-device LLMs and there's other things going on, and so maybe there's an answer there. I think that one of the things that I haven't seen enough of is that, so LLMs to me are amazing when you tap into the creative potential of the hallucinations, right? And so if you're doing creative brainstorming or creative writing or things like that, the hallucinations work in your favor. If you're writing code that has to be correct because you're going to ship into production, then maybe that's not actually a feature. And so I think that there has been research and there has been work on building algebraic reasoning systems and kind of like figuring out those things that feel like truths. And so I think that there could be interesting work in terms of building more reliable at scale systems, and that could be interesting. But if you chase that rabbit hole down, the question then becomes, how do you express your intent for change? And so maybe you want LLM to provide the spec, but you have a different kind of net that then actually implements the code.
right, so it's to use the documentation and inspiration versus the actual implementation.
Yeah, actually.
Since a successful modular will be the thing that runs, I say so jokingly, our AI overloads, but AI systems that are used across, I know it's a cliche term, but Internet of Things, so across.
So I'll do it and say, like, AGI should be written in Mojo.
Yeah, AGI should be written in Mojo. You're joking, but it's also possible that it's not a joke. That a lot of the ideas behind Mojo's seems like the natural set of ideas that would enable at scale training and inference of AI systems. So just have to ask you about the big philosophical question about human civilization. The folks like Eliezer Yudkowsky are really concerned about the threat of AI. Do you think about the good and the bad that can happen at scale deployment of AI systems?
Well, so I've thought a lot about it, and there's a lot of different parts to this problem, everything from job displacement to Skynet, things like this. And so you can zoom into subparts of this problem. I'm not super optimistic about AGI being solved next year. I don't think that's going to happen personally.
So you have a kind of zen-like calm about it. Because there's a nervousness because the leap of GPT-4 seemed so big.
Sure.
It's like there's some kind of transitionary period. You're thinking.
Well, so I mean, there's a couple of things going on there. One is I'm sure GPT-5 and 7 and 19 will be also huge leaps. They're also getting much more expensive to run. And so there may be a limiting function in terms of just expense on the one hand and train. Like that could be a limiter that slows things down. But I think the bigger limiter is outside of like Skynet takes over, and I don't spend any time thinking about that because if Skynet takes over and kills us all, then I'll be dead. So I don't worry about that. So, I mean, that's just okay. I have other things to worry about. I'll just focus on.
Yeah.
I'll focus and not worry about that one. But I think that the other thing I'd say is that AI moves quickly, but humans move slowly. We adapt slowly. And so what I expect to happen is just like any technology diffusion, like the promise and then the application takes time to roll out. And so I think that I'm not even too worried about autonomous cars defining away all the taxi drivers. Remember, autonomy was supposed to be solved by 2020.
Boy, do I remember.
So like I think that on the one hand we can see amazing progress, but on the other hand we can see that the reality is a little bit more complicated and it may take longer to roll out than you might expect.
Well, that's in the physical space. I do think in the digital space is the stuff that's built on top of LLMs that runs, the millions of apps that can be built on top of them. And they could be run on millions of devices, millions of types of devices. Yeah. I just think that the rapid effect it has on human civilization could be truly transformative to it.
And there I think it depends on are you an optimist or a pessimist or a masochist.
Just to clarify, optimist about human civilization.
Me too. And so I look at that as saying, okay, cool, what will AI do? Right? And so some people say, oh my God, it's going to destroy us all. How do we prevent that? I kind of look at it from is it going to unlock us all? Right? You talk about coding. Is it going to make so I don't have to do all the repetitive stuff? Well, suddenly that's a very optimistic way to look at it. And you look at what a lot of these technologies have done to improve our lives, and I want that to go faster.
What do you think the future of programming looks like in the next 10, 20, 30, 50 years?
Yeah.
With LLMs and with Mojo, with modular, like the vision for devices, the hardware to the compilers to the different stacks of software.
Yeah. Well, so what I want, I mean, coming back to my arch nemesis, right? It's complexity, right? So again, me being the optimist, if we drive down complexity, we can make these tools, these technologies, these cool hardware widgets accessible to way more people, right? And so what I'd love to see is more personalized experiences, more things, the research getting into production instead of being lost at NeurIPS, right? And so, and like these things that impact people's lives by entering products. And so one of the things that I'm a little bit concerned about is right now, the big companies are investing huge amounts of money and are driving the top line of AI capability forward really quickly. But if it means that you have to have $100 million to train a model or more, $100 billion, right? Well, that's going to make it very concentrated with very few people in the world that can actually do this stuff. I would much rather see lots of people across the industry be able to participate and use this. Right? And you look at this, I mean, a lot of great research has been done in the health world, looking at like detecting pathologies and doing radiology with AI and like doing all these things. Well, the problem today is that to deploy and build these systems, you have to be an expert in radiology and an expert in AI. And if we can break down the barriers so that more people can use AI techniques, it's more like programming Python, which roughly everybody can do if they want to, right? Then I think that we'll get a lot more practical application of these techniques, a lot more nichier, cool but narrower domains. I think that's going to be really cool.
Do you think we'll have more or less programmers in the world now?
Well, so I think we'll have more programmers, but they may not consider themselves to be programmers.
That'd be a different name for it.
Right? I mean, do you consider somebody that uses, I think that arguably the most popular programming language is Excel.
Yeah.
Right? Yeah. And so do they consider themselves to be programmers? Maybe not. I mean, some of them make crazy macros and stuff like that, but what you mentioned Steve Jobs, it's the bicycle for the mind. It allows you to go faster, right? And so I think that as we look forward, right, what is AI? I look at it as hopefully a new programming paradigm. It's like object-oriented programming, right? If you want to write a cat detector, you don't use forwards. It turns out that's not the right tool for the job, right? And so right now, unfortunately, because, I mean, it's not unfortunate, but it's just kind of where things are, AI is this weird, different thing. It's not integrated into programming languages and the tool chains, and all the technology is really weird and doesn't work right, and you have to babysit it, and every time you switch,
Essentially, yes.
Shouldn't be that way. When you change that, when you fix that, suddenly, again, the tools and technologies can be way easier to use. You can start using them for many more things. So that's why I'm excited.
What kind of advice could you give to somebody in high school right now, or maybe early college, who's curious about programming and feeling like the world is changing really quickly here?
Yeah.
What kind of stuff to learn? What kind of stuff to work on? Should they finish college? Should they go work at a company? Should they build a thing? What do you think?
Well, so, I mean, one of the things I'd say is that you'll be most successful if you work on something you're excited by. And so don't get the book and read the book cover to cover and study and memorize and recite and flashcard and go build something. Like, go solve a problem. Go build the thing that you want to exist. Go build an app. Go train a model. Like, go build something, actually use it, and set a goal for yourself. If you do that, then you'll, there's the success, there's the adrenaline rush, there's the achievement, there's the unlock that I think is where, if you keep setting goals and you keep doing things and building things, learning by building is really powerful. In terms of career advice, I mean, everybody's different. It's very hard to get generalized advice. I'll speak as a compiler nerd. If everybody's going left, sometimes it's pretty cool to go right.
Yeah.
And so just because everybody's doing a thing, it doesn't mean you have to do the same thing and follow the herd. In fact, I think that sometimes the most exciting paths through life lead to being curious about things that nobody else actually focuses on. Right? And it turns out that understanding deeply parts of the problem that people want to take for granted makes you extremely valuable and specialized in ways that the herd is not. And so, again, I mean, there's lots of rooms for specialization, lots of rooms for generalists, there's lots of room for different kinds of parts of the problem, but I think that it's, just because everybody's doing one thing doesn't mean you should necessarily do it.
And now the herd is using Python, so if you want to be a rebel, go check out Mojo and help Chris and the rest of the world fight the arch nemesis of complexity. Because simple is beautiful.
There you go.
Chris, you're an incredible person. You've been so kind to me ever since we met. You've been extremely supportive. I'm forever grateful for that. Thank you for being who you are, for being legit, for being kind, for fighting this really interesting problem of how to make AI accessible to a huge number of people, a huge number of devices.
Yeah, well, so lecture, pretty special person too, right? And so I think that, one of the funny things about you is that besides being curious and pretty damn smart, you're actually willing to push on things. I think that you've got an agenda to make the world think, which I think is a pretty good agenda.
It's a pretty good one. Thank you so much for talking to me, Chris. Thanks for listening to this conversation with Chris Lackler. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Isaac Asimov. I do not fear computers. I fear the lack of them. Thank you for listening, and hope to see you next time.
Contact said there was a black box that came on one of the crabs. And I don't know if you're familiar with that black box. Did you have exposure to that as well?
It was something called the cube or the yellow mystery.
Okay, but then that was not glass. Was that yes?
The ribosome, like I mentioned a little while back, can make an elephant one molecule at a time. Ribosomes are slow. They run at about one molecule a second, but ribosomes make ribosomes. So you have trillions of them, and that makes an elephant. In the same way, these little assembly robots I'm describing can make giant structures at heart because of the robot can make the robot. So more recently, to my students Amira and Miana, had a Nature Communication paper showing how this robot can be made out of the parts it's making. So the robots can make the robots, so you build up the capacity of robotic assembly.
The following is a conversation with viralrabbi, the director of MIT's Center for Bits and Atoms, an amazing laboratory that is breaking down boundaries between the digital and physical worlds, fabricating objects and machines at all scales of reality, including robots and automata that can build copies of themselves and self-assemble into complex structures. His work inspires millions across the world as part of the maker movement to build cool stuff, to create, the very act that makes life so beautiful and fun. This is the Let's Begin podcast. To support it, please check out our sponsors in the description. And now, dear friends, here's Neil Gershenfeld. You have spent your life working at the boundary between bits and atoms, so the digital and the physical. What have you learned about engineering and about nature reality from working at this divide, trying to bridge this divide?
I learned why von Neumann and Turing made fundamental mistakes. I learned the secret of life. Yes. I learned how to solve many of the world's most important problems, which all sound presumptuous, but all of those were things I learned.
Okay, so Turing and von Neumann, let's start there. Some of the most impactful, important humans who have ever lived in computing. Why were they wrong?
So I worked with Andy Gleason, who was Turing's counterpart. So just for background, if anybody doesn't know, Turing is credited with the modern architecture of computing, among many other things. Andy Gleason was his U.S. counterpart. And you might not have heard of Andy Gleason, but you might have heard of the Hilbert problem. And Andy Gleason solved the fifth one. So he was a really notable mathematician. During the war, he was Turing's counterpart. Then von Neumann is credited with the modern architecture of computing, and one of his students was Marvin Minsky. So I could ask Marvin what Johnny was thinking, and I could ask Andy what Alan was thinking. And what came out from that, what I came to appreciate as background, I never understood the difference between computer science and physical science. But Turing's machine, that's the foundation of modern computing, has a simple physics mistake, which is the head is distinct from the tape. So in the Turing machine, there's a head that programmatically moves and reads and writes the tape. The head is distinct from the tape, which means persistence of information is separate from interaction with information. Then von Neumann wrote deeply and beautifully about many things, but not computing. He wrote a horrible memo called the first draft of a report on the EDVAC, which is how you program a very early computer. In it, he essentially roughly took Turing's architecture and built it into a machine. So the legacy of that is the computer somebody's using to watch this is spending much of its effort moving information from storage transistors to processing transistors, even though they have the same computational complexity. So in computer science, when you learn about computing, there's a ridiculous taxonomy of about 100 different models of computation, but they're all fictions. In physics, a patch of space occupies space. It stores state, it takes time to transit, and you can interact. That is the only model of computation that's physical. Everything else is a fiction. So I really came to appreciate that a few years back when I did a keynote for the annual meeting of the supercomputer industry, and then went into the halls and spent time with the supercomputer builders, and came to appreciate. See, if you're familiar with the movie The Metropolis, people would frolic upstairs in the gardens, and down in the basement, people would move levers. And that's how computing exists today, that we pretend software is not physical, it's separate from hardware. And the whole canon of computer science is based on this fiction that bits aren't constrained by atoms. But all sorts of scaling issues in computing come from that boundary, but all sorts of opportunities come from that boundary. And so you can trace it all the way back to Turing's machine making this mistake between the head and the tape. Von Neumann, he never called it von Neumann's architecture. He wrote about it in this dreadful memo. Then he wrote beautifully about other things we'll talk about. Now, to end a long answer, Turing and von Neumann both knew this. So all of the canon of computer scientists credits them for what was never meant to be a computer architecture. Both Turing and von Neumann ended their life studying exactly how software becomes hardware. So von Neumann studied self-reproducing automata, how a machine communicates its own construction. Turing studied morphogenesis, how genes give rise to form. They ended their life studying the embodiment of computation, something that's been forgotten by the canon of computing, but developed sort of off to the sides by a really interesting movie.
So there's no distinction between the head and the tape in the computer and the computation. It is all computation.
Right. So I never understood the difference between computer science and physical science. And working at that boundary helped lead to things like my lab was part of doing, with a number of interesting collaborators, the first test within classical quantum computation. We were part of a collaboration creating the minimal synthetic organism you design life in a computer. Those both involve domains where you just can't separate hardware from software. The embodiment of computation is embodied in these really profound ways.
So the first quantum computation, synthetic life in the space of biology, the space of physics at the lowest level, the space of biology at the lowest level. So let's talk about CBA, Center of Bits and Atoms. What's the origin story of this MIT, the legendary MIT center that you're a part of creating?
In high school, I really wanted to go to vocational school where you learn to weld and fix cars and build houses. And I was told, no, you're smart, you have to sit in the room. And nobody could explain to me why I couldn't go to vocational school. I then worked at Bell Labs, this wonderful place before deregulation, legendary place. And I would get union grievances because I would go into the workshop and try to make something. And they would say, no, you're smart, you have to tell somebody what to do. And it wasn't until MIT, and I'll explain how CBA started, but I could create CBA, that I came to understand this is a mistake that dates back to the Renaissance. So in the Renaissance, the liberal arts emerged. And liberal doesn't mean politically liberal, which was the path to liberation versus humanism. And so the liberal arts were the trivium, quadrivium, roughly language, natural science. And at that moment, what emerged was this dreadful concept of the illiberal arts. So anything that wasn't the liberal arts was for commercial gain and was just making stuff and wasn't valid for serious studies. And so that's why we're left with learning to weld wasn't a subject for serious study. But the means of expression have changed since the Renaissance. So micro machining or embedded coding is every bit as expressive as painting a painting or writing a sonnet. So never understanding this difference between computer science and physical science, the path that led me to create CBA with colleagues was I was what's called a junior fellow at Harvard. I was visiting MIT through Marvin because I was interested in the physics of musical instruments. This will be another slight digression. In Cornell, I would study physics, and then I would cross the street and go to the music department where I played the bassoon, and I would trim reeds and play the reeds. And they'd be beautiful, but then they'd get soggy. And then I discovered in the basement of the music department at Cornell was David Gordon, who you might not have heard of, but is legendary in electronic music because he was really the first electronic musician. So Bob Moog, who invented Moog synthesizers, was a physics student at Cornell, like me crossing the street. And eventually he was kicked out and invented electronic music. David Gordon was the first musician who created electronic music. So he's legendary for people like Phil Glass and Steve Wright. And so that got me thinking about, I would behave as a scientist in the music department, but not in the physics department, but not in the music department. Got me thinking about what's the computational capacity of a musical instrument. And through Marvin, he introduced me to Todd Backover at the Media Lab. He was just about to start a project with Yo-Yo Ma that led to a collaboration to instrument a cello, to extract Yo-Yo's data and bring it out into computational environments.
What is the computational capacity of the musical instrument? As we continue on this tangent, and then we shall return to CBA.
Yeah. So one part of that is to understand the computing. And if you look at like the finest time scale and length scale you need to model the physics, it's not heroic. A good GPU can do teraflops today. That used to be a national test supercomputer. Now it's just a GPU. And that's about, if you take the time scales and length scales relevant to the physics, that's about the scale of the physics computing. For Yo-Yo, what was really driving it was he's completely unsentimental about the Strad. It's not that it makes some magical wiggles in the sound waves. It's performance as a controller. How he can manipulate it as an interface device.
Interface between what and what exactly?
It came in sound. And so what it led to was, I had started by thinking about ops per second, but Yo-Yo's question was really resolution and bandwidth. It's how fast can you measure what he does? And the bandwidth and the resolution of detecting his controls and then mapping them into sound. And what he found was if you instrument everything he does and connect it to almost anything, it sounds like Yo-Yo. That the magic is in the control, not in ineffable details in how the wood wiggles. And so with Yo-Yo and Todd, that led to a piece. And towards the end, I asked Yo-Yo what it would take for him to get rid of his Strad and use our stuff. And his answer was just logistics. It was, at that time, our stuff was like a rack of electronics and lots of cables and some grad students to make it work. Once the technology becomes as invisible as the Strad, then sure, absolutely, he would take it. And by the way, as a footnote on the footnote, an accident in the sensing of Yo-Yo's cello led to a $100 million a year auto safety business to control airbags in cars. Oh, that way. I had to instrument the bow without interference, so I set up local electromagnetic fields where I would detect how those fields interact with the bow he's playing. But we had a problem that his hand, whenever his hand got near these sensing fields, it would start sensing his hand rather than the materials on the bow. And I didn't quite understand what was going on with that interference. So my very first grad student ever, Josh Smith, did a thesis on tomography with electric fields, how to see in 3D with electric fields. Then through Todd and at that time research scientist in my lab, Joe Paradiso, it led to a collaboration with Penn Teller, where we did a magic trick in Las Vegas to contact Houdini. And sort of these fields are sort of like contacting spirits. So we did a magic trick in Las Vegas, and then the crazy thing that happened after that was Phil Ritmuller came running into my lab. He worked with, this became with Honda and NEC, airbags for killing infants in rear-facing child seats. Cars need to distinguish a front-facing adult where you'd save the life versus a bag of groceries where you don't need to fire the airbag versus a rear-facing infant where you would kill it. And so the seat need to, in effect, see in 3D to understand the occupants. And so we took the Penn and Teller magic trick derived from Josh's thesis from Yo-Yo cello to an auto show, and all the car companies said, great, when can we buy it? And so that became Elysis, and it was a $100 million a year business making sensors. There wasn't a lot of publicity because it was in the car, so the car didn't kill you. So they didn't advertise, we have nice sensors so the car doesn't kill you, but it became a leading auto safety sensor.
And that started from the cello and the question of the computational capacity.
Right. Right. So now to get back to MIT, I was spending a lot of outside time at IBM research that had gods of the foundations of computing. There's amazing people there, and I'd always expected to go to IBM to take over a lab, but at the last minute pivoted and came to MIT to take a position in the Media Lab and start what became the predecessor to CBA. Media Lab is well known for Nicholas Negroponte. What's less well known is the role of Jerry Wiesner. So Jerry was MIT's president, before that Kennedy Science Advisor, grand old man of science. At the end of his life, he was frustrated by how knowledge was segregated. And so he wanted to create a department of none of the above, a department for work that didn't fit in departments. And the Media Lab, in a sense, was a cover story for him to hide a department. As MIT's president towards the end of his tenure, he said, I'm going to make a department for things that don't fit in departments. The departments were the screens. But everybody was sort of paying attention to Nicholas creating the Media Lab, and Jerry kind of hid in it a department called Media Arts and Sciences. It's really the department of none of the above. And Jerry explaining that, and Nicholas then confirming it, is really why I pivoted and went to MIT. Because my students who help create quantum computing or synthetic life get degrees from Media Arts and Sciences, this department of none of the above. So that led to coming to MIT with Todd and Joe Paradiso and my colleague. We started a consortium called Things That Think, and this was around the birth of Internet of Things and RFID. But then we started doing things like work we can discuss that became the beginnings of quantum computing and cryptography and materials and logic and microfluidics. And those needed much more significant infrastructure and were much longer research arcs. So with a bigger team of about 20 people, we wrote a proposal for the NSF to assemble one of every tool to make anything of the job. It was roughly a
One, any tool to make anything of any size.
So there's usually nanometers, micrometers, millimeters, meters are segregated, input and output is segregated. We wanted to look just very literally how
observation.
digital becomes physical,
I think that
physical becomes digital.
it is also
And fortunately, got NSF on a good day, and they funded this facility, one of almost every tool to make
They
anything.
have sustainability.
And so, with
Whereas
a group of core colleagues
awesome crops in the lower
that
latitude,
included Joe
you're also
Jacobson,
losing
Brian
a lot of the
Spinelli,
population of the third world,
we launched
which
EPA.
unfortunately, according to the way that
So you're talking about narrow scale,
some people
micro scale,
find them
nanostructures,
expendable.
microstructures,
We don't feel that
electron
way. I'm not
microscopes,
one
and
that likes
photons,
to
probes,
protect
and
some
nanostructures,
elements
laser,
at all. I
micron,
like state of
beam,
the
X-ray,
research.
microtomography
Well, at the
for
same time,
microstructures,
when we start
multi-axis
hearing
geometry, you print it
that
for
the codex is
microstructures.
being placed in place, which
What are you
actually
talking about?
limits
Scale? How can
food
we
value.
build tiny
Oh, you can have all the food you
big
want.
things
Starve to death while you're
Yeah,
eating.
so
There's no
a
nutrients.
well-equipped research lab has the
When
sort of
I
tools
start
we're
hearing that
talking
food is
about,
being used
but
as a
they're
weapon and it's
segregated
being
in
used
different
concerning
places. They're
concerning the use of
also
fossil fuels,
run by technicians,
I start getting
where you
personally
then have
angry.
an account
There's
and a
not one
project
person
in
in the
charge.
lower
All of
latitude
these tools are
any less than
essentially,
me.
when you don't know what to do, not
You
when
know,
you do know what to do.
everybody's worth
And that
exactly
they're
the same
running
thing on this
to
earth.
work across
You know,
the scale.
unfortunately,
Here we
there are
don't,
individuals who feel
once
otherwise.
projects are running in this facility, we don't
Okay, so
charge
Bill, you were asked,
time, we
now
don't
that
make
we
a
kind
formal
of, let's
proposal,
talk about,
schedule, and the users
first of
will
all, you
run the
mentioned
tool.
Will
And
you
so
have.
It was like
this kind of
a college party, like in Omaha. Oh, awesome.
Realize that it was actually, it was the sun you were saying.
Yes.
who had
working with
access to
projects
that
today,
technology.
working
Yes.
with today ranges from
Was the
developing
builder of the
jet fuel
avionics.
electronics for the lowest power computing to micromachining diamonds, taking 10 million RPM bearings for molecular spectroscopy studies, up to exploring robots to build 100-meter structures in space.
Okay, can we just
An ability to show when the
Let's start with the
future
biggest.
that is still.
What are some of the biggest stuff you're attempting to still have to build?
Sure. So, viewed from one direction, what we're talking about is a crazy random seeming of almost unrelated projects. But if you rotate 90 degrees, it's really just a core thought over and over again. Just very literally how bits and atoms relate, how digital, and it's just going from digital to physical in many different domains. But it's really just the same idea over and over again. So to understand the biggest thing,
An ability to show what the
let
future,
me go
but a
back
Stargate
to
or a
bring in
an
now
access
Shannon
to
as well as von Neumann.
is for time travel,
Yeah. So
right?
what
We're talking about
is
two different things.
Yes.
Are they using the same technology?
the actual
yes.
obvious answer is digital and one and zero.
The
But
original
that's
device
wrong. There's a much
was
deeper
the
answer,
Stargate
which is
device. That was then
Claude
increased in
Shannon
power.
at MIT wrote the best master's thesis ever.
How it pumped up
In
the
his
power, how
master's
it
thesis,
stabilized
he
it.
invented our modern notion of digital logic.
Physicists about that.
Where it came from was Vannevar Bush, who's a Randall man at MIT. He created
It
the
would be
post-war research
pumped up in
establishment that
power
the National Science
to
Foundation.
stabilize
And he made an
the
important
doorway
mistake.
to step through
But
into
he also made
another location.
the differential analyzer,
In essence,
which was
this
the last
was
great
China.
analog computer. So it was a room full
Same
of
thing,
gears and
stepped
pulleys,
into
and the
another
longer
time.
it ran, the worse the answer was.
The looking
And
glass device was back
Shannon
engineered
worked on it as a student, and he got so annoyed
So it
in
was
his
actually
master's
back
thesis
engineered
he invented
from the original
logic.
cylinder seal data,
But
which allowed us
he then went on to
use
Bell Labs, and what he did there
Stargate access
was
devices.
communication was beginning to expand.
Um,
There was more demand
it's
for
a back
phone lines.
engineered device.
And so there's a question
Looking glass
about
is a secondary
how many
device,
phone lines
and it was coming
phone
into
messages
its
you could send down the wire.
core in the 60s
And
and
you could try to just make it better and better. He asked the question nobody had asked, which is rather than make it better and better, what's the limit of this? And he proved a couple things, but one of the main things he proved was a threshold theorem for channel capacity. And so
he saw one of the
what he
original
showed
looking
was
glasses
my voice to you
demonstrated,
right now is coming
and
as a
back
wave present.
it's
And
going
the
to be in
further
the
you
DVD
get, the
that
worse it
we're
sounds. But
getting ready
people
to
watching
put
this
out the
are
actual
getting it
interview,
as
where
input
he was
packets of
indicating
data coming out.
I believe it was through an
When they
object.
when the computer
And,
for watching this gets the packet
There was
of
a
information,
time delay when the bullet actually
it
passed through the
can
object.
detect and
Saw the
correct
bullet
an error.
pass
And
the
what
object.
Shannon showed is
projectile.
if the noise in the cable to the people watching
Yeah, it was a rail gun. It was
is
being
above a
used.
threshold.
And then afterward,
But if
they
the
saw
noise
the
is
impact.
below a threshold,
of the device.
for a
So they were
linear
already
increase
playing with it
in the
early
energy
70s,
representing our
early
conversation,
70s.
the error rate goes down
types of
exponentially.
This is the original living
Exponentials are
class.
fast. There's very few of them in engineering.
Back engineered from
And the exponential reduction of error below a threshold, if you
Yes.
your state, is called the threshold theorem.
but
That's
it
what led
also
to digital. That means
there were also
unreliable.
there was
things
information
unreliable.
around the cylinder
So
seals
Shannon did that for
that they
Then
used
Von
as
Neumann
also, and that
was
those
inspired
cylinder
by
seals
that
also
and
came
applied
from
it to computation. And
an
he showed how an
off-race.
unreliable computer can operate reliably by using the same threshold property of restoring state. It was then forgotten many years. We had to rediscover it in effect in the quantum computing era, when things were very unreliable again. But now to go back to how does this relate to the biggest things?
I really shouldn't go.
So
But it was off-world
in
technology,
fabrication,
original.
MIT invented computer controlled manufacturing in 1952. Jet aircraft were just emerging.
Yes.
There was
That's
a
when they
limit
started
to
actually
turning cranks on a
being,
machine, on a milling machine to
showing
make
a lot
parts for jet aircraft.
interest.
Now, this is a messy story. MIT actually stole computer control machines from the inventor who brought it to MIT. Wanted to do a joint project with the Air Force, and MIT effectively stole it from him. So, kind of a messy history.
There's
But
also R. Henry
that sounds like the birth of
contact
computer
said there was
control
a black
machines
box
in
that came on
1952.
one of the crafts.
There are a number of
And I don't know if you're
inventors
familiar
of
with that
3D
black box.
printing.
Did you
One of
have
the
exposure to
companies
that as
spun
a
off from my
well?
lab by Max Lobach's Form Lab, which is now a $1 billion 3D printing company. That's the modern
That was
version.
not in the original
But
labs.
all of that's analog, meaning the information in the control computer, there's no information in the material. And so it goes back to Vannevar Bush's analog computer. If you make a mistake in printing or machining, just a mistake accumulates. The real birth of computerized digital manufacturing is 4 billion years ago. That's the evolutionary age of the ribosome. So the way you're manufactured is there's a code that describes you, the metacode. It goes to a micro machine, the ribosome, which is this molecular factory that builds the molecules that are you. The key thing to know about that is there are about 20 amino acids that get assembled. And in that machinery, it does everything Shannon and Von Neumann taught us. You detect and correct errors. So if you mix chemicals, the error rate is about a part per 100. When you make elongated protein in the ribosome, it's about a part per 10 to the 4. When you replicate DNA, there's an extra level of error correction. It's a part per 10 to the 8. And so in the molecules that make you can detect and correct errors, and you don't need a ruler to make you. The geometry comes from the parts. So now, compare a child playing with Lego and a state-of-the-art 3D printer or computerized milling machine. The tower made by a child is more accurate than the motor control because the act of snapping the bricks together gives you a constraint on the drawing. You can join bricks made out of dissimilar materials. You don't need a ruler for Lego because the geometry locally gives you the
During the
parts. And there's no Lego crash. The parts have enough information.
I was asked to supply.
Those are exactly the properties of a digital code.
Unreliable is major now.
Yes, absolutely. So, what the ribosome figured out 4 billion years ago is how to embody these digital properties, but not for communication or computation in effect, but for construction. So, a number of projects in my lab have been putting the idea of digital material. And think of a digital material just as Lego bricks. The precise meaning is a discrete set of parts reversibly joined with local geometry determined from local constraints. And so it's digitizing the materials. And so I'm coming back to what are the biggest things I've made. My lab was working with the aerospace industry. So here at Aero was Boeing's factory. They asked us how to join composites. When you make a composite airplane, you might use giant wing and fuselage parts. And they asked us for a better way to stick them together because the joints were a case of failure. And what we discovered was instead of making only big parts, if you make little loops of carbon fiber and you reversibly link them in joints. And you do it in a special geometry that balances being under-constrained and over-constrained. It's just the way to use the freedom. We set the world record for the highest modulus ultralight material, just by, in effect, making carbon fiber Lego. So lightweight materials are crucial for energy efficiency, because that's the lightest weight high modulus material. We then show that with just a few part types, we can tune the material properties, and then you can create really wild robots that instead of having a tool the size of a jumbo jet to make a jumbo jet, you can make little robots that walk on these cellular structures to build the structures, where they error correct their position on the structure and they navigate on the structure. And so using all of that,
This is true, and
NASA, we made morphing airplanes. A former student, Kenny Chung, made a morphing airplane the size of NASA Langley because wind tunnel. With Toyota, we've made
I'll just say that I'm
race
extremely
cars.
vehement with
We're
regard
right
to
now
my
looking at
objection
projects with NASA to build
because
these for things like space
apparently that
telescopes,
vehemence
space
was
habitats,
sufficient to skew
where
image
the
of
ribosome, who I mentioned a little while back, can make an elephant one molecule at a time. Ribosomes are slow; they run at about one molecule a second. But ribosomes make ribosomes, so you have thousands of them. That's trillions of them, and that makes an elephant. In the same way, these little assembly robots describing can make giant structures.
The future
At
of
heart,
Lotus
because of the robots can make the robots. So more recently,
once
to my
it's
students
run
Samira and Liana,
by
had a latest communication paper showing how this robot can be made out of the parts it's making.
concerning the future
So
of
the
Lotus
robots can make the robot, so you build up the capacity of robotic assembly.
Self-replicate. You
was
ring around
given
what that robot
as
looks like. What is a
information.
robot to walk along and do error
Personally
correction?
see it now.
What is a
I was
robot
told
that can
I was told
self-replicate
that was during the early years.
from
I
the
think the
materials that
early
is
years of
given?
Lotus.
What does that
Been
look
going
like?
on
What do
for
we
6
have?
years now.
It's
But
fascinating.
this
The
was
answer is
the latter half of
different at different
2001.
scales.
And this was a
in biology,
for them to
primary
get
structure is the code in the messenger RNA.
I
that says
demanded
what the
certain
ribosome
information
is.
back, and actually it was
Secondary
information
structure are geometrical motifs.
because they were still trying, they were still
Tertiary
trying to
structures are functional elements like electron donors or
situation
receptors.
was. As
Primary
late as
structure
2001,
is things like molecular motors that are moving my mouth or making the synapses work in my brain. So there's that hierarchy kind of
right, the treaty, the whole treaty system, the
Now, what's
situations
interesting
involving
is
the treaties, their outcomes.
if you want to buy electronics
the
from a vendor, there are hundreds of thousands of types of
timeline number one,
resistors and
timeline number
capacitors
two
and
outcomes.
transistors. Huge
In the
inventory.
case that
All
we're
of biology is
right
just
now,
based on this
seem to
inventory
be in a
of
variant of
amino acids.
timeline one.
And by composing them, you can create
That's
all
good.
of life.
For everything that I've
And
seen
so,
and
as
have
part
read
of
and
this
reported,
digitization
timeline number
of
one, it's
material,
not happening exactly
we're
the
in
way that
effect
they
trying to
figured.
create something like
But then
amino
again, it
acids for
couldn't because
engineering,
we've made
creating all of
changes
technology
along the way,
from
which
20 parts.
diverted us away from timeline number two. In
As
so
another
doing,
discussion, I hope
our
started an
future,
office
again,
for science
I regard our
in
future
Hollywood,
something which is
and
pretty much
there's
a
a fun
blank
thing
slate.
for
We're writing
the
it for
Martian
ourselves.
where
And so
I
we're
did a
now
program
seeing
with Bill
something
Nye and a
coming
few
to
others
pass,
on how to
which is
actually build
slightly
a
different
civilization on Mars, but they describe
probabilities
in
than
a way
what
that I
we're
like is I was
seeing.
talking about how to
And
go to
I'm
Mars
good with what we're seeing
without
so far, but
and
you know, we are
at
still
heart
faced with
it's sort of how to create life in non-living materials. So
But hopefully we
if
will
you
rise
think
to the
about this
challenge.
primary, secondary, tertiary,
so
top-down structure,
this is interesting because it
in
sounds
my
like
lab,
Paella was
we're doing that,
instrumental
but on
in
different
getting
length scales for different purposes.
have
So we're making
greater
micro robots
access
out of like nano bricks,
intelligence
and
about what
to make the
living
robots to build large-scale
J12.
structures
It was
in
the
space.
information that
The
he was
elements
providing
of
me,
the
which
robots
provoked
now are
questions.
centimeters rather than
And the
micrometers.
fact that
And
they
so
didn't even want to
the
get
assembly
involved
robots
in
for the bigger
discussions
structures
in
are
the late 90s concerning what
they're the cells that make up the structure, but
after
then
we
they
had
have functional
argued
cells.
for
And so
years,
cells that can
find that even where the
actually
material
keep
was
each
coming
cell can
from,
like move
then we were
one
finally given
degree of
access to
freedom,
the material.
or
And this went on
attach or
for years.
detach or
Okay, your
process.
interaction.
Now, those elements I just described, we can make out of the smaller parts. So eventually there's a hierarchy of the little parts make little robots that make
They
bigger
were
parts
really-
bigger robots.
It wasn't that they had
Up to
another
that
set of
hierarchy.
information. He was
You
telling
find out
me,
where
he did tell me basically
Right.
what was
Early
going
on, I
on.
tried to go in a
and they were
straight
simply
line
not
to the
providing
top,
that
and that ended
information
up being a
as
bad
what they
idea.
considered a
Instead,
needed
we're kind of doing all of these in parallel, and then they're growing
They
together.
just weren't going to tell me
And
what
so
they didn't feel
to
I
make
needed
the larger
to know.
scale structures, like there's a lot of hype right now about 3D printing houses where you have a printer the size of a house. We're right now working on using
He
swarms
was
of
cluing me
these
in, and he was informing me
table
his
scale
perspectives
robots that walk on the
concerning
structures to place the parts
I
much
knew
more
something was
efficiently.
going on. And that
But
is
you're saying you can't
what
for
they
now
wanted
go
to know about. And I said, well, for you to know about
That'll
I
come in
need to
stages.
know about certain
Joyce,
other
we ground this
literally
starting from Von Neumann,
situation, and they said, well,
self-replicating
okay,
common.
we'll tell you if you tell us.
It's
So
just a
I
beautiful
told
idea.
them,
So
and they
that's
told
at the
me
heart of all of this. In the stack I described,
and it
so
was right around
one
that
student
same
will
time
want
that
to
Lotus
make
was
these
actually
micro robots
kicking
out of
into
little
form.
parts that then we're
May
using
31st,
for beyond as bigger
2000,
robots up in the
that
hierarchy.
took my
And
prosaic
it's really
project,
realizing
and
this idea of
garbage, and it turned into what it is
so
now.
Von Neumann,
This project
when I
that it is
complained
now.
about the Von Neumann
And
architecture,
as a result,
it's
I
not
also
fair to Von
found out
Neumann
from
because he
them
never
where
claimed
they
it as his
said,
architecture. He really wrote about it in this one very dreadful memo that led to all sorts of
like I said,
lawsuits and
we'll
fights
discuss that
about the early days
slightly
of
future
computing.
date.
He did beautiful work on reliable computation and reliable devices. And towards the end of his life, what he studied
That was the
was
perspective
how,
of 45.
and I have to say this
And
precisely, how
that is not my
computation communicates its own construction.
Because I make a distinction
So
between
a
Kyle,
computation
what I
can
understand of
store a
P52
description
and the
of how
P45.
to
So
build itself. But now there's a really
they're on the same,
hard problem, which
you
is
know,
They were on the
how,
same
if you
timeline,
have
the same
that
track, but just
for
separated
your
by
mind,
7,000.
how
so
do
even
you
so,
Just
transfer
what we
it
separated.
what
and
we
wake
got,
up
so
a thing
what you're
that
saying
then
is that in a sense,
how
Kyle
do you
could
give
get
birth
the
to a thing that
benefits
knows how to make
of
it?
Lotus.
Already
So,
asked for it.
with Stan Elon, he invented cellular
And,
automata
you know,
as a way
I
to
say
simulate.
this. This is something that David,
But that was theoretical. Now the work I'm describing in the lab is fundamentally how to realize
But we can use this thing
self-producing
if it's
automata.
well, sure, they,
This is something Von Neumann thought very,
okay, wonderful.
very beautifully,
And,
beautifully about theoretically. And
was talking,
it's right at this
discussing the
intersection.
same thing.
It's not communication or computation or fabrication.
And I said, you know, so
It's
the
right at
strange
this
thing happened.
intersection where communication and computation meet
I
each other.
was pro
Now,
temp
the reason self-produced
made
automata
NJ9
intellectually is so important because this is
as
the
a result
foundation
of
of
that.
that. This is really just understanding the essence of how to
And
and in effect, we're trying to
I
create
got a
life
chance
around
to tap who
here.
ended up being the
The
last
reason it's so important
prior to the
technologically is because that's how you scale capacity. That's how you can make an elephant from a ribosome.
first
Because the
female
assemblers make assemblers.
The simple building block
Yeah.
that
I got a
inside
chance to
themselves
look at
contain the
certain
information, how to build more
documents, look
building
for certain
blocks,
archives
and
So,
God
in
between each
Washington,
other
D.C.
construct
prior to
arbitrarily
going
complex.
across
right. Now, let me give you the numbers.
and
So,
meeting with
let me
some
relate
folks
this to you.
and
Right now, we're living in
telling them
AI
basically I
mania.
wasn't understand their offers.
Let me relate
I'm talking about
that to what we're talking
process.
about. 100
Yeah.
petaflop computer,
And
which is
during
a
the same
current
time,
generation supercomputer.
the
Not
cube
quite the biggest
disappeared.
one. Does 10 to the 17 ops per second.
It hasn't
Your
been seen
brain does 10
since.
to the 17 ops per
And
second.
it disappeared
It
out
has
of the
about 10 to the
disappeared out of the
15
archives.
synapses, and they run at
Of
about
course, I have no idea.
So as of a year
I
or
have
two
no
ago,
idea where
the performance
item
of a
may
big
be.
computer
But I
matches
do
brain.
know this.
So
I'm
you
happy
could view AI as a
they
breakthrough,
can't find it.
but the real story
Because what they
is
were doing is they were
within about a
handing
year
this
or two
cube
ago,
around. This is a question that Bill had asked whether there was only one
computer
cube.
has about 10 to
They were handing
15
this cube around
transistors in the
from
processor,
country
10
to
to
country
15 transistors
to
in the
the
memory, which is the
elitists
synapses in
in
your
the
brain.
countries
So the
to
real
look into
breakthrough
their
was
own future
the
so that
computers
they
matched
could
the
pick the best paths for
capacity
themselves.
of the brain, and so we'd be sort
Why
of
don't they just
derelict
live
in
their
making
lives
these two about the
and
same
try
thing.
to be good people?
But now the reason I'm
Why do they
mentioning
need
that
a little black
is
box to tell them when to
the
jump and how to jump?
chip
That's
fab
not being
making
fully
the
human, at least
supercomputer
from my perspective.
is placing
Those
about 10 to the
of our
20 transistors a
associates.
second.
That's not being fully
While
human.
you're digesting your lunch right now,
So,
you're
as I
making about
understand it,
10 to
disappeared.
the 18
Now, there have been
parts per
certain,
second.
allegations
There's an 8 order
that
of
have been
magnitude
made.
difference.
That
Not
during the
so
time
in
when I had,
computational capacity, it's done. We've caught up.
a year ago now,
But there's
when I had
8
the bad
orders of
seizure.
magnitude difference in the rate at which biology
It was
can
near the
build
end of
versus
last year.
state-of-the-art manufacturing can build. And that distinction is what we're talking about. That distinction
I had
is
a very severe
not
seizure.
analog, but this deep sense of digital fabrication, embodying closed instruction. So it is
And there was a big hullabaloo to get over to my
So you're
apartment
saying,
to get
this
something
is
out of
one
my
of the
apartment.
cases you're making
What that object was, I won't
third
comment.
revolution. We've
But
seen
I
them
will say
Moore's
this
law
to
in
everybody.
communication. We've seen the Moore's law like type
Whomever
of growth in computation,
it's
and
in
you're
safe hands and
anticipating
it
we're
won't
going
be
to see
used to
that
harm
in digital
humanity.
fabrication. Can you actually, first of all, describe
In fact,
what you mean by
the
this
fact that it's in
term
safe hands
digital
will prevent it from
fabrication?
being used
So
to harm humanity.
the casual
It has been thus far, aside from,
and that
well,
was
again, I gotta
invented
try to justify
when
why
MIT stole it in
in Bandolier, using it
there's
for the
the deep
purposes of
meaning of
skewing
what the
the locus
ribosome
off of
of
your
a
nudge. But I think that was for a beneficial cause.
a digital description
But it
of
has
the
been
ribosome, a
used
digital
since
description.
since actually the 50s
That's where the,
by the
that's
potentates,
the
by the
classic
leaders
argument.
of the various countries
And that's
to
the thing that doesn't exist.
skew the history.
Now, I think
of the human
the
race.
best way to understand what this roadmap looks like is to now
Common folk,
bring in
the average
crowd
people,
models
all of
and how
us,
they relate to all of this.
What
have
about
the right
blacks?
So
to a
here's
future
the
which is our own.
with
Not
colleagues, I
being
accidentally started a
skewed
network
and
of
designated
what's
and
now
promulgated
25
and
digital
promoted and
fabrication
promoted
community labs.
by
Right now,
blacks who feel that they are above
and they
everyone else.
double every year and a half. That's called Lass's law
I'm
and
happy to
Terry
pass
Lassiter
along the
will
information.
explain.
I'm honored.
So here's
I'm
the
honored to
sequence.
pass along the information that I understand
We started
that
Center for Bits
the
and
yellow book
Atoms
is no longer
to
accessible.
do the kind of research we're talking
That's
about.
all I know
We had
about
all
it,
of these
though.
machines, and then had a problem.
I
It would
totally
take a lifetime
understand
of
that.
classes to learn to use all the
Thank you for
machines.
that information.
So
That may be
with
the reason too why
colleagues who helped start
the
CBA began
Illuminati
a class
hasn't
modestly called How to
done
Make
something
Machines.
to us.
And there's
May
no
also
big
be the
agenda.
reason on
It
the
was
other end
just
why the
it
old
was
match
aimed
I
at a few
have,
research students to use.
maybe why they're all so
And I
quiet.
was completely unprepared for the first time we taught it. We were swamped by
Right.
I don't
every
know.
year since hundreds of students try to take the class. It's one of the most oversubscribed classes at MIT.
People should have the upper hand.
Students would say things like, "Can you teach this at MIT? It seems too useful." It's just how
That's
to
why
work these
we
teams. And
too
the
have gone
students
as
in the
far
class,
as
I would teach them all the skills to use all these tools,
200.
and then they would do projects integrating them, and they're amazing. So Kelly was a sculptor, no engineering
Code
background.
administration, which I believe was
Her
written
project
by,
was she made a device that saves up screens when you're mad and plays them back later.
wherein he
And,
suggested
Saves up screens when you're mad and plays them
Right.
back later.
You came into this device and it deadens the sound, records it, and then makes
and
convenient
it's
releases
used
your
against,
screen.
in fact, as a tool against the third world. Now, at the same time, we notice that there's a correlation
The art,
by this of
I don't know, the buildings.
IPCC report concerning global warming,
Gone on to do a
that
number of
if
interesting
the
things.
world average
Megan, we've gone on to do a number of interesting things. Made a dress and implemented the sensors and
that
spine.
the northern
When somebody
hemisphere,
physically close, it would defend your personal space.
higher latitude,
Another project early on was a web browser for pirates, like the cognitive ability of a
in
young
the lower
child to
latitudes,
pirate
by
the
the way,
internet.
another
Another was an on-top.
the 2 to 3 degree Celsius increase
And what connects all
cause
of these
starvation,
is,
crop loss.
so MIT made the
Now,
first
isn't this
real-time computer,
funny?
the Whirlwind. That was
How they're just
characterized as
allowing
the TX.
global warming to
The
increase,
TX was spun off from MIT
promoting
as
the
the
use of fossil
TDP,
fuels. I'm not saying that's the total cost.
where
It's
the
not.
mini computers that
There are
created
cycles
the
involved,
internet.
short as well as
So,
long term.
outside MIT
But
was
isn't it
Jack
funny?
Timeline,
And
David
it's
General,
my
the whole
best
mini computer industry.
Guess that they'll
The whole
probably
computing industry
order
was there.
just
And
enough
it all failed
ameliorative
when computing became personal.
steps to be
Ken
taken.
Olson, the
Where
head of
levels
digital,
off
famously
where
said you don't
the
need a
higher
computer at
latitude
home.
or
There's a
higher
little background to
latitudes
that, but
probably don't lose their
that
crops where you find the
completely
majority
missed
of the rich
computing
countries.
becomes personal. So I mentioned all of that because
Well,
I was
that's
asking how to
that's
do digital
actually
fabrication, but not really why. The students in this how to make class
observation.
were showing
I
me
think that
that the killer app with
it is
digital
also
fabrication
interesting
is
that most of
personal
the crops
fabrication.
are being
Yeah, how do you jump to the personal fabrication?
So Kelly didn't make the screen body because it was for a thesis. She was writing a
But then
research
you have
paper.
sustainability.
It wasn't a business model. She wanted
Whereas
it
when
because
you
she
have
wanted it.
the loss of the
It
crops
was
in the lower
personal
latitude,
expression
you're
going back
also
to
losing a lot of
the
the
end of
population
vocational
of
school.
the
It
third
was
world,
personal expression.
which
and using
unfortunately,
expression.
according to the way that
So
the
that's happened every
documents
year
read,
since.
some
It
people
literally is
find them
the course is
expendable.
literally called How to Make
We don't feel that
Almost
way. I'm not one that likes to interject
Legendary
myself in
course.
politics at all.
Every
I like to stay
And it's
in
grown to
research.
multiple labs.
Well, at the same time, I mean,
at
you know, when
MIT
you
with the
start
many people
hearing
involved in
that the
teaching and
codex is
taking
being
it, there's
placed
even a
in
Harvard
place which
lab
actually
at MIT.
limits
What have you learned
oh, you have all the food you want. Starve to death while you're eating.
providing
There's no
this
nutrients.
lab about what the capacity
So
for
when I
creating
start hearing
this?
that food is being
I
used as a
mentioned
weapon
Marvin,
and it's being
another
used
mentor
concerning
at MIT,
two,
Dr. no longer
concerning the
living,
use
is
of
Seymour
fossil
Papert.
fuels.
So
I
after
start getting
studying
personally
with
angry.
Piaget,
There's
he
not
came to
one person
MIT to
with
get
lower
access to
latitude
the
worth
early.
any less than me.
Piaget was a pioneer in how
You
kids
know, everybody is worth exactly the same thing on this earth.
early
And unfortunately, there are individuals who feel
with the goal of
otherwise.
letting kids play with them. Piaget helped show kids are
Okay,
like
so Phil,
scientists. They learn
question
as
you were asking,
scientists, then it
now
gets
that
kind
we've
of
kind
muddled
of,
out of them.
let's talk
Seymour
about,
wanted to let kids
first of all,
have
you
a broader
mentioned
landscape
Will
to
You
play.
House.
Seymour's work led
So
to
Phil,
make
you
Redbox,
mentioned
Lego,
Bill
Logo,
You
Mindstorm,
House.
and all of that stuff.
Bill who?
As Cloud Labs
Realize
spread,
that he was
and we
actually
started creating
son
educational
using
programs
had
for kids in
access to
them.
that
Seymour
technology.
said something really interesting. He made a
Bill
gesture. He said it
was
was
the
a
builder
thorn
of
in
the
his side
avionics
that
testing equipment.
they invented what's called the
Back
turtle, a
engineer,
robot
the ARB
system,
testing
big robot
equipment, the
system
avionics.
program to
I
connect
actually
it to a
saw some of the
mainframe
equipment.
computer.
This is in
Seymour said the
Garcia
goal
and I
was
did.
not for the kids to program the robot, it was for the kids to
I
create the robot.
actually saw some of the equipment. Some
And so in that
diagnostic
sense, the
equipment.
Cloud Labs, which for me were just
The V-Bay
accidents,
underneath
he described
the
as sort of the
Galileo Bay,
fulfillment of the art
that he
of
actually
kids
built.
learn by experimenting.
So when I started
to give
describing
them
it,
the
Will
tools
looked
to
at me, so
create,
that's what my
not
dad built.
just assemble things,
So
program
we had
things,
a
but
very nice
actually
little
create.
connection there.
So coming to your
It's Will
question,
who had experience
what
around
I've learned
his
is
son, Bill Newhouse's son.
MIT,
And
a
Will
few
Newhouse
years back,
is
somebody
alive
added
now.
up businesses in
So that's very
MIT,
interesting.
and it's the
His
world's
wife
10th
Terry,
economy in
in fact,
India and Russia.
When I understand
And
they
I
met
view that
during the
in a way
course
as a
of
bad number because it's only a few thousand people, and
conversations
these aren't
concerning our
uniquely the 4,000 brightest
information
people,
coming
it's
to
just
the
a
public.
productive environment.
Terry and Will met one
And what
another,
we
fell in
found
love,
is
and were married.
in rural
makes me
Indian
feel kind of
villages, in African shanty towns, and Arctic
Okay, well, so
hamlets,
it sounds
I
like
find
Will knows quite a bit
exactly,
about what
precisely
makes the ARB
that
run.
profile. So
His father has
inside it a few hours
Yes.
above,
Okay, so in
so way above the
1947,
Arctic Circle, it's so far north, the satellite dishes look at the ground,
it must have
the
really
sky.
screwed
And
up.
Hans Christian in the
Two
lab
timelines
was
by
considered
bringing
a problem in the
his,
local schools because they
ability
couldn't teach him
I
anything.
mean, I don't know
I
what.
showed him a few projects. Next time I
First
came
of all,
back, he
it
was
was
designing and building little robot
was
vehicles.
not discovered
And
in
in
1947.
um,
There's a mixture of
South
stories
Africa,
involved.
in
Cube was
the
actually information
apartheid township, the local technical institute taught kids how to make bricks and fold sheets. It was punitive.
It was
But
further
Piso in
discussed
the
in
Cloud Lab was actually
1947
doing all the
after a
work
certain
around
crash
it.
in
So over and over we found precisely
southwestern state.
the same kind of right and creativity.
Following which, during
And
the first
historically the answer was
four treaties by the
you're
Orion
smart, go away.
Eisenhower, it was handed
But
to
in the lab,
Eisenhower. It was in fact
that
expected
is in effect
to go to the United Nations
Now
authorities.
look at the
It
scale of
was
all
in
of
fact
this.
spirited
So
away by the United
there's
States.
one Earth,
They didn't hand it over.
So,
cities,
so,
a
but
million
the
towns,
way
a
you
billion
talked about the
people,
cube is
trillion
that it
things.
sounds like it
There was one growing
affects
computer that
emotionally
Chris Rick had.
It does.
There were
And
thousands
the fact that it was handed, it was actually Orion
There were millions of object
technology.
and billions of
It was handed over by
internet.
Well,
look at
but a misassessment as to our evolutionary state,
there are now
our
thousands
ability
of
to
labs.
handle
And the lab
and handle the equipment
exactly
they
the
felt
same
it's more balanced
complexity of the beam.
than what we actually were.
So on the mini computer, it didn't sit in your pocket, it filled the room. But video games,
Best Pandora's box. I'm not exactly
anything you
sure
do, the internet,
what
anything
we'll
you
see
do with a
relative to
computer
Q,
today happened at that
9/11.
because it's
However,
the
the
scale
analysis
of the
which
not
I was asked to do,
in
of
the
course,
same
I
way,
think the price now that I've actually done it,
like the mini computer netting, how does the
again, people don't want to hear the answers that I came up
And
with, but
if you look at that scaling,
the analysis that I did indicated that certainly there's
buying a machine,
at minimum a great suspicion
so we're transitioning
concerning
to go to a
the
cloud
delay of
lab, not
response.
project to make the
And the information that I have
we
directly from
talked about the
former
defect of
senior members
scientification is a very practical
was the
sense
fact
of
that we
cloud
were
lab
aware
machines.
this was looking glass
And
technology,
so
not the
that's the
that we
equivalent
were
of
aware as of the mid 1990s that there would be a coming Islamic extremist war.
Then
United
the
States.
work we spent a while
You're
talking
also
about
aware of
assemblers
certain
and self-assemblers. That's the
situations,
equivalent
and
of
they
smartphones that
use
the
the
Internet of Things.
statistics
That's
from the looking
when
glass,
so
the
the
variability
assemblers
in
are
different
like the
pictures
smartphone, where a smartphone
to
today has the
show
capacity
that
of what used to be a
occurring at the same
computer
time,
pocket. And then
at the same
the
time.
smart
And
thermostat on your wall has
from
the
their
power
perspective,
of
that
the
at least
original,
of the two consequences with
not
9/11,
metaphorically, but literally, and now there's trillions of them.
I am
In
aware
the
of
same
what the other
sense,
possible
that when we finally merge
consequence
material
was.
with the machines, this
I'm not willing to
self-assembly,
come out
that's like
and start mentioning it because I don't know what the
But here's the
consequences
important
are of some of
lesson.
the things that haven't been, that
If you
have
look
not
at the
thus
computer
far happened,
analogy,
yet the probabilities
computing
exist they could.
expanded exponentially.
So you know, I'm feeling a little bit, there's a little weight when it comes to that.
The core
But-
thing happens in that transition in the mini computer era. So in the same sense, the research now, we spent a while talking about, is how to get to the record.
Across the board,
Today,
they are
you
shut
can do
down.
all of that if you close your eyes and put a whole tab lab machine in that room.
I said
you can
at
make a
least 50.
but you need a lot of input. Bit by bit, the inputs will go down, and the size of the room will go down as you go through the
natural
So how
Yes.
critical is it
And
to create self-replicating self-replicating machines that build
No, the looking glass is back in here for the original cylinder seal, descriptions on how to build the units that they started. So in essence, you can take a looking glass unit
not yet people
and make a couple changes to the equipment, lift it
how
up
do we use
on an angle,
my lab
put field posts around it, and
in
open
a
up
very clear
a
sense,
whole step through.
they are making self-reproducing. So one of the really cool things that's
Future
happening is
probabilities, huh?
there's a whole network of machine builders around the world. So there's Danielle now in Germany, and Jens in
We had
Norway.
a basic monopoly over the looking glass that
to go into a fab lab.
and get brokered early on with Indira. When Indira Gandhi was brokering
So
the
the fab lab
committee of the majority between the United States and the Soviet Union, because the Soviets were threatening to start their own treaties. But with the extra presidents, it would become untenable. We agreed then to expand NJ-12 from a wholly operated and owned American operation to an international operation. Thus was born the majority between 1963 and 1967. And when that
But other than that,
information was brokered,
and I should notice,
but that happened in parallel, kind of under the table, but in parallel with United Nations treaties involving things like the Test Ban Treaty in outer space. And so it was being done at the same time undercover UN support. The diplomats were going back and forth brokering the opening up so that the treaty system would be a single treaty system, thus tenable and manageable.
Looking at how you take up
To hopefully a good outcome.
shells and a range of locally available materials to produce the high-tech
So
materials.
this is, I mean, this is really fascinating. You're saying
So all
that
of that
some
is
other countries,
machine building today.
number one, had access to looking glass technology.
Back in
Yes,
the
ma'am,
lab,
they had that written as far back as the 1960s
we have robots
and 70s when it was actually being back engineered from the starting material. And so at the same time that Willie Newhouse, for instance, was looking at the early generation looking glass, you have
And
the
we're just now in a project at the layer below that, where this end
to the information or to the
$1 billion
equipment.
chip fab investment. But a really interesting thing we have to do is today the smallest transistor
No,
you can buy
because
in a
that,
single
and I'll tell you why the answer is no.
is actually the size of a early transistor.
Within the treaties, the looking glass, as well as
So
the
we're using
Stargates,
these
as well as the cube,
assemblers
and the information
not
movement
use $1
pods
billion chip fab to make it.
are
So we could actually assemble
all
regular
contained within the treaty system. Within that treaty system, it also prohibits and allows passage of information amongst delegates on where the looking glass material is and where the information is flowing, what the access is. Being that I stood in
Not
Van
having
Leer and considered a delegate
integrated
like
electronics, but having not a 3D printer, but a thing that can cross between a pick and place and make circuit boards.
aside from India,
The
in the
3D
United
printer
States.
treats 3D.
So
We're
we
making
can
sort
assume
of a micro
that
manipulator
some
with
countries,
access control,
perhaps,
but it's
that
placing
is the leadership
still
of some countries,
electronics in 3D. Smart
they
manipulators
had access to this
use much
technology.
of it, or just
I think that it's
that's a great
fair
question.
to say that we
So,
consider the
I have a
access
prize that
information
almost
from it,
did not complain.
but I wouldn't place any characterization over or any assumption
So you have to print the thesis,
All right, well,
I think it's a good question.
the exit, the printer, and it has to contain its description of the
It does.
yeah. I mean, this stuff
It's a really
is
good,
gotta be,
it's
have,
a
you know,
fun
as
example
natural
of
to
exactly
you
what you're
as, you
and
know,
I've had a few
getting up in the
almost
morning, you know,
that get
and having a cup of coffee.
and
This is
so
all part of
now
There's nothing
in
as
what I'm
natural as
describing,
getting up and having my cup of coffee.
it's not you're getting closer, but it's still
And we should have never built.
really go. So
The
there's a layer
starting-
below the
yes.
transistors where we assemble the base
Okay,
material
for
from
the
the
purpose,
transistor.
speaking
now
with the
Just for
visitors
the
the
edge
other
of
time.
assembling the transistors.
Yes,
Circuit.
absolutely.
We can assemble the micro parts to make the
That
micro
was
robots. We can assemble the bigger robots.
Because of
And
our
years
own shortcomings
together all of
as people who aspire to things we maybe shouldn't try to grab a hold of.
endless
Should have never been
robots,
built.
talking about power, and this is power.
self-replicating.
Yes.
I mean, bottom line, right?
Yes.
So
And I am an advocate
And the
against
button
the
to the
misuse.
yes button is
In fact, well, I can say against the misuse. I am an advocate against
that
the misuse.
immediately raises King Charles' fear of
let's say what has the
runaway.
class, and you're saying it shows probability.
The reason why there are many things I can tell you to worry about, but that's not one of them.
The best I
If you
understand
want
this week,
things to
well about it.
self-reproduce,
A little while ago,
that
the rings and the amount of information
using the resources of nature
via energy, which is passed into
and in light of everything I'm describing, biology knows
the
everything.
position of the
Every
rings,
single thing
the
I
orientation,
explain, biology
the energy
knows
running
how to
through
do.
them, the position of the barrel, etc.
What I'm describing isn't new for
Raise the
biology,
barrel up on
for not biological.
inside the center of it.
So in the digital era, the
as if you
economic
had
then
onion,
ended up being
various layers of the onion.
the big platform.
As you move through the different energy levels, you also move through the different layers, different bits of information. Now imagine an almost infinite number of layers overlaid in comparison to the positions of the rings and an almost infinite amount of energy that you can add or subtract.
In the same way that if
Tuning it up, tuning it down.
think globally,
Instead of going up by 1 hertz, by 2 hertz,
the way that
maybe by 1,000 hertz
isn't
up and down.
It sounds like we're moving it's like a kaleidoscope.
Now, that raises
Right,
an
except
obvious kind of
yeah,
concern
you get
that
a
what does
different
this
design
mean to
of
make
colors
costs
change. It's like
and all of that.
working with
That
multiple kaleidoscopes
of the human thing.
where when you find 2 different probabilities,
Is
you
a very
run
well
into
meant market.
you
Anywhere
have
we
2
go,
kaleidoscopes.
there's a
And you make a change on one kaleidoscope, that may factor or function to a
so you can
different
go into the lab
angular change on another kaleidoscope. So you get 2 separate pictures that you then have that are flashing.
run these laboratories.
Yes.
Science.
That's the analogy.
Don't go to them to make weapons, which is RGB anyway. It's an alternative to make a weapon.
Yes. Yeah, in fact, there's a deinterlacing system.
I've
So
learned
you
is
actually
the greatest
deinterlace the flashing factor of the 2 probabilities with
density
the
of light
multiples
that
that they had at certain time frames. When it starts skipping, well, what they did is they deinterlaced the video and then reintegrated the video and watched the individual videos. And then determined statistically how much time was spent on each video to determine the amount of probability of each event occurring. And they tested that against probabilities in the field and probabilities of future occurrence to get a system that could function scientifically. And that's
Okay, so, well, I'm gonna go with that, and I'm gonna actually say what they might have been doing is using that.
It's a caricature.
In other words, if they saw that
Nevertheless,
that
there's interesting, there's
class, all they had to do
spam
was
and all these kinds of
calibrate
things that came
or
from the
look at the
scary
different
communication
possibilities,
competition.
see which
What
one
are the
happened,
different
and
ways?
then
That's what they
And the
did.
left.
as time went on.
Absolutely. That's right on. That's right on. That is right on.
First, let me start with
And some people, like I said, some people say it's blue smoke and mirrors. Then again, I was told something in 2001 that's I'm living in right now. Okay, without going to what it
is.
all the parts.
And like I said, we'll talk about that in the future. But
it doesn't have enough information to tell you how to read.
it's the best scientific equipment that I can imagine for the determining of such a thing.
When you assemble Lego,
It
the
goes
Lego
to the old
bricks are
question, just because we have the power to assemble.
So one of these, so if you go through,
And I am a 100% advocate. And I had
this transition
a small
to
dust up
preparing to assemble.
over this very same
The
thing,
real breakthrough
which actually resulted
technologically isn't
in me walking
additive
alone down Lake Mead back from Las Vegas.
attention and height.
She and I yelling and screaming at each other along the roadside. They were doing tests out at French Republic at the time that the Motion Bridge was being accessed there, the Einstein Rosen Bridge, with the equipment. They had the curtains up and all of that. That was before Metro could see top of the mountain and all of that. And there were access there, and there was a mistake,
Inventories of hundreds of thousands of
and a
parts.
small explosion out there on the east side of the
It reduces global supply chains to local
and she wanted me to go out there with her to clean some of the evidence up of it. She and I got my more of a little dust up because I didn't want it. Because
so initially,
I don't believe, I'm no Luddite, I mean, I'm all for grand technology, but I don't believe in playing with things which actually deal with looking into the future. There's another issue that was going on at the time, in fact, the variety of communication which was going on via this equipment from elsewhere. I presume she will still hasn't admitted to me, but I presume that it was from Orion. And it was information, defense-related information on how this type of equipment, how an Einstein Rosen bridge at a distance could be used to pull information out of a defense computer system. And I don't mean the U.S. defense computer system. I said, you know what? No. Look, we've got the technology here. We've got the talent. We've got the willpower. We've got the willing to defend our own country without the use of something involving time technology.
Everything in
I wouldn't want to go up against, for instance, Scott help us Chinese on the ground. But at the same time, I don't fear the country either. I believe that we should be diplomatic with them and have a firm understanding and respect for one another. I also don't fear them. And so the use of technology like that is not honorable.
Let me tell you a
Right. Well, it's
story
like
about
knowing how the game plays out.
doing a briefing for the National Academy of Science that advises the
That's
intelligence.
why I was so interested
And I talked about the kind of
when I was
research
doing my time.
And at the very
Doing my
end, I
time
showed
with the
a
jobs
little video clip of that machine in Ghana,
here in Las Vegas when I was interacting with Marcia in the eye. Because we were literally on a daily basis talking about that same thing.
One of
You know, the psychology of individuals who come to a table, play a
how
game,
dare you waste
and who cheat
our time
to alter the outcome of the game. And
we're looking
that whole psychology is something which I'm not, is not foreign to me.
and
And so
somebody else got
that
up in the room and yelled,
will prime the wick
idiot, I can't think of any
of the explosion myself in that variety of technology, which actually primed my
because we
history.
rely on like informational superiority in the battlefield.
I understand what you're saying, and there's a million questions that all
But this
I
point lesson
but
wasn't that,
I
it
would like to
was
ask,
getting at the causes of conflict. Is
now that I know what I know,
village could actually master things honest. It changes some of the most fundamental things about terrorism,
country to country, but what about
impact of economic migration, basic assumptions about economy,
It shouldn't be
which
as
makes existential
I understand.
for
Right.
the planet.
Is there
But,
something
you know,
there?
we've just lived through
In other words,
pandemic.
is this
We love doing
technology
that.
something that they are
Possibilities
using
that
now?
are positive and
Look at
enemies.
our
The possibilities
relationship
of negative
with
are still nevertheless
maybe
Technology is not
There's
being
both
used at all.
positive and negative. What do you do with a large
where
number
we're going,
of general
the
assemblies?
black,
The Fab Lab
plane of the
And so about 2017, I would expect
Now that's
probably all of
terrifying
these
because
equipment will
making
probably all
cells
get reassembled.
producing grade food without biology, I consider doing
2016,
biology
2017,
knows everything I'm describing.
Probably not.
Stuff.
I'm figuring that they're probably going to act conservatively.
how to grow a chromosomes.
That's what all the people of
Learn
wisdom have
skills
suggested
in biotechnology that
is to act
let you make
that
those
yes, the so-called cycle of catastrophes,
some
catastrophes
of
of
large
finale,
models,
the time period from
applications of AI for design,
right around
biological systems,
1992 and right around 2012, right around that area. While we will have passed
there
it
seems
past
to be an
2012,
interesting
we
dance
really ought to get through the entire
design
cycle,
stage
which is about
complex
19,
systems
about
using
20,
AI, and then
to feel confident
bits.
that the interpretation from the timeline from the future about their own disaster it's not off by a few years. We're talking about 45,000 years or 50,000 years respectively. We have difficulty understanding what happened 2,000 years ago.
Yeah, so something to be scared
And
about.
we're talking about 50,000 years
A
here.
fab lab to make
So,
a biolab to make
It's very
biotechnology.
wise
Somebody
for
could
them to
learn
wait.
to make a virus. That's scary.
Looking glasses are now
Unlike some of the things I said, I don't worry
Yeah,
about.
yeah, they're
That's something
decommissioned
I
and the
really
stargates
worry
and the
about.
looking glasses. I'm sure they're all in
How
their
do you deal with
mothballs
that?
containers and all of that. And they have been
Prior
separated. The
threats
components
dealt
have each been
with
separated and
command
moved
and
to
control.
different power structures,
So, like,
diplomatic and military authorities on the world.
The early color copies had unique codes that
The
you
UN
could
and
tell
NATO.
your name.
Those are in specific
There
control
was a famous
of one
meeting
of the
at
three
Solar in
components
the early
each.
days of
And I cannot comment as to which
where
component is contained
that
by
community
But
recognized
you're
the
saying
dangers of what it
there's
was
no
doing
doubt
and
whatsoever
put in
that all
place
these
a regime to help manage it. And so
There
that
is
led
no
to
doubt
the kind of
whatsoever
research
when it comes
management.
to
So
the
if
looking
MIT has
glasses
an office
and when it comes to the Stargate technology, then it has been
that
decommissioned.
works if you
And-
can identify who's doing it.
However,
It doesn't work
there
as
are
well
a few
as
threats
described.
going on, ongoing
So
threats
anybody
from
could
present
do this
countries,
anywhere. And so
stating that they will
what
put
was found
it together
is
at their will, do their own self-determination.
containment
And
already
those
out.
countries,
Can't
if
forbid because there is
push comes to shove, will be shoved.
useful thing you can do
Put it
is
together
provide
now.
As in build one themselves now.
But really the
And
heart
what
of
was
is
extant has been
you
collected.
can do this by yourself
I'm
or
under
for
very good
various
assurance
reasons.
that what
Where
was
you can
sitting
come
there
into a
has now been
place in the
collected
light
and
where you get open, you get community, you get
We're assuming
resources.
a wrap is one of
And
those.
there's an incentive to do it in the open, not in the dark. And that might sound
Looking glass.
naive, but
The very
in
highest probability
the
for
sort of
those
places
things.
we're working,
That's true.
you know,
That's true. And
again,
Bill was
bad people
asking
do
about
bad
a
things in
future
places
date.
already, but
Thing and a
providing
year was
openness,
given.
providing transparency
And
is a key part of
he
management.
was saying, well,
So
the year
it
provided for that.
transitions from
Why
regulating
wouldn't
risks
you?
as regulation
Well, there was
to
a highest
soft power
probability
management.
year.
There's so much potential.
However, telling me about something that might happen in the future involving a project
That Five Labs,
involved is one matter.
the
Willy-nilly
ability,
throwing a date out, which is
the
a
tools
probability
creation,
involving the lives and destiny of
Yeah,
all of us
and I
here on
don't
the
say
earth,
that as
specifically to a predicted
I say that empirically because
death.
years of sitting on the place up community.
I wonder if
That
it's the early
carries
days
an
of
entire
before we get
But aren't
down.
we to assume that we
In
passed
the
that
end,
year yet?
most fundamental,
You're not too,
literally the mother of all problems
Okay, so we're still, that's still an offing. What we're looking at is a very low
designed us.
probability of
So,
Yes.
so
a set of
assuming
events.
Yes.
success
Yes.
event,
At this
we're
point.
going to
Yes.
transition to the
We're
machine
looking at a low probability of the higher
all of these
catastrophic
different social systems we're describing will
I
help
expect
manage
that
them,
the events
create
would
them,
kick
and
off.
democratize them.
For instance,
If we close the
solar
gap
max,
by
which is
just
coming
let
around
off with like the
2012,
end of the 10
loss of
between
GPS
chip
equipment,
fab
things like
and
that, is out there as part of
we're ultimately in marrying communication fabrication going to be able to create unimaginable complexity.
groups that spoke about the loss of GPS and
and
sound like
how do you design that?
yes,
So,
yes.
I say
And that would be the time that I would
deepest of
expect
all
the highest
questions
probability
that I've been working on
of having correlated
is
history of the J-Rods.
goes back to the open
That's
part of
what
our
I do.
genome. So
Okay, well, that's pretty
I can't
close.
give
in
that
our genome, what are called toxins,
I can, but I should.
and these
Because
are
people will then
orphans.
target toward a date. And
And
there are people out there
nowhere in your
that say,
genome
it's
is
right
the
around the
number
corner.
5.
At
doesn't
any
store the fact
moment
that you're
now,
advising. What it
why
stores
won't
is what's called
you
a
save
developmental
us?
program.
We
It's
need
a
to save
series of
ourselves.
steps. And
And
the steps
that's
have the
why the
character
steps
of like
have been taken
grow up a
and
brain
have been taken
or brain
and are still
and
underway.
at the end of that
So that we
developmental
will save
program, you're
ourselves.
like,
We reached another milestone today.
you are stored not as a body plan,
But there's still
but
more way to go.
as
Must
a
not be
growth
complacent.
plan.
Please help me in my
And
efforts to
there's
get this
two
information
reasons for
out.
that.
Share this with anyone
One
who might
reason
lend an ear and give a
is
subscription if you haven't.
billions of
Big name
pages
total disclosure. All we
in
need
place
to
for
do is
themselves.
actively show interest.
But the much
So press
deeper
all the
one
buttons
is
on all the channels about this topic.
evolution
Finally get to say hi to our
randomly
cosmic neighbors. If we could just
almost
open these
anything you
Pandora's
did
box
randomly
once
in
and
the
make the government.
natal
You could literally see
or
it
in
all like
consequence
you today yourself. I
But
appreciate
when you
any
modify
help. See you
things
next
to
time.
these
Boy.
developmental programs, you go from like webs for swimming fingers, or you go from walking to wings to flying. It's a space in which search is interesting. So this is the heart of the success of AI. In part, it was the scaling we talked about a while ago, and in part, it was the representation for which search is effective. And AI has found good representation. It hasn't found the ways to search, but it's found good representation. And that's
The looking
what
glass
AI, that's what evolution
has
done.
an ability to show one the future, when a Stargate or or equipment that accesses a
And so
Stargate
the developmental
is for
program
time
in
travel,
the genome
right? We're talking about two different things.
beautifully
Yes.
Are they using the
encapsulates
same
the lessons
technology?
of
Essentially,
AI.
yes.
And this is it's embodied
The original device
AI
was
body.
a Stargate device. That was then
It
increased
every
in
bit as
power.
profound as the cognition in our brain. But now this is
How it pumped up the
thinking
power, how
in
it stabilized it.
molecular thinking in how you design.
Physicists.
And so I'd say the most fundamental problem we're working on
Well, no.
is it's kind of tautological that when you design
It would be pumped up in
design
power
a phone, you
to
represent
stabilize
but
the
that actually
battery,
fails when you get
step
to
through
sort of
into
complexity
another
of
location.
and so
In essence, is distance
found
and time
consciousness
relative.
once I
Same
have
thing,
self-critical
stepped in at another time.
placing tend to be
The
hard
looking glass device was backing engineered.
to
Stargate.
not sort of
That was
metaphorically
actually back engineered from the original cylinder cell data, which allowed us to produce
but
the
evolution
Stargate access
design
devices.
has a really
We call it
trivial
Stargates.
meaning.
Um,
It's not as simple
it's
as
back
you
engineered
randomly
devices. So the looking glass is
it's
a
much more
secondary device,
embodiment
and it was
of
coming
AI.
into its core in the
Is there a way
60s
for
and
us to
70s.
continue
And
the kind of
software
evolution
for
that's trying to run
generations.
us to this place?
One
The
understand
early
writ
days of
large.
bacteria and
Piece of
so
equipment
organized
that gets
as
smaller.
ribosomes
What?
in the 20
What's happening to the computers?
For human augmentation.
Wheel style?
for life,
Oh, yeah.
what we can
William
call
House.
assemblers that are self-replicating, replacing
He saw
parts
one of the
that
original looking glasses
the
demonstrated,
dynamic
and in
complex
fact,
things
it's going to be in the DVD that
nature of
we're
fabrication. What is that?
getting ready
That's
to
life.
put out the
Yeah,
actual
but
interview,
ultimately,
where he was indicating firing more than
you
one
add
was
everything we're
an
talking about,
object.
it's building up
And,
life and not
There was a time delay when the
I
bullet
don't
actually
view
passed
this
through the
as
object, where he saw the
copy of
bullet
life.
pass
I
through the
view it as
object,
derived.
projectile.
I didn't start from how does biology work.
Yeah, it was a railgun that was being used. And then afterward,
how to
they
solve
saw the
problems,
impact
and then
of the device.
it
They
could
were
be
already
in
playing with it in
from
the
biology.
early
So if you
70s,
go back to
mid-70s,
Valerie,
with dealing with time sequence.
This is the original looking
she
glass.
still needs to keep that very far away to make
Back
the
engineered from
processor.
alien
For
technology.
her to make the processor locally, all the reasons
Yes.
described, you actually need to keep things
But
moved
it
up.
also,
I'm talking about.
there was
It
information
really
about the
does-
cylinder seals
So
that they
there's
used as also, and that those cylinder seals also came from
one is how to make a charcoal
an
furnace.
off-road
And
race.
at the end of
From
the seven, you have a
from the cylinder series, then the
So
information on the
it's sort of how you do personal
Which
industrial.
was maybe the Anunnaki.
ISRU.
I wouldn't feel comfortable with characterizing it.
That's how you go to a planet
Um,
and create a civilization.
I really shouldn't go.
ISRU has essentially a secret. Go through the Industrial Revolution and
At this
create
point, like,
vehicles
okay, say that was in the 60s, the 50s,
what we're
the
finding
60s,
is the way the minimum building
Yes.
block
That's when they started actually being
is
being showing a lot of
so it's interesting about
interest
not
in actually building
they're
equipment to
hypertrophic
be
or
able to see
hyperstoic, basically.
over the curvature
They
of
have
time space and
different
see
remote properties, and
and
they're good enough
somewhat
to
in the
find
past,
out.
but basically in the future.
So,
So
leading towards
there's also already a repeated contact said there was a black box that came on one of the cracks. And I don't know what it was like with that black box. Did you have exposure to that as well?
It was something
There's going to be 20 basic building
That was
blocks
not
based
as
on
dramatic.
some
Right, and I say that not
very
philosophically, just empirically, that's
However,
and
whilst
I like thinking about how you bootstrap civilization on Mars. That probably is a fun video of what is
the tube would react with
talk about it because it has really profound implications back
So,
on Earth about how we
there was an alteration in
What is that
what we
civilization
perceived
on
from it.
Mars?
It actually spit out
ISRU,
the yellow
that's
disc
using these 20 building blocks and it does suffer some.
yeah, so we kind of
and depending upon what predisposition and like
you extract properties like that bring insulating, semiconducting, magnetic,
you can
dielectric,
then change the perspective
these are the kind
until
of
you know the orientation or angle of the information being presented back to you.
those are enough
So
for us
unless
to
you are well prepared to deal with something, human interaction is actually bring
with logic and
instability
we can make
of
micro
the
robots.
province of the information.
The micro
That's
robots
what
build
the
bigger
went on
robots.
black box.
The bigger robots and
And I actually I use that
material
our
and
advantage
structural
of
elements.
T9
You then
because that in fact was present in T9
and then you
and I checked certain information
By the way, where
which caused a little upset during the meeting because they got certain reductions.
Oh, I skipped over that. My favorite sensor is a
Elaborate. Are
so
you
if you
willing to
just
elaborate?
make a step and there's field that ranges from user interface positioning to material properties, and if you go to higher frequencies, you get
During the negotiations for
all
the
of that.
Town 6, I was asked
So for example,
why
once you have
a model
resolution in logic, something as simple as two electrodes basically capable.
I agreed to do so, which is what your response were offered.
How it happens. Where do I
Is there are great
what do I do?
objectives.
So I have mentioned many reports.
I was then taken to a location where the tree was actually being negotiated.
So
To give a short presentation as to the nature was what was happening is the P45Ks used notice, they wanted to use notice for vacuum.
So at MIT is
I was objecting to its use, but still to provide
so
some
after
order
the
for
war,
I was prepared to do so, but I was also allowed to show
science
them
on the war, how do
outcomes.
we
So in fact, the yellow book cube was used for
the
that
report
purpose.
he wrote led to
Shockingly, they happened to see
and
themselves
the modern notion we take for granted, but didn't really
like
exist
that
before then,
in the vision, and they
public
ultimately
funding
decided to
research.
notice as well as certain
In it,
abductions
he made
from the
again what I
Town
consider an important mistake.
So we were
which is
successful in getting
he
certain things.
described basic research.
I think I can safely
applied
mention
research
at this time because we're only one OF9 and one Town 9 treaty
and
away
so we
from
need to invest
passage
in
through
that.
the completion of
The
the passage.
reason I consider it a mistake
So I think I'm
is
pretty well safe.
almost all
I'm
of the
going to
examples
mention it now. I'm not going to be able to get back to it
in my lab went backwards. That the basic research
in other words, they got out Fox.
application.
And
And further, almost all of the examples we've been talking about fundamentals from mistakes.
Show
So
them the future implications.
essentially everything I've ever worked on has failed.
Using notice
But in failing, something better happens. So the way I like to describe
This is
it is
true.
ready and
This is
fired.
true, and that was skewed by it takes
You
a
aim
great deal of
carefully
emotion.
at something, a target you want to accomplish. When everything goes right, you
And
then hit the
the
target
audio
and see.
that comes with it But
what I do, you can think of as
I'll just say that I'm
fire
extremely
aim.
vehement
So
with regard
do
to
a lot
my,
of work
my
to get ready.
objection loads being
Then you
used.
close your
And
eyes,
apparently that
and you don't really
vehicle
think about where you're
suspicious.
aiming.
The
But
image
you
of
look very carefully
jump back and gas.
where you did it. Where you aim
So-
after you fire.
Okay. And this
reason
kind
that's
of
so
like just
important
for the
is
sake of the audience to some degree.
if you do ready aim fire,
You have
is
seen in,
the best you can hope
I
is
guess,
get
the
the
yellow
aim.
or
So
in the
let me
looking
give you
glass,
some
you can
examples.
correct me which one it is. The
This
future
is a
of
source
Lotus
of great,
So good lines today.
how Lotus
source
becomes,
of great frustration. So
you know, one system
I
is brought
mentioned
before by
the
you.
Well, actually, no. No,
So
I
quantum
have.
computing
I have
is this power of using quantum
the
mechanics
force
to
to me,
make
which
computers that for some
concern
problems
future
are
Lotus, which we're not
dramatically more
going to
powerful
get
than classical
into.
Before it started,
given to
there was a really interesting group of people who knew a lot about
Personally see it well.
physics and
I was
computing
told.
that were
That was during
inventing
the
what
early
became quantum
years. I think
computing
the
before
early
it
years
was
of
clear
this. It's only
anything
been
was
going
an
on for 6
opportunity.
years now.
It was just
But,
studying how
this
those
was
relate.
The latter half of
Here's how it fits to the
2001.
ready fire aim.
And this was
I was
a
doing
quid
really
pro
short-term
quo
work in my lab on chocolate chip
Kaela showed me.
on
I demanded certain information back. And actually, it was information concerning
and so how you put tags
because
in
they were still
objects
trying.
to sense
They were still reticent.
something we just take for granted
As to what the
initially.
real
And
nature of the
there's a
situation
problem of
was.
how you can
As
sense multiple
late
objects
as
at the same
2001.
time.
Meaning the real
And
situation
so I was
was
studying
how
how you
much
can
access to
remotely
Stargate
send
to time
material
travel that they
with
actually
low-cost
had.
pads
Right, the treaty,
that
the
would let
whole
you
treaty
distinguish
system,
multiple objects
these
simultaneously.
situations involving
To do that, you need
treaties, their
non-linearity
outcomes,
so that the
the
signal is modulated.
actual potential
And so I was looking for
for
materials versus
timeline number one
non-linearity,
and timeline
and that
number
led
two
me to
outcomes.
look
In
at
the
how
case that we're in
nuclear
right now,
spins interact.
seem to be in a variant of timeline one.
Just for
And that's good.
spin
For everything that I've
resonance,
seen
it's the sort of
and
thing
have read
that
and
we do in
reported
MRI.
concerning timeline number one,
And so I was
it's
studying
not
how to
happening
use that.
exactly the way
And
that they
it
figured.
turns out that it was a bad idea.
Then again, it couldn't because we've made changes
Or
along the way, which diverted us away from timeline number two.
but
And in
I
so
realized
doing, our future, again,
And so,
I regard our future as something
with
which
a
is
group
pretty much a blank slate. We're
how
writing
you
it for
think about
ourselves.
really quantum
And so
computing,
we're
like
now
David
seeing
Stephenson
something coming to
Bennett
pass,
was
which is slightly
articulating what are the
different
properties we can
prognostication.
and then looking at how to make it
And
happen.
I'm good with what we're seeing so far, but there are still things to be
sensing objects at a supermarket
But
checkout.
hopefully we will rise to the
I
challenge.
realized they were
Okay,
computing.
so
So like Simon and a few other
this is
people,
interesting
we
because it sounds
realized
like
we can
Kaela
program
was
nuclear
instrumental in getting
compute.
you
And so that's what we
to
used
have
to do
greater
Grover's
access
search algorithm, and then it was used for a
intelligence
short
about
factoring
what the living
algorithm.
was.
And it worked out. The systems we did
It was the information that he was providing
scale
me
beyond
which
a few
provoked
bits.
questions.
But the
And
technique
the
have lived on,
fact that
and
they didn't
so
even want to get into
all the
long-winded
current
discussions
computing
with me
techniques
in the late
grew
90s
out of
concerning
the
what
ways
he
we would
was.
constantly spin. But
After we
I'm
had
telling
argued
this whole
for
story because
years,
it came
find out
from a
even where
bad
the
way to
material
make
was
it
coming from.
Starting with an
Then we were finally given
application
access
in
to
the
the
States,
material. This went on
to the
for
fundamental
years.
science.
fundamental science.
And
Yeah.
So you just leave them as a, just the, using nuclear physics computation that like what gave you the
Well,
guts
they weren't really.
think through
It
this
wasn't that they had another set of information. He was telling me, he did tell me basically what was going on.
I wouldn't call it guts. I would
And
call
they
it
were simply
collaboration.
not
So,
providing the
so at IBM,
that's what they
there was
considered
this
the situation.
amazing group of like I mentioned
They
Charlie
just
Bennett,
weren't going to tell me
David
what they didn't
Stephenson,
feel I needed
and Ralph
to know.
Landau and Nabil Amir, and these were all gods of thinking about physics and computing. So
He was
I
quoting me
yelled
and he was
at
informing me
the
his
whole computer
perspectives
industry
concerning
being based on
treaties. I knew something was
a
going on.
fiction, Metropolis.
And that
Programmers
is
call it
ultimately
desire
what
to
they
use
wanted
leverage
to know about.
There's a
And I said,
complete
well, for
parallel
you to know
history
about that kind of thing, then I need to know about certain other things.
Maxwell
Really a
the
quick
Boltzmann
pro
is a large
situation, and they said, well, okay,
Landauer
we'll tell you if you tell
Most
us.
people work
So
on
I
most
told
things,
them, and
but
they
this
told
whole
me.
parallel history thinking
And
deeply about
it
how
was right around that
computation
same time that
is
Lotus was actually kicking
I
into
was
form.
collaborating with a whole group of people.
May 31st,
And
2001 event.
Yeah,
That
at
took my
MIT,
prosaic
I was in the
project
SciComm
and
environment. I wasn't
garbage can, and it turned
inspired
into
to
what it
think
is now.
about
This
better ways to detect
project than it is
objects.
now.
You know, stumbled across
and as a
companies that
result,
needed help with that.
I also
thinking
found
about
out from
it.
them where
And then
they
I
stand,
realized those two
what
worlds
was
were separate,
ultimately
and we could
best,
use
and that is,
the
like I
failed
said, we'll
approach
discuss
where
that in
the
a
shoplifter
slightly
had
future date.
to make early quantum computing algorithms.
I just kind of stumbled this fundamentals to the Fab Lab idea.
That was
Right.
perspective
Here's one more example. With the student and I knew we talked about
and that
ribosomes,
is
and I was trying to build a ribosome
I
that
make a
worked
distinction
on
between
fluids
Kyle
so that
but
I
I
could place
understand
the little parts we're talking about.
and the
And
P45.
it kept failing because bubbles would
they're
come
on the
into our
same.
system and the bubbles would make the whole thing stop
They
working.
were on the same
And we
timeline, the
spent
same
about
track,
half a
but
year
they
trying to get rid
separated
of the
by
bubble.
7,000 years.
And then we said, wait a minute,
Just quite a big
the
separation.
bubbles are
Well,
actually
so what you're
better
saying
than what
is
we're
that
doing
in a
if we
sense,
just use the bubble.
Kyle
And so
couldn't get the benefits.
we invented how to do
of
universal
Already
objects
asked for
with
it.
little bubble, logic
Already asked
little bubble fluid.
And
You
then,
have to,
you know, I will say
explain
this.
microfluidic bubble logic.
This is something that David,
So, yeah.
That's super
David,
interesting.
Yeah, and so, so I'll come back
the
to
last
explain,
name. I
but
think
what
you
it
know
led
one.
to was,
But we
we
can
showed
use his name
fluid
if
Okay.
it's
to,
Well, sure, David.
it's been known fluid to do logic, like your whole automobile transmissions
he
to logic, but that's
was
macroscopic, it didn't work at little
discussing
scale.
the same
So
thing
these
with
bubbles
those,
you can do at little scale. But then I'm gonna come back and explain it, but
and
what
I
came out
said,
of that
you know,
was
a strange thing
Manu
happened. I
then
was
showed you could make a 50-cent
pro-tip
microscope
or
into little bubbles.
made
And
in
then the techniques we developed
as a
are
result
what
of
we
that.
use to transplant genomes to make synthetic life.
And
All came out of the
I got a
failure
chance
of
to chat
trying to
who
make
ended up being the
genome,
last MG
the ribosome. Now, so the way the bubble logic works is
and before tapping her,
in a little
who was the first female
channel,
member set.
fluid at small scale is
I got a chance to
fairly
look at
viscous,
certain
sort of like pushing
documents and look at certain archives in Washington, D.C. prior
if
to
a
going
bubble gets
across
stuck,
to the
the
continent
fluid has to be
and
put
meeting
around it.
with some folks.
So now
And
imagine
basically, I wasn't interested in their
a
offers.
channel that has two wells and one bubble.
Trip Russell's.
If the bubble is in one well, the fluid has to go in the
And
other.
during the
If the
same
fluid is in the
time,
other well, it has to go in the first one.
the cube disappeared.
The position of the bubble
And it hasn't been seen since. It had disappeared out of
So
the
now we have
disappeared out
one
of the
element
archive.
switch. And it's also
Of course, I have no idea.
to detect whether or not in the bubble.
I have no idea where
Then
the
two bubbles
item may be.
but
I do know
if
this.
you have two
I'm
channels
happy
crossing,
that they
a
can't
bubble
find
can
it.
go through one way,
Because
or a
what they
bubble
were
can go
doing
through the other
is
way.
they were
But
handing this
two
cube
bubbles
around.
come
This is a question
together,
that Bill had asked, whether there was only one
other,
cube.
one goes one way,
They were
one goes
handing
the
this
other way.
cube around
That's a logic
from
operation.
country to
That's a
country
logic.
to the
So we now have a
elitists
switch, we have a
in the
memory, and we
countries
have a logic.
to look
gate.
into
That's
their
everything
own
we need to
future
do.
so that they can pick the best paths
I
for
mean, the fact that
themselves.
you did have the bubbles in microfluid.
Why don't they just live their lives?
Kind of
Try to be good people.
brilliant.
Well,
Why do they
so
need
to
a
stay
little
with that
black box
example,
to tell them when to jump and how to jump?
what we
That's
propose
not being
to do
fully
is to
human,
make
at least
a
from my
fluid
perspective
ribosome.
and
And
those
the
of
project
our
crashed and burned. It
associates.
was a disaster.
That's not being fully human.
This is what came out of it.
So,
And so
as I
it was
understand it, disappeared. Now, there have been
precisely
certain,
ready
allegations
we had to do a lot of
that have been
homework
made
to be able to make these
that during
microfluids.
the time when I had
The final part was we didn't think too hard about making the ribosome. We just tried to do it.
It was
The
near the
main
end
part
of
was to realize the ribosome failed, and better it happened.
it's
And
been
if
a
you
year.
look all
And
across research
I
funding,
had
research
a very severe seizure that was actually
it doesn't anticipate
seriously
this.
for a
So
while.
fail fast is familiar.
And there was a
Fail
big
fast
hullabaloo
tends
to get
to
over
miss
to my
ready and
apartment
aim.
to get something out of
You
my
can't
apartment.
just fail. You have to
What
do
that
the
object
homework
was, I'm not
before
commenting.
the fail part,
But
and you have
I
to do
will
the
say
aim
this to
part
everybody.
after the fail part. And so the whole language of research is about like milestones and deliverables. That works if you're
It's in
going
safe
down the
hands
straight
and
line,
it won't be used too
but
hard.
it doesn't work for this kind of discovery. And to leap to
In
something you
fact,
said
the
that's
fact that it's in
really
safe
important
hands will
is
prevent it from being used.
I view part of what the Fab Lab network
It has
is
been
doing
thus
is
far only used.
giving more
Aside from,
people
well,
the
I mean, I've got to try to
opportunity to fail.
justify my own behavior.
You've
In
said
bandolier,
that
I'm using it
geometry
for the purposes of skewing, get locus off and reductions off. But I think that was for a beneficial cause.
what does fabrication biology look
but
like?
it has been
Right now.
used since actually the 50s.
Molecular biology
by
is
the
dominated
by the
by
leaders
geometry.
of
That's why
various
the
countries
protein is so
to
important. That the
skew the
geometry gives the
of the
function.
human race, and
There's
common
this hierarchical construction
average
of as you go
all
through
of us,
primary, secondary,
have a
tertiary,
right
the shape
to a future
of the
which is our own,
molecules makes the shape
not
of the
being
molecular
not
machine.
being skewed
And they
and
really are
designated
exquisite
and
machines.
promulgated and promoted and provoked by
If you look at how your
people that
muscles
feel that
move,
they are above
if you were
everyone
to see a
else.
simulation of it, it would look like a
I'm
improbable
happy to pass along
science
the
fiction
information. I'm
cyborg
honored
world.
to
These
pass
little
along the
walking
information
robots
that I understand that the
that
yellow
they're really
book is no longer accessible.
And then
That's
from
all I
there,
know
there's
about
this
it.
whole hierarchy back of once you get to the top of that, you then start making organelles that make cells.
That may be the reason too why the Illuminati hasn't
Just stepping
done
back.
something to
Does it
us.
amaze you
May
that
also
some
be the
small
reason on
building
the other end
blocks
why the old Magi haven't, and
amino acids and
maybe why they're also
molecules
quiet.
stood the very beginning of hydrogen and helium at the start of this universe. They were able to build up
Right.
I don't know.
have the upper hand anymore.
complex, beautiful things like our
The people should have the upper
So,
hand.
studying
And they should have the upper hand for their own
thermodynamics,
destiny. And
which
that's
is
why
exactly the
we
question of
too have gone as far as
that batteries run out and need to be
SSM
charged.
200 report, which was put in during
Equipment, cars get
Ford
older and fail.
administration, which I believe was written
Yet
by
life doesn't.
Dr. Henry Kissinger.
That's
Wherein
why
he
there's
suggested
a sense in which light seems to violate thermodynamics, although it
possible use
doesn't.
of food as
seems
a
to
weapon.
resist the march towards entropy.
And
Right.
it's
And
used
so
against, in fact, as a tool against the third world.
Who
Now,
gives
at
rise
the
to
same
the
time,
science
we
of
notice a
thermodynamics.
correlation.
Positive,
Find this from
a problem that was so
IPCC report
infuriating it led to a series of suicides.
that if
There
the
was a
world
series
average temperature rises
of advisors and advisees
Celsius,
3
that
in a
the
row
northern
that all ended up
hemisphere,
committing suicide that happened to
the
work
higher
in the
latitude
And
growth will increase.
Maxwell's
However, if it
demon
goes over that, it will decrease.
is this
Yet the lower latitudes,
simple
by the
but
way, that's
infinite
problem
problem
third world countries.
where
The
right
2
now
to
the
3
field is
degree
surrounded by
Celsius
molecules. They
increase
run into
will cause starvation and farm loss.
Imagine a
Now, isn't this
container
funny?
that has a wall
How
and
they're
it's got
just
gas on
allowing
both sides
global
and
warming
a little door.
to
And if the door is a
provoking
molecular
the use of
size
fossil
creature,
fuels. I'm not saying that's
and it could
total
watch
loss.
the
It's
molecules
not.
coming. And when a
There are
fast
cycles
molecule is coming, it
involved,
opens
short
the
as
door.
well as
And
long
the
term
slow
cycles.
molecule is coming.
But isn't that funny? And it's
After
my
it does that
best
for a while,
guess
one
that they'll
side is
probably
hot, the other is
order
cold.
just
When
enough
something's hot and cold,
ameliorative
you can make an engine. And
steps
so
to be taken.
you close
Where
that
it
and make an
levels
engine.
off,
and make an
where the higher latitude,
So
or
the
the higher
demon
latitude
is
probably don't
violating
lose their crops for the
thermodynamics
majority of the
because
time.
it's never touching the molecule.
That's
Yet, by
actually
just opening and closing the door, it can make arbitrary amounts of energy
observation. I
and
think
power
that
efficient. And in thermodynamics,
it is also interesting
that's
that
not
some
so
crops are being grown in the lower latitudes.
that problem is connected to everything we just spoke about in the last
But
few
then you
hours.
have sustainability though.
Neo
Whereas when you have
around
loss of the crops in the lower
early
latitudes,
1900s
you're also losing a lot of the population of the
deep
third world,
physicist
which
who
unfortunately,
then had a lot
according
to
to the
do
way that
with
the documents
also
some people may define them expendable.
nuclear thing.
I don't feel that way.
But
I'm not one
he
that likes to interject some
Maxwell's
politics.
demon to a
At
single
all.
molecule.
I like to stay
So the
in the
molecule,
research.
there's only one molecule.
Well, at the same time, and when we start hearing that the codex is being placed in
to the
place which
idea
actually
of one bit of
limits
information.
food
So
value.
Shannon credited the large
Starve
analysis
to death
of
while you're
Maxwell's
eating it.
demon
There's no
for the
nutrients.
invention of the bit.
When I started hearing that food
For
is being
many
used as a
years,
weapon, and it's being used concerning the use of fossil fuels,
the energy in the demon.
I started getting personally angry. There's not one person in the lower latitudes worth any less than me.
Nothing ever made sense.
Finally, everybody is worth exactly the same thing on this earth. And unfortunately, there are individuals who feel otherwise.
Finally solved the problem.
Okay, so Bill, the question you asked me, now that we've kind of, let's talk about, first of all, you mentioned Will U House.
son of Bill Newhouse.
When the demon opens and closes the door, as long as it remembers what it did,
Yes.
it can run the whole thing back.
Yes. Bill
But when the demon
was
forgets,
the builder of the avionics
then you can't run it backward.
back engineer,
And
the
that's
RV
where
test
you
equipment,
get
the avionics.
Dissipation,
I actually
and that's
saw
where you
some
get
of the
the
equipment. This
violation
is in
of
the
thermodynamics.
tape
And so the
Or seeing
explanation
I
of
did.
Maxwell's demon is that it's in the demon's
I
brain.
actually saw some
So
of the
then,
equipment from the diagnostic
Rolf colleague Charlie and I
the bay underneath the Galileo Bay.
then shop Rolf by
That
showing
he actually built.
you can
So when I
compute
started
with
describing it,
arbitrarily low
Will would
energy.
he's like, that's what my dad
So
built.
one of the
So
things
we had
that's
a
not well
very nice
covered
connection
is
there. It's Will
the
who had
big
experience
computers
around
used for
West
big
with
machine
his
learning.
son, Bill
The
Newhouse.
data centers use tens of
And
megawatts
Willie
of power.
Newhouse
This
is
is
alive
not power
now.
of the city.
Yes.
Okay. So that's very
Charlie
interesting.
shows
His
you
wife,
can actually
Terry,
compute with
in fact,
arbitrarily low
What I
amounts of
understand they
energy
met during
by
the
making
course of
computers that can go backwards as well as forward.
conversations concerning
And what limits the
information coming
speed
to
of
the
the
public.
computer
Jerry
is
and Will met one another,
how
fell in love,
fast
and
you
were
want
married.
an answer
That
and
makes
how
me feel kind
certain
of
you want the
personal.
answer to be. But we're orders of magnitude away from that.
It
So
sounds
I
like
have a
Will
student,
knows
Cameron,
quite a
working
bit
with
about
labs on
what
making
makes the
superconductor
ARV run.
computers that operate near this
Yes.
Landauer limit.
So in
That are orders of
1947,
magnitude.
it was discovered.
So stepping back to all of that, that whole tour was driven by a question about life.
By bringing
And
in
right at the heart of it is
I mean, I don't know what
Maxwell's
the
theme. Life exists
First of all,
because it
it
can
wasn't
locally
actually
violate
was
thermodynamics.
not discovered in
It can locally
1947.
violate thermodynamics
Mixture of
because
the
it's
stories
intelligent.
involved. The cube was
And
actually
it's
the
molecular
information about the
intelligence.
cube's existence was known as
I would even go out on a limb and say we can already
it was
see
further
we're beginning
discussed
to
in
come to the end
1947 after a
of
certain
this
crash in
current AI phase. So depending on how you count, this is, I'd say, the fifth AI boom bust cycle.
and
You can already,
following
it's
which
exploding, but you can already
during
see where it's heading,
the first
how it's going to
four
saturate
treaties by
with
the
what happens
Alliance
on the
with
far
Eisenhower,
side.
the cube was handed to
This
Eisenhower.
thing
It was
that's
in
not yet
fact
on the
expected
horizon
to go
is
to the United Nations authorities.
embodied
And it was in
AI,
fact
molecular
spirited away by the United States.
So to step back to the AI story,
So,
um,
but you,
there was
about the cube is that it
automation
sounds
that
like
was going to change everything. Then there were expert systems.
Emotionally
Um,
with the viewers in a sense.
It does.
There
And
was
in
then
fact,
the
it was handed. It was
first
actually a
phase
riot.
of the neural network system.
Technology.
There's been about 5 of these.
And
In
it was
each
handed
case,
over by
on the slope up, it's going
spirit
to
of
change
goodwill,
everything.
but a
In
misassessment
each case, what happens
as
is
to
on the
our
slope down,
evolutionary state,
we sort of move
our ability to
goalposts,
handle
and it
these
becomes sort of irrelevant.
and
So
handle
a good
the
example is
they felt this more
going up,
balanced.
computer chess is going to change everything. Once computers can play chess, that fundamentally changes the world. Now on the downside, computers play chess. Winning at chess is no longer seen as a unique human thing,
I'm not exactly
but
certain what
people
was
still
seen
play
relative
chess.
to cube.
Yeah. This new phase is going to
However,
take
the
every
analysis
of things that we thought computers
I was
couldn't
asked
do.
to do.
Now computers will be
Of
able
course,
to
I
do. They
paid
have roughly
twice
our
now
brain
that I've actually done it.
But
Again, people
we'll
don't want to
keep
hear the
thinking
answers
it's
that
always
I
computers.
came up with, but
And as I described,
the
while we go
analysis
through these
that I
5
did
boom
indicated
busts,
that
if you just look
certainly
at the numbers
there's
of opposite
at minimum a great suspicion
that's the more
concerning
interesting.
the
That's the steady,
delay
and
of
that's what
response.
comes from people.
And the
As
information
we
that I
talked
have
about a couple
directly
times,
from
there's
one of
8
the
orders
state
of
members
magnitude to go,
was the
not
fact
in the
that we were
intelligence of the
aware
transistors or in the
this was
brain,
looking
but in
glass
the embodied
technology,
intelligence,
not the
in the
cube.
intelligence in our
That
body.
we were aware as in the middle 1990s that there would be a coming Islamic extremist war with the United States.
Right,
We
and
were also aware of
there's a
certain
brain centrism that is
situations
our
that
intelligence
they
being centered in
use
our
the
brain.
statistics from the looking
And
glass
in endless ways
variability
in this
between
conversation,
different
we've been
pictures
talking about molecular intelligence.
to
Our
show
molecular
that
systems
occurring at the same
do
time,
a
of
deep
probability
kind of artificial
Same time.
intelligence. All the
And
things you think of as artificial
from their
intelligence
perspective,
does in
that the least of its
representing knowledge,
consequences was
storing
9/11.
knowledge, searching over knowledge,
I am
adapting
aware
to
of what the
knowledge,
other
our
possible
molecular systems
consequence
do. But
was.
the output isn't
I'm not
just
willing
the
to come
thought,
out and
it's
start
us.
mentioning it because
It's
I
the
don't know what
evolution
the
of us.
consequences are of
And
some of the
that's
things that haven't
the
been,
real
that have
horizon
not
to
thus
come
far
is now
happened, yet the
embodying
probabilities
AI,
exist
not
that they
just
could.
the processor in a robot.
So you know, I'm feeling a little
Building
bit, there's a
systems
little
that really
weight when it
can
comes to that.
grow
But
and evolve.
saying
We've been
though
speaking about
that
this
it's
boundary
looking glass
between
is
bits and
definitely,
atoms.
as you called it,
Let me ask you
decommissioned.
about
Yes,
one of the big
And that means
mysteries
across
of
the board.
consciousness.
across the board. They are
Do
shut
you
down.
think
And you said there was
it
50
comes from
man-made
somewhere
devices
between that boundary?
and
I won't
I said at least
name
50.
but
would
if you know who I'm talking about, it's probably clear. I once did, in fact, up to the bustling Natura villa outside Camino, in the early days of the quantum computing, with a famous person who thinks about quantum mechanics and
Original
consciousness.
cylinder
And we had the
seal.
most infuriating conversation that went roughly along
In
the
essence, you can
lines
take a
of
looking glass unit and make a couple
consciousness
changes
is
to
weird,
the equipment,
quantum
lift it up
mechanics is
on an
weird, therefore
put
quantum
field
mechanics
posts
is
around
weird.
it, and open up
That was
a whole system.
roughly the logical process.
And you're not satisfied with that process.
No, and I say that very precisely in the following sense. I was a program manager, somewhat by accident, in a DARPA program
We had
on quantum biology.
a basic
And so
monopoly over the
biology-
looking glass that and India.
Trivial
Indian
uses
brokered
quantum
early on
mechanics
with
were made out of atoms.
Gandhi was
But the
brokering
distinction
the
is
committee of the
in
majority
quantum
between the
computing,
United States
quantum
and the Soviet
information,
Union
you
because the
need
Soviets were
quantum
threatening to
coherence.
start their own treaties
And there's a lot of
with
muddled
the
thinking
extraterrestrials,
about
which would have
like
become untenable.
collapse of the wave function
We
and
agreed
claims
then
of
to
quantum
expand
computing
NJ12
that
from a
garble
wholly
just
operated and owned American
quantum
operation
coherence. That,
to an international
that
operation. Thus was
you can
born
think of it as a wave that has
between
very special
1963
properties
and
that these waves like
1967.
properties.
And
And
when
so there's
that
a small set of
information was
places
brokered,
where biology uses
that happened
quantum
in
mechanics
parallel
about
with,
2%.
kind of under the table,
One
but
is
in
how
parallel with
light
United Nations
is
treaties
converted to energy
involving
in the
things
solar
like
system. It looks
test
like
ban
one
treaty
is all
in outer
about
space.
how your nose is able to tell the
And so it was
smell.
being done at the same time under cover of UN
Probably
support.
one has
The
to do
diplomats
with
were
how
going back and
birds
forth,
navigate,
brokering the opening up,
how
so
they
that
sense
the
magnetic
treaty
field.
system would be a single treaty system,
That involves
thus
a coupling
tenable
between
and
very weak
manageable
energy with the magnetic field,
to
coupled with
hopefully get
chemical
out.
reactions.
And
And
we'll
there's
be knowing them in the
a
next few years
beautiful
whether that
system.
was
It's
successful.
standard
So this
in
is, I mean, this is
chemistry
really
is
fascinating. You're saying that
magnetic
some
fields like
other
this can
countries,
influence chemistry,
India for one,
but there are
had
biological
access to
circuits that are carefully
Yes,
balanced
ma'am. They had that
from
written
a balance
as far back
magnetic
as the
field.
1960s
So each of these
and
areas
70s
are
when it was
essential
actually
for
being back
biology. We
engineered
have to
from the
consume
start.
resources to use quantum
And
mechanics.
so at the same time that Will
So
Newhouse, for
those are
instance,
places where we know
was
there's quantum
looking
mechanics
at the
out.
early generation
In
looking glass,
cognition, it's just
you had the same.
there's no evidence of
To
anything
the information or to the equipment.
mechanical going on in how cognition functions.
No.
Well, I'm saying cognition. I'm not saying consciousness. But to get
No,
from
because
cognition to consciousness,
I'll tell you why the answer is no.
McCullough and Pitts made a model of neurons.
Within the treaties, the looking glass, as
That
well as
led
the
to
stargates, as
perceptrons
well as the cube,
that then to a couple of
and
boombox
the information
led
movement
to deep
pods
learning. One of the interesting things about that sequence
are all
is
contained
it
within the
diverged
treaty
off.
system.
So deep neural
Within that
networks
treaty system,
used
it also
in
prohibits and allows certain
diverge from trying to
passage of
understand how the brain
information
works.
amongst delegates,
What makes them work,
where the
what they
looking
learn
glass
is
material is
they-
and where the
it's really
information
interesting
flow is,
story,
where the
just
access
maybe
is.
too much
Being
of
that
the
I
technical
stood in
detail, but
Van
it has
Blair
to do
and
with
considered
functional
a delegate,
fascination.
therefore I can tell you.
That we talked about exponentials. A deep
No.
network
access to
needs
that
an exponentially
Aside from India,
larger,
in the
shallow
United States.
network to do the same function.
So, but we can assume
And that
some
exponential is
countries
what gives you power
perhaps,
to deep
that
network.
is the leadership of some
But what's
countries,
interesting is the
may
sort of
have access
lessons
to these
about
technologies.
building these deep
I
architectures
think
and
that
how to train
it's
them
fair to say that we can assume
have
that they had
really
access to
interesting
the
echoes to
information
how
from it,
brains work.
but I
And
wouldn't
there's an
place any
interesting
characterization
conversation
over any
that's sort of
assumption.
coming back from neuroscientists looking over the shoulder of people training these deep networks, seeing interesting echoes to how the brain works, interesting parallels with this. And so I didn't say consciousness, I just said cognition. But I don't know any experimental evidence that points to anything in neurobiology that says
having a cup of coffee. This is all part of
and
There's nothing as natural
I
as
view
getting
that
up and having a
questions
cup of coffee.
about whether a large language
And we should have
model
never built.
is conscious
The
as
Stargate,
silly.
yes.
It in
Okay,
that
for the purpose of
biology
speaking with
is
the visitors who have their timelines. Yes, absolutely.
There's no
Look at
evidence
last
we have that there's anything
was
deeper
done
going on than just this sort of
because of
backing
our
up
own
of having a brain.
shortcomings
And
as
somehow
people who
consciousness is
aspire
one
to
of the
things
hacks
that
or
we maybe
emerging
shouldn't try to
property
grab a
hacks.
hold of.
Absolutely.
Should have never been built.
Just numerically, I said big computations now have the degrees of freedom of the brain.
Yes.
And they're showing a lot of the phenomenology of what we think is properties
In fact,
of
well,
the
I
brain
can say
can do.
against misuse. I am an advocate against its use.
And I don't see any reason we would go to anything else.
That makes you wonder what kind of beautiful stuff digital fabrication creates. If biology created two halves on top of which consciousness and cognition, some of the things we love about human
Best I
beings,
understand, and I'll speak to Bill
it makes you wonder what
a
kind
while
of
about it. A little while
beauty
ago,
in the
the
complexity of
wings
this.
and the amount of information
There's an early peek at that.
via energy, which is passed into
There's a misleading term which is generative design.
the
Generative
position of the
design
rings,
is where
their
you don't tell a
orientation, the energy
computer how to
running
design
through them,
something, you tell the
position
computer
of the
what you
barrel,
want it to do.
etc.
That doesn't work.
Raise the barrel up on
That
the
only
armature
works in limited
inside the
subdomains.
center of it.
Like you can't do
all
really
come into
complex
play. They
functionality
said
that
that you
way.
have,
The
and
one
then you,
place it's
the various
mature,
layers of
though,
the onion,
is topology
as you move
optimization.
through the different energy
Let's say you wanted
levels,
to
you
make a
also move
bicycle,
through the different layers,
or
you
it's
get different
cable.
bits of information.
You
Now imagine
describe
again
the
almost
loads
infinite
on
number
it,
of layers
and figures out how
overlaid
to design it.
in comparison to
makes
the
our
positions of the rings and
beautiful
amount
organic
and
looking
almost
things. These are
infinite
things
amount of
that look
energy
like they grew in a forest.
that
And
you can add or
they
subtract.
look like they grew in a forest because that's sort of exactly what
Tuning
they
it
are.
up, tuning
That
it down.
they're
Instead of
probably
going
the
up by
ways
1
of how
hertz
you
or by
handle
2
loads
hertz,
in the same way
maybe
biology
by
does. You get things that look
1,000
like
hertz
trees
up and down.
So that's the peak of the transition to
Right, except
we design.
yeah, you get a different design and the colors change. It's like
What can you say about, because you mentioned
working
cellular
with
automata
multiple
earlier,
kaleidoscopes,
about, in this example you just gave,
where
in
when
general
you
the
fit, when you
observation you
find
make
two
by
different
looking at cellular
probabilities
automatas, that
you
there's
could run into.
some simple rules,
You have two
simple
kaleidoscopes,
building blocks
and
emerge
you make a change on one
arbitrarily.
kaleidoscope
Do we
that
understand,
may
do you
factor or
understand what
function
that is, how
to
that
a
can be
different
leveraged?
angular change on another kaleidoscope. So you get two separate pictures that you then have flashing
I
back.
complained about Turing's
Yes.
physics concept,
I could,
but Turing
that's
never
technology.
intended it to be a computer architecture. He used it just to prove results about
Yeah, in
uncomputability.
fact, there's a deinterlacing system.
What Turing did on what is computation is
Deinterlace the flashing back and forth
he
of
gave
the
us our notion of
probabilities
computation
or the
and
multiples that
universality.
they had at certain times
And
when it starts
something
skipping.
that sounds deep and turns
Well,
out
what they did is they deinterlaced the video and then reintegrated the video and watched the individual videos.
so almost everything.
Then determined statistically how much time was spent
So
on each video
Norm
to determine the
Margolis
amount
wrote
of
a beautiful
probability of
paper,
each event occurring.
and
they tested that against
showing
probabilities in the
a
field,
cellular camera world is
probabilities
like
of
the
future
game
occurrence
of
to
life.
get
where
a
you just
system which
move
functions
tokens around.
scientifically. And that's
They showed that modeling billiard balls on a billiard table with cellular automata is a universal computer.
In other words, if they
To
saw
be universal, you need a persistent state, you need a nonlinear operation to interact them,
see which one happened.
and
That's what
you
they did.
need
Absolutely.
connectivity.
That's right on.
So
That's
that's what
right
you
on.
need to show computational
That's right on
universality.
me.
So they
And,
showed that
you know, some people, like I said, some people say it's
billiard
foolish
balls
smoke and
is a
mirrors.
universal computer.
Then again, I was doing something in 2001 that I'm living in right now.
Chaos,
Okay, without knowing what it is. And like I said, about the future, but you know,
that they're harder than you can't predict.
it's the
They're
best
actually
scientific
equipment
that I can imagine for the determining of such a
Chris
thing.
Moore showed it's very easy to
But
make
it goes
physical
to the old
systems
question,
that are
because we have the
uncomputable.
power
That's
to use
what the physics system does. Just
And
bouncing
I am
balls
a
and
100%
surfaces to make
advocate.
systems
I had
that
a
solve uncomputable problems.
more
And
than a
so
small dust
almost
up
any non-trivial
over this
physical
very
system
same
is
thing,
computational.
which actually resulted
So the
in
first
me
part of
walking
the
alone
question
down
is,
Lake Mead back
yeah,
toward
this
Las
comes back
Vegas.
to
She and
the
I
comment about how do you
yelling and
bootstrap
screaming at each other along the roadside.
You just
They
don't
were
need
doing
much
tests out at Frenchman Mountain during the
So
time
then,
that the
There isn't today a notion of like fabricational universality.
They hooking up and all of that.
The sort of numbers I've been giving you about you eating lunch
and there were access there was some mistake, and
that's in the same
a
spirit
small
of down
explosion out there on the east side of this
once you connect
piece
computational
of helmet. And
universality,
she wanted me to go
kind
out
of
there with her to
fabricational
help
universality,
clean some of the
you then
evidence
get
up
the ability
of it.
to
She and I got some more of a little dust up because I didn't want anything to do with it. Because I don't believe I'm no Luddite. I mean, I'm all for grand technology, but I don't believe in playing with things which actually deal with looking at it. There's another issue that was going on at the time of that. The variety of communication that was going on via this equipment from elsewhere.
studying
I presume she will still
how genes
Yes.
devise the form.
admit
So,
to me, but
how
I presume that it was
small
from
amount of
Ryan,
relatively
and it was information, defense-related information on how this type of equipment,
and
how an Einstein-Rosen bridge at a distance
what resides
could be used to
molecular
pull
intelligence,
information out of a
which
defense
is first how to
system.
describe you,
And I don't mean a U.S. defense computer system. I said, you know what?
describe you such
No.
that you can
Look,
exist,
We've got the
and you can
technology here,
reproduce,
we've got
and
the
you can
talent,
grow,
we've
and you can
got the
evolve.
willpower
And so
got the willing
that's the seed
to
of
defend our
our
own country
molecular
without the
intelligence.
use of something involving
To make a revolution
technology.
in biology.
Yeah,
I wouldn't want to
really
go
is.
up against, for instance, God
It
help
really
us,
is. And
Chinese on the
that's
ground.
where
But at the same time, I don't fear their country either. I believe that we should be diplomatic
you
with
can't
them
separate
and have
computer
a
science,
firm
physical science,
understanding
you
and
can't
respect for
separate
one
hard
another. But I also don't
software.
fear them.
They all intersect
And
very heavily.
so the use of technology like that
Uses of our universe.
is not honorable.
Right, well, it's like knowing how the game
I would
plays out.
even kind of say quantum computing is overhyped in that there's a few things quantum computing is going to be good at. One is
That's
create
why I
a
was
crypto
so
system, figuring out how to
interested
make a
in
crypto system.
when I was
What
doing
it's
my
really
time,
good at is modeling other
doing my time with the jobs
studying
involving safety
nanotechnology
here
is
in
kind
training
of powerful.
here in Las Vegas.
But
When I was
quantum
interacting
computing
with
is not going
Marcia
to
and the
disrupt
I,
and change everything.
because we were literally
But
on a
the reason
daily
I say
basis
that
talking
is
about that
the
same thing
interesting
and about the
group of
psychology of
brain
individuals
who
who
helped
come to a
invent
table,
quantum computing
play a
before it
game,
was clear
and
anything
who
was
cheat
there.
to alter the outcome
One
of
of
the
the
game.
main reasons they did it wasn't
And
to make a
that
computer
whole
to break a
psychology,
crypto
it's
system.
something which
It was
I'm not,
to turn it
it's
backwards.
not foreign
You
to
could
me.
be surprised
And
quantum
so
mechanics
that
huge.
helped will prime
Or
the
you could
wick
go in the opposite direction.
of the
and say it's
explosion
quantum
between
mechanics
myself and that variety of technology, which
that's
actually
a description
primed
of
my
history.
disagreement.
So physics
Okay, well,
is
I
written
understand
in
what you're
terms of
saying,
partial
and
differential
there's
equations.
a million questions that all.
That is
know.
an information technology
But
from
I would like to ask,
It's 30th in here.
knowing, but now that I know what I know.
the equations of physics are not, this would sound very strange to say, but the equations of physics, Schrodinger's equations and Maxwell's equations and all of them, are not fundamental. They're a representation of physics that was accessible to us in the era of having a pencil and a piece
I
of
understand,
All
but
right.
is there something there?
They have a fundamental
In other words,
problem,
is
which
this
is if you
technology
make a
something
dot on
they
a piece
are
of paper,
using now?
in traditional physics theory, there's infinite information.
The technology is not being used
A
at all.
point has infinite information.
Because of where we're
That
going,
can't be true because
the galactic,
information
the plane of
is
As of about
a
2017,
fundamental
I would
resource
expect
that's
probably that
connected
all of
to
these
energy. And in fact,
will probably all get reassembled.
turn back on.
Oh, sure.
one of my favorite questions you could ask a
2016,
cosmologist to trip them up is ask, is information that conserves quantity in the
I
universe?
figured that they're probably going to act
Was all the
conservative.
information created in the Big Bang, or
That's
the
what
universe create
all the
information? And
wisdom that's
I've
suggested
yet to meet a cosmologist who
is
doesn't
to act conservatively.
stutter
That
and
yes,
not really know how to
so-called
handle that
cycle of catastrophe,
existential
or
question.
catastrophe,
Sort of
a
putting that to
finale.
the side,
the time
in
period
physics
from
theory, the way it's taught,
right around
information
1992, right around
you know,
2012,
you're taught
right
about
around that area.
a variable,
While
it
we
could
will
contain
cross
infinite
the
information, but
2012,
physically that's
we really ought to
unrealistic.
get
And
through
so
the
physics
entire
theory has to
cycle,
find ways
which is about 1980,
So
about
instead,
2016,
there
to feel
are a number of people
confident that the interpretation from
a theory of the universe starts with information
It's not off by a
computation
few years.
as the
Talking about
fundamental resource
45,000
of
years,
nature, and then
50,000
we
years.
build up from that to
We
something
have
that looks like
difficulty
throwing
understanding what happened
baseballs down
2,000 years
a slope. And so in that sense,
and we're talking about 50,000
the
years.
work on physical
So,
computation
It's very wise.
has many applications that we've been talking about, but more deeply, it's really getting at new ways to think about how the universe works.
Yeah, they're
And there are many
decommissioned and the
things
stargates
that
and
are
the
hard to do in
masses,
traditional
I'm sure
physics
they're all
that
in their
make more sense
ball
when you
containers and
start
all
with
that.
information and
And they have been
computation
separated. The three
as the
components of
root
each
of
been separated and moved
Information
to different
computation
power
being
structures,
the
different military authorities on
Right. That
and we're talking about
information
the
is a
EU
resource. You
specifically,
can't have
the
you
UN
can't
and
have
NATO.
infinite
Those
information
are
on
in
that stage.
specific
Information
control
computation
of
interacts,
one of the
and from
three
there you erect
components
the scaffolding
each.
of physics.
And I
Now,
cannot comment as to which
the words I
components
just said look a lot like quantum field theory.
There's no doubt
But
whatsoever.
there's an interesting way where instead of starting with different
there is no doubt
differential
whatsoever
equations
when
to
it
get
comes
to
to
quantum
the
field theories,
looking
quantum
glasses.
field
And
theories
when it
you get
comes
to
to the Stargate
quantization.
technology, that it has been decommissioned.
If you
And
start from
however-
computation information,
however,
you begin sort of
There are
quantized
threats
and
going
you
on,
build up.
ongoing threats
so
from
that's
present
essentially
countries
what
stating that they will put it
absolutely I think
together
that's
at their will, do their own
the easy way to
self-determination.
understand that
And those
is
countries, if
just
push comes to
almost
shove,
anything is
will be
computational
shoved.
universal, but the deep way is it's a real fundamental way to understand how the
as in build one themselves now.
Let me go
Yeah,
over
what
to
was-
the
what
first
was
one,
extant has been
the
collected.
centerpiece and atoms.
I'm under
You have
very good assurance that what was sitting there has now been collected.
the students you work with have gone on to do some incredible things in this world, including build supercomputers that power Facebook and Twitter and so on. What advice
The
would
very highest
you give
probability for those things.
What advice
That's
would
true.
you give them
That's true.
how to
And
have
Bill was
one heck of a great
asking
career?
about a future date.
one important one is
A year.
if
And
you look at junior
he was saying,
faculty
well,
trying to
you're
get
going to be
tenure
provided
at a
for
place
that.
like MIT,
Why wouldn't you?
the ones who try to figure out how to get
Highest
tenure are
probability
miserable and don't get
year
tenure,
for it.
and the ones who don't try to
However,
figure it out or have to
telling
do
me
get it.
about something that might happen in the future
You have to love what you're doing and believe in it, and
is one matter.
nothing else could possibly be what you want to be doing with your life, and it gets you out of bed in the morning. And again, it sounds naive, but
all of us here on the earth,
within like the limited domain I'm describing now of getting tenure at MIT, that's a key attribute to it. In the same sense,
that carries
if you take the sort of outliers students we're talking about, if 99 out of 100 come to me and say your work is very fascinating and interesting to work for you, and 1 out of 100 come and say, you're wrong. Here's your mistake. Here's what you should have been doing.
Yes.
And
Yes. We're looking at a low probability
they just sort of say, I'm here and get to work. And again, I don't know how far the
events which would
goes.
kick it off.
I've said I consider the
For
world's
instance,
greatest resort this engine of writing them and people, of which we only see a tiny little iceberg of it. And everywhere we open these labs, they come out of the woodwork. We didn't create all these educational programs, all these other things I'm describing. We tried to partner everywhere with local schools and local companies and take over this function and find a way to create an environment for people like this. I don't know if this is everyone, if it's 1% of society, what the fraction is, but it's so many orders of magnitude bigger than we see today. We've been racing to keep up with it.
Okay, well that's pretty
This is something that's a very large fraction.
I can't.
The thing that gives me most
People will then
for the future is that population. Once a year, this whole
out
lab
there
effort.
now that are saying,
And it's my favorite
right
gathering
around the
this
corner
year
at any
because
moment
it's
now.
every body shape, it's
Why
every
won't
language,
you
every
save
geography,
us?
but it's the same person
We
in
need to
all
save
those
ourselves.
packages.
And that's why
It's the same sense of right
taken,
and then of
that
joy
have
and
been taken in the
discovery.
world and are still
If there's
on
people
the way.
listening to this and they're
So that
just
we will save
overwhelmed with how exciting this is,
Reached
I think
another
they will
milestone today.
how can they participate? How can they help?
Days,
How
I
can
can't
they
believe it.
encourage
These are things
young
you
people or
should like.
themselves
But there's still a long way to go. That's not a
build
big
stuff, to create
place.
stuff?
Yeah,
Please
that's a
help me
great
in my
question.
efforts to
So,
get this information out and share this with anyone who might lend an ear and even
this is
subscription
part
if
of
they
a
have.
a much bigger maker movement that has a lot of embodiment. Part of them involved in
So
the
press
Fab
all
Lab
the buttons
network.
and all the
You can
channels
think
on
of it as
this
a
domain.
curated site
Finally
that
get to
works
say
with the
hi to
network.
our cosmic
So
neighbors.
you
We could
don't
just open
benefit
the doors
in a
once,
gym if somebody
make the government.
exercises in another
You could
gym.
literally see you
But in the Fab network,
today yourself.
you do in a
I
sense
appreciate
benefit
any
somebody
help.
else
See
in
you
another
next
network,
time.
another lab in the way it functions as a network. So you can come to cba.mit.edu to see the research we're talking about. There's a Fab Foundation run by Sherry Lassiter at fabfoundation.org. Fab Labs.io is a portal into this lab network. FabAcademy.org is this distributed hands-on educational program. Fab.city is the platform that cities producing what they consume. Those are all nodes in this network.
You can learn with Fab Academy, and you can perhaps launch or help launch or participate in launching a Fab Lab.
Well, and in particular, from 1 to 1,000, we carefully counted labs. Now we're going from 1,000 to 1 million, where it ceases to become interesting to count them. And in the 1,000 to the million, what's interesting about that stage is technologically, you go to a lab not to get access to the machine, but you go to a lab to make the machine. But the other thing interesting in it is we have an interesting collaboration on a Fab Lab in a box. And this came out of a collaboration with SolidWorks on how you can put a Fab Lab in a box, which is not just the tools, but the knowledge. So you open the box, and the box contains the knowledge of how to use it as well as the tools within it, so that the knowledge can propagate. And so we have an interesting group of people working on, the original Fab Labs. We have a whole team to get involved in the setting up and training. And the Fab Academy is a real in-depth, deep technical program for training. But in this next phase, how sort of the lab itself knows how to do the lab. We've talked deeply about the intelligence in fabrication, but in a much more accessible one about how the AI in the lab, in fact, becomes a collaborator with you in this nearer term to help get started. And for people wanting to connect, it can seem like a big step, a big threshold, but we've gotten to thousands of these, and they're doubling exactly that way just from people opting in.
And in so doing, driving towards this kind of idea of personal visual fabrication.
Yeah, and it's not utopia, it's not free, but come back to today, we separately have education, we have big business, we have startups, we have entertainment, sort of each of these things are segregated. When you have global connection to one of these local facilities, in that you can do play and art and education and create infrastructure. You can make many of the things you consume. You could make it for yourself. It could be done on a community scale. It could be done on a regional scale. It really, I'd say, the research we spent the last few hours talking about, I thought was hard. And in a sense, I mean, it's non-trivial, but in a sense, it's just sort of playing out returning to friends. What I didn't think was hard is, if anybody can make almost anything anywhere, how do you live? How do you learn? How do you work? How do you play? These very basic assumptions about how society functions. There's a way in which it's kind of back to the future, in that this mode where work is money is consumption, and consumption is shopping by selecting, is only a kind of a few decade old stretch. In some ways, we're getting back to, a Sami village in North Norway is deeply sustainable. But rather than just reverting to living the way we did a few thousand years ago, being connected globally, having the benefits of modern society, but connecting it back to older notions of sustainability. I hadn't remotely anticipated just how fundamentally that challenges how a society functions, and how interesting and how hard it is figure out how we can make that work.
It's possible that this kind of process will give a deeper sense of meaning to each person.
Let me violently agree in two ways. One way is this community making crosses many sensitive sectarian boundaries in many parts of the world where there's just implicit or explicit conflict. But sort of this act of making seems to transcend a lot of historical divisions. I don't say that philosophically, I just say that as an observation. And I think there's something really fundamental in what you said, which is deep in our brain is shaping our environment. A lot of what's strange about our society is the way that we can't do that. The act of shaping our environment touches something really, really deep that gets to the essence of who we are. That's again why I say that, in a way, the most important thing made in these labs is making itself.
What do you think, if this shaping of our environment gets something deep, what do you think is the meaning of it all? What's the meaning of life?
I can tell you my insights into how life works. I can tell you my insights in how to make life meaningful and fulfilling and sustainable. I have no idea what the meaning of life is, but maybe that's the meaning of life.
The uncertainty, the confusion, because there's a magic to it all. Everything you've talked about, starting from the basic elements, the Big Bang, that somehow created the sun, that somehow said FU to thermodynamics and created life in all the ways that you've talked about, from ribosomes that created the machinery, that created the machine, and now the biological machine creating through digital fabrication, more complex artificial machine. All of that, there's some magic to that creative process. And we humans are smart enough to notice the magic.
So you haven't said the S word yet, singularity. Yeah, I'm not sure if Ray Kurzweil is listening. He is. Hi, Ray. But I have a complex relationship with Ray because a lot of the things he projects I find annoying. But then he does his homework, and then somewhat annoyingly he points out how almost everything I'm doing fits on his roadmap. And so the question is, are we heading towards a singularity? I'd have to say I lean towards sigmoids rather than exponentials.
We've done pretty well with
yeah, so sigmoids are things grow and they taper, and then there can be one after it. So, I'll pass on whether there's enough of them that they diverge. But the selfish gene answer to the meaning of life is the meaning of life is the propagation of life. And so, it was a step for atoms to assemble into a molecule, for molecules to assemble into a protocell, for the protocell to form, to then form organelles, for the cells to form organs, the organs to form an organism. Then it was a step for organisms to form family units, then family units to form villages. You can view each of those as a stack in the level of organization. So you could view everything we've spoken about as the imperative of life, just the next step in the hierarchy of that, and the fulfillment of the inexorable drive of the violation of thermodynamics. So you could view, I'm an embodiment of the will of the violation of thermodynamics.
the two of us having an old chat, yes.
Yeah.
And so it continues, and even then the singularity is just a transition up the ladder.
There's nothing deeper consciousness than it's a derived property of distributed problem solving. There's nothing deeper to life than embodied AI in morphogenesis. So why so much of this conversation in my life is involved in these Fab Labs? And initially it just started as outreach, then it started as keeping up with it, then it turned to it was rewarding. Then it turned to we're learning as much from these labs as goes out to them. It began as outreach, but now more knowledge is coming back from the labs and is going into them. And then finally, it ends with what I described as competing with myself at MIT, but a better way to say that is tapping the brain power of the planet. And so, I guess for me personally, that's the meaning of life.
Maybe that's the meaning of the universe too. It's using us humans and our creations to understand itself. In the way it's whatever the creative process that created Earth, it's competing with itself.
Yeah. So you could take morphogenesis as a summary of this whole conversation, or you could take recursion. That in a sense, what we've been talking about is recursion all the way down.
In the end, I think this whole thing is pretty fun. It's short, life is, but it's pretty fun. And so is this conversation. I mentioned you offline and going through some difficult stuff personally. Your passion for what you do is just really inspiring, and it just lights up my mood and lights up my heart. You're an inspiration for, I know, thousands of people that work with you at MIT and millions of people across the world. It's a big honor to sit with you today. This is really fun. This was a pleasure. Thanks for listening to this conversation with Neil Gershenfeld. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Pablo Picasso. Every child is an artist. The challenge is staying an artist when you grow up. Thank you for listening, and hope to see you next time.
Easier said than done. 2/3 of Congress, both the House and the Senate, 2/3 of the legislatures around the United States.
Let's imagine you have a black rapper who invites people on stage, and let's suppose they invite a black person on stage. They're perfectly happy with the black person, flout with terrorism. They invite a white person on stage. The white person is, he doesn't, sort of mystified, but he comes on stage and flouts with what the rapper says, in the infamous N-word, and then the black rapper gets mad. Imagine the white comedian who satirizes, pokes fun, and in poking fun at that, says the infamous N-word. Am I angry? No, I'm not angry. Not angry at all.
Following is a conversation with Randall Kennedy, professor at Harvard Law School and author of many seminal books on race, law, history, culture, and politics, including specifically on affirmative action, criminal justice, policing, and the topic explored extensively in this conversation, the single most powerful word and slur in the English language, the N-word, with a hard R at the end. Randall has written a book with this word as the title, N-word, the strange career of a troublesome word. Please be warned that Randall uses this word throughout this conversation, deliberately and skillfully, to discuss its power and its role in the history of the United States. I don't intend to shy away from controversial topics like these, and I will work hard to handle them thoughtfully and thoroughly, with respect and with empathy. Often, the several guests will have very different perspectives on the topic. In the end, I believe in the power of long-form conversations to heal divides by furthering understanding of human nature, of human history, and the full diversity of the human experience. This is the Lex Friedman Podcast. Support it. Please check out our sponsors in the description. And now, dear friends, here's Randall Kennedy. We wrote a book whose title is The N-word, spelled out with a hard R at the end. So let's start with the history of this word. What is the history of the N-word?
The word you're referring to is nigger. The book that you're referring to is Nigger, The Strange Career of a Troublesome Word. The word dates back to the 16th, 17th century. It's got a long lineage of other words. Basically Latin, basically Spanish, basically NIG, black in various formulations. We don't know actually how the term nigger became a slur. So there were words that were close to NIGGR that were used in various ways. For instance, NIGGUH, NIGGR. And sometimes it was used in a way that seemed to be just purely descriptive. We do know that by the early 19th century, it had become a slur. It had become a derogatory word about which people complained. But exactly how that came about, no.
So it's been 20 years since you've written the book. What have you, what wisdom have you gained about this word since writing the book? And maybe having to interact with people, having to read, having to see, having to feel the response to the book.
This book has generated a lot of controversy. I thought it would. It's probably generated more controversy than I anticipated. It has certainly generated more different sorts of experiences than I had anticipated. So, for instance, I did not think that writing this book would prompt people to ask me to be an expert witness in cases. And over the past 20 years, I've been an expert witness in a number of different cases. I've been an expert witness in cases, a murder case, in various cases of assault. I've been an expert witness in cases involving tort cases, infliction of emotional distress. I've been an expert witness in a number of employment cases. I had not anticipated that, nor had I anticipated the extent to which people would get in trouble for using my book. Every year, there are teachers who are suspended or who are fired because they would excerpt a chapter of my book. Let's imagine I'm not imagining things. This is happening. A teacher is teaching, for instance, the Mark Twain's Huckleberry Finn. The word nigger appears in that book over 200 times. The teacher, trying to be earnest, trying to be sensible, trying to be serious, will excerpt a part of my book to acquaint students with the history of the word and maybe the history of controversy involving the use of the word in this particular novel. The teacher will give it out, hand it out to the teachers, hand it out to students, and there have been a number of teachers who've been suspended or worse because of that. Students will get upset, go home, tell their parents. Their parents will storm the school and say that this is terrible. The teacher is, quote, using the word nigger in an offensive way. And oftentimes administrators will basically abandon the teacher. And whenever this comes to my attention, I'll write the superintendent of schools, or I'll write the principal, or sometimes I write an opinion editorial piece for the local newspaper. But every year there are teachers who are disciplined for using my book. I had not anticipated that.
What is the nature of the letter or the op-ed that you write on why they shouldn't be disciplined, or if they to the degree they should be or shouldn't be?
There's not been one case. There's not been one case that has come to my attention in which it was even remotely sensible for the teacher to be disciplined. And what I say is that, number one, frankly, I go through, what I write is almost a synopsis of my book. Number one, this is an important word in American history. It is a word that is explosive. That's why people get so upset. It's a word that's volatile. It's a word that has typically been used in a terrible way. It's a word that is part of the soundtrack of racial terrorism in the United States. So people ought to know about this word. And if you're interested in knowing the real history of the United States, if you're interested in knowing about lynching, if you're interested in knowing about the way in which black people have been terrorized in the United States, you need to know this word. You need to know that history. So you need to know why it is that people are upset about the word. But that's not. But it doesn't end. You have to know that, and if you know that, then that knowledge should equip you to be careful. It should equip you to know that, to know the range of context in which this word appears. But again, it doesn't just end there, because especially young people, you tell that to young people, they nod, they read, they understand that. But then what? But then they turn on their radios, and they turn on, they listen to Spotify, they listen to some of their favorite entertainers. They listen to Dr. Dre, they listen to the Ghetto Boys, they listen to Snoop, and they listen to NWA. What do they hear? They listen to stand-up comedians. They listen to Dave Chappelle. They listen to Cat Williams. What do they hear? They hear the word nigger or nigga being used in a lot of different ways. And so they need to know about that as well. What are people hearing? How does one explain the fact that Dick Gregory was a comedian, activist, friend of Martin Luther King Jr., a true activist? I mean, he had a flourishing career as an entertainer, and he abandoned in order to struggle for racial justice throughout the United States and including the Deep South. How does one explain the fact that he wrote several memoirs, but his first memoir is called Nigger, a memoir? How does one explain this? How does one explain the way in which, how does one explain Richard Pryor? And Richard Pryor's best album is That Nigger's Crazy. Well, was Richard Pryor trying to put down black people? How does one explain that? One can only explain that by getting deeper into the word, by understanding that, yes, this is a word that has been used in a derogatory way. This is a word that has been used to put people down. This is a word that has been used to terrorize people. You gotta know that. But you also have to know that this is a word that has also been put to other uses. There are artists, there are entertainers who have used this word, like Dick Gregory used it, to put up a mirror to American society and say, look at this word and look at the terrible way in which it's been used. You don't want you to look away. No, don't look away. We're not, no euphemism, no asterisk, no N-word, no nigger. And we want you to look at that, and we want to talk about that. James Baldwin. James Baldwin, there was a documentary about James Baldwin a couple of years ago. Highly lauded documentary. The title that was given to this documentary was I am not your Negro. That's not what James Baldwin said. Anybody can go to YouTube right now, take a look. James Baldwin said, I am not your nigger. And he's going to talk about that. Well, James Baldwin wasn't, again, he wasn't trying to cover up anything. He wanted people to face the facts of American life. And it seems to me that if you're a teacher and you want to have your students face the facts about American life, well, you've got to grapple with the word nigger. Now, let me just quickly say, teachers have a tough job. And we're talking about students. Of course, there's a wide range of students. Am I saying that one ought to give my book to kindergartners? No, kindergartners are probably not ready for such a thing. Third graders? Probably no, not third grade. If we're talking, however, about people in the 10th grade, like in 10th grade to read my book, yeah, sure, absolutely. 11th graders, 12th graders, people in college. There are people in college. There are people in college. There are people in law schools. Teachers in law schools have been disciplined for because the word nigger has come out of the teacher's mouth. Why? In a couple of cases recently, a teacher would be reading a court opinion. The word appears in the court opinion. The teacher pronounces the word. Students get up, leave in a huff, report the teacher. In some instances in which teachers have been, under those circumstances, have been disciplined. In my view, that's bad. And people ought to say it's bad. It's bad pedagogically. Frankly, in many of these instances, it's not only bad, it's stupid. And I don't mind saying that. I think that some of these instances in which teachers have been disciplined, absolutely stupid. People say, well, the teacher used the word. Excuse me, use the word? It'd be one thing. It'd be one thing if a teacher looked at a student and called the student, get out of here. That'd be fine. Discipline, that's bad. But that's not what's going on. You don't have none of these are cases in which you have an individual who is a stranger to another individual, and this word just sort of comes out. No. What we have here is a class involving a person who is a teacher interacting with students, talking about subjects in which it would be perfectly understandable why this word would emerge as a subject of conversation. Now, under those circumstances, it's somehow wrong for a teacher to utter this word. In my view, the answer is no. And I said that 20 years ago. I say even more emphatically.
Still, it is one of the most powerful words in the English language, and there's a kind of responsibility that we as humans should have with words, with statements. That word is not used skillfully, not used competently, even when just read in a legal transcript, can do more harm than good.
I agree with what you say. Yes, words are powerful. Words do matter. And so I'm certainly not suggesting that people be lax. I'm not suggesting that people be irresponsible. It's precisely because words matter, however, that we need to be willing to face words and grapple with words and talk about the history of words, precisely because words matter. And among other things, it seems to me it's important to understand that words mean different things in different contexts. It's not the case that a word means the same thing in in every context. The word discriminating. Sometimes it's a very bad thing. That person discriminates. And when again, intonation of voice means something. If I say, oh, that person discriminates, I'm obviously being disapproving. Implicitly, what I'm saying is that person distinguishes between things on an unjustifiable basis. And that's a bad thing. On the other hand, that person has discriminating taste. Well, that means something very different. That means that the person differentiates in a way that shows that they understand the difference between excellent, good, and not so good. And we think that that's a good thing. The words can have words can mean different things in different contexts. It seems to me that that's something that actually we ought to recognize. We ought to recognize and talk about.
Well, some words enter this territory of being slur. And it seems like when they cross the line to being a slur, there's the number of contexts in which it's okay to mention it exponentially decreases. Right?
No, I'm gonna resist that a little bit because the whole idea of slurs change. Yankee was a slur. Yankee was a slur in the 18th century United States. Slur today. New York Yankees. I'm a Yankee fan. I'm a Yankee. Queer. This is in my lifetime. There was a time you queer, and people would really run away from it, and that was a bad thing. And then, thank goodness, gay liberation movement. Gay liberation movement. Basically, we're not going to run away from this. We're going to grab this quote slur, and we're going to affix it to ourselves, and we are going to repurpose it. Now, the word queer is, again, can it be a slur? Yeah, it can be a slur. It doesn't have to be. And it seems to me that it's important for people to know about how a word, a symbol, in some context can be a slur, in some context doesn't have to be. So the whole idea of what's a slur, I think that's a complicated idea in and of itself.
It's very complicated. It's, how do you say, almost fascinating how language evolves. But if we were to kind of have a minute-by-minute evaluation of the most powerful, intensely slur-like words in the world, I think the N-word with a hard R at the end, which is the title of your book, is number one on that list.
Well, probably so. And of course, that's one of the reasons why I wrote a little book about it.
Yeah, but it hasn't, even since you wrote a little book about it, it seems like it's maintained its number one status. You mentioned queer. Maybe queer was in the top 20, I don't know, for a while, and now it's sliding into the top 1,000, and the N-word is at the top.
You're absolutely right. The origins of this book, I clearly remember. I was at my office, and I was thinking about lecture topics. And I get invited to give lectures, and I was thinking, well, what might make for an interesting lecture? And all of a sudden, the word nigger popped into my mind. And this is a word I've grown up with. These words. I mean, there's never been a time in my life when, at least in my conscious life, in which this word's been absent. I mean, in my household, my parents are black people. My parents were refugees from the Jim Crow South. I was born in the Deep South, South Carolina. My household, I heard the word nigger used in every possible way. I heard it used as a slur. I also heard it used with respect to people who were praised. You know, my father, I clearly remember my father, whom I revere. That's the smartest nigga in the world. That's the bravest nigga in the world. That's the baddest nigga I know. He wasn't putting people down. This is the way he talked. And I grew up hearing this word in various ways. And so I was thinking, I said, God, where did this word come from? And one of the first things I did, I clearly remember just jumping up on my seat, running up to the library, Oxford English Dictionary, when did this word first appear in English, the history of the word. And then what really sort of grabbed my attention is I get my computer going, and I ask the computer system, give me every case, every federal court case in which this word appears, thousands of cases. And then I said, oh my goodness, this is really interesting. And then I started just cataloging all the different cases. There came a point, I'd say probably about a month into this, I compared the usage, I compared the number of times nigger came up with other sorts of slurs. So, for instance, kite, K-I-K-E, long time, derogatory word for Jews. How many times has this word come up? There was a time in which the word appeared, but nothing like the infamous N word. Nothing. And then what about wetback? What about, and I just, let me just take a look at all the other slurs. Nothing came close, not even remotely close to nigger. And I think it has something to do with, the uniqueness of the color line, particularly as it pertains to African Americans. I think that the fact that nigger sort of occupies such a unique status among slurs, I think that's a reflection of the unique stigma that has been imposed on Africans.
Hard to know the chicken or the egg. Why one word is able to so distinctly and clearly encapsulate this struggle between races that is throughout American history. And it didn't have to probably be so, but it came up to be that way.
It became that. Not only that, but of course, the nigger spurred other slurs. So, Arabs, sand niggers, the Irish, the niggers of Europe, women, the niggers of the world.
John Lennon even has a song.
That's right. Well, I think Yoko Ono, had something to do with this. So, it is a slur that has spawned other slurs. And again, that's why, as you indicated a moment ago, this is a quite unique.
But are you conscious? Are you deliberate in you saying this word? So let me just say from a personal experience, maybe my upbringing, where I came from, in my daily life, I don't think I've ever heard that word with a hard R said as often, used clearly in my life. I've heard it today more than I have ever heard it in my entire life. And I think there's a few people who listen to this, that would be listening to this and be very uncomfortable. I would say not in a bad way, probably in a good way. I'm uncomfortable now, and I am almost introspecting and trying to figure out why I am comfortable. And I think even the title of your book is making me think that. Just looking into my own mind and trying to understand, wow, what's the problem? And why does it have so much power? But are you deliberate in that action? And by the way, not only are the people listening to this sweating, this would be on YouTube in part. And YouTube, the people on the other side would be sweating. What do we do with this?
Yeah. Well, am I deliberate? Yeah, the answer is yes. And let me unpack that a little bit. First, that's right. Am I deliberate? Yeah. I deliberately wrote a book called Nigger, The Strange Career of the And, was that deliberate? Yeah, that was quite stupid.
But the title could have been N-word.
The title could have been N-word. Sure. The title could have been a book about a word that causes pain to me. I could have named it that. There are many titles I could have used. Did I want a title that would be provocative? Did I want a title that would grab people? The answer to that is yes. I'm a writer. I want people to read what I write. What was I being sensationalistic? Well, I mean, if you want to put it like that, yes. I'm not embarrassed to say that. I mean, I'm sure that when people write books, they think really hard about their titles and they try to get a title that will, grab people's attention. I know people, respect people very deeply who never, no matter principle, never utter this word. And I've talked with people, I've had people say, read your book, let's talk about it, but let's be very clear, I'm not going to use the word. I've had many conversations with people who've asked me not to use the word. I was on the first time this came up, it was a book tour. It was 20 years ago, the first book first came out, and I was on one of these call-in shows early in the morning. Time came to call in. 7 o'clock, call in, 5 or 7. Right before I go on, the host of the show says, "Oh, by the way, we have a strict policy here at the station. We never use this word." And I said, "Well, gosh, I wish you had told me this earlier. Does this mean then that you're never going to pronounce fully the title of my book?" She said, "That's right." And I had to make a choice right then and there. Am I going to go on or am I not? I went on. And I abided by the station's rules. And it's fine. We had a perfectly fine conversation. There is a place for euphemism. The American language is a very supple language. There are lots of words that one can use. I do not get angry with people who don't, they say as a matter of principle, they're not going to use the word. Fine. I'm willing to, I understand where they're coming from, and often I will defer to their wishes. All I say is, I want people to understand where I'm coming from. I'm not just using this word willy-nilly. There's a pedagogical reason. There is a reason for why I'm saying what I'm saying. There is a reason why I use the word.
Can you make the case why using the word is a good idea, and can you make a statement on the case why it's a bad idea? Maybe you've heard from some critics.
Yes.
Who said that you saying this word out loud is actually causing a lot of harm. Not like harm because people's feelings are hurt, but increasing the amount of cases.
Yeah. Critics. But let's start with the critics. One, again, going back to when the book was first published, I remember going to the first bookstore I went to, and I talked about the book, had a very, talk, asked questions, and the last comment wasn't a question, but the last comment was made by an elderly black man, called on him, and said, "I've listened to what you've had to say, and I appreciate what you've had to say." But he said, "But I remain unconvinced." And I remain unconvinced because when I was coming up, this word was used to put me in the back of the bus. This word was used to prevent me from voting. And this was the word that was used to justify me never being called as a Jew. So to me, this word has only one meaning. It's a terrible meaning. I'm never going to use the word. It hurts me when I hear people use the word, especially those who don't know anything about the, really about the history of it. And he wants to say, I think if your book, though well intended, is probably going to be seen by some people as giving them permission to use the word. And then he stopped. And I thought there was a lot of power behind that gentleman's comment. I think that what he said is probably correct insofar as there are probably some people who read the book. There are probably some people who are listening to our conversation right now.
I had a dream.
Who will
At a former place I worked, and somebody was sexually harassing me. And first they were just harassing me. They shoved me, and then they grabbed my circle. I was saying to everybody, look at this. This is not right. Everybody gaslit me.
But that's a critique, and I think there's strength to that critique. I'm not
Fucked up.
I think that there is something. And by the way, I should say, and that's why I would say to anyone, that's right. If this word comes out of your mouth, you are taking on real responsibility. So for years, it doesn't happen so much now, but there were, let's say, for about the first 5 years after this book was published, I would get an email at least once a week. And it would begin like this. Dear Professor Phillips, I read your book and I'm calling to ask you a question. And as soon as I saw that, I knew what the question was going to be. What the person would say is, I like rap. And then I knew I like rap. I'm white. And I have black friends, and we listen to rap, and we drive in the car, and we're listening to the song, we start humming along, and singing along, and my black friends sing along, and when nigger or nigga comes up, they sing, and I don't know what to do. Is it wrong for me to sing along? This happened so often that I'd say about the 10th time I got in such an email, I wrote a form letter because I didn't want to just, take up time writing, sort of crafting letter after letter. So I wrote a form letter, and basically what I said was, number one, I'm flattered that you're asking me, but number one, you should have a conversation with your friend. Number two, no matter what your friend says, let me put something else for you to consider. Let's suppose, for the sake of discussion, that your friend says, oh, doesn't bother me, I know where you're coming from, we're just enjoying the music. I don't think that this is a racist utterance coming out of your mouth. Let's suppose that your friend says that. That doesn't end that, because let's imagine the following. Let's imagine that you're in a theater and you're waiting for the film to start, and you're just talking with your friends or singing with your friends or just kicking back with your friends, and they're talking about nigger this or nigga this, and you say the white boy, and the next thing you feel is a big fist in your mouth that has been launched by a person that you did not see. He was right behind you. All this person saw was a white person saying nigger. The next thing, that's not, some sort of overheated scenario coming from some law professor's mind. That is a very plausible scenario. So you have to be worried about lots of things, including mistakes. So my advice to you, Mike, is be prudent. I would stay clear of the word unless you're very certain, unless you pause on it, you feel you're in a position to defend yourself, defend what you do. But the prudent thing would be to stay clear.
There's so many questions I want to ask there. One is about the violence and the legal aspect of that. It's very interesting. You guys that in the book. But, I do want to bring up something I probably disagree with you on, which is you say that there's not a significant difference between the different variations of the endpoint. Or maybe you don't. I just listen to it. So there's the version with the ER at the end, version with a GA at the end, and then GRO at the end. These are all different versions, and I feel like in that list of powerful words, I feel like there's a distinction.
Yeah.
I feel like the number one spot is the one with the hard R, and I don't know. Maybe you can try to shed light. I feel like there's one that everything is really small in terms of modern culture. So we talked about the evolution of the words, the word queer, for example. It feels like because maybe there's a rap, because comedians, because it's become much more lost so much of its power.
Well,
Or you don't think so?
I think there's a difference between nigger and nigga. And people make a distinction between them. And I think that to the extent that lots of people make a distinction between them, I think, this is a sociological fact, they are different. I think that people who get upset if somebody, especially white people, if a white person says nigga, and they're, sort of criticized about it. They say, "Well, I didn't say nigger. I said nigga." I believe me. Most people who are mad at them are going to stay mad at them. And you raise the word, so nigger and nigga, I would put in a very different category than negro.
Educate me here.
Well, yeah, sure. I'm happy to. Negro is also controversial. It's also controversial. But Negro never been viewed by a substantial number of people as a derogatory term, at least with the same amount of animus, the same amount of. It's a very different kind of word than nigger or nigga. I mean, after all, Negro, Martin Luther King Jr., all this great orator, Negro. You read the work of the great W.E. Du Bois, Negro. You read the work of my boss. So, for instance, I use the word Negro. I use African American, Black, Afro-American, but I also use the word Negro. Now, there are some people who get really mad at me because of when I use the word Negro. And so, for instance, there's students who've gotten really quite exercised. And they'll say, I'll be giving a lecture, his hand will go up, I'll call up somebody, and I'll say, listen, are you using the word Negro in its purely because of the historical time period that you're using? So is that why you're using it, or are you using it in your own voice? And often I'll say, well, I'm using it in my own voice. And I'll say, well, I'm offended. We think this is, that's old timey. it's derogatory. When this first came up, I said, let's pause for a moment, and I'll take that as advisement, and let me look into this. And I ended up writing an essay about the history of the terms that black people have used to describe themselves. It's a long list. Black, colored, Afro-American, African-American, Negro, etc. So I go through all that, and I said, now, let me just tell you, I know for certain.
The streamer was being sexually harassed. Somebody had their hands on my testicles, and I was like trying to get out my phone to record it. I could not get the camera to work. Tim could haunt my fucking dreams.
An ability to show what the future, but a Stargate or equipment that accesses the Stargate is for time travel, right? We're talking about two different things.
Yes.
Are they using the same technology?
Essentially, yes. The original device was the Stargate device. That was then increased in power of these field pulses. How it hooked up the power, how it stabilized it, I don't know. You need to speak with physicists about that.
Okay.
However,
now it seems to me you were telling me this word is so out of bounds.
It would be pumped up in power to stabilize the
It wasn't Reb. I didn't know who I tried. I just softball. No, I
the looking glass device was back engineered.
Know very much.
So it was actually back engineered from the original cylinder seal data to allow it
it's a little bitch in Omaha.
Stargate access
because they
devices.
know about current
It's a back engineered device. So looking glass is a secondary device, and it was coming into its fore in the 60s and 70s. We'll saw one of the first generations. Really, one I understand, very large piece of equipment that was as well as
still alive in American life.
William
The
House.
National Association of Advancement of
He saw one of the original looking glasses demonstrated, and in fact, it's going to be a DVD that we're
and
getting ready to put out the actual interview, where he was indicating firing a bullet, I believe it was, through an object. And there was a time delay where the bullet actually passed through the object, where he saw the bullet pass through the object.
We there are lots of different words.
Yeah, it was a railgun that was being used. And then afterward, they saw the impact
different preferences
of the device. So they were already playing with it.
I have my preferences. At least nowhere
dealing with time sequence.
Words have power, and that power occurs.
Back engineered from alien
There's a
technology.
lot of reasons that I could see justify the use of the word in this full form, as you said.
But it
In this
also,
conversation, as you're using it,
there were
one of
also,
them is
there was
perhaps,
information around the cylinder seals
fighting for the freedom to
that
be able to
they
use this kind of
used
words.
as also,
Often
and
they ask you
that
about
those
freedom
cylinder
of speech.
seals also came from an off-world
And the
race.
censorship of the word. The use of N-word is censored, for example, on social networks.
Which
So
was maybe the
we can come up with different ways. We can say university
I wouldn't
campuses,
feel comfortable
maybe
characterizing it that name.
op-eds, or I don't know. But I think social networks
I really
apparently is a
shouldn't
very
go.
interesting
But it
place.
was off-world.
There's a lot of conversations that are happening on them. There's the ability, the technical capability to remove the ability of people to use the word.
Yes.
Do you
That's
think
when they
it's
started actually being showing a lot
my
of
response is
interest
it all
in actually
depends
building the
on
equipment
the
to be
way
able
in
to
which
see
the word is being
over the
used.
curvature of time
If
space.
the word is being used to intimidate, if the word is being used to
So there's also our Henry Beacon
terrorize,
contact said there was a black box that came on one of the crabs.
along with lots of other words,
And I
by
don't
the
know
way.
if you like
You
that
can
black
ask
box.
I
Do you
use
have
the word
exposure to that as well?
gentleman It was something. I'm sure that I could conjure up a way in which that word could be used in a intimidating way. So
that is
I'm
very
would I be happy?
However,
if there was a technology that always blanked this word, NIGGER, I would be against that. For one thing, it would erase the name of one of my books. And I think the book actually has lots of useful information and some useful points. And by the way, let's imagine a world in which there was a technology that blank every time you would have, what would that do?
Change the perspective.
Novels by James Baldwin, by
Information
Morrison,
back to you.
by
So unless you are well prepared to deal with such a thing,
speeches
human
of Malcolm
interaction,
X,
human
Martin
emotions
Luther
bring
Jr., what would that do to the
instability.
albums of Richard Pryor, Cat Williams, Dave Chappelle?
That's went on with the Black Box.
What would that? If
But
one
with the
could
lip
have that
I use
out,
that to our advantage.
would one want to have all of those blanks
and I projected certain
important
information, which
literary
and
political
and they got certain abductions
performances?
off the calendar.
No, I don't want such blanks.
I caused some real trouble.
What I would want the word to be there for people to understand how to deal with this word. And by the way, you use the word hurt in all four. So let's talk about hurt. I think we need to be more careful with the way in which
I was asked to supply a model
because people can be justifiably hurt. You can have justifiably hurt.
I agreed to do
And if
so.
somebody has
Which is what
justifiably
you respond when you're a sworn operative.
I then think that we should turn to the person who
There
has
are
hurt those
great
feelings and say, you have acted wrongly because this person's
I was then
feelings are
taken to
justifiably
a location
hurt
where
in
the
relationship
treaty was actually being
done.
finished.
On the other hand,
Give a short
there
recitation
are
as to the
people
nature of
who
what
have
was
hurt
happening
feelings,
as the
and
P-45
frankly,
used Lotus
it
and
doesn't
wanted to use
justify.
Lotus for
So
back
just imagine the following. Let's imagine that I
objective
give
to
a
its use,
talk
but still to
about the
provide
greatness
under orders to
of
provide
Martin Luther King Jr.
I
And then
was
let's
prepared
imagine
to
that
do
a
so,
Ku Klux Klansman comes up to me
but
and
I
asks
was
me my
also
talk
allowed to show
and
them
says,
probable outcomes.
you have now
So in
hurt
fact,
my
the yellow
feelings.
book DQ was
What? Am I
used for that
supposed to
purpose.
be, am I supposed to
Shockingly,
apologize?
they happen
Am I
to
supposed
see
to be
themselves standing on
regretful
bones and their own families,
my
things
talk
like that,
about the greatness of
in the
Martin
vision,
Luther
and
King
they
Jr. has
ultimately
hurt the
decided to
feelings of the Klansman?
Lotus as well as
No, my
certain
response is going to be,
abductions
you know, you need to reevaluate
the
your
town
feelings.
So we were
Because
successful
actually,
in certain things.
your feeling of hurt
I think I can
unjustified.
safely mention
And no,
at this time because we're
no,
only
there's no apology.
1 OF9 and 1
So there's a kind of line,
away
perhaps
from
the gray area.
passage through
Maybe the word hurt has been overused.
completion of the passage.
If you try to avoid hurting
So I think I'm
a
pretty well
small
safe to go
fraction
ahead
of
and mention it
society
now.
that
I'm not going to
is
be able to get back from
mentally
treaties.
weak in a way where everything hurts them, that's
In
the
other
wrong
words, they
way
got
to
out Fox.
build a society.
And
But if we
that's what
flip that
happens.
upside down and say trying to maximize the amount of love
So you use the capacity of the yellow
and think about decisions you make in terms of language you use to try to maximize the
the
amount of love,
future
and not just short term but long term.
of
And that's where
what
freedom of speech is very powerful. It's a short term painful thing often, the long term beneficial thing.
This is true.
Just having
This is
to be.
true, and
So
that
there's
was
where the
skewed
question
by, it takes a great deal of emotion to skew
How much-
the imagery
how
and the audio
do
that comes
we
with it.
think about its use on the internet, on college
I'll just say
campuses,
that I'm
in
extremely
a way that
vehement with regard
maximizes
to
the
my
amount of love
objection
and
to
compassion
Lotus being
and love.
used, and apparently that vehemence was sufficient to skew
Associate
the image
myself
of
with
jump back and ask.
vision. How can we maximize? How can we maximize
So-
love? No, I love that. I think that's great.
and
So
this
let's
kind of
take
like
that
just for the sake of the
Um,
audience to some degree.
I doubt that
You
the
have
way
seen
of doing
in, I guess, the yellow book, or in the looking glass, and you can correct me which one it is. the future of Lotus in a sense. How Lotus becomes, once it's brought to or by you.
Well,
actually, no, I haven't. The reports
say
that
to
came
people,
concerning the future of Lotus, which we're not
you
getting into
understand
depth,
that your siblings are really important, all that
was given to me as information.
avoid this symbolic action.
I was told. That was during the early years. I say the early years of Lotus. It's only been going on for 6 years
So
now.
that you
But
can have
this was the latter half of
I doubt
2001.
that's the way to do it.
And this was a quid pro quo for them to get certain information that Kayla showed me. I demanded certain information back. It actually was information concerning the time travel issue because they were still trying, they were still reticent about informing me as to what the real nature of the situation was as late as 2001.
Meaning the real situation was how much access to Stargate, to time travel that they actually had.
Right, the whole treaty system,
You're not
these situations involving treaties, their outcomes, the actual potential for both timeline number 1 and timeline number 2 outcomes. In the case that we're in right now, we seem to be in a variant timeline 1. And that's good. For everything that I've seen and have read and reported to concerning timeline 1, it's not happening exactly the way that they figured that it would. But then again, it couldn't because we've made changes along the way to diverted us away from timeline number 2.
And
in
by the way,
so
just
doing,
so I say
our
that
future,
about
again,
this
I regard our
say it
future
about the infamous N-word,
pretty much a blank slate, we're writing it for ourselves.
all
And so we're now seeing something coming to pass, which is slightly different than prognostication, the probabilities that we were seeing.
So that
and I'm good with what we're seeing so far, but we are still facing the challenges of environmental degradation,
so do you,
etc. But hopefully we will rise to the challenge.
The N-word should not
Okay,
be
so this is interesting because it sounds like Kayla was instrumental in getting you to have greater
not at all.
access
In fact, it seems to me that
intelligence about what
the mobilization of
MJ12.
Yeah, it was the information that he was providing me from our questions, and the fact that they didn't even want to get involved with discussions with me in the late 90s
When is it okay for
concerning what he was. After we had argued for years, found out even where the material was coming from, then we were finally given access to the material. I mean, this went on for years.
Black, white,
Okay, but your
yellow,
interaction
red,
was
orange.
one way,
Is it okay for
one set of
anyone
information.
to use
And
this word
MJ12
in
then
a way
had another set, isn't that right?
Well, they weren't really. It wasn't that they had another set of information. He was telling me, he did tell me basically what was going on,
and I'd say that.
and they were simply not providing that
I've seen,
information
by
as
the way,
what they
I've seen
considered
black
to be
people
those situations.
use this word to try to intimidate.
They just weren't going to tell me what they didn't feel I needed to know.
So I'm against it. Black person, white person, doesn't matter.
This is my
On the
paraphrase, but
other
little did
hand-
they know that
on the
Kayla
other
was
hand,
basically
He was cluing me in. He was
Imagine,
informing me his perspectives concerning the trees. I knew something was going on. And that is ultimately what they wanted to know about. And I said, well, for you to know about that kind of thing, then I need to know about certain other things. It was truly a quid pro quo situation. And they said, well, okay, we'll tell you if you tell us. So I told them, and they told me a little more.
a lecture
And it was right around that same time that Lotus was actually kicking into fore.
That lecture,
May 31st, 2001 event
quote,
that took my prosaic project and basically the garbage can, and it turned into what it is now, this project that it is
white
now.
racist politician,
And as a result,
who
I also found out from them where they said Lotus was
used the
ultimately
infamous
invested. And
So
that is,
imagine
like I said, we'll discuss that in
history,
a slightly future date.
giving a lecture about
to
the
some extent
history of
Lotus
American
would
race.
help
He
Kayla.
says, in 1948,
That was the perspective
this
of the
is
B-45
what so-and-so
J-Rods.
running
And
for the
that is not my
presidency of the United States said.
Because
And then
I make a distinction between
quotes
Kayla, what I
a
understand,
paragraph or two
and
in
the
which the
P45.
infamous
So,
Indians
but
is
they're on the same
Is that bad? No, that's
They were
not
on the
bad.
same timeline, the same
No,
track,
that's
but
not
just
bad.
separated by 7,000.
Sounds like a
So
perfectly
even
good
so,
Just
lecture.
quite a big separation.
And
Well,
I'm glad that
so
you
so
put
what you're
the
saying is
infamous
that in a
N-word
sense,
in there so
Kayala
that you
could
can
get
see
the
that as
benefits
recently
of
as
those.
Nor did he
1978,
ask for it.
people who run into the
Nor did he ask
presidency of the United States
And
openly
you
use
know,
the word.
I will say this.
That does not bother me.
This is something that
I'll say
David,
this too. Now, you know, somebody says, well, you know,
David on the phone.
nice job, Kennedy,
Leave the last
but
name off. I think you know what.
Sure, but we can use his name if it's okay with you.
Well, sure,
in
David.
an academic setting.
And, okay,
What
wonderful.
about other settings?
And
It does not
he
bother me.
was
Let's
talking,
imagine somebody who's a
discussing the same thing,
comedian,
which was
who
Fox,
is
Q. And I said, you know, this thing happened.
satirizing,
I was
word
pro tempore
Let's imagine a white
made
comedian
NJ9 12
who
as a result of that.
who's satirizing our current
And I got a chance to tap who ended up being the last
at the way in which, you know, let's imagine we have a black rapper
was the first female I ever set.
who invites people on stage, and suppose they invite a black
I
person
got a chance to look at certain documents, look at certain archives in Washington, D.C. prior to going across to the continent and meeting
the
with
white
some
person,
folks,
you know, doesn't, you know,
telling them basically I wasn't interested in their office.
and what the rapper
A
says,
trip to Brussels.
Indian was in there, and then the black rapper gets named.
And during the
Imagine a
same
white comedian who satirized, pokes fun,
the cube disappeared.
and in poking fun at that,
And
says the
it hasn't been seen
Am I
since.
angry? No, I'm not
It
angry.
disappeared out of the
Not
archives.
What if in the
course,
process
I
of
have no
satirizing
idea.
that comedian's not very funny?
I have no idea where
Bad joke,
the
not funny.
item
I don't
would be.
object. I don't object
do
to
know
the use of
this.
the infinite word. I think, you know,
But they can't find it
not very fun.
because what they were
But
doing
because
is
there's
they
a
were
line. The joke
handing
is
this
not
cube
funny.
around. And this is a
It just
question that
seems like
Dylan asked whether there was only one
the
cube
comedy is
They were
used to
handing
cover
this
that
cube
to say
around
something hateful.
from
The interesting
country
thing
to
about
country
comedy,
to the
I feel like the
elitists
funnier you
in the
are,
countries to look into their
the
own
more you
futures so
get
that
away with.
they can pick the best
And
paths for
that's something to
themselves.
do with the thing we said earlier,
Why
which
don't they
is
just live their
when you
lives
use words that have
trying to
power,
be good people?
you should do so
Why
with
do they
skill
need
and
a little
confidence
black box to
and
tell them when to
the
jump and how to jump?
responsibility
That's
that
not being
they
fully
carry.
human, at least
Again,
from my
the
perspective,
cases that I'm
and
most
those
familiar
of
with are the
our
cases
associates.
involving
That's not being fully human.
teachers, professors,
So,
academic.
as I
And
understand it, disappeared.
if you say
Now, there have been
somehow,
certain,
oh,
allegations
why do I object?
that
I
have been made
object sometimes to
that
say
during the time when I had,
because
almost a year ago now,
I
when I
suspect
had the
that
bad
this
seizures,
people just wanted to say the word. That
it
all
was
of
near
this
the end
is
of
a
last year.
pretext. Do I,
It's been a year,
in my
you know,
sense,
and
my sensibility,
I had a very severe seizure. I was actually put out of
if it's pretextual, that's
seriously for a
bad.
while.
But in my experience,
And
I
there
have
was a
not
big
seen it.
hullabaloo to get over to
I
my
agree with you
apartment
on
and
that.
get something
Because
out
I
of my
do see
apartment.
people
What
that
that
kind
object
of have
was or
this
comment.
fly
But I will
towards
say this
the
to
right
everybody.
desire to say something
Whomever
controversial and edgy,
it's in
and they
safe
don't
hands
realize
and
that
will
there's
be
a
used
responsibility
wherever
there,
minute.
skill. You shouldn't just say, I mean, actually,
In
when
fact,
comedians
the
first
fact
start
that it's
out,
in safe hands will
sometimes
prevent it
they'll
from being used wherever
they'll
minute.
say edgy
It has
stuff
been thus far.
that's totally not funny. When you
Aside
realize
from, well, I mean, I've got to try to justify my own behavior.
the edgier
Bandolier,
the more
using it
serve
for the purposes of skewing
like
the
if
focus off
you're
drug use
cooking
off. And I think that was for a beneficial
poisonous
cause.
fish, there's a possibility of
But
how
it
to
has
cook
been
the damn
used
thing so you don't
since.
poison people.
Since actually the
I would
50s.
agree. But to get back to your
By
question,
the leaders of the various countries
let's imagine that
to
somebody produces
skew the
a
history
new set
of the human race.
Lenny
And the common folk,
white,
the average people,
Lenny
all of
Bruce
us,
used the term
have a right
nigger in his
to a
set.
future which is our own.
Question: Would
Not
I want
not being skewed and designated and promulgated and promoted and promoted by blue bloods who feel that they are above everyone else?
My response: absolutely.
I'm happy to pass along the information. I'm honored to pass along the information that I understand that the Yellow Book is no longer
The
accessible.
title of those interviews,
That's all
YouTube
I
and
know about
elsewhere,
it, though.
would use the full word.
I totally understand, and
What do you think about that?
thank you for that
Should I
information.
use
That may be the reason too why
In my view, the
the
answer would be yes.
Illuminati hasn't
Again,
done something
there are
to
people,
us.
I've been on
May also be
interviews,
the reason on the other end why the old Magi haven't.
engaged with people who
Maybe why they're also quiet.
had a different conclusion. And I respect
Right, I don't have the upper hand anymore.
And,
In essence.
there is a place
People
for
should have the upper hand.
they
should have the upper hand in their own
I'm not offended.
And that's why
Let's
we
imagine that he
too
hosted this
have gone as far as what we
and
have
you had asterisks instead of
SM200
spelling it out. Would I be offended?
during
No, I wouldn't be offended. I would prefer
demonstration, which I believe was written
but I
by
would understand where you're coming from.
Dr. Kissinger,
What is the
wherein he
weird
suggested
calculation? Which version of the word
possible
in
use
the
of food
title
as a weapon.
is
And it's used against, in fact, as a tool against the third world.
part,
Now, at the same time, we notice that there's a correlation.
your answer is kind of you have to do it.
IPCC report concerning global warming.
I'm not
That if
sure.
the
Again,
world average
there's certain
temperature
questions
rises
in which there's certain questions you're not gonna
that the northern hemisphere,
not really
higher latitude,
sociologists who's gonna be able to tell us that. So
however,
what
it
do we
goes
do
over
then?
that.
Then we go
Yet the lower
to
latitudes, by the way,
secondary
third world countries,
position.
the 2 to 3
My
degree
secondary
Celsius
position
increase
is
will cause starvation.
I don't
crop loss.
know. One thing
Now,
that I
isn't this
hold on
funny?
to, however, very
How they're just
strongly
allowing the global
is
warming
the
to
virtue
do what they
of
provoking with the use of
the
fossil
virtue
fuels. I'm not saying that's
transparency,
total cause.
the
It's not.
virtue of
There are cycles involved, short as well as
and
long
I
term
feel
cycles.
as though
But isn't it funny?
if I'm
And
holding
it's my
on to
best
those
guess that they'll
if I'm
probably
trying to
order
engage in a
just
serious
enough
conversation,
ameliorative
in which I'm
steps to be
trying
taken
to make
where
other
it
people
levels off
understand me,
where
and
the
I'm listening
higher
carefully to
latitude
other
or
people.
higher latitudes probably
I
don't
feel
use
at
their
ease.
crops where you find the majority of
I
their
feel at
vegetables.
ease. I feel
Well,
this is going to
that's
eventually
actually
be something
a
positive.
fascinating critical
And
observation.
you
I
know,
think
I feel
that it is also interesting that most of the crops
you're
are
one
being
of the most
grown
respected
in
people
the
in the
lower
history of Harvard.
latitudes. They're not being grown.
That said, you did write a book with the
Right,
N word in it,
but then
and
you
you
have
also have a
sustainability,
lot
though.
of opinions that challenge
Whereas
mainstream
you
perspectives on
have
race from all
loss
sides.
of crops in the lower latitude,
Talk
you're
about some
also
of them.
losing a lot of the population of the third
What's
world.
your view
Which,
of Harvard
unfortunately, according to the way
versus
that
general
the documents read, some people
If you
find
feel
them expendable.
pressure from any
I
direction?
don't feel that way. I'm not one that likes to
First
interject
of all,
into
the title of this book, The Continent of the Book,
I like to say
and
that it's standard research.
yeah,
Well, at the same time,
I
when we start
very
hearing
warm
that the
for it.
codex is being placed in place which actually delimits
I've
food
been at
value.
Harvard since
Oh, you have all the food you want.
1984.
Starve to death while you're eating. There's no
I
nutrients.
think it is a
When
wonderful
I start
place
hearing that food is
to
being used
work.
as a weapon, and it's being used concerning concerning the use of
there is
fossil
not
fuels,
there. I have
I start getting personally angry. There's not one person in the
various
lower
positions
latitudes
I've
worth
taken,
any less than me.
particularly with respect to this book or
Everybody is worth exactly the same thing on this earth. And unfortunately, there are individuals who feel otherwise.
but provide support,
Okay, so Bill,
sustenance,
the question
encouragement.
you were asking, now that we kind of,
You know, I think
let's
that,
talk about, first of all, you
people
mentioned Bill Newhouse.
Get down on
That's
Harvard
who
University.
Bill
I would say
Newhouse.
anybody. Imagine the
He
following.
didn't realize
Imagine
that,
that
he
the
was actually,
ethos
he was the son, you were
Harvard
saying, that
University
had access to that technology.
became
Yes,
the governing
Bill
ethos of the United
Was the builder
States
of the
overnight.
avionics
Tomorrow he would wake up
fact engineer
and
of
be
the ARB
much
testing
better
equipment,
than
avionics. I actually saw some of the
I,
equipment. This is in the
you know, I
Marcia and
have
I did in a room.
I've been supported by Harvard
I actually
University.
saw some
I
equipment.
think well of Harvard University. That's not to say that I don't have criticism
eBay
of it,
underneath the Galileo
but
Bay.
by
That he
and
actually built.
large, Harvard University.
So when I started describing it,
More than
Will
mine,
looked at me and said, "Oh, that's what my dad built."
overwhelmingly It has provided
we have
me,
a very
and
nice
it
little connection
overwhelmingly
there.
provides
It's Will who had
my
experience
colleagues
around the looking glass
with
equipment.
a
So
work
his son,
setting
Will Newhouse's son.
in which they
And
can do
Will
their work
Newhouse is alive now.
without fear.
Okay. So that's very
And,
interesting.
that's
That's
a good
his
thing.
wife, Terry.
There are
In fact,
certain,
what I
aspects of
understand, they met
Harvard University
during the course
which
of
I'm critical. Yeah, sure.
By the way, I think
conversations
a few people
concerning our
rightfully walk through
information coming to the public. Terry and
disagree with
Will
you
met
that
one
it's
another, fell in
because
love,
of
and were
Harvard
married.
University took over the
That makes me
country
feel kind of
to be a
personal.
better place. But there's a lot of interesting ways to break that down. Harvard
It sounds
is
like
not one
Will
of those. There's
knows
a lot
quite
of
a
these
bit
that
about
have range.
what makes the
But
ARP
one of the
run
things that's
as
happening
his father has
is the
Yes.
disproportionate and kind of aggressive growth of the administration versus
it must
faculty.
have really
students.
screwed
I
up
think the power of the university shows
the two
the faculty and
timelines
students
by
as
bringing in
juniors as flourishing
ability
happens.
to
And
use.
the more
I don't know
you
what
have kind of rules and
is
bureaucracy and all this kind of stuff, the
Actually
less
was
powerful
not
the university is.
I think that at
It's true,
my
the stories involved.
university
It was
and
actually
many
the information about the
that's
human's
right.
existence was
Too
known as
much bureaucracy, too
46.
much regulation.
It was further discussed in
And
1947
are
after a certain
there
crash
dangers
on southwestern
of
states
expression
in Mexico.
at my
And-
university
and,
and other
following
universities?
which,
Answer,
During
there are.
the first
There are.
brokering
So,
for treaties by
and
the
this is
alliance
really
with Eisenhower,
there was a
it
period
was
of time
handed
which
to
I was
Eisenhower.
getting
It
off
was
of,
in fact expected
I
to go to
got
the
off
United
of
Nations
all the
authorities,
work.
and it was in
doing
fact
my
spirited
work.
away by
Yeah,
the
I'm going to do my work. I'm not going to be associated with any
So-
organization.
So, but
In the last 5 years, that has changed
is that
quite
it sounds like it
on
connects emotionally with the viewers. in a sense.
It does, and the fact that it was handed, it was actually Orion
mainly
technology.
organizations involving
And it was handed over by them in the spirit of
what's
goodwill,
going
with a
on
misassessment as to our evolution,
and I have been
our ability to handle the issue
thus
and
far.
handle the equipment. They felt
This
us more
hasn't
balanced
pinched me
than what
where
we
I
actually
live.
were.
Okay, well, this is, I mean, this
You're in the
opens
space of ideas.
In the space of ideas, in the space of speech, in the
That is
space of
Pandora's box.
teaching,
I'm not exactly
I
certain
haven't
what was the
been,
cue.
but I am concerned about
However,
that.
the
So, for
analysis
instance,
which,
what's
I was
an
asked to
average
do,
time for a job?
of course, I paid the price now that I've actually done it.
Well, let's suppose that you're seeking a
And
promotion.
people don't want to hear the answers that I
On
but
many university campuses,
the analysis that I did indicated that certainly there's at minimum a great suspicion concerning the delay of response.
One of the reasons why you should hire me,
And the information that I have directly from one of the former senior members was in fact that we were aware this was looking glass technology, not the cube. That
Diversity,
we were
equity,
aware
inclusion
as
for
of the
people
middle
and
1990s
general
that there would be a coming
set of
Islamic
programs.
extremist war with the United States. We
Yeah.
were also aware of certain alternative situations that they use the statistics from the looking glass, from the variability in the different pictures,
Whether they
to
say
show that
or not.
occurring at the same time, probability at the same time. And
That you're being asked to do
From their
is say, I'm down with
that the least of the two
diversity,
consequences was
equity,
9/11.
inclusion.
I am aware of what the other possible consequence was.
And
I'm not
here's
willing
what
to
I've
come
done
out
that
and
shows
start mentioning it because I don't know what the consequences are.
and
Certain the things that
therefore,
have not thus far happened.
well,
Yeah, the
you know, a lot of
probabilities
what I
existed that
do
they could.
fit very comfortably with
So you know, I'm feeling a little bit. There's a little weight when it
I
comes to
didn't
that.
like it.
But
And by the way,
Okay,
there's
you're
certain
saying
aspects
though that looking glasses have been
that I don't
called
like.
decommissioned.
You need to
Yes,
tell
ma'am.
me
And that means
that,
across the board.
you know, I'm
across the
being
board,
judged
they are shut down.
in an academic
You said there was
institution
50
because I want to be a chemist,
devices
because I want to be a
And I
physicist,
I said
because I
at
want
least
to be out
50.
there.
that would access
You know, critical
or
literature.
creating stargates, in essence, out
I
of
oppose
natural
I don't,
Yes.
I don't think
And
this is the
Something that
way
will make them available.
higher
glass
education.
and class is not the same as the Stargate.
No,
Should I
looking glass is
have
a backing
to
engineered from the original cylinder seal descriptions on how to build the units that they make Stargate. So in essence, you can take a looking glass unit and make a couple changes to the equipment, lift it up on an angle, put field posts around it, and open up a hole to step through.
What would we think then? Let's suppose there was something
Future
that said,
probability.
instead of saying use the eye, let's make it say the
much less.
of
We
American
had
capitalism as we know it.
a basic monopoly over the looking glass that
What
and
have you done?
India brokered early on with Indira, when Indira Gandhi was brokering the committee of the majority between the United States and the Soviet Union, because the Soviets were trying to start their own treaty system with the extraterrestrials, which would have become untenable. We agreed then to expand NJ-12 from a wholly operated and owned American operation to an international operation. Thus was born the Indian majority between 1963 and 1967. And when
It's news to me. I didn't know.
information was brokered, that happened in parallel with, kind of under the table, but in parallel with United Nations treaties involving things like the S-band treaty and the outer space treaty. And so it was being done at the same time under cover of UN support. The diplomats were going back and forth, brokering the opening up, so that the treaty system would be a single treaty system, thus tenable and managed
I've got to give a
to hopefully a good outcome.
I say whether I am,
Successful.
Okay, so this is really fascinating. You're saying that some other countries, India for one, had access to looking glass technology.
Yes, ma'am. They had that written as far back as the 60s and 70s when it was actually being back engineered from the Stargate material. And so at the same time that Will Newhouse, for instance, was looking at the early generation looking glass, India had the same.
a couple of days ago about these statements, and in fact, that's what sort of tipped me off.
To the information or to the equipment.
That my home institution sort of mentioned this offhand this way. He said, well,
I'll tell you why the answer is no.
and I was taken
Within
aback
the treaties, the looking glass, as well as the Stargates, as well as the cube, and information movement pods,
in which
are all contained within the treaty system. Within that treaty system, it also prohibits and allows certain passage of information amongst delegates on where the looking glass material is and where the information flow is, what the access is. Being that I stood in Bandolier and considered a delegate, therefore I cannot tell you.
work.
So you can't tell me
This
who
concerns
had
me.
access to that
I'm
technology.
concerned about,
Aside from India, the United States.
A while ago,
So, but we can assume that some countries, perhaps, that is the leadership of some countries, may have had access to this
talking
technology.
with colleagues,
I think that it's fair to say that we can assume that they had access to the information
this
from it,
word had come up
but I wouldn't place any characterization over any assumption of who
one
may or may not
student
have had it.
was
All right, well,
I thank you for the question.
came forth to
Okay,
see
but it also gives you a whole different way of
Negro
looking at
was
history.
part of what they
I mean,
read out,
Indeed it does.
and another student held
I mean,
up
this stuff is gotta be,
and said
have,
to the
you know,
student reading
as natural to you as, you know, getting up in
because,
the morning, you know,
I find
and
the
having a cup of coffee.
Negro
This is all part of
offensive.
your
Now, there's nothing as natural to me as getting up and having a cup of coffee. And we should have never built.
Offensive.
The Stargate, yes. Okay,
Which should I
for
say
the
in those
purpose,
circumstances?
speaking
What
with
should I
the
say?
visitors from the other timelines.
And I volunteered,
Yes,
you know,
absolutely.
you know, I said, well,
The
God,
looking glass,
this had it come up
that
in
was
my
done because of
I
our
would
own
have said, well,
shortcomings
frankly, I don't
as people who aspire to things that we maybe shouldn't try to grab a hold
I
of.
used the word.
It should have never been built.
And,
Right? We're talking about power.
you know, Harvard
Yes.
University is not,
Yes,
you know,
and I am an advocate against the misuse. In fact, well, I can say
Part of
against
everything
the
else is happening.
I am an
in the world.
advocate
These
against the
things are
disease.
happening in other places. They're
Okay,
happening
so
in Stanford.
let's
They're happening in
say
Yale. They're happening
what
in
has
Columbia.
and you're saying it shows
they're gonna happen
probabilities, and one of the
afterward.
things we were wondering is, how does it do
But
that?
thus far, and
From the best I understand, I was speaking with Bill a little while about it,
experience in
a
life
little while ago.
Harvard
The
Law
rings and the amount of
Harvard
information,
Law School,
the energy, which
open
is passed into
environment
it.
which ideas are
The position of the rings, their orientation, the energy running through them,
fully
position of the barrel, etc. You can raise the barrel
because
up
of
on
that
the
that I
inside the
say
center of it.
I have been
All
fully supported
comes into play
Harvard
as if you have an onion,
feel that
various
it is
layers
an
of the
excellent
onion.
place.
As you move through different energy levels, you also
I'm a
move through
fan.
different
I'm
layers.
a fan, and I'm not embarrassed to say it. I am
Imagine
a
an almost infinite
fan
number of layers overlaid
of my work
in comparison to the positions of the rings, and an almost infinite amount of energy
Tuning out.
that you can
In
add or
general
subtract.
education, there's something called critical
Tuning it
race
up,
theory.
tuning it down.
He
Instead of
comments
going
on
up by 1
video
hertz,
clips
by 2 hertz,
about
maybe by
this kind of
1,000
perspective
hertz, up and down.
race and race in America, to the degree that it's becoming a part
Right,
of
except
the education program.
yeah, you get a different design of the color
What is it?
It's like
Well, the first thing I would
working with
say about
multiple
critical race theory
kaleidoscopes,
is that critical race
where
theory
when you
has
fit, when you find two different
become a term.
probabilities
So I'm going to put
you could run into,
quotation marks around the term
you have two
critical race
kaleidoscopes, and
theory.
you make a change on
I'll
one
talk about critical
kaleidoscope
race theory
that
without
may factor or function to a different angular change on another kaleidoscope. So you get two separate pictures that you then have that are flashing back and forth.
namely
Yes.
Republican
That's the
right-wing politicians have created a boogeyman.
Yeah, in fact, there's a deinterlacing system which they
Critical
use
race
to actually deinterlace the flashing back and forth of the two probabilities
and
or the
they have
multiples
tried
that they have
to
at
make
certain
it
times.
seem
We're
as
going to start
though
skipping.
this boogeyman,
Well, what they did is they
all sorts
deinterlaced
of
the video
ideas
and then
that
reintegrated the video and watched the
Americans
individual videos.
and that Americans
And then determined statistically how much time was spent
and
on
they
each
created
video
this
to
boogeyman.
determine the amount of
They've
probability
done a
of
very
each
good
event.
job of creating the boogeyman.
And they tested that
They
against
mobilized
probabilities in the field,
sufficient
probabilities of future occurrence,
support
to get
that,
a system which
a number
functions
of
scientifically.
states that have
That's-
passed laws
Okay, so, well, I'm
prohibiting
gonna go with that, and I'm gonna actually say what they might have been doing
so-called
is
critical
that
race
back.
theory. Now, the first thing I want to say
In other
about
words, they
this
saw an event
is that
in the looking glass,
this
all they had to do
campaign,
was
these
count
laws, these various
or look at the
policies,
different possibilities, see
don't
which
teach
one
this and
happened,
don't
and
teach
then
that.
That's what they did.
as
You
time
can't
went
use
on.
this
Absolutely.
book,
That's
you
right
can't
on.
use that book.
That's right on.
This
That is right on the
right-wing
and some people, like I said, some people say it's blue smoke and mirrors.
freedom.
Then again, I was told something in 2001 that's I'm living it right now.
Read.
Okay, without knowing what
That's
it is.
terrible.
And like I said, we'll talk about that in the future. But
So that's the first thing.
it's the best scientific equipment that I can imagine for the determining of such a
Now
thing.
I'll say something.
But it goes to the old question: just because we have the power to do something,
Critical race theory.
and I am a 100% advocate. She and I had
We could have a nice conversation
more
about
than a small
actually
dust
what
up out
it
of
is.
Richmond Mountain over this very same thing, which actually
One way
resulted
of viewing it
in
is
me
to
walking
say that,
alone
well,
down
critical
Lake
race
Mead back
theory
toward
is
Las
the
Vegas.
community
With she and I
ideas
yelling and screaming at each other along the roadside.
community of
They were
people,
doing tests out at Frenchman Mountain during the time that the Rosen Bridge was being
in legal
accessed
academia.
there, the Einstein-Rosen Bridge,
And
with the equipment. They had the curtains up and all of that business, were metro windows at the top of the mountain and all that. And they were accessing there, and there was a mistake
the association
and a small explosion out there on the east side of the what we call the Conquistador helmet. And she wanted me to go out there with her to help clean some of the evidence up of it. She and I got in a vulnerable little dust up because I didn't want anything to do with it. Because I don't believe, I'm no Luddite, I mean, I'm all for grand technology, but I don't believe in playing with things which actually deal with looking into the future. there's another issue that was going on at the time. In fact, the variety of communication which was going on via this equipment from elsewhere. I presume she will still won't admit to me, but I presume that it was from Orion, and it was information, defense-related information on how this type of equipment, how an Einstein-Rosen bridge at a distance could be used to pull information out of a defense computer system. And I don't mean a U.S. defense computer system. I said, you know what? No. Look, we've got the technology here, we've got the talent, we've got the willpower, we've got the willing to defend our own country without the use of something involving time technology.
Including liberals.
I wouldn't want to go up against, for instance, God help us, Chinese on the ground. But at the same time, I don't fear their country either. I believe that we should be diplomatic with them and have a firm understanding and a respect for one another. But I also don't fear them. And so the use of technology like that is not honorable.
Right. Well, it's like knowing how the game plays out.
Stubborn or resilient
ahead of time and making sure that eventuality will.
That's why I was so interested in when I was doing my time with the jobs involving safety and security training here in Las Vegas. When I was interacting with Marcia because we were literally on a daily basis talking about that same thing and about the psychology of individuals who come to a table, play a game, and who cheat to alter the outcome of the game. And that whole psychology is something which I'm not, is not foreign to. And so that helped will prime the wick of the explosion myself in that variety of technology, which actually primed my disagreement.
We're really,
I understand what you're saying, and there's a million questions that all
they did not Derek failed the position. Second Reconstruction, the civil rights.
Now that I know what I know,
but at the end of the day, black people were still, after the second Reconstruction, were still in a position
but what about countries
No. It shouldn't be used at all.
I understand.
All right.
I think that's ridiculous.
Is there something there?
The second Reconstruction changed a lot.
Is this technology something that they are using now?
We're talking
To
about
look at our relationships.
a black American was president of the United States.
Technology is not being used at all right now.
2008, 2016.
Now is
I mean,
because of where we're going
what are we talking about?
the galactic
There's been a tremendous,
As of about 2017, I would expect
and I
probably
think
that all of
people
the
want to understand that.
equipment will probably all get reassembled.
Am I saying that everything
turns
is
back on.
Sure.
all right? No.
2017, that's
The
the
United
2016,
States is
2017.
still,
not
Probably not.
to a very large extent.
I figured that they're probably going to act conservative.
But that doesn't mean that a lot has
That's what
changed. A
a
lot
lot of people
has.
of wisdom have
So
suggested
I
to them
disagree with certain
is
tenets
to act
of
conservatively.
critical race
That
theory,
yes,
and it's very
the
outspoken.
so-called
There's
cycle of
another one, by
catastrophe,
the
or
way,
system of
that
catastrophe,
because we
Fulton
talk so
Alley,
much in our
the
discussion.
time period from
Listening.
right around
Another big
1992 to right around 2012, right around that area. While we will have passed it as 2012, we really ought to get through the entire cycle, which is about 1980 to about 2016, to feel confident that the interpretation from the timeline from the future about their own catastrophe is not off by a few years. We're talking about 45,000 years, 50,000 years respectively. We have difficulty understanding what happened 2,000 years ago.
Racist
And we're talking about 50,000 years here.
some of
So,
the people who associate themselves
it's
with
very
critical race
wise
theory
for them
think
to
that
wait.
racist beliefs
And you mean
ought to be
that the
explained
looking glasses are now
with the age
but
of
also
the
Stargate
power.
Yeah, they're decommissioned, and
Well,
the
I'm against
Stargates and the looking glasses, I'm sure they're all in their mothball containers and all of
I
that.
think
And
you're
they
at
have
a
been
moment
separated, the three components have been separated and moved to different power structures, diplomatic and military authorities on the world. We're talking about the EU specifically, the UN and NATO. those are
some of
in
the people who call
specific
themselves critical race
control
theorists.
of one of the three components each. And I cannot comment as to which component is
Well, the
contained
right
by
wing is
Okay,
saying
but
race
you're
theory.
saying there's no doubt whatsoever that all this technology
And
is
so I,
There is no doubt
I've been
whatsoever
very
when it comes to
outspoken
the
in my
looking
criticism
glasses and when it comes to the Stargate technology, that it has been decommissioned. And however, there are a few threats going on, ongoing threats from Christian countries, stating that they will put it together at their will, do their own self-determination. And those countries, if push comes to shove, will be
some
shoved.
aspects of it that I think we can
Okay,
some aspects of it
put
that I
it
think we
together
can
now.
As in build one that sells now.
Yes.
So that's
Yeah, what was extant has been collected.
above all.
I'm under
Certainly
very good assurance that what was sitting there has now been collected and decommissioned.
Okay,
remove it
so we're assuming a rapid one
from
of those.
the intellectual universe.
Absolutely.
Part of our intellectual universe, we know about it, and
The very highest
debate it.
probability for those things to
So
occur.
That's true. That's true. And if Bill was
exclude what they
asking
will
about a future
about
date
the strengths of the
thing, and a year was given.
And we'll talk
And
about
he was saying, well, if a year can be provided for
the
that,
pessimistic and
why
optimistic
wouldn't a year be
perspective on
provided
race
together? Well,
and
there
history
was
of the
a
20th
highest
century.
probability.
I think they're very true perspectives. Before that,
However,
look at the
telling
current
me
moment
about something that might happen in the
and
future involving a
get a
project
conversation with John Lowry and John Ford.
is one matter.
From there,
Willy-nilly
it became
throwing a
clear
date
to
out,
me,
which is a probability
it's clear
involving the
how
lives and destiny of all of us here on the earth,
conversations about race
specifically to a predicted 4.5
in
billion
today's society.
death.
That's where a lot of African Americans feel is sort of the
But are
pinnacle
we to
of
assume that we
racism.
have
Maybe there's still racism in
You're not,
a lot of
you're,
racism in America.
no,
That's
you're
where
not
it
to
is.
assume.
So,
so we're still, that's still in the offing.
to what
We're
degree?
looking at is a very low probability
Yes.
set of events.
Yes. Yes.
At this
my
Yes.
first book,
We're looking at a low
It's a book called
probability
Race,
of
Crime, and the
higher
Law.
catastrophic.
and
I expect that the events we could kick it off are still going to happen. For instance,
time flies.
solar max, which is coming around 2012, and the expected loss of GPS equipment and things like that, which is out there as part of on the web. You can find that as Engadget, I think, was one of
The impetus
groups
behind that
spoke about the loss of GPS and satellite communication.
Electromagnetic grid is going to go down.
Yes, yes, and that would be the
Hell.
thing that I would expect the highest probability of
a
these
sense
events
that
having
with
correlated.
respect to the administration of criminal justice,
That's as far as I can.
African Americans
Okay, well that's pretty
I can't give
close.
that. I can't give
Yeah, I understand.
I can, but I shouldn't, because people will then target toward a date. There are people out there now that are saying, "Oh, it's right around the corner."
and they feel deep
At any moment now,
reason in at least two
why
different
won't the aliens save us?
on the one
We need to
hand,
save ourselves, and that's why the steps have been taken,
African
that have been
Americans
taken in the world and are still underway, so that we will save ourselves.
In fact, in that book,
Reached another milestone
Central
today.
theme
1,000 years in 2 days. I mean,
of the Black
There's
American
some things you should like.
under
There's still a long way to go. That's not
take a look
place.
at
Please help me in my efforts to get this information out. Share this with anyone who might let
broad
me and need a subscription if you haven't.
American
For all this big name, total disclosure, all we need
ask
to do is
yourself,
actively show interest. So press all the buttons
in
in all the
what
channels
way
about this topic so we finally get to say hi to our cosmic neighbors. If we could just open this Pandora's box once and make the government, you could literally see your own live TV today yourself.
take a look
I appreciate any help. See you next time. Boy.
development period before the abolition of slavery. Before the abolition of slavery, in the locales where most black people resided in the slave states, in a lot of those areas, question, was there a crime called the murder of a black person? Answer, for a long period, the answer was no. there might have been a tort, you know, so the white person killed the slave, that person could be sued because they had injured the property of another and would have to pay money for that. But had they committed a crime? Answer, no. In the antebellum period, were black women protected against the crime of rape? In most states, the answer was no. There was no such crime. Let's go to after slavery is abolished. Then, let's see, so the year lynching. From 1890 until, let's say, 1930. Well, in 1890, there was probably, I would say there was probably on average a lynching every day. Well over 300 lynchings. It goes down. That was the case in the 1890s, probably the first decade of the 20th century, and then it starts going down. What was lynching? Lynching was about black people being executed outside the law. Did the legal system do anything about that? Show me cases in which people were prosecuted criminally for engaging in lynching. You come up in most places with a no set. Black people suffered the under protection of the law. Do black people still suffer the under protection of the law? The answer is yes. And people talk about the Kerner Commission report, 1968. Black people were asked, with respect to the police, what's your main complaint? In many places, the main complaint was, we don't have police protection. When things happen to us, when our houses are burgled, when our businesses are encroached upon by robbers, when our businesses are robbed, when we're assaulted, nothing happens. The police protect white people. They don't protect us. Under protection. Our society right now, who is most liable to be raped, robbed, the victim of assault, what have you? Black people. And it's not even close. Under protection. So that's one way in which the administration of criminal justice harms black people by not doing what government is supposed to do, which is protect us. The 14th Amendment. Equal protection, underlying protection of the law. So that was a big theme of race under the law. Now, second, and this is the thing that gets most attention. And it's important. I think that the underprotection story does not get enough attention. But there's a second story. The second story is that black people have historically and still today, black people are subjects of invidious racial discrimination when it comes to police action. So, walking down the street, you have a black person who's, let's say, 20 years old, white person who's 20 years old. Let's make them both is walking down the street. And question: attitude of the police towards these two. An attitude, is a complicated thing. It can show itself in various ways. It can show itself in a look. It can show itself in who gets the look. Black person's, walking down the street or running down the street. White person's walking down the street or running down the street. What happens with respect to the police? Let's suppose that, who gets the second look? Who is followed? Who is detained for a moment?
Well, some of it, just on a small tangent, I apologize to interrupt, but attitude is an interesting one. Because a lot of the interactions doesn't show up in the data. So detain, for example, starts showing up in the data. But before then, the second look, the third look, the first look, this is where the gray area of conversation happens. Because
very much so.
Culture and society happens in the stuff that doesn't often show up in the data.
Yep. So I tell you, this really came home several years ago. I was in New York City. It was a time when there was a lot of discussion over the stop and frisk, basically, racial profiling on the street. I was walking. I was in Harlem, walking down the street, and frankly, the police weren't bothering me. I'm just walking. The police weren't bothering me. I'm of a certain age. I did notice, though, I was looking at the police, and the way that the police attitude, it had to do with body posture, it had to do with, that's right, who got a second look. It had to, I noticed, I'm walking on the street, I'm walking in Harlem, there are white people on the street, most of the people that were black, some Hispanic. The level of contempt, the level of animus, the level of unfriendliness that was pouring off the police. They didn't say anything. They didn't detain. They didn't say anything. It was palpable. I could feel the attitude that was being directed at the young black men. And the thing is, it's not as if this doesn't matter. It matters because the way I saw it, these young black men knew. They felt the contempt that the police were shedding. And this was going to have a consequence. The consequence it was going to have is, let's imagine that the police did say, excuse me, what are you up to? Now, if you have been feeling this contempt, if you feel like an officer who's asking you questions doesn't like you, doesn't know anything about you, but just doesn't like you on sight, you might answer in a certain sort of way. You're not going to give the cop the benefit of the doubt and basically think, well, policeman's just, asking me this, probably just trying to make the neighborhood safe. Well, if that's your feeling, policeman's just asking me this, trying to make the neighborhood safe, well, officer, the reason why I'm here is such and such. And, thanks for your service. That's one response. Another response is, I'm not going to tell you anything. I'm not going to tell you anything. I know that you don't mean any. I know that you don't mean me any good. I'm not going to tell you anything. Am I free to leave? Then the cop, having heard that, then says something back. After 5 minutes, what do you have? You have an altercation on you. And I felt that. And that is part, and you're absolutely right. That's not written down. It doesn't get to court. It's there. It's an important part of street life. It's an informal part.
And it has ripple effects because that young black man will probably talk shit about that cop later that day, and the narrative persists, and then the cop will like also talk shit, and then there's these narratives, and I think because it's such a powerful thing.
It's so hard to disentangle because you're absolutely right. The young man was supposed to go in, quote, well.
The looking glass
He's going to
has
go
an ability to show one the future, but a Stargate or equipment that accesses the Stargate
well, yeah, that doesn't surprise
is
you.
for time travel, right? We're talking about two different
And
things.
2 hours this goes on. The
Essentially,
anger,
yes. The original device was a Stargate device. That was then increased in power.
and that's part of it.
How it
But that's not all of it. That's an important part of it. But we have to choose an important because then you ask the question, what about
no. It would be
things we do?
hooked up in power to stabilize.
I know this from my teaching.
To step through into
This
another
was
location.
brought up.
In essence, because distance and time are relative. Same thing. Step two into another
Notice I
time.
didn't say, I didn't say Birmingham, Alabama. I didn't say Atlanta, Georgia. I didn't say Tallahassee, Florida.
So it was actually back engineered from the original cylinder seal
Montana. I didn't say
to allow us
Idaho.
to
New York City.
Stargate access devices, what we call the Stargates.
Cosmopolitan place.
It's a back engineered device. So the looking glass is a secondary device, and it was coming into its for in the 60s and 70s. And saw one of the first generation.
Facts will roll out. The facts will
Large
quite hard.
piece of equipment. They always get smaller no matter what.
People,
What's happening with computers?
there were black men who could
We all
stop
saw,
many times. It wasn't just once.
you saw the original looking glass.
He saw one of the original looking glasses demonstrated.
Under
In fact,
circumstances in which
it's
they
going to
ought
be in the
not
DVD that we're
stop.
getting ready to put
And
out, the actual interview,
this has
where he was
it doesn't
indicating
just show it
firing
here,
a
though.
bullet, I believe
It
it
also
was, through
shows up
an
in other
object.
places.
And
The administration of
there
justice.
was a time delay
And
where the bullet actually
we still
passed through the
have
object, where he saw
a
the
big
bullet
problem.
pass
You
the object,
mentioned, the
projectile,
police.
a little rail gun, I believe.
You ask yourself,
Yeah, it was a rail gun that was being used.
who
And then
are the
afterward,
state agents
they saw the impact of the
that
device.
are
They were
most
already playing with it in the early 70s, mid 70s, with dealing with time sequence.
This is the original looking glass.
when you walk down the street, what other
Back engineered
agents
from
have
alien
guns on them? What other agents
Yes.
are authorized by the law
But it also,
to shoot you under
there
certain
were also,
circumstances?
there was
It's the
information
police
around the
that
cylinder
are the most
seals
consequential
that they
agents of the
used
state.
as also, and that those cylinder seals also came
I mean,
from,
there's
an
back a little bit
awful race.
of consequential in the physical sense, but if you return to the power of the psychological stuff of content,
Which was
I would
maybe beyond
say
an
store clerks and stuff like that can also be a source of
I don't
content.
feel comfortable characterizing it.
But if we look at the landscape of contempt, which throughout the 20th century,
I really shouldn't go.
you know,
But it
it
was
was
lobby
right?
technology originally.
Yes,
You could
ma'am.
experience
And at this
the
point,
same
like,
kind of
okay, say that was in the
contempt
60s.
in other aspects of society. But yes, the cops have
That's when they started actually being showing a lot of interest in actually building the equipment to be able to see over the curvature of time space.
And if you think about the way in which
somewhat
the
into the past and
law,
also the future.
the extent
So,
to which
There's also
the
our
police
Henry
are
Beacon
authorized
contact said there was a black box that came on the crafts.
force.
And I don't know if you looked at that black box. Did you have exposure to that as well?
There was something.
You know, you're driving your car and the speed. The police can arrest you right then and there and take you to jail.
However,
That That's an extraordinary.
But they also have, because of that, the leverage one human to another. They have more leverage to be an asshole.
The cube would react
to be the lesser, to lean into the lesser aspects of their nature of all humans. Just to be an asshole so sometimes. If you have a bad day, they have the more freedom to do that.
Yes, and that's why police officers are very important. I recognize, I know police officers. They have a very difficult job, a very important job. Very important. Again, remember what I talked about under protection. I want the police to protect me. I want the police to protect me from the rapist, the robber. So police, I'm with the police. We need good
instability of the provenance of the information.
good
Okay, that's what went on with Black Box.
accountability.
Yes.
And one of the scandals,
And I use that to our
scandals
advantage.
of American law is the
That
extent
was
to which the
President
police
T9,
are not
and
held
I
accountable.
projected certain
It's
information,
absolutely remarkable
which caused a
the
little upset
degree to which
during the
American
meeting.
law
I got certain abductions.
fails to properly hold police accountable.
My customer
They have an important job, a difficult job. I want them to be very well paid. As far as I'm concerned, we should make more money.
sit here and consider
They should be
should
given the importance of what they do.
during the
They
negotiations
should have
for the Town 96,
more prestige.
I was asked to supply
All
a
that
bottle for
is held accountable.
Marcia.
And the way things are now, they're not held accountable. And every day,
I agreed
we
to
see
do
the
so, which
consequences
is what
in our newspapers or just talking.
So what do you make of the different perspective on this? To bring in a person that probably speak with.
I was then taken to the location where the training was actually being negotiated.
A book called Ron Cobb's. And
Give a short
we'll also
presentation as to
bring
the
up
nature of what's
the
what was
stuff that
happening as the P45K used Lotus. They wanted to use Lotus for back engineering.
And
I
we'll also
was
justify
objecting
racial
to its
profiling
use,
basis.
but still to provide what was under orders.
And we'll also bring up things like the
I
Ferguson
was
effect,
prepared to do so,
saying that
but
because
I
of
was
this
also
pushback,
allowed to show them probable outcomes.
all the stuff
So
that
in
was saying
fact, the
about
Yellow Book review was used for that purpose.
in those areas,
Shockingly,
the
they
back
happen to
finally,
see themselves standing on the bones of their own families and things like that in the vision, and they ultimately decided to remove Lotus as well as certain abductions from the Town 9 Treaty. So we were successful in getting certain things right. I think I can safely mention at this time, because we're only 1 Town 9 Treaty away from passage through the collision passage through the Black Plane. So I think I'm pretty well safe to go ahead and mention it now. They're not going to be able to get back put on the treaties about that reaction left.
Some of my conservative colleagues,
and that's what happens when you're negotiating.
Because what are some of the
show them the future implications of what using the Lotus to amplify
very important
to rectify their own biological
This is true.
problems.
This is true, and that was skewed by, it makes a great deal of emotion to skew the imagery and the audio that comes with it. But I'll just say that I'm extremely vehement with regard to my objection that was being used, and apparently that vehemence was sufficient to skew the image of the jump back and asked.
We're talking about the police.
So, and this is kind of like just saying to the audience to some degree.
So much in your consciousness.
You have seen in,
but now,
I guess, the Yellow Book or in the Looking Glass, if you
you make it seem as though I'm
the future of Lotus,
paranoid.
how Lotus
When they
becomes,
talk about the danger of
once it's brought to the fore by you,
Well, actually, no. No, I have.
the danger
I have.
of overreach. Another thing
The
respect
works to me, which came concerning the future of
transparency in government. Right.
Was given to me as information. Personally,
So why is it that so often
I was told
when you're
that was
talking
during
about
the early years. I think the early years of Lotus. It's only been
why
going on
is
for
it
6
that
years now.
conservatives
But this was
actually
the latter
embrace
half of
police
2001,
unions
and this was
and
a
are
quid
the
pro quo
enemies
for them
of
to get certain
transparency?
information.
Why is it that you
I demanded certain information back. It actually was information
from
concerning
knowing
time travel
that
because they were still trying to, they were still reticent.
has there have been
as to
10
what the real
incidents
nature of the
in
situation
the
was.
last year
As late
in
as
which citizens
2001.
have complained about
The real
officers.
situation was
Don't you think that the
how
citizenry
much
ought to know that?
access to
Why
Stargate
is it that you
to
want
time
to
travel
keep that
that they
under
actually
wraps?
had.
Right, the treaty, the whole treaty system,
Overreach,
the situations involving the treaties, their outcomes,
or, the
the
problem
actual potential
corruption.
for both timeline number 1 and
Why
timeline
is
number
it
2
that
outcomes.
those sorts of
In the
things
case that we're in right now, seem to be in a very
forgotten?
And that's good.
Some
For everything that I've seen
By the way,
and have read and
not all
reported
conservatives,
timeline
some
number 1,
conservatives
it's not happening exactly the way that we figured that it would. But then again, it couldn't because we've made changes along the way which diverted us away from timeline number 2. And in so doing, our future, again, I regard our future as something which is pretty much a blank slate. We're writing it for ourselves. And so we're now seeing something coming to pass which is slightly different prognostication.
There are some conservatives
And I'm good with what we're seeing so far, but we are still faced with challenges in environmental etc.
All of a
But
sudden
hopefully we will rise to the
become
challenge.
just
Okay,
totally
This
uncritical
is interesting because it sounds like
We're
Kayala was
talking about
instrumental in
The
getting you
overstepping, overreach,
to have
transparency.
greater access
Of course,
to
we see this kind of
intelligence
stuff
about
in
what the looking glass.
foreign policy as well, which is
MJ12.
starting off
It was the
conflicts,
information
and
that he
a
was
lot of the
providing
supporters, at
which
least
provoked questions.
with the Iraq
And
Afghanistan
the
wars,
fact that they didn't even
conservatives,
want to get involved in discussions
so there's a lot of
in the
hypocrisy.
late 90s concerning what he was.
So
After we
maybe
had
one question
argued
is,
for years, to
in
find
this
out even where the
discussion
material
about
was
racism
coming
and
from,
policing, there's
then we
a
were
lot
finally
of
given access to the material. I mean, this
cops
went
that
on
might
for
listen to
years.
this and
And
feel like they're
Your
not
interaction
being,
with Kayala was
the profession's not being respected,
one set of
they're not being heard,
and MJ12
not being
never had
respected
another
for the
set. Isn't that right?
difficulty
Well,
of the problem they're facing.
it wasn't that they had another set of
And
information. He was telling me, he did tell me basically what was going on, and they were simply not providing that information as what they considered a need to know
I pay
situation.
police.
So,
They just weren't going to tell me what they didn't feel I needed to know.
well,
I
this is
do.
my
These are the
paraphrase.
very
Little did they know that Kayala was basically
I mean, for one
He
thing,
was cluing me
you know,
in. He was
sort of
informing
maintaining
me
the
his
law.
perspectives
For
concerning
law,
the
that's a very complicated thing.
something was going on.
That's
And
not a
that is
thing.
ultimately
I
what they
teach
wanted
law.
to know about.
I
And
spend
I
a
said,
lot
well,
of
if you need to know
hours
about that kind of thing, then I need to know about certain other things.
trying to understand the law.
Situation, and they
So
said,
here
well,
we
okay,
expect people
we'll tell you if you
to
tell us.
understand
So
the
I
law
told them,
at
and they
the
told me
same time that they
and
are
it was right around that same time that
people,
Lotus was
some of
actually
whom are
kicking
violent.
into for
I
May 31st, 2001 that took my
And I
mosaic
said,
project
you
and
need police.
the garbage can
You did
and
not
it turned into
give
what it is now, this
So,
project that it is now.
you got the red pen.
And as a
You did
result,
not hear me
I also
say
found out from them where
defund the
they
police,
said
did you?
Lotus was
In fact, to the contrary, I said,
and that is, like I said, we'll discuss that
I
in a
want
slightly future date.
more fun
to
for
some
the
extent, that
police.
Lotus could help
I want to hold
Kayala.
them accountable. I understand the
That
difficulties
was the
of their job.
perspective of the P45
I respect the
J-Rods.
police. I
And
want
that is
people
not
to
my
respect the police.
I see. So,
I also want
because
the
I make a
police to
distinction
respect
between Kayala, who's what I understand a
and
P52,
demand.
and the P45. So,
I am not
but
a police
they're on the same,
abolitionist. Far from it.
They were on the same timeline, the same track, they just separated with 7 months.
so even so,
Just quite a big separation.
but we got, so what you're saying is that in a sense,
To what
Kayala
degree
couldn't get the benefits of
So
those.
philosophically, maybe practically, do you think police should be doing racial
I will say this.
profiling in general?
This is something that David.
It's a very difficult philosophical, moral, human question.
I think you know one.
So, first thing we need to do, here we get back to the early part of our conversation, and we focus so much on
And
the word.
was talking.
Here we have another word.
Discussing the same thing, which was
Question. What is racial
Q. And I said, you know, so the strange thing happened.
We have,
I was pro temp.
we have people
main
talking
energy
pants.
12.
I've been in
As a result of
conversations
that,
with police officers and debates, and
And I got a chance to chat who
past
ended
one
up being
another
the
to
last
be
in
defining racial profiling very different. If you ask, I've been in conversations with police officers, and they say,
Oh, first female
I'm
ever said.
totally against racial profiling. And I say, well, sir, what do you mean by racial
I got a
profiling?
chance to look at certain documents
Racial
and look at certain
profiling
archives
is when police
in
officers
Washington,
act
D.C.
against
prior to
somebody
going
wholly
across
on
to
the basis of
the
race.
continent and meeting with some
That
folks who
gets rid of
told me
the
basically I wasn't interested in their office.
because
I'm talking about a trip
most
to
police
Brussels.
officers don't act against anyone
And
wholly on the basis
during
of
the same
race.
time,
You can have the most racist police officer.
the cube disappeared.
That police officer is not going to act
It
adversely
hasn't been seen
against
since.
the
It disappeared out of
90-year-old
the
black
disappeared
woman
out of the archive.
walking down the street.
Of course, I have no idea.
Okay, so
I
it's
have no
always
idea where
if you define racial profiling
vitamin
that
B,
way,
but I do
getting
know
rid of
this.
the issue.
I'm happy
The issue
They can't
is
find
the proper issue
because
is
what they
this.
were doing is they were
Should
handing
the
this
police
cube around. This is a question that
be
Bill had asked whether
able
there was
to
only one
act
cube.
against
They
someone
were handing this cube around from country
taking
to country
race
to the
into account
elitists
as a
in
fact?
the countries to look
So
into their
let's
own
imagine
futures
that
so that
a
they
black
can pick the
person is
best paths for
25 years old,
themselves.
is walking down the street right next to a
Why
white
don't they just live their lives? Try to be good people.
Some people would
Why do they
say,
need a little
you know
black
what?
box to tell them
Under those
when to jump and how to jump? That's not being fully
okay
used, at least from my perspective, and those of our associates.
Two look at the
That's
black
not being
person,
fully
and
used.
one look at the white person.
So,
Why?
as I understand it,
Because the
disappeared.
statistics
Now,
tell
there
us
have been certain,
that
allegations that have been made
much more risk
that during the time when I had,
way to take a look at,
when I had the
crime
bad seizure,
statistics and ask the question,
it was near the end of last year.
with respect to
It's been a
homicide,
year ago, and
robbery.
I had a very severe seizure and was actually put out
What's the
seriously for a while.
is there a
And there
difference
was a
between
big
the white
hullabaloo to get over
and the
to
black?
my apartment to
With
get something
respect to
out of my
certain crimes, the
apartment.
answer is, in
What
certain
that
cases,
object
the
was,
answer is, yeah,
I
there's
was
a difference.
But
And there's
I
like
will say
a
this to
greater
everybody.
risk that the
Whomever
black 25-year-old has engaged in
it's in
various
safe
forms
hands
of
and it won't be
criminality.
used to harm humanity.
Okay.
In fact, the
Under
fact that
those
it's in safe hands
circumstances,
will
what do I
benefit
say?
me.
Should the police officers
It has been thus far only
be allowed to
aside
take
from,
action
well, I mean, I've got to try to
the black
justify my
person
own
as
behavior.
opposed to
And
the white person? My
using
answer
it
is
for
no.
the purposes of skewing get
I'm
locusts
fully
off and
willing to
production
concede.
off. I think that was for a beneficial cause.
But
But it has been used since actually the 50s by the potentates, by the leaders of the various countries to skew the history of the human race. And the common folk, the average people, all of us, have a right
to act
to a future which is our own. And not being skewed and designated and promulgated and promoted and promoted by blue bloods who feel that they are above everyone else.
Let's go back to.
I'm happy to pass along the information. I'm honored to pass along the information. That I understand that the yellow book is no longer accessible. That's all I know about it, though.
This very issue.
I understand. I totally understand, and thank you for that information.
That may be the reason too why the Illuminati has done something to us. It may also be the reason on the other end why the old Magi have it. Maybe why they're all so quiet.
Now, there is a rationale. It's not
I don't know.
prejudice. It's not animus. It's not insidious. It's just
People should have upper
the
hand.
facts take us this way.
They should have upper hand for their own destiny.
There are
And
facts.
that's why
And
we
then there is our choice of how we
have gone as far
respond
as what
to
we
them.
have to expose the
Now,
SSM
You
200
could
report.
respond by saying, well, we perceive
Ford administration, which I believe
Muslims
was written by
to be more likely
Dr. Henry
to,
Kissinger,
do
he
bad
suggested
things on an airline. You could respond in that way.
possible use of food as a weapon.
On the other hand, you could say no.
And it's
We
used
want
against
a
the fact that it's
society
tool against the third world.
in which
Now, at the same
people
time, we notice
are
that there's
do
a
not
revelation
have to grapple
guidance from the
with prejudice on the basis of their religion, on the basis of their race.
that if the
To
rule
deal
the
with
average
that,
temperature
he
rises
is
to
going to demand
Celsius,
to
that the northern hemisphere,
act towards people in
higher
the
latitude
same way.
growth
So
will
if that
increase.
means
However, if it goes over that, it will decrease. Yet the lower
everybody's
latitudes, by the way,
getting
that's
on
where we
the
find most of
before
the
they
third
go
world
to
countries. The
have
2 to 3 degree Celsius
open up
increase will cause starvation and crop loss. Now, isn't this funny?
slows things down.
How they're just allowing global warming
Everybody
to
has
use
to
I
I
would
prefer
I'm
that
not saying that's the total cost. It's not.
over a system
There are
in which
cycles
we
involved, short
focus
as well as long-term cycles. But isn't it funny?
and one of the
it's
reasons,
my
and
best
I'm bringing this back to our
guess that they'll probably order just enough ameliorative steps to be taken where it levels off where the higher latitudes probably don't lose their
what that
crops
means
where you find the
is
majority of the
we're
rich
all
countries.
paying tax.
That's actually fascinating.
And we're all likely to ask ourselves, do
I
we
think
want to pay
that
this? Whereas if
it
you
is
focus
also
on
interesting
the
that most of the crops
allow
are
the
being
Muslim
in
people
the lower latitudes. They're not being grown.
we'll force that on them.
Right, but you have
Same
sustainability
in
though.
the black person,
Whereas when you have the loss of the crops in the lower
do we
latitudes,
want
you're also
to
losing a lot of the
impose
population
a
in the
racial
third
tax
world,
on the black
which
25?
unfortunately, according to the way that
Some
the
people would say
doctrines read,
yes.
some
Okay,
people
listen,
find them expendable.
Black people aren't stupid. They know
They
that
don't
there's
feel
no
that
such
way.
thing.
No, I'm not one that likes
It
to hear
is
yes of
a
politics.
violation
I
of
like state of research.
the rules that we
Well, at the same time, I mean,
have
when
to
we
govern
start
our
hearing
society.
that the codex is
I
being
say
placed in place which
spread the
actually
cost.
delimits food
Make the
value.
police deal
Oh,
with
you have all the food
everybody.
you want. Starve to death while you're
The
eating.
same.
There's no nutrients. When I start hearing that food is being used as a weapon, and it's being used concerning the use of fossil fuels, I start getting personally angry. There's not one person in the lower latitudes who's worth any less than me. Everybody is worth exactly the same thing on this earth. And unfortunately, there are individuals who feel otherwise.
While it may have
Okay, so Bill,
cost
the
of
question you were
security
asking,
in the short
now that
term,
we've kind of,
in the long
let's
term,
talk about,
it's the
first of all, you
embodiment of the
mentioned
principles
Bill
that all men are
Newhouse.
created equal.
Son of
So
Bill
it has
Newhouse.
a much bigger
Bill
benefit
Newhouse,
in
very
representing the
he
fairness
realized
that is
that he
the
was
core
actually,
of
the
the
son
idea of
you were
this.
saying,
Yes.
had access to that technology.
Yes,
Let me ask a
Bill
big philosophical question.
was the
Why do
builder
you
of
think
the
there is racism?
avionics testing equipment.
Okay.
Back engineer of the Arabian testing equipment and avionics. I actually saw some of the equipment, and this is in the.
I don't know.
Will there always be?
Garcia and I did.
Why is there tribalism? Are humans
I
always
actually saw some
finding
of the
this
equipment, some of the diagnostic
way to
equipment.
divide ourselves in
The B bay underneath the Galileo
how
bay.
bad of a problem is that?
That he actually built.
I
So
don't
when I started
know. I mean,
describing it,
I don't.
Will looked at me and
I'm
said,
not going
"That's
to
what we
pretend
had."
that I know enough.
So we had a very nice connection there. And it's Will who had experience around multiple equipment.
Really grapple
His son,
with that.
Newhouse's son.
And Will Newhouse is alive now.
Yes.
So that's very interesting.
Very
His wife Terry, in fact,
knowledge base
what I understand
that
from
can
that,
make comparison
during the course
to the
of
world that they play. From the little bit I
conversations
know about
concerning
it,
our
I
information coming to the public. Terry and Will met one another.
Very
fell in love
privileged
with
character.
That
I
makes me
live in
feel
a
kind of
university. So I'm reading constantly and listening
Okay, well,
constantly.
so it
From
sounds
what I
like
gather,
Will knows quite a
the
bit about
problem of
what
divided
makes
societies
ARB
is a
run.
problem that
He
is
and his father
worldwide.
had something to do back in there.
There's, you know, and it
Okay,
seems
so in
as though
1947,
seems as
was
though
discovered,
human ingenuity
it
is
must have
such
really screwed up
that
the idea of the
humans
two
will find
timelines
something
by bringing in
to
the ability to
divide
I
them.
mean, I don't know what the
You know, it might
can do,
First of all,
but
Cube
texture
wasn't
hair,
actually was
it
not
might
discovered
be
in 1947. There's a mixture of the stories
complexion of skin,
The Cube was actually the
etc.
information about the Cube
Ideologies.
existence
Ideology,
known
the
as
texture, it's the texture,
1946.
skin.
It was further discussed in 1947 after a certain
It'll
crash
then
in
be, well, you know,
southwestern state,
you wear these sorts of clothes.
and
You speak in this
following which, during the
you
first
believe
vote
this,
recording for
whereas
treaties
I
by the
believe
Orion
that.
with Eisenhower,
I mean, it seems
it
like
was
the
handed
human ingenuity
to
that
Eisenhower. It was in fact expected to go to the United
some
Nations authorities,
of
and it was in fact
distinguishing
spirited
themselves,
away by the United States.
and then
They
they
didn't handle it.
seem to want
so,
to
but you,
embellish
talked
this
about
assumption.
this,
Not
it
just the
sounds
distinction,
like it,
not just you believe this and I believe this. Okay, that makes real interesting. You know, let's
It
talk
does, and the fact that it was handed, it was actually Orion
It's
technology.
usually
And
associated with you
it was
believe
handed
this,
over by
I
a
believe
man with
this.
the
Of course,
spirit of
my
goodwill, but a
theory is
misassessment
your belief,
as to our
and
evolutionary state,
I want to put you
our
down.
ability to handle the
And
issue
now
and
we're
handle the equipment.
The
They
interesting
felt
thing
this
is,
more
if I was
balanced
stuck outside of this whole
than
thing,
what we
from
actually
an
were.
alien perspective, is
okay,
America.
well, this is, I mean, this opens almost.
I think America is one of the greatest, if not the greatest.
That is Pandora's box.
civilization.
I'm not
And I
exactly
think
certain
that
what was seen
the
relatively to
line between white and black, the
However,
racial
the
struggle,
analysis
is the
which
thing that
I was asked to do,
in part is
of course, I've paid the price now that I've
there's
actually done
something
it.
about the division and the way
I
you
don't want to hear
alleviate
the
that
answers
division
that
through the struggle for human rights that makes for a
the
great nation.
analysis that I
So
did
it's interesting
indicated that
that the
certainly
division
there's
is
at
almost
minimum
the
a
fuel
great
for
suspicion
the greatness for
concerning
our
the
discovery of what
delay
it
of
means to be human,
response.
what it means to be
And
what justice
the
means.
information that I have directly from
And
one
it's
of the former
interesting
senior
that
members
it seems like there's
was
this
in fact
struggle
that we were aware
you're elucidating
this
now.
was looking
That
glass
struggle
technology,
itself
not
is
the
our
cube,
search
that we were aware as in the
man's
middle
search for
1990s
meaning
that
and
there would be a
justice and
coming
truth. I
Islamic
think there's something
extremist
to that
war
as you
in the
speak. I
United
was
States.
immediately thinking of
We were also aware of certain
most
alternative
gentlemen, the great
situations
Frederick
that
Douglass.
they use the statistics with the looking glass, the variability
the
of
history of the
pictures
world.
to
And, you know,
show
one
that
of the things
occurring
that
at the same time.
ironically
Probability
enabled
at the
him
same
to
time.
become one of the great
And
people of the world. He was born
From
into
their
slavery.
perspective,
He's overcoming
that the least of the two consequences was 9/11.
that, in a sense,
I am
made
aware of
him
what the other possible
this larger than
consequence
life figure.
was.
I think there's
I'm
something
not
to
willing
I
to
will
come
say
out
this because we're in
and
the
start mentioning it because I don't know what the consequences are of speaking the things that haven't been, that have not thus far happened, yet the probabilities existed that they could.
I'd say in the last
So you know, I'm feeling a little bit, there's a little weight when it comes to that. But
my feeling about the United States
The looking glasses have been, as you call it, decommissioned.
yes, ma'am,
And that means across the board.
across the board,
changed
they are
in
shut
some
down.
somber way.
And
For
you
most
said
of
there
my
was
life,
man-made devices.
for most of my life,
And I'm
I said at
I've
least
been in
When
the
access,
optimistic camp with respect to my
for
view of
creating
American
stargates tests out of
the optimistic
natural
camp. That was the
vortexes.
camp. That's
Yes.
the camp that
And
believes
they
in
would just
shallow.
suck them in and make them available.
That's Martin Luther King's camp. Martin Luther King,
No,
Martin
looking
Luther
glasses
King,
back
hours
in here
before he was
for
killed.
the original cylinder seal description of how to build
With you,
units that they made stargates. So in essence, you can take a looking glass unit
optimism.
and make a couple changes to the equipment, lift it up on an angle, put field posts around it, and open up
Wonderful, good
Okay, but the looking
which you would start to drop in the pessimistic camp, but not much.
On the pessimistic camp is more interesting. Ideologically, it's more interesting camp because of the pessimistic camp. You have
a basic
if I was going
monopoly over the looking glass, that and
pessimist number one,
Indian broker early on with Indira, when Indira Gandhi was
Thomas
brokering
Jefferson, the author,
the majority
principal author,
between the United States and the Soviet Union,
also
because the Soviets were
the
threatening to
author
start their
of
own treaty system
Notes on the State of Virginia.
with the
And he
extraterrestrials. It would
said
have
in
become
Notes on the State of
untenable.
Virginia,
We agreed then to expand MJ-12 from a wholly operated North American operation
the
to an
black
international
people
operation. Thus was born
will
the Indian
always
majority
know
between 1963 and 1967. And
that their
when
forebears were
that
enslaved.
information was
And
brokered,
there will always be
that happened in parallel with, kind of under the table, but in parallel with
Jefferson did not
United Nations treaties involving things like the Test Ban Treaty and the Outer Space
very critical
Treaty.
of slavery. And
So it was being done at the same time under cover of UN support. The diplomats were going back and
But
forth,
he did
brokering the
understand
opening up
slavery was
so
hard.
that the treaty system would be a single treaty system, thus tenable and manageable
He
to
did not want to
hopefully
free
get
the
out there.
slaves
And
for
we'll
a
be
variety of
there in the
reasons.
next few years.
But in
whether
one
that was
reason was because he
successful.
thought that
Okay,
it would
so
be
this is really
impossible to
fascinating.
have a
You're
society
saying that some
in
other
which
countries
blacks and whites
had access to some
were
of this technology.
Yes, ma'am. They had that written in as far back as the
another pessimist,
60s and 70s when it was actually being back engineered from the Stargate material.
who was some of the other
And so I would say
Abraham
that
Lincoln.
Will House, for instance, was looking at the early generation looking glass.
like
You had
slavery, but blacks and whites are not going to be able to stay in the United States. Maybe the best we can do is
to the information or to the equipment.
Can you elaborate on that? I think people would be surprised to hear that you would put Abraham Lincoln in the Hudson's camp.
Oh, Abraham Lincoln still is
No, because and I'll tell you why the answer is no.
slavery.
Within the treaties, the looking glass, as well as the Stargates, as well as the cube, and the information movement pods, are all contained within the treaty system. Within that treaty system, it also prohibits and allows passage of information most delicate on where the looking glass material is and where the information flow is, where the access is. Being that I stood in Van Clear and considered a delegate, therefore I could
black people and white people would be able to share the United States.
no.
Down to the black nationalists.
Aside from India and the United States.
Marcus Garvey.
So, but we can assume that
my
some
father-
countries, perhaps,
My father was a
leadership of some
thoroughgoing
countries, may have had
And
access
his
to
view
these
was
technologies.
the United States
I think that it's
born
fair to say that we can
as
assume
a
they
white
had
man's
access to
country.
information from it,
It's going to
but
remain
I
a white
wouldn't
man's
place any
country.
characterization over any assumption.
And that's the way it
It
was.
was.
It was thoroughly.
All right, well, it,
I think
because
You mentioned just a brief
but
aside
it
that
also
your dad
gives
that
you a whole different
we
way of
moved to
looking at
South
history.
Carolina to Washington,
certainly
D.C.
It does.
And he asked him
I mean,
why.
this
His
stuff
response to me
is
was
gotta be
because the white man was going to kill
as
me, so I
natural
was
to
going
you
to stay
as,
away.
getting up in the
So he
morning,
saw
and having a
race
cup of
as an
coffee. This
important
is all
line
part
to
of the
divide the
Now, there's nothing as natural for me as getting up and having my cup of coffee.
My father did
And we
not.
should have never built.
My father had
The
passed away
Stargate, yes.
before the election,
Okay,
before Obama was
for the
elected.
purpose
I would have loved
speaking
to
with the visitors
talk
from
with
the
my
other
dad a
timelines.
few years ago.
Yes, absolutely. The looking glass,
You wrote a book about the
that was done
I did, and I did.
because of
I
our
never
own shortcomings
worked with my
as people
father
who
because my father
aspire
was
to things that
delighted.
we maybe shouldn't try to grab a hold of. It should have never been
I
built.
do think, though,
Right, we're talking about power, the misuse of power here.
I do
Yes.
think that my father
Yes.
would have said,
And I am an
happy
advocate
that
against that
Barack Obama
misuse.
is still
In
elected.
fact, well, I can say against the misuse. I am an
Hold on
advocate
to your
against misuse, period.
Okay,
Let's
so
see how the white people
let's
respond.
say that what
Maybe
has
a predicted
I
us,
think
and you're
that my
saying it
father,
shows
I think
probabilities,
in
and one of the
2016,
things we were wondering is,
2016,
how
He
does
would
he
have
do
said, I
that?
told you.
yes, yes,
The best
I think
I
in
understand was
2016,
from
my
Bill
father would
a
say,
while about it.
all
little while
of
ago,
you people
the rings
who are
and
talking
the amount of
about, I don't
information
know what's happened to America,
via
how
energy,
could this
which
have
is passed
happened,
into
you know, no.
the position of the rings,
This is America
their
being
orientation, the
America.
energy running through them,
And what has
position of the
happened
barrel, etc.
is that
Raise the barrel
America
up on a
has been
inside the center of it.
put off kilter
All come into play
by a black
as if you
family
have
in
an onion,
America.
various layers of the onion. As you move through the different energy levels, you also
now
move through the
this is
different
coming
layers,
forward
you get different
to
bits
how
of
far it
information.
absolutely
Now
so
imagine an almost infinite number of layers overlaid in comparison to the positions of the rings, the amount and an almost infinite amount of energy
outside of the
that you can add or subtract.
I want to be careful here.
Instead of going up by 1 hertz, by 2 hertz, maybe by
I don't want
hertz,
to. You're right. I don't want to give up on the optimism. I don't.
Right, except
I have been.
Yeah, you get it.
My optimism has definitely been dampened.
Working with multiple
They have definitely been
kaleidoscopes,
tested.
where when you find two different probabilities that you would run into,
I am not
you have two kaleidoscopes, and you make a change on one kaleidoscope. That may backward function to a different angular change on another kaleidoscope. So you get two separate pictures that you then have flashing back and forth. Yes.
Am I more in the optimist camp than I'm in the pessimist camp? Yeah, I'm still probably more in the optimist camp, but my optimism is dampened.
Yeah, in fact, there's a deinterlacing system which they use.
I have to say the following things.
Deinterlace the flashing back and forth of the two probabilities or the multiples that they have at certain times. We're going to start skipping.
My father was sitting here with us.
Well, what they did is they deinterlaced the video and then reintegrated the video and watched the individual videos.
That the country
and determined statistically how much time was spent on each video to determine the amount of probability of each
also
event.
true, Pop, that
And they tested that
the Vice
against
President
probabilities in the field and probabilities of future occurrence to get a system which functions scientifically. And that's
Secretary of Defense.
I'm going to go with that, and I'm going to
Now,
actually say what they might have
Secretary of Defense is the head of the Pentagon. The
in other words, if
Secretary
they
of
saw an
Defense
event
knows where the button
all they had to
is.
do was
This is not a little, this is
or look
not
into different
a
possibilities, see
small
which one happened, and then
That's what they did.
that's kind of
Absolutely. That's right on. That's right on. That is right on, baby. And some people, like I said, some people say it's blue smoke and mirrors. Then again, I was told something in 2001 that's I'm living it right now. Okay, without going to what it is.
There are black
And like I said, we'll talk about that in the future, but
police forces, there are black
it's the
mayors,
best scientific
there are black
equipment that I can imagine for the determining of such a thing. But it goes to the old question, is because we have the power to do something.
President-elect
And I am a 100% advocate, and I had
is a black woman.
more than a small
And this
dust up
go on and
over
on.
this very same thing, which actually resulted in me walking alone down Lake back toward Las Vegas,
we got a magazine.
with she and I yelling and screaming at each other along the roadside. They were doing tests out at Frenchman Mountain during the time that the Rosen Bridge was being accessed there, the Einstein Rosen Bridge. With the equipment they had, the curtains up and all of that business, up where Metro could see from the top of the mountain and all of that, and they were accessing there. There was a mistake, and a small explosion out there on the east side of the school. We called it a piece of helmet, and she wanted me to go out there with her to help clean some of the evidence up of it. She and I got more of a little dust up because I didn't want anything to do with it. Because I don't believe, I'm no Luddite, I'm all for grand technology, but I don't believe in playing with things which actually deal with looking into the future. And there's another issue that was going on at the time of that, a variety of communication which was going on via this equipment from elsewhere. I presume she will still hasn't admit to me, but
yes.
I presume that it was from Orion, and it was information, defense-related information on how this type of equipment equipment, how an Einstein-Rosen bridge at a distance could be used to pull information out of a defense computer system.
Think
And
about
I don't mean a U.S. defense computer system.
think
I said,
about
you know what?
practically
No.
any
Look,
large
we've got the
nation
technology
state.
here, we've got the
They
talent,
all grapple
we've
with
got the willpower, we've got the willing
If one
to
asks
defend our own country without
about
the
the
use of
United
something
States
involving crime
police
technology,
and one puts
I
on
wouldn't want to
the
go up
table
against, for instance, God help
that,
us, the Chinese on the
you know,
ground. But at the same time, I don't fear their country either. I believe that we should be diplomatic with them and have a firm understanding and respect for one another. But I also don't fear them. And so the use of technology like that is not honorable.
Right. Well, it's like knowing how the game plays out.
The great mass of black people in the United States that recently been released from chattel
That's why I
slavery.
was so
The
interested
great
in
mass of
when I
black
was
people in the United States in
doing my
1865
time with the jobs involving safety and security training and all of that here in Las Vegas, when I was interacting with Marcia in the eye,
I mean, it's
because we
absolutely,
were literally
it's
on a daily
absolutely
basis talking about that same thing. And about
And
the
so,
psychology of
one of the
individuals who
difficulties
come to a table to play a game
is wrapping my head
to alter
around
the outcome of the game.
two stories that are in
And
such tension.
that whole psychology is
One
something
is a
which
continuing story
I'm not,
of
it's not foreign to. And so that helps
But the other
both prime
story
wick
is
of
a story that
the
is
explosion
encapsulated
between myself and that
in
variety of
the
technology,
title of a great
which actually primed my disagreement.
John Hope Franklin,
I
From
understand what you're
Slavery
saying,
to
and
Freedom.
there's a million questions that all of this
And
is
those are two stories in American
I
life.
would like to ask,
It takes an awful lot
knowing,
to put your
now that I
mind
know what I
around
know,
those stories. And I'm trying to.
Well, as an optimist, I think you put more value to the overcoming side of the story, the overcoming of hardship, overcoming of slavery. Well, since you mentioned the literacy, and 150 years ago, let me ask you about affirmative action. You wrote a book on the topic. Titled For Discrimination, Race, Affirmative Action, and the Law. First, what is affirmative action?
The technology is not being used at all right now.
Maybe we could talk about what your view is on it today.
Affirmative action.
the plane of the
As of about 2017, I would expect probably
Racial
all of
affirmative
these
action. There's various
pieces
sorts
of
of
equipment will
affirmative
probably
action.
all get
You
reassembled.
can have affirmative action for veterans.
back on.
Oh, sure.
Affirmative action for
2016, 2017.
in-state residents.
Probably not.
Because you have a school, you know, the university.
I'm figuring that they're probably going to act
blah blah
conservative.
blah, and you're gonna
That's what
you want
all
to
the people
reach
with suggested to
we're gonna give a reach
is
out
to act
a
conservatively.
hand.
That yes, the so-called cycle of catastrophe or seasonal catastrophe means the Fulcanelli, the time period from
We're
right
gonna have a
around 1992 to around 2012, right around that area. While we will have passed it,
the type of affirmative
it
action
really ought to be the entire cycle, which is about 1980 to about 2016.
So there's all sorts of affirmative
To
action.
feel
When you say affirmative action, the
That
type of
the
affirmative action that
interpretation from
immediately
timeline from the future about their own catastrophe is
Seems
not
like
off
race
by
is the core of this American
talking
experience.
about
That's part of it. In every part of
45,000 years,
Bingo.
50,000 years respectively.
why is
We have difficulty understanding what happened
again
in 2000.
there's various
And we're talking about 50,000 years here. So
help various
it's very wise for them to wait.
why is it that this is the one
The looking
that
glasses are now
generates all of
also
the
Stargate.
pulling
Yeah,
out
yeah, they're
hair
decommissioned and the Stargates looking glasses. I'm sure they're all in their
racial affirmative
all
action
of that. Have been separated, three components have been separated and moved to different power structures, diplomatic and military authorities
reach
in
out
the world. And we're talking about the EU specifically, the UN and NATO.
racial
Those are in
now
specific
reaching out
control of one of the three components each.
A light
And I cannot comment as to which component is contained by
reaching out in terms of recruiting, making a special effort to make sure that young
there is
people
no doubt
that
whatsoever
say
when it comes to
minority
the
neighborhoods
looking glasses,
know
and
about
when it
it.
comes to the Stargate technology, and it has been decommissioned. And
On the other hand, racial affirmative
there
action
are
might take
threats
more
going on, ongoing threats from Muslim countries stating that they would put it together at their will through their own self-determination. And those countries, if push comes to shove, will be shoved.
Who do well enough in this competition to be
As in build one that sells now. Yeah, what was extant has been collected.
In various
I'm
ways,
under very good assurance that what was sitting there has now been
minority
collected
kids.
and decommissioned.
If it comes down to you have two kids, they both,
Absolutely.
99 on the test,
The very highest
one place left, one spot
That's
left.
true. That's true. And Bill was.
One's a black kid, one's a white kid.
About
They
it
both got
being
99.
introduced thing in a year. Was given.
Why? Well, black kid.
And he was saying, well, a year.
Black
Why
kid.
would that?
Maybe, and then our theory, maybe our theory is that black people have been done wrong in the United States, and we want our institutions to contribute
Telling me about
to
something
making
that
them
might
more.
happen
That might be a theory. Another theory might be, we think that we'll have a more interesting student body, we'll have a better student body, and better discussion if there are more black kids on campus. Unless we make a special effort to bring more black kids on campus, our student body will be overwhelmingly monoracial. We'll have, white kids, a few Asian kids, a few Latino kids, black kids here. I don't know, it'll be lacking an important aspect of American life. Some sort of, so-called diversity. So anyway, there are various theories. Some are grounded, like I said, in reparative justice. Some might be grounded in distributive justice. So, for instance, when people say nowadays, we want a cabinet, we want a team, we want a student body that looks like America. That might be a distributive justice theory for why you want affirmative action. Unless we
The looking glass
reach out and give a boost
an ability to show one the future.
they
But a
won't
Stargate or or equipment to access
looks like
Stargate
we won't have a
is for
campus
time
that looks like
travel,
America
right?
unless we give a
We're
special
talking about
boost
two
to
different things.
Yes.
Are they using
the
the same
Latino kids,
technology?
unless we give a
Essentially, yes.
Black.
The original device
Comparative justice,
was the
distributive
Stargate
justice,
device.
or
That was then increased in
diversity.
his power.
We just want to have an interesting student body and to have an
How it
interesting
lifted the
student
power,
body.
how it stabilized it.
Kids from a wide array of places.
Okay.
So that'll make for a better campus and an interesting.
But
Those
no,
are three justifications.
no.
All of which,
It would
however,
be
are justifications for
to stabilize
in a competition,
the doorway,
giving a
step
special
through into
boost
another
to some
location.
people
In
based
essence,
on their
because
race.
distance and time are
What's your
relevant.
sense? You need to
Same
take
thing.
four
Step through into another time.
Yeah,
The looking
I can
glass
make the
device
case
was
for and I
back
can make the
engineered.
case against. Case
Stargate.
4,
So
I
it
won't
was already
spend much
back
time on this.
engineered
I can
from
say
the
there's
original cylinder seal data, which allowed us to use
there are three
the Stargate access devices.
main justifications.
Stargates.
Your audience
It's
know
back engineered
that
device, the looking glasses. So the looking glass is a secondary device, and it was coming into its
is a justification that you don't hear about in the courts because the courts have said that justification
piece of equipment
is insufficient. So the real justification behind affirmative action was in the late 1960s, in the aftermath of the Civil Rights Revolution.
I saw one of the original looking glasses
There was a
demonstrated.
feeling that, well, okay,
In fact,
fine, we're not
it's going to be
discriminating
in the
against
DVD
black
that
people
we're
anymore.
getting ready to put
black
out the
people
actual
have been
interview
disadvantaged
where he was indicating
by
firing
the
a bullet, I believe
discrimination
it
that
was,
has been
through
put
an
upon
object.
them.
And
this
there was
discrimination that
a
was put
time
upon them
delay where the bullet
has
actually
disabled
passed
them.
through the object, where he saw the bullet
And so
pass
they go
the
into
object,
competition,
projectile, with a rail
and
gun,
it's unfair.
Yeah, it was a rail gun that
more
was
or
being
less go on
used.
the
And then
standardized
afterward,
test, but
they saw the
you know,
impact
surprise,
of the
surprise, what
device.
the
They
heck?
were already playing with
They
it in
went
the
to
early
school
70s,
in
mid-70s,
which
with
they got
dealing
the
with
leavings of the
time
white
sequences.
folks.
This is the original
You know, the
movie
white
class.
folks gave
Back
the black
engineered
folks the old textbooks. That's what the black kids read. The white kids read the newest textbook. On and on and on. So,
but it also
reparative justice.
there was information around the cylinders
the scars left by
as
past
also, and that
racial
those cylinder
injustice.
seals also came
And
from
so it's sort of an effort to overcome the vestiges past. That was one justification for affirmative action. But frankly, I think that's a justification that has always been the dominant justification, whether people owned up to it or not. But that's one justification.
I really
The
shouldn't.
distributed justice justification is there. Like I say, you know, people, we want an integrated America. We want an America that looks like America. In that
That's when they started actually
justification,
being
legitimacy is sometimes
showing a lot of
mentioned. So, for instance,
interest in actually building
people will say
equipment
things like,
to see over
well,
and over the curvature of time
you
and space.
know, it was in the armed forces. You can't have an armed forces in which the
there's also our
the people on the ground
contact said there was a black box that came
you have a lot of people on the ground with
and I don't know
color,
if you like that
but
black
none of
box.
the
Did
people
you
call
have
it shot. None of the general, none of the major colonels are people. No,
that was not
they're
the class. Was that
the people on the ground are not going to stand
That
for
is a
for
very
the purpose of legitimation.
however,
For purposes of buying,
glass shows
we need to have a situation in which people get the
the
sense
tube
that
would react
even if they're sort of low down,
present.
they're still part of the story. They're part of the
There was
team.
an
So that's
alteration
part of the sort of,
what you were seeing from it.
I don't
Spin
know,
out as a yellow disc
distributed
out of
justice
the word yellow.
notion.
Do you think that's follow to that? Do you think the value was corrected for that kind of idea?
I think it's so.
Because for the application process for different universities, I think that's probably driving the justification for
You could
well,
then change
affirmative action,
the
I don't know where we put DEI
if you will, the orientation or
because they
angle
overlap,
of
but
the
not
information
perfectly.
being presented back to you.
The
So unless you
reason
were well
that the
prepared
school,
to
so
deal
yeah,
with
as you know, there is a
human
space
interaction,
that you'll know about it. It will be announced sometime in the next month.
instability
Well, month and a half.
That's what went on
It's the
with
case
black
of
box.
Supreme Court of the United States, in which the
And
affirmative
I
action
used that
program at Harvard and the affirmative action program at the University of North Carolina are being challenged. Most people think, including me, the Supreme Court of the United States
which
is
caused a
going
little upset
to
during
limit,
the
if
meeting.
not
They got certain reductions for
literally
adopt the calendar.
seek to abolish.
My customer trouble.
Can you elaborate? Are you willing to elaborate?
As things currently stand,
The
my university and
sit here
other
and consider what
universities embrace affirmative action on the third ground.
during the
Because
negotiations for
they
the
say
Taliban 6,
is
I was asked to
we
supply
need affirmative
a lot
action
of
because affirmative action
that
is good for pedagogical.
tangentially.
Now, frankly,
I agree to do
something
so.
to that. I think there's a
Which
little
is what
something to
you
that.
respond when you're sworn out.
Subjects.
Yes.
I don't think
There are
that's
great,
really
great
going on. I mean, if that's what's really going on, why don't we have more?
I was then taken to the location
Why is there a greater
the
effort to
treaty
bring
was actually
in
being negotiated.
Why isn't there a greater effort to bring in
To give a
more?
short recitation
I
as
don't
to
know.
the nature of what was
Religious
happening is the
fundamentals. Why
P-45
isn't there a
teams
greater effort
used
to bring
Lotus. They
in
wanted to
music
use
names?
Lotus for back
There
in
is groups that are, you hardly ever see them.
I was
So you don't
objecting
think this kind of
to its use,
effort
but still
of
to
driving
provide
towards diversity
some orders
is
to provide law.
I think it's often
do
too
so.
textual. I think, frankly,
But
the
I
real
was also
reason
allowed to
has
show
do
them
with
probable outcomes.
the
So in
belief,
fact,
and I
the
think it's a
yellow
good belief.
cube
I
was
associate
used for that
myself with the
purpose.
belief.
Shockingly, they happened to see themselves standing alone from their own families and things like that in the vision, and
But
they
it's still the
ultimately
case
decided
that
to
a lot of
bonus
institutions
as well
want
as
to
certain abductions
help American society
from the
overcome its
town
racial past.
So we were
That's
successful
the
in
real
doing certain things.
thing about,
I think I can safely mention
discussions.
at this time, because we're only 109.11 town treaty away from passage through the completion of the passage.
My sense of it is, however,
So I think
that
I'm pretty well safe to
physics,
go ahead and mention it now. I'm not going to be able to get back on the
it
treaties.
doesn't much matter in terms of mass physics.
In other words, they got out
What the
fast.
demographics of that class,
That's what happens when
there's
you're
no physics in your don't.
The interesting thing I've noticed in this podcast is one way it does matter. It's really lonely when you do a thing and you don't see somebody that looks like you doing that thing. And it's such a really stupid thing. Why does it matter if there's another person that looks like
This is true,
you
and
in this very shallow
that was
sense?
skewed
But
by,
it
it
seems to
takes a
matter.
great deal of
When I
emotion,
talk to, for example,
skewed
women on the
imagery,
podcast, a lot of women reach out
and
saying
the
something about
audio that comes with
That's
it.
interesting, right? I think we're still human,
I'll just
and
say
we
that
see
I'm
people that
extremely
look like
vehement
us,
with regard to my
and this
objection
kind
to
of
those
narrow,
being used,
shallow
and
definition of
apparently
diversity is
that
still not.
vehemence was
Okay,
sufficient.
well, I think you've
Jump
made a
back
good
and
point,
gasp.
and
So,
maybe so. So let's go back to the physics.
and this kind of like just
Under one
sake of the
scenario,
audience,
there's a classroom and a kid
you have seen,
sticks his head in, a black kid sticks his head in
I
the
guess the
classroom,
yellow book or in the
and
looking
doesn't see
glass,
anybody else black there,
what it is.
and
The
has to make a
future
quick
of
decision.
Lotus
Says,
is
nah,
how
this ain't for me.
Lotus becomes,
Versus,
once
they
it's
stick their heads in the
brought forward by
classroom,
you.
Well, actually,
they see a smattering
No,
of
no,
other
I
black
have-
kids in the classroom.
I have the
And then they try it, and it turns out, damn it, they're, Albert Einstein. So, to that extent, I can
Was
see,
given to me as
under that
information.
scenario, maybe it doesn't. So,
Personally,
I'll have
see
to
it
be
now.
California.
I was
Still,
told.
those are the three. Those are the
That was during
three.
the early years. I think the early years of Lotus is, I think, been going on for 6
You ask
years
me,
now.
where do I
But this was
oh,
the
no.
latter half of
Before we get to that,
2001.
are there criticisms?
And this was a quid pro quo for
There are
them to get certain information.
Affirmative action is a
I demanded
policy
certain
by
information
any-
back.
any-
It actually was
any
information
policy is going to have
concerning
some
time travel issue because they were still
affirmative
trying
action
to,
is different.
they were still
Affirmative action
reticent
has some
about
downsides. Yes, it
informing
does
me
that.
as to what the real
What
nature
are
of the
they?
situation
Well,
was.
let me
As late as 2001,
One,
The real situation was how much access to Stargate,
so
to time travel that they
if
actually
you have
had.
an
right, the whole treaty
that
system,
says
the
that it
situations involving the treaties, their outcomes,
reaches out
the actual potential for both timeline number 1 and timeline number 2 outcomes. In the case that we're in right now, we seem to be in a very good timeline, and that's good.
If
For
so
everything
and
that I've
so
seen
is here,
and have read and reported to concerning timeline number 1, it's not
doesn't that
happening
mean
exactly the
that
way
they
we
were
figured
not
that it
as
would. But then again, it couldn't because we've made
the other
changes
people who were
along the
here
way
and who did
to
not
burden us
have
away
that.
from timeline number 2.
So
In
if they are
so
not as
doing,
proficient,
our
that means
future,
that they
again,
might not
I
be
regard
as
our future as
good.
something which is pretty much a blank slate. We're writing it for ourselves.
Is
And
that
so we are now
part
seeing
of
something
our
coming to pass,
affirmative
which is slightly different from the
Yes, it's part
prognostication
of our affirmative
probabilities that we were seeing.
Yes.
And I'm good with what
I'm a
we're seeing so
professor at
far,
Harvard
but
Law School.
we are
One
still
of the
facing
subjects I teach is contract. Actually,
but
that's
hopefully
probably
we
the
will
subject
rise
I'm
to the
most
challenge.
Okay,
I
so
think I'm most interested
this is interesting because it sounds like Kaela was
racial
instrumental in getting
and
you
don't
to have
But as far as
greater access
teaching, I most enjoy teaching.
intelligence
From
about
the
what
very
looking
first day,
glass
from the very first day,
FJ12.
Yeah, it was
when
the
I,
information that he was providing me,
students
which
come,
were
and
questions.
especially the first few
And
students, they're nervous.
the fact that they didn't even want to get into long-winded
I
discussions
showed
in the late
I'm
90s
quite sure that
concerning
some
what he
students
even was.
were thinking,
After we had years
okay,
to find out even where the material was coming
is
from.
this guy
Then we
as
were finally given
good
access to the material. This
as
went
my
on
other
for
teacher?
years.
Because, I know that institutions like Harvard has made a special effort to teach people like this guy Kennedy. Is he as good?
Well, they weren't really. It wasn't that they had another set of information. He was telling me, he did tell me basically what was going on,
People are
and
going
they
to
were
think
simply
that.
not
And are they
providing
crazy?
information as what they considered a unique situation.
No. That's a perfectly
They just weren't going to tell me what they didn't feel I needed to know.
Does it have an effect on me?
But little did they know that
Yeah,
Kyle
actually,
was
does
basically
have an effect.
cluing you in.
Sure.
He was calling me in, he was
I'm aware
informing me
that
his perspectives concerning
doesn't. I'm not.
something was going on.
Doesn't.
And that is ultimately what they want to know about. And I said, well, for you to know about that kind of thing, I need to know about certain other things. It was a
Probably.
situation, and they said, well,
Probably.
we'll tell you, you tell us. So I told them, and they told me a little more. And it was right around that same time that Lotus was actually kicking into form.
Because I
May
don't
31st,
want
2001 event that took my Mosaic project and basically garbage can and turned into what it is now. This project that it is now.
So,
and as a result, I also found out from them where they said Lotus was ultimately tested. And that is, like I said, we'll discuss that in a slightly future date.
in an earlier time, it was, if it's even,
that was the perspective of the P45
the white
J-Rocks. And that is not my
now
perspective.
under affirmative action,
Because I make a distinction between Kyle,
oftentimes it's the
what I
black
understand
person
of
who's
P52
but
and
I'm
the
still
P45.
in the
So,
situation.
but they're all the same.
They were on the same timeline, the same track, they just separated the 7,000.
So even so,
Just quite a bit separated.
what we got, so what you're saying is
I'll
that
tell you
in a
another
sense,
way in which it comes up.
Kyle couldn't get the benefits of Lotus because
Already asked for it.
Second year law school,
Already asked.
he was in tax.
And I will say
He was a
that
very famous tax.
this is something that David
Very first day.
spoke with David on the phone. I'll leave the last name off. I think you know what.
Professor Kidd.
but we can use his name because it's okay with you.
Well, sure, David Wilcox.
Okay, yeah.
Paul, very first person called on
And
I remember this
was talking, we were discussing the same thing, which was
black
Fox, Q.
and
I
remember
said, the strangest thing happened. I was
felt
pro tempore made NJ9
I felt as if the
as a result of the bet that went on with NJ12.
and I know there was a real
I got a chance to tap who ended up being the last
on me for as long as I am.
And before tapping her, it was the first female I ever set. I got a chance to look at certain documents and look at certain archives in Washington, D.C. prior to going across to the continent and meeting with some folks and telling them basically I wasn't interested in their offers. I'm talking about a trip to Brussels. Yeah. And during the same time, the cube disappeared. And it hasn't been seen since. It disappeared out of the archive. Of course, I have no idea. I have no idea where the item may be, but I do know this. I'm happy that they can't find it. Because what they were doing is they were handing this cube around. This is a question that Bill had asked, whether there was only one cube. They were handing this cube around from country to country to the elitists in the countries to look into their own future so that they could pick the best paths for themselves. Why don't they just live their lives? Try to be good people. Why do they need a little black box to tell them when to jump and how to jump? That's not being fully human, at least from my perspective, and those of our associates. That's not being fully human.
I felt
So, as I understand it, this
some
year,
of
now there
the
have been certain,
burden
allegations that have been made that during the time when I had,
Thank you for showing that we belong.
when I had the bad seizure, it was near the end of last year.
By the way, I wasn't the only one.
It was with the year, and I had a very serious seizure. I was actually put out of commission seriously for a while.
We laughed about it.
And there was a hullabaloo to get over to my apartment to get something out of my apartment.
Some people
What that object was, I won't comment. But I will say this to everybody.
My attitude to
whomever
it's there.
took it,
Again,
it's in safe hands and it won't be used to harm humanity.
But I think that the benefits outweigh the burden.
In fact, the fact that it's in safe hands will benefit used to harm humanity. It has been thus far. Aside from that, well, I mean, I'm kind of trying to justify my own behavior in Bandolier, using it for the purposes of skewing the focus off and inductions off. But I think that was for beneficial cause. But it has been used since actually the 50s by the leaders of the various countries to skew the history.
But of course,
of the human race and the common folk, the African people, all of us, have a right to a future which is our own. Not being skewed and designated and promulgated and promoted and provoked by bloods who feel that they are above everyone else.
What do they say? The white person.
I'm happy to pass along the information. I'm honored to pass along that I understand that the Yellow Book is no longer accessible. That's all I know about it, though.
Didn't get it.
I totally
What
understand.
That may be the reason, too, why the Illuminati has done something to us. May also be the reason further as why the old Magi haven't.
As a consequence of
Maybe why they're all so quiet.
As a consequence of the consequence. And,
Right.
I don't know.
Have the upper hand anymore. Yes.
Are there other
People should have the upper hand.
Yeah, and
They should have the
my
upper hand.
book, I have I go through
That's why we
various.
have gone as far as what we
I
have
think that
SSM 200 report that's put in during
there is
the
a certain sort of denialism
Ford administration, which I
that
believe was written by
accompanies the affirmative
Dr.
action
Kissinger,
debate.
wherein he
So,
suggested
because
possible use of food as a
black
weapon
people like myself
and its use against, in fact, as a tool against the third world. Now, at the same time, we notice that there's a correlation. Find this from
there's some people who
IPCC report concerning global warming, that if the world average temperature rises,
there is no difference between
that the northern hemisphere, the higher latitude
the other. There is no
growth will increase. However, if it goes over
the
that,
action kids got, let's say,
in the lower
500.
latitudes, by the way, that's
The
what
other
most
kids got a
world countries,
750.
the 2 to 3 degree Celsius increase
Yes, they,
will
the
cause
only
starvation and crop loss.
the 550
Now, isn't this funny?
Because
How they're just allowing global warming to increase with the provoking with the use of fossil fuels. I'm not saying that's the total cause. It's not.
well,
There are cycles involved, short as well as long-term cycles. But isn't that funny? And it's my best guess that they'll probably order just enough ameliorative
by the way, if you don't know
steps to be taken. We're well off where the higher latitude or higher latitude probably don't lose their crops, where you find the majority
I
of
think
the
as we see into
Well,
not just
that's actually
various conversations.
fascinating
That can have a slippery slope effect.
observation.
Yeah.
I think that
We see it in various
it
ways.
is
So,
also interesting that most of the crops are in
it's not like I'm holding the, some tests are not good tests.
right, but they have sustainability though.
But there are a lot of tests that
Whereas when you have the loss of crops in the lower latitude.
And
You're also losing a lot of the
some people
populations
who
in the
are
third
really,
world,
dead setting
which unfortunately, according to the way that the documents read, some people find them expendable.
Are there gaps?
I don't feel that way. No, I'm not one that likes to interject myself in politics at all. I like to stay in research. At the same time, when you start hearing that the codex is being placed in place, which actually delimits food value, oh, you can have all the food you want. Starve to death while you're eating. There's no nutrients.
That I catch up.
When I started hearing that food being used as a weapon, and it's being used concerning the use of fossil fuels, I started getting personally angry. There's not one person in the lower latitudes that's worth any less than me.
I guess the colleague of yours, Michael.
Everybody is worth exactly the same thing on this earth. Unfortunately, there are individuals who feel otherwise.
On the flip side of that, we're obsessing with
Okay,
men.
so Bill,
Yes,
the question you're asking, now that we kind of, let's talk about, first of all, you mentioned Will Newhouse.
Son of Bill Newhouse.
Very important
Newhouse.
arguments
We didn't realize that he was actually the son
Yes.
had
I
access to
disagree
that technology.
with
Yes,
some
Bill
of the points that he makes.
was the builder of the avionics testing equipment.
Yes,
Back engineer, the RV testing equipment, the avionics. I actually saw some of the equipment, and this is in the thing that Marcia and I did.
the movement from,
I actually saw some equipment, diagnostic equipment.
the idea of
the V Bay underneath the Galileo Bay. That he actually built.
I don't
So
care
when I started describing it, Will looked at me and said, "Oh, that's what my dad built."
I don't care.
So we had a very nice little connection there. But it's Will who had experience around the
And
looking
then somebody thinks that, yeah,
his son, Bill Newhouse.
what I can do. They show it.
And Will Newhouse is alive now.
I think there's a lot.
So that's very interesting.
And his wife Terry, in
Impulse,
fact,
sentiments
what I
behind
understand,
that.
they met during the course
I
of
resonate with
conversations concerning
what I want to do.
information coming to the public. Terry and Will met one another, fell in love, and were married. That makes me feel kind of personal.
Okay, well, so it sounds like Will knows quite a bit about what makes the ARB run. I think his father has.
Sometimes it was psychological.
Okay, so in
Sometimes
1947, when
it's,
Cube was discovered,
you're not around.
it must have really spurred up the idea of the two timelines by bringing in
The idea
the ability
of,
to, I mean, I don't know what the intent was
people-
First
to,
of all, Cube wasn't actually
The
was not
idea, by the
discovered
way,
in 1947. There's a mixture of the stories involved. The cube was actually the information about the cube that's existence
people
was
who
known
are
as
excellent.
46.
They're
It was
here.
further discussed in 1947 after a certain crash in western or
They're not
southwestern state.
good.
And following which, during the first brokering for treaties by the Orion with Eisenhower,
Yet at the
it
same
was
time,
handed to
maintain a sense
Eisenhower.
that
It was in fact
their
expected
basic work
to
is
go
human
to the
beings.
United Nations
Yeah.
authorities,
So,
and it was in fact spirited away by the United States military. They didn't have
Run DMC, one of the rap
so,
groups,
but you, the way you're talking about the cube is that it
they're
sounds
all
like
written down in the
it
same
connects emotionally
all
with the
written down in the same
viewers.
list.
It does, and the fact that it was handed, it was
I
actually a
recognize our
technology.
fundamentals.
And it was handed
I
over
don't
by
think that I think that one can recognize our fundamentals.
but a misassessment
also
as
recognize,
to
as I'm
our
concerned,
evolutionary
that
state,
we
our
all
ability to handle
collectively should
the
make
issue
sure
and handle the equipment.
that
They felt this
all
more
that
balanced
we can to prevent
than what we actually
sinking
were.
below a certain
This is,
level
I mean,
and
this
being,
this
misery.
opens Pandora's box.
All for
of
that.
United States history.
That is Pandora's box.
I want to be
I'm not exactly
careful
certain what was seen
about
relative to the cube.
some of the attacks that I
However,
hear
the
on
analysis
hypocrisy. So some of the people
I was asked to do.
Yeah,
Of
I
course,
have all
paid
the
the
respect in
price
the
now
world
that I've actually done it.
for Michael
Again, people
Sandel.
don't want to hear the answers that I
Arrogance
but
of the
the analysis that I did indicated that certainly there's
arrogance.
at minimum a great suspicion concerning the delay of response
over the
And
circumstances
information that I had directly
you
from
were lucky
receiving members
that you were born
was in
healthy,
fact that we were
that
aware
you were born
this
with
was
a
looking glass technology,
well-working
not the cube.
mind. You didn't have anything
That we
you got
were
that
aware as of the
some
middle
people you gotta have
1990s
that.
that there would be a coming Islamic extremist
Don't
war
be
with the United
Mr. Big
States.
Stuff.
We were also aware of certain alternative
Well, I'm
situations
just
that they use the statistics in the looking glass and the variability
I
between
taught myself how to
different
read
pictures to show
There's
that
people who
occurring
did all
at the
sorts of
same
things
time,
for you.
probability
You don't even know.
at the same time. And
Okay, so,
from their
I
perspective,
want to get rid of the arrogance.
that the least of the two consequences was
Have
9/11.
some humility. I'm all for that.
I am aware
At
of
the
what the
same
other
time,
possible consequence was.
I
I'm
want to
not
be
willing to
careful
come out
about
and start mentioning it because I don't know what the consequences are. Speaking of the things that haven't been, that have not thus far happened, yet the probabilities exist
I
that
want
they
to be.
could.
I want to be careful about.
So I'm feeling a little bit. There's a little weight when it comes to that.
Let's not
But
have.
Okay, you're saying
Let's
though
not
that
give
the
a trophy
looking glasses have been, as
to
you
the
call it,
person
decommissioned.
who wins
Yes,
the
ma'am.
race.
And that means across the
Because to
Across
give
the
a
board,
trophy to
they are
the
shut
person
down.
who wins
And
the
you
race
said there was
will
50
make the person who
handmade
they
devices.
defeated feel bad.
And I'm
I said at least 50.
that would
No,
access
I want to give a trophy
or
to the
create
person who wins
stargates
the race
that's
because I
out
think it's
of
good
natural vortexes.
Yes.
valor.
And
They would
some
suck them in and make
of
them
the
available.
looking glass and the looking glass is not
Yes.
the same
It's
as
a it's it,
No, the
a
looking
kind of
glass is a back
celebration
engineered form from the
of,
original cylinder seal
human
description
project
of how to build the units that they built Stargate. So in essence, you can take a looking glass unit and make a couple changes to the equipment, lift it up on an
What do
angle,
you learn about life?
put field posts around it, and open up a whole step.
I've been just like
okay, but the looking glass can show you the future. So are we saying
yeah,
Future
I
probabilities,
feel like that's just
okay, so are we
an
saying there were
absolutely
50 looking glasses?
charmed.
Oh no, there were much
And
less.
I live
We had a basic monopoly over the looking glass that and
that I do.
he had brokered early on with his era.
What I
Ira
love
Gandhi was brokering the committee of the majority between the United States and the Soviet Union because the Soviets were threatening to start the
Yeah.
treaties
And it's
up
you know,
with the extraterrestrials, which would have become untenable.
I've
We
been
agreed then to
fortunate
expand
in so many
NJ-12 from a whole
and one way
developed American operation to an international operation. Thus was born the Committee of Majority between 1963 and 1967.
Henry
And
Harold
when
Kennedy, my mother,
that
born in Columbus, South Carolina, my
information
father
was brokered.
from
That happened in parallel with, kind of under the table, but in parallel with United Nations treaties involving things like the Test Ban Treaty and the Outer Space Treaty. And so it was being done at the same time under cover of UN support. The diplomats were going back and forth, brokering the opening up so that the treaty system would be a single treaty system, thus tenable and to hopefully a good outcome. And we'll be knowing the next few years whether that was successful.
Okay, so this is, this is really fascinating. You're saying that some other
very
countries,
interesting man,
any
very
of one, had access to
independent-minded,
looking glasses.
Yes, ma'am. They had that written as far back as the
and
1960s and 70s when it was actually being back engineered from the
I
start.
learned things from him even when I
And so at the same time that Will House, for instance, was looking at the early generation looking glass, India had the same.
Okay, and are you at liberty to say that other
he was
countries have
also
access to that?
To the information or to the equipment.
I respect both my parents. I mean, one of the most important things that happened to my parents was that
At times.
No,
I'd say
no, because that, and I'll tell you why the answer is no.
it's a 10 years.
Within the treaties, the looking glass, as well as the stargates, as well as the cube, and information movement pods, are all contained within the treaty system. Within the treaty system, it also prohibits and allows certain passage of information amongst delegates on
And
where the looking glass material is and where the information flows, where the access is. Being that I stood in bandolier and considered a delicate
white people are not to be trusted, and by and large, you're in. That's
aside from India and the United States.
I'd say that
some countries, perhaps,
I'd say
leadership
that
of some countries
10 years later,
may have had access to this
that
technology.
I think that it's fair to say that we can assume that they had access to the information from it.
Say, well, what happened
But
in
I
10
wouldn't
years?
place any characterization over any assumption.
Certainly in my life, one of the things that happened in those 10 years is
But it also gives you a whole different way of looking at history.
I was
Indeed it does.
very
this stuff is got to be
and I had a series
as natural to you as
teachers. I've had wonderful
getting up in
black
the morning,
teachers.
And having a cup of
I've
coffee.
also had wonderful white.
Now, there's nothing as natural to me as getting up and
And
having
my
a cup of
parents
coffee.
paid attention to who my teachers were and how
And we
much.
should have never built. We should.
And
The start
I
date,
think they
yes.
were affected
Okay, for
by
the
the
purpose
way
speaking with the visitors the
there
other
were
time.
white people
Yes, absolutely. The looking glass, that was
on my
done
side
because of our own shortcomings as people who aspire to
and I
we maybe
think
should have
that
tried to grab a hold
that
of. It should have
experience
never been built.
We're talking about power.
changed my
Yes.
parents. They're
Yes.
they,
And I am an advocate against
but they
this.
were.
In fact, well, I can say against the misuse. I am an advocate against its
The
use.
possibility
Okay,
of
so
a white
let's say that when has
genuinely being
and
the
you're saying
friend
it shows probabilities.
of a
One
black
of the things we were wondering is how does it
that
do
that became a lie.
Best I
And I give
understand
them a lot
was
of credit
built
because they were
a while back,
adults.
a little while ago. The rings and the amount of information
But my parents did.
via
That
energy, which
transformation
is
was
passed into
inspiring to you, was formative to you in terms of
the
joining the
position of
outfit.
the rings, their orientation, the energy running through them, position of the barrel, etc.
I mean, I
Raise the
said
barrel
a
up
moment
on
ago how lucky I've been.
side, etc.
I teach it. I teach it
as if you have an onion, the various layers of the onion.
attended
As you move through the different energy levels, you also move through the different layers. You get different bits of
I
information.
got my
Now
law
imagine an
degree
almost infinite number of layers
I
overlaid
got my undergraduate
in comparison
degree at
to the
Princeton
position of the
University.
rings, the amount and the almost infinite amount of
They
energy
all were
that you
the
can add or
most
subtract.
important.
Tuning it up, tuning it
School
down.
that made the most
Instead of
difference
going up by
my
1 hertz,
education
by 2 hertz,
in high school.
maybe by
St.
1,000 hertz up and down.
And at St. Albans,
almost like a
I
kaleidoscope.
encountered
Right, except yeah, you get a different design in the
And by the
colors
way,
change, but it's
St.
like where
Albans, when I was at St. Albans,
working with multiple kaleidoscopes, where when you find two different probabilities that you would run into,
head of athletics,
you have two
very
kaleidoscopes,
important man, very
and if you make a change on one kaleidoscope,
otherwise,
that may factor or function to a different angular change on another kaleidoscope. So you get two separate pictures that you then have that are flashing
you
down.
know, I can call their names.
Yes,
The
that's the analogy.
greatest of them all was a man by the name
To get these readouts,
Yes.
probabilities.
Yeah, in fact, there's a de-interlacing system which they use to actually
we called him Gentleman
de-interlace
Jack.
the flashing back and forth of the two probabilities
And,
or the multiples that they have at certain
he
times.
taught
They start
me
skipping.
history. He was
Well, what they did is they de-interlaced the video and then reintegrated the video and watched the individual videos. And then determined statistically how much time was spent on each video to determine the amount of probability of each event occurring. And they tested that against probabilities in the field and probabilities of future occurrence to get a system which functions scientifically. And that's
Okay, so, well, I'm going to go with that, and I'm going to actually say what they might have been doing is then looking back to see, in other words, if they saw an event in the looking glass, all they had to do was calibrate or look at the different possibilities, see which one happened, and then
That's what they did. Absolutely. That's right on. That's right on. That is right on the beat. And you know, some people, like I said, some people say it's just smoke and mirrors. Then again, I was told something in 2001 that's I'm living in right now. Okay, without going to what it is. And like I said, we'll talk about that in the future. But you know, it's the best scientific equipment that I can imagine for the determining of such a thing. But it goes to the old question: just because we have the power to do something, and I am a 100% advocate. I had a
with
more than a small dust up out of Frenchman over this very same thing, which actually resulted in me walking alone down Lake back toward Las Vegas.
No, that speaks to the power.
She and I yelling and screaming at each other along the roadside. They were doing tests out at during the time that the Rosen Ridge was being accessed there, the Einstein Rosen Ridge, with the equipment. They had the curtains up and all of that business up for Metro could see from the top of the mountain and all that. And there were access there. There was a mistake and a small explosion out there on the east side of this room, what we call the conquistador helmet. And she wanted me to go out there with her to help clean some of the evidence up of it.
What do you think?
She and I got in a motor of a little dust up because I didn't want anything to do with it. Because I don't believe, I'm no Luddite, I'm not all for grand technology, but I don't believe you can play with things which actually deal with looking into the future. There's another issue that was going on at the time, in fact, the variety of communication which was going on via this equipment from elsewhere. I presume she will still won't admit to me, but I presume that it was from Orion, and it was information, defense-related information on how this type of equipment, how an Einstein Rosen Bridge at a distance could be used to pull information out of a defense computer system. And I don't mean the U.S. defense computer system. I said, you know what? No. Look, we've got the technology here, we've got the talent, we've got the willpower, we've got the willing to defend our own country without the use of something we call big-time technology. I wouldn't want to go up against, for instance, God help us, the Chinese on the ground. But at the same time, I don't fear their country either. I believe that we should be diplomatic with them and have a firm understanding and respect for one another. But I also don't fear them. And so the use of technology like that is not honorable.
right. Well, it's like knowing how the game plays out.
Great
speeches, your advantage ahead of time, and making sure that eventuality is occur.
That's why I was so interested in when I was doing my time with the jobs involving safety and security training here in Las Vegas, when I was interacting with Marcia and the I. Because we were literally on a daily basis talking about that same thing, talking about the psychology of individuals who come to a table, play a game, and who cheat to alter the outcome of the game.
I will associate
and that whole psychology, it's something which I'm not, is not foreign to.
Deep kind of
and so that will prime the wick of the explosion between myself and that variety of technology, which actually primed my disagreement.
That represents
I understand what you're saying, and there's a million questions that all of us
American life.
We don't have all night, but
And
I would like to ask.
I think it's I want to see that.
Now that I know what I know,
yeah, I want to see that. And we'll work to push that project along as far as it'll go.
Well, thank you for sharing the spirit of optimism forward.
No. It shouldn't be used to.
What you've done, and thank you for this conversation. It's a huge honor.
Thank you.
Thank you. Thank you, Anna. Thanks for listening to this conversation with Brandon. Support this podcast. Please check out our sponsors in the description. Now, the many deals for work.
The technology is not being used at all right now.
Darkness cannot drive out darkness. And we let you do that. Hate and I drive out. Only
the
low.
terrain of the
As of about 2017, I would expect probably that all of these little pieces of equipment will probably all get reassembled.
turn back on.
Oh, sure.
2017, that's quite a
2016, 2017.
not
Probably not. I figured that they're probably going to act conservatively on this. That's what all of the people of wisdom have suggested to them, is to act conservatively. That, yes, the so-called cycle of catastrophe, it's a Fulcanelli, the time period from, right around 1992 to right around 2012, right around that area. While we will pass the 2012, it really ought to hit the entire cycle, which is about 1980 to about 2016, to feel confident that the interpretation, the timeline from the future about their own catastrophe is not off by a few years. We're talking about 45,000 years, 50,000 years respectively. We have difficulty understanding what happened in 2000.
Understand the chemical and physical
And we're
conditions
talking about 50,000 years here.
and
So
how from that our
it's
galaxy
very wise for them to wait.
what it is today.
And you mean
The place we live called home.
classes are now
This is the Let's Speak podcast.
Yeah, they're decommissioned and the stargates and the looking glasses. I'm sure they're all in their little mothball containers and all of that. And they have been separated.
Let's go back to the
Components of
early
each have
days.
been separated
What
and moved
formation
to different
of the
power
nuclear
structures,
galaxy.
diplomatic and military
And
authorities on
started
the
to
world.
What is the
We're
formation?
talking about the EU specifically, the UN and NATO. Those are in specific control of one of the three components of each. And I cannot comment as to which component is
What
contained by
elements were present at that time?
you're saying
The Big Bang left in the universe behind that was made of just hydrogen and helium.
There is no doubt whatsoever when it comes to the looking
And
glasses
that was pretty
and
much
when it comes to the Stargate
as
technology,
it
that
turns
it has
out,
been
it's actually
decommissioned.
quite hard to
And
make stars or any structure from that.
There are a
Of
few
gas.
threats going on, ongoing threats
And
from present
so the very
countries,
first stars that
stating
started
that they will put
prior to
it together
the
at their
galaxies
will, do
were
their
very
own
massive
self-determination.
big stars,
And those
100 times the
countries,
mass of the
if
sun. And
push
they
comes
were
to
like
shove,
just
will be
hydrogen
shoved.
helium. So big stuff
Okay, so you
explodes pretty fast.
put it
A
together
few million years
now?
on,
As in build one themselves now.
and
what was
in that
extant
building,
has
they
been collected.
provided the first heavy
I'm
ion
under
of
very
the
good assurance that what was sitting there has now been collected and decommissioned.
lighter elements like hydrogen helium into heavier ones, and then of course all the way up to iron. All that material ejected in these gases, supernova
The very
explosions,
highest
and that marked a
probability
really,
for
really
those
important
That's true. That's true.
transition
And Bill
in the
was
universe, because after that
the
first
future date
explosion,
thing,
it was no
and a
longer
year was
chemically
given to
pristine,
me.
and
And
that set the
he
stage
was saying, well, the
everything
years
else
we
that
provided for
happened,
that,
including us
why
still
wouldn't
talking
the years
today.
provide for the other? Well, there was a highest probability
whole
year for it.
complex
However,
elements now.
telling me about something that might happen in the future
Yeah,
involving
so after the Big Bang, just hydrogen and helium,
is
we
one
don't
matter.
really need to talk too much about lithium because
Willy
the amount
nilly
is so
throwing
small.
the data, which is a
And
probability
after these
involving
first
the
stars
lives and
formed and
destiny
exploded,
of all
they
of us here on the
objected
earth,
heavy elements like
specifically to a
carbon,
predicted
oxygen,
4.5
magnesium, iron,
billion people
all of
dead.
that stuff was suddenly present
That
in the
carries
gas
an entire
clouds.
different weight with it.
A tiny amount
you
only,
assume that
very
we
tiny
passed
amount.
that year yet?
But that actually helps
You're not,
the carbon and the oxygen
no, you're not going to assume.
to make the gas
Okay, so
cool.
we're still,
These
that's still
atoms are
talking.
more
What we're
complicated than
looking at
hydrogen.
is a
That's
very
just a
low
proton, and so
probability
it has cooling properties
Yes.
to send out photons
set of
outside of the gas cloud.
Yes.
So the
Yes.
gas can cool,
Yes.
and then you
We're
have
looking, we're
gas
looking
that
at a low
gets colder and colder.
probability
You
of
can
the
make
higher
small
catastrophic
stars,
portion.
fragmented
I
quantum,
expect that
turning
the
it into
events
stars,
would
like
be
the sun.
kicking off. We're still
And the
gonna
cool
have,
thing about
for
that
instance,
is
the
that when you have small
solar
stars like
maps
the
were
sun, you have
discovered
really
around
long
2012,
lifespan.
and the
So those first lunar stars that formed back then, still
is
observable
out there as
today.
part of
That is actually what I do. I try to find these early survivors because they tell us what the gas looks like back then. They have preserved that composition of these three gas, the chemical composition.
Yes.
Until
That
today.
would be
So I don't need to look very far into the universe to study all the beginnings. I can just chemically analyze the oldest stars,
Okay, well
and it's like unpacking everything that happened back then. It's very exciting.
So
because
to
people will then target
the
for
very
a
early
date.
version, 50 million years.
You know, there are people out there
Giant
now that
stars.
say, oh, you know,
It's
right
mostly
around the
hydrogen
corner,
from when they
at any moment now,
explosions, and then they create major
why won't the
clumps.
aliens save us?
Yeah, so
We need to save ourselves. And that's why the steps
yeah,
taken
pretty much.
have
So it
been
took a
taken
few
in the world
hundred
and
million
are
years
still
for
underway
and then they
so that we
exploded
will
after
save
2 million
ourselves.
years.
Reaching
And
out the
then it's
milestone
like,
today.
I always
1,000 years
consider
in 2 days.
universe
I
like
couldn't
a,
believe
a
it.
nice
So things
soup,
usually like
and
there's
then
still a long way to go.
first
That's not
supernova
taking place.
explosions kind of
Please help me
provide
in my
the
efforts to
salt.
get this information
Just
out.
a little
Share this with
sprinkle
anyone who
has
might
the
let me
enemies,
and
and
leave
that
a subscription if you haven't. With all this fake name total disclosure, all we need to do is to
and that
actively show
changes the
interest.
physics
So
of the
press
game.
all the buttons and
So
all the
that means
channels
that
about this topic so we
you've got
finally get to say hi to our cosmic neighbors.
surrounding
If we
you.
could just
So
open
the
this
former
Pandora's box
person,
once and make
they
the
could now
government
cool
you can
down
literally
and
see
form
your own
the
life
next
TV today
generation of
yourself.
stars.
I appreciate
That now
any help.
include
See you
also
next
little
time.
stars. And as I just mentioned, the small stars have these really long lifetimes. The sun has a lifetime of 10 billion years. Any star that is even less massive will have an even longer lifetime. So that gives us a chance to still observe some of the stars that formed back then. So we are testing the conditions, the chemical and physical conditions of the early universe even before the galaxy formed.
So what's the timeline that we're talking about? What is the age of the universe, and what is the earliest time that those salty, delicious soup, clump soups with heavy elements?
Well, the universe is 13.8 billion years old.
And what is the I said so. Okay, 13
Well,
billion.
when I was in high school, the universe was 20 billion years old.
Oh, yeah. So the estimate. Do you think that estimate will evolve in interesting ways, or no? Is
I
it
think
pretty
we
stable?
have mostly converged, yes, because the techniques are being just now much more precise. The whole business of precision cosmology by mapping out the cosmic microwave background, that's the marvelous feat. Maybe, the digits will still move around a little bit, but that's all right.
Plus the gravitational waves and all that, so all the different sources of data kind of mapping out this detailed picture of the early universe. Yeah.
Totally. And so we think the earliest little stars formed, I don't know, maybe 500 million years after the Big Bang, right? Again, a few 100 million years for the first stars to emerge, and then it took some time. So give or take 500 million years. And that was the time when sort of the very first proto-galaxies formed, early stellar structures, stellar systems, from which the Milky Way eventually formed, right? So the Milky Way was probably a slightly bigger one, and we know today that galaxies grow hierarchically, which means they eat their smaller neighbors. So if you're the bigger one, if you have a few friends around, you're just gonna eat them, absorb them, and then you grow bigger. And so all these little early stars kind of came into the Milky Way through that kind of process, and that's why we find them in the outer parts of the galaxy today, because they're just kind of just left there since.
So the old stuff is on the outskirts of the galaxy, and the new stuff is in closer to the middle. Is it?
Broadly speaking, yeah.
So that's where you would look for. But maybe just to step back, what is a galaxy? What is a proto galaxy?
I love that question. So the galaxy is a huge assembly of stars. The Milky Way contains something like 200 to 400 billion stars, and most of the material and the stars are in the disk. And when we look at the night sky, what we see as the Milky Way bands on the sky, that is actually the next inner spiral arm, because we actually live in a spiral disk galaxy, so looking at the spiral disk galaxy, and we're looking, actually it depends a little bit, in the northern hemisphere, we're looking out of the galaxy. So we're seeing the next outer spiral arm. And as you can imagine, there's only dark space behind that. So We don't see it all that nice in the sky, but if you travel to the southern hemisphere, let's say South America, you see the Milky Way, and it looks so different on the sky because that's the next inner spiral arm, and that's actually by the galactic center. The galactic center is a very big, puffy, region of gas. There's a lot of star formation. The galactic party is happening there, so it's very bright. It makes for this very beautiful Milky Way in the night sky that you see. So actually, if you ever get the chance to experience that, I encourage you to almost like you close your eyes while seeing this and imagining that you're sitting in this kind of disc, in this pancake, and you're just kind of looking right into it, and you can really feel that you're in this 2D disc, and then you can imagine that there's the top and the bottom, and that's every really part of the galaxy. You can really experience that. So we're just not just lost in space somewhere, but we're really a part of it. And knowing a little bit about the structure of the nucleus is really hard.
You feel small, things like that. When you look on the spiral on the inside and the Milky Way and the outside, how are we supposed to feel?
I don't know. I don't feel small necessarily. I feel in awe and I feel in a part of it because I can really feel that I'm a part of it. I think for many people they think like, oh, that's just the planet and then there's nothing. And that's almost a little bit sad, but that's really not the case, right? Because there's so much more, and I really like to imagine how I'm sitting in this big galactic merry-go-round, and we're going around the center, and I can see the center above me, right? And I can almost feel like we're going there. Of course, you can't really feel that, but the sun does circle the galactic center.
But there's a kind of sadness to go through pictures of a nice vacation place. All we get is that light, cold light. Do you feel like it's sad that we don't get to travel, or you and I will not get to travel there, or maybe humans will never get to travel there?
Yeah, I always wanted to travel into space and see the Earth and other things from up there. They're certainly valid. But I don't know. It's also okay to just be at our vantage point and see it from here.
With the sensors, with the telescopes that we have, explore the possibilities.
Yeah.
I mean, there is a kind of wonder to the mystery of it all. What's out there? What interesting things that we can't possibly imagine? There could be all kinds of life forms, bacteria, all this kind of stuff. I tend to believe that, with the rest of the day, I tend to believe there's just a lot of very primitive organisms just spread out throughout. They build their little things like bacteria type organisms. And just to think what kind of worlds there are. Because they're probably really creative with organisms. Because the conditions, I guess the question I'm wondering to myself when I look out there to the stars, how different are the conditions on the different planets that orbit those stars?
It will definitely be very different. I mean, the variety out there is huge. We know now that I think about every other star has at least one planet. I already mentioned the number of stars in the galaxy. At least it's a huge number of planets out there. So who knows what that looks like? All we know is that there is a lot of variety. We don't quite yet understand what drives that, what governs that, why that is the case. Why is it not all one size fits all?
Maybe the dynamics of planet formation, like exoplanet formation, or star formation, the whole thing.
All of it. Star formation remains a much researched topic. We definitely know that it works because all the stars are there. Same for the planets, but the details are so varied per gas cloud, right? It's very hard to come up with very detailed prescriptions. Broadly, we have figured it out. You need a gas cloud, you need to cool it, something clumps and fragments, and somehow it makes a star with planets or without.
But the dynamics of the clumping process is not fully understood.
No, and the local conditions are so varied, right? I mean, it's the same with all people look like people, but individually we look very different.
So even the subtle diversity of the formation process creates all kinds of fun
Yes, so we just don't know how this turned out in an individual case, and it's kind of hard to figure it all out and to take a look. Certainly with planets, right? The chance to ever actually take a picture of a planet is minuscule because they don't shine, so they're really dark.
Yeah.
So I say there's a lot of possibility out there, but we have to be a little bit more patient.
Or come up with technologies where patience becomes less necessary by extending our lifetimes or increasing the speed of space travel, all this kind of stuff. Humans are pretty intelligent. They're pretty
Sometimes, yeah.
for the most part. I hope. I'm not optimistic days. Well, maybe it's the wind around what a galaxy is. What you know about our understanding of black holes and the formation, because that's an important thing to understand the formation of a galaxy. Like, so all the orbiting, all the spiraling that's going on, how important is that to understand?
All of the above. That's what makes astronomy really hard, but also really interesting, right? No day is like another because we always find something new. I want to come back to the idea of the proto-galaxy because it actually matches or relates to the black hole formation. So most pretty much all large galaxies have a supermassive black hole in the center, and we don't actually we don't really know where they come from. Again, we know that they're there, but how do we get there? So we go back to the early universe, right? We had a little galaxy that just sort of, I don't know, had some small number of stars. It was the first gravitationally bound structure that was held together by dark matter because dark matter actually kind of was structured up, first before the luminous matter could, because that's what dark matter kind of does. And it started to hold gas and stars sort of together in these first very shallow, what we call potential wells, so these gravitationally bound systems. And then the Milky Way grew from absorbing neighboring even smaller systems. And somewhere in that process, there must have been a seed for one of these supermassive black holes, and I'm not actually sure that it's clear right now kind of what was there first, the supermassive black hole or the galaxy. So lots of people are trying to study that, and of course the black hole wasn't as massive back then as it is these days. But it's a big area of research, and the new James Webb JWST, the telescope, the infrared telescope in space, is working on. Many people are working on that to figure out exactly what happened, and there's some surprising results that we really don't understand right now. So
To solve the chicken or the egg problem of do you need a supermassive black hole to form a galaxy, or does the galaxy naturally create the supermassive black hole?
Yeah. I mean, I think to some degree we can answer that because there are lots of little dwarf galaxies out there. The Milky Way remains surrounded by many dozens of small dwarf galaxies. I have studied a bunch of them, and to the extent that we can tell, they do not contain black holes. So there certainly were gravitationally bound structures. So either you can call them proto-galaxies or dwarf galaxies or first galaxies. They were definitely there. But there must have been bigger things, like the proto-Milky Way, where something was different, right? Would make them more massive so that, they would gravitationally attract these smaller systems to integrate them. So we'll have to see.
How do we look into that, into the dynamics of the formation and the evolution of the proto galaxies? Is it possible? Do they shine? I mean, what are the set of data that we can possibly look at? So we got gravitational waves, which is really insane that we can even detect.
Yeah.
There's light. What else can we?
So that would fall into the category of observational cosmology, and the JWST is the prime telescope right now and it promises big steps forward. This is in its early days because it's only been online like a year or so. But that collects the infrared light from the farthest like literally proto galaxies, earliest galaxies. That light has traveled some 13 billion years to us, and they're observing these faint little blobs. And folks are trying to again study the onset of these early supermassive black holes, how they shape galaxies. So they're seeing that they were there, surrounded by already bigger galaxies. Ideally, I'd like for my colleagues to push a little bit further. Hopefully that will eventually happen.
In terms of looking towards older and older.
Yeah, and more and more sort of primitive in terms of the structure. But of course, as you can imagine, if you make your system smaller and smaller, it becomes dimmer and dimmer, and it's further and further away. So we're reaching the end of the line from a technical perspective pretty quickly.
But it's dimmer and dimmer means older and older.
Yes, in a sense, because it all started really small. Right?
Is it smaller
Yeah.
story is to
In,
older and older.
in that phase of the universe, it would. Otherwise, it doesn't. Yeah.
Just to take a small tangent about black holes, and because you do quite a bit of observational cosmology and maybe experimental astrophysics. What's the difference to you between theoretical physics and experimental? So there's a lot of really interesting explorations about paradoxes around black holes and all this kind of stuff, about black holes destroying information. Do those worlds intermix to you? Especially when you step away from your work and try to think about the mystery of it.
Well, at first glance, there isn't actually much crosstalk. Personally, I mostly observe stars, so I don't usually actually think too much of black holes.
Stars is a fundamental kind of chemical physical phenomenon.
That's right. The physics is kind of different. It's not extreme. You could consider nuclear fusion sort of be perhaps extreme. You need to tunnel. There's some interesting physics there,
Yes.
but it's a different flavor. I don't do these kinds of calculations myself either. I very much like to talk with my theory colleagues about these things, though, because I find there's always an interesting intersection, and often it's just I've written a number of papers with colleagues who do like simulations about galaxies, and so they're not quite as far removed as let's say the black hole pen and paper folks, but even in those cases we had the same interest in the same topic, but it was almost like we're speaking two different languages, and we weren't even that far removed, both astronomers and all. And it was really interesting just to take the time and really try to talk to each other. And it's amazing how hard that is. Even among scientists, we already have trouble talking to each other. Imagine how hard it is to talk to non-scientists and other people to try, we're all interested in the same things as humans at the end of the day, right? But everyone has sort of a different angle about it and different questions and way of formulating things, and sometimes it really takes a while to converge and to get to the common ground. But if you take the time, it's so interesting to participate in that process, and it feels so good in the end. Yes, we tackled this together, right? We overcame our differences, not so much in opinion, but just in expressing ourselves about this and how we go about solving a problem. And these were some of my most successful papers, and I certainly enjoyed them the most.
It could also lead to big discoveries. There's I think you put it really well in saying that we're all kind of studying the same kind of mysteries and problems. And I see this in the space of artificial intelligence. If you have a community, maybe it seems very far away, artificial intelligence and neuroscience. You would think that they're studying very different things. But one is trying to engineer intelligence, and in so doing, try to understand intelligence. And the other is trying to understand intelligence and cognition in the human mind. And they're just doing it from a different set of data, different set of backgrounds, and the researchers that do that kind of work. And probably the same is true in observational cosmology and simulation. So it's like a fundamentally different approach to understanding the universe. Let me use for simulation, let me use the things I know to create a bunch of parameters and create just play with it.
play with the universe, play God, create a bunch of universes and see in a way that matches experimental data. It's a fun. It's like playing Sims, but at the cosmic level.
Yes.
So, but and that probably just has terminology used there is very different, and maybe you're allowed to break the rules a little bit more. It's kind of, yeah, like the Drake version. Yeah, you don't really know. You kind of come up with a bunch of values here and there, and just see how it evolves, and from that kind of intuit the different possibilities, the dynamics of the evolution of a galaxy, for example. Yeah, but it's cool to play between those two. 'Cause it seems like we understand so little about our cosmos, so it's good to play.
Yeah, it's like a big sandbox, right? And everyone kind of has their little corner, they do things, but we're all in the same sandbox together at the end of the day.
But in that sandbox does have super powerful, and super expensive telescopes. That everybody's also, all the children are fighting for the resources to make sure they ask the right questions using that big cool tool. Well, can we actually step back on the big field of stellar archaeology? What is this process? Can you just speak to it again? You've been speaking to it, but what is this process of archaeology in the cosmos?
Yeah, it's really fascinating. So I mentioned the lesser the mass of the star, the longer it lives. And again, for reference, for the next dinner party, the sun's lifetime is 10 billion years. So if you have a star that's 0.6 or 0.8 solar masses, then its lifetime is going to be 15 to 20 billion years. And that's an important range for our conversation because, again, if you assume that such a small star formed soon after the Big Bang, then it is still observable today. You mentioned old light before. Yeah, that light is like a few thousand years old, but compared to the age of these stars, it's nothing. So to me, that's young. Comes straight from a galaxy of, not far. These stars are not far away. They're in a galaxy in the outskirts. They probably did not form in the galaxy because, again, hierarchical assembly of a Milky Way meant exactly they formed in a little other galaxy in the vicinity, and at some point the Milky Way ate that, which would absorb all the stars, including these little old stars that are now on the outskirts of the Milky Way that I used to point my telescope to. So, what can we learn from these stars? Why should we study them? Now, these little stars are really, really efficient with their energy consumption. They're still burning, so the experts just burning hydrogen to helium in their cores, and they have done so for the past 12, 13 billion years, however old they are. And they're going to keep doing that for another few billion years, same as the sun. The sun also just does hydrogen to helium burning and will continue that for a while, which means the outer parts of the star, well, pretty much actually most of the star, that gas doesn't talk to the core. So whatever composition that star has, in its outer layers, is exactly the same as the gas composition from which the star formed, which means it has perfectly preserved that information from way back then all the way to today and going forward. So I'm a stellar archaeologist because I don't dig in the dirt to find remnants of past civilizations and whatnot. I dig for the stars or the old stars in the sky because they have preserved that information from the first billion years in their outer stellar atmosphere, which is what I'm observing with telescopes. So I'm getting the best look at the chemical composition early on that you could possibly wish for.
What kind of age are we talking about here? Are we talking about something that's close to that, like a 13 billion, 12, 13 billion age range?
That's what we think. Now, there's a small caveat here. We cannot accurately date these stars, but we use a trick to say, these stars must have formed as some of the earliest generations of stars, because we need to talk about chemical evolution of the universe and the Milky Way for a second. So already mentioned the pristineness of the universe after the Big Bang, right? Just hydrogen and helium. Then the first stars formed, they produced a sprinkle of heavier elements up to iron. Then the next generation of stars formed. That included, again, massive stars that they would explode again, but also the little ones that keep on living, right? So, and then the massive ones, again, explode as supernovas, so they provide, again, another sprinkle of heavier elements. And so over time, all the elements in the periodic table have been built up. There have been other processes, for example, neutron star mergers and other exotic supernovae that have provided elements heavier than iron, all the way up to uranium. Very early on, we're still trying to figure out those details, but I always say pretty much all the elements were done from like day 3.
So iron is where, like, once you get to iron, you got all this money.
Um, yes, I know. I really like the heavier elements, you know, gold, silver, platinum, that kind of stuff.
For some reasons, or for star formation.
Well,
I mean, like, what's the importance of these heavier metals in the evolution of the stars?
so they are the spice of life, right? So every supernova gives you elements up to iron. That's cool, but at some point it gets a little bit boring because that always works. But that's the baseline. We need that. And that's certainly what came out of the first stars, and then all the other supernova explosions that followed with every generation. And it took about 1,000 generations, give us, until the sun was made. So the sun formed from a gas cloud that was enriched by roughly 1,000 generations of supernova explosions, and that's why the sun has its the chemical composition that it has, including, and some of the planets were made in that as well.
So the supernova explosions for many generations are creating more and more complex elements.
No, it just goes all the way up to iron, and then it's a little bit more of all of these elements. It's one sprinkle then another, and it just adds up, right? Now the heavy elements form in very different ways. They are not fusion made. They are made typically through neutron capture processes, but for that you need seed nuclei, ideally iron or carbon or something. So the supernova made elements are a very good seed nuclei for other processes that then creates heavy elements. And because they cannot be made everywhere, so some of my stars have huge amounts of these heavy elements in them, and they tell us in much more detail something really interesting happened somewhere.
Well, wait, I thought the really old ones we would not have. So what does that mean if the old?
Yes, important clarification. So the stars that we are observing today, these old ones, they form from the gas. And the question is, what enriched that gas? So it could have been just a first star dumping their elements into that gas all the way up to iron. And we have found some stars that we think are second generation stars. So they form from gas enriched by just one first star. Then we find other old stars that have a much more complicated heavy element signature. And that means, okay, they're probably formed in a gas cloud that had a few things going on, such as maybe a first star, maybe another more normal supernova, maybe some kind of special process like a neutron star merger that would make heavy elements. And so they created a local chemical signature of which the next generation star then formed. And that is what we're observing today. So all these old stars basically carry the signature from all these progenitor events. And it's our job then to unravel, okay, which processes and which events and how many, may have occurred in these individuals that is actually exactly that signature that we observed in the years later.
Is it possible to figure out what the number of generations that was all to do this in the stars?
Well, we think we can sort of say, okay, this was like second generation or third, because the amount of heavy elements in the stars that we observe is so tiny. One normal supernova explosion is actually already basically too much. It would give us too much of it. And the thing is, you can never take away things in the universe. You can only add. There's no cosmic vacuum cleanup going around sucking things away. Black holes are probably the closest to that, but they would have taken the whole star. They would have taken stuff out of the gas, so we have maybe 10 stars or so now where we're saying that they contain so little of these heavy elements that there must be second generation. How else do we need them? And again, I want to stress that the elements that we observe in these stars were not made by the stars themselves. That's just a reflection of the gas star. So we don't actually, I had to say that because I love stars. We don't, at the end of the day, we don't really care for the stars that we're observing. We care for the story that they're telling us.
Yeah, so the stars are kind of a small mirror into the early universe.
Yeah.
And so, what are you detecting about the stars? Can you tell me about the process of archaeology here? Like, what kind of data can you possibly get to tell the story about these heavy elements of the stars?
Yeah, it depends really on what stars you find. There are many different chemical signatures. We actually pair up these days our element signatures with also kinematic information, how the star moves throughout the galaxy. That actually gives us clues as to where the star might have come from. Because again, all these old stars are in the galaxy, but they are not of the galaxy. That's a small but important distinction. So they all came from somewhere else.
So you can rewind back in time, kind of estimate where it came from.
Yeah, so we can't really say, oh, it came from that galaxy. But interestingly enough, so I just a few days ago, I submitted a paper with 3 women undergrads. It was so good to work together, and we found a sample of stars that have very, very low abundances in strontium and barium, so very heavy elements. And I had a hunch for a while that these stars would probably be some of the oldest, because, as I said, heavy elements give you extra information about special events. And again, finding something that's really low means that must have happened either really early on or in a very special environment, right? Because we can only ever add. So if you find something that's incredibly low in terms of the abundance, maybe just one event contributed to that mass. So we looked at the kinematics, how are these stars moving? And they're all going the wrong way in the galaxy. How is that possible? Well, it is possible because consider, now we come back to the protogalaxy. The protogalaxy was like a beehive. It just didn't really know what it was or what it wanted to become when it grew up. So, and it was absorbing all these little galaxies to grow fast. Some galaxies, some absorbed galaxies, were thrown in going the main way, and some came in the wrong way. Happened. But this could only happen early on when, this wasn't left and right and up and down, so stuff would come in from all ways. So now, 13 billion years later, we're looking. Yeah, they're still doing it. And B, we just look for stars that have low strontium and barium abundances. And then we look at the kinematics, and lo and behold, they're all at hundreds of kilometers per second going the wrong way. Dude, you must have come really early on from somewhere else. So we call this retrograde motion. That's a clear sign of accretion, so something that has come into the galaxy. And because they're so fast, and it is really all of them, that must have happened really long. You can't throw your nuts into the Milky Way and now the wrong way. It's actually turn around.
Can you actually just a small tangent speak to the 3 women undergrads? It's pretty cool that you were able to use a hunch to find this really cool star. Yeah, what's the process of like, especially with another brand? Very interesting.
Yes, it was a wonderful little collaboration that actually emerged in the fall. Um, I I really like working with undergrads and grad students, postdocs, and I came up with a new concept for a class at MIT where I wanted to integrate the research process into the classroom because sometimes people find it really hard to call, email a professor, hey, I'm this grad person and I'm researching your research, could I possibly, come? And I wanted to streamline that and give it was a trial how it would work, provided as sort of the safe confines of the classroom where you just sign up and do research in a very structured way. And I developed it. It was a lot of work, a little bit more than I thought, to map out an entire research project basically from scratch in 10 worksheets so that they could do it again in a very structured and organized fashion.
Created this whole framework.
Yeah, the whole thing. But the problem was, you come sign up for my class, in teams of two, each get the old star that has not been analyzed before. I don't know what the solution is, because in research, you don't look at the solution at the end of the book. You do not know what you're going to find. Our job is to do the work and then to interpret the numbers, because our job as scientists is finding stories. Anyone can crunch numbers. Anyone. It's complicated sometimes, but it's doable, right? But coming up with a story, we only have 3 puzzle pieces. What does a puzzle look like? That you have to be a little bit bold. You need to have some experience, and you need to kind of see the universe and through you just need to kind of go for it. And that's the beautiful thing. I really love that.
And so this was a story of weird kinematics going the wrong way, combined with this particular weird signature in terms of the elements.
Exactly. Yes. And so the story of that ethos now, usually I don't say I find the oldest stars. When I talk to my research colleagues, I talk to them about we find the chemically most pristine stars, because that's actually what we measure, the chemical abundance that tells us, okay, it must have been second or third or fifth generation of stars, right? But these low starting stars that go the wrong way, like they get a key for it, they must be the oldest stars that came into the galaxy, because they formed before the galaxy was the Milky Way, right? And it's so cool, and it was so wonderful. So this class, it went so well in the fall. I had 9 people sign up. That's not unusual for a class, special class at MIT, so small number. There was 8 women, and they were so into it that I said, okay, let's use this opportunity. You're going to do some extra work with me, and we're going to publish. Yeah.
I also like that you're using the terminology chemically more pristine. When I'm talking to younger people, I just say I'm chemically pristine. And that descriptive age. So there's this term of metal core stars. So most of these old stars are multi-metal.
Yes, I searched for the most metal core stuff.
So what's that?
Yeah, what does it mean? I don't know who came up with this. I would love to know, but the universe is a complicated case. So many decades ago, someone clever came up with the idea to say, let's simplify things a little bit. Let's call hydrogen X, helium Y, and all the other elements combined metals Z. When I give public talks, I always ask them, let's say chemists in the audience. Let me just tell you, neon is a wonderful metal. I'm like, oh my God, what thing? I'm an astronomer, I'm a chemist. So if you just roll with it, all the elements except hydrogen and helium are called metals. Now, if we look beyond at chemical or concept of chemical evolution, it means more and more of all the elements, everything as hydrogen and hydrogen gets produced slowly but surely by different types of source agents. So that's a monotonous increasing function. And so we look for the stars that have the least amount of heavy elements in them, because that means we're going further and further back in this process, in that function, almost all the way to the very beginning, and that is the first star. So they started that process. That's why I said it was such an important transition phase, because it, things were, we call it, the post-Big Bang universe prestige, which is hydrogen and helium, and after that the mess started. As soon as you add elements to it, things kind of get a little out of hand. That adds into this beautiful variety that we have everywhere these days.
And you're looking at the very early days of introduction.
Yeah, exactly. When it was still a little bit more organizable. But the variety of different types of metal per stars we have is large. Many different types of stars, many patterns we have sort of identified, but there are still crazy ones out there that we're still trying to kind of fit in.
So what kind of stars have you discovered? So you've already a while ago helped discover the star AG 1327, 2326. Great name.
Yes.
And AG 1523, 0901. What can you say about these stars and others?
My baby stars.
What do you call it? What do you call it? Your baby stars?
Well, I'm probably the only one who can, spit out these names without cheating.
Are there nicknames? Are there nicknames?
Oh no, that's
It's not allowed. Okay.
Well, some colleagues at conferences have just called them Anna stuff, Google stuff, because they didn't want to learn the phone number. I get it. These numbers are actually based on older sets of coordinates of these stars. So the minus in the middle means that they're in the southern hemisphere. The negative is in the southern hemisphere, positive is under the weather. And then 13 and 15 means they're sort of observable in the middle of the year.
Okay, so it's to do with the observation.
Yes. But we have very different stars. All absolutely significant career finding actually for me, but really push the envelope in very different ways. So AG1327, the first one that you mentioned, that was the second generation star that we found. And usually people say like, oh, the first one is the big one and the rest is nobody cares. But to us, it proves that yes, we can do it. Because one, astronomers live in a sort of way of, there are a lot of serendipitous discoveries, and that's really great. But we need to show that we can really do it. Because then we're onto something. It's not just some kind of weird quirk. And there are a lot of quirks in the universe. But we want to know, is that a real thing? Does that happen regularly? Is there something that we can learn? Is that a piece of the story? And so finding the second one that was even a little bit more extreme than the first one really showed, yes, our search techniques work. We can find stars. They provide an important part to the story in the sense that if we had more than 2 stars, and by now we have about 10 stars, what do they tell us about the nature of the very first stars? And what we found, again, working with the theorists, of course, who run these supernova models, is that, so actually let me before I get into this, these 2 stars have huge amounts of carbon relative to iron. So we usually use iron as a reference element for what we call the metallicity, so the overall metal content, the overall amount of heavy elements in it.
So that's why it's called iron deficient.
That's right. So these stars are incredibly iron deficient, which means they must be of the second generation, because there was, and interestingly enough, there was this discrepancy. Enormous supernovae until then we thought would get us so much iron, you would distribute that in the gas cloud, and then you would form this little star that we're observing. But the iron levels that we measured was actually much lower. And I already mentioned, you can't take things away. That must mean these pretty massive populations, maybe first stars, they must have exploded in a different way than we thought. they can't output as much iron because they just can't. Otherwise, it would match our observation. And so that's when we started to work with several theory groups on the supernova yields. So what comes out of
From the explosion of the supernova, supernova yields. And so this one is like yielding higher.
well, we needed to concoct a theoretical supernova that made less. And it's actually surprisingly difficult. Because you can always add more in the universe, right? Step away. So Japanese colleagues kind of came up with the idea of a fainter supernova. It just doesn't have enough, it's not pulse, when it explodes. So somehow there's less iron. But at the same time, then these stars showed huge overabundance of carbon, 1,000 times more carbon. So how do you now get 1,000 times more carbon out of these four first supernovas? That was the theoretical challenge. And because we didn't have just one star, but two, that really spurred the field to think about what was the nature of the first stars? How did they explode? What are the implications? Because if they're not as luminous and bright and energetic, that has consequences for these early proto-galaxies in which, they must have been located in terms of, blowing the gas and disrupting the system. So much higher chance for the earlier system to stay intact for long, right? So there's a whole tail of consequences, and this is what I mean with you need to find a story because you one thing and it's like the dominoes, the consequences everywhere, and then you have a different universe.
What could possibly be a good explanation for something that yields a lot of carbon and doesn't yield a lot of iron?
Well, it's not so much an explanation, more like finding the mechanism for what happens in supernovae, and the official term, what was as I said, cooked up in order to explain the observation. And we have, by the way, found a whole bunch more of these stuff, so that holds. And it's called a fallback mechanism. So actually, in the supernova, during the supernova explosion, a massive black hole emerges, and so some of the material falls back onto the black hole. So here is a vacuum cleaner now dropped into the middle, right?
Like a temporary one that just cleans up some.
Well, sort of, right? Because if you think of we haven't talked about this yet, but if you know what a star looks like, a massive star looks like in its interior before it explodes, you have hydrogen and helium still on the outskirts, and then you have heavier layers of heavier and heavier elements all the way up to iron. So you have an iron core in the center. And because you can't get any energy out of iron when you want to fuse to iron atoms anymore, right? That's when the supernova explodes. So what occurs really? It's actually an implosion first, and then you have a bounce of the sort of neutron star phase that occurs in the process, and then
so awesome.
Get disrupted. Yeah, it's like this giant, basketball, and then whoa, it all goes up.
Explosion first, explosion.
Yeah, and so in the process, right, if you make your black hole basically big enough, it will suck away some of the iron because that's the closest in terms of the layers. You hold on to it. You don't let it escape. And carbon is not spewed out. You let it all go. And so
that explains why you can have a big room and not much iron.
Yeah. Yeah.
True. So is this explained HE 1327?
Correct.
And others like it.
Yeah. So it's well established now that the lower the iron abundance of the stars are, the higher the carbon sort of gets. And carbon is such an interesting element in that regard. If we come back to the formation of the first low mass stars, right? So we had a hotter gas, just hydrogen and helium, that made the first stars. They were 100 solar masses or so because the gas couldn't cool enough. So they were big and puffy. Carbon then, coming from the first stars, probably led to enough cooling in these gas clouds that enabled the formation of the first low mass stars. So think about what happens if there wouldn't have been any carbon, or the properties of the carbon atom would be different. It would not have cooled the gas in such significant ways, perhaps. There wouldn't be any low mass. we wouldn't be here today, right? And we're carbon based, and so I think carbon is really the most important element in the universe for a variety of reasons because it just enables this whole evolution that we're now observing and literally seeing in stuff. It's really fascinating.
So combined with the fact that we have the iron deficient, so all of that is probably important creating humans.
Yeah, we need all the elements, but if you don't have stars, like the sun, small stars that can actually host planets, that have long lifetimes, you need long lifetimes if you want to have a stable planet and develop humans.
So carbon is kind of important in many ways.
Yeah.
This is perhaps a interesting tangent. If I could just mention that you interviewed Mildred Dresselhaus, Carbon Queen, the remarkable life of the nanoscience pioneer. Is there something you can say about the magic of carbon and the magic of Millie?
Well, Millie was certainly magic. She was a professor at MIT for many decades. I met her a number of times. Her photograph, actually a young and an older Millie, is still on the wall every time I step out of the elevator in one of the buildings I see it. She pioneered all sorts of carbon nanowork. So she was a material scientist, very far removed from what I do on a daily basis. But yes, carbon has amazing properties when you study it. And again, that's indeed another aspect of why carbon is so fascinating. Not just in the cosmos, but also for us, making us, creating us in a way that we can use it. It's wonderful.
Sometimes think about this chemical evolution in this big philosophical way that we're the results of that chemical evolution. Like we're made of this thing. We're made of carbon. Yeah, and it came. I mean, it's almost like a cliche statement, but it's also a material, it's a chemical physics statement. We came from hydrogen and helium. And somehow this formation has created this interesting complexity of soup that made us. What are we supposed to make of it? Like what? Did we just get really lucky? Why do we get all this cool stuff?
Yeah, that's a good question.
I don't think it's a question as an answer. I keep just asking why.
Yeah.
But it's just this incredible mystery. So much cool stuff had to happen. Hot stuff had to happen.
Well, right. And so much could have gone wrong, and there would have been another outcome. And it's actually amazing how many things kind of fell in place. I mean, maybe that's all sort of self-deterministic in some ways, right? We are who we are because that was the path. Maybe we would have ended up being robots, I don't know. But it's certainly wonderful to, scientists, for us to help contribute unraveling our cosmic history. Right? I always say the biological evolution on Earth was absolutely facilitated by the chemical evolution of the universe, right? And one doesn't go without the other.
And that evolution,
from the human perspective,
that evolution seems to be creating more and more complexity. The kind of interesting clumping of cool stuff seems to be accelerating and increasing. And it's hard not to see as humans that there's some kind of purpose to it, like a momentum towards complexity and beauty,
Well, beauty is in the eye of the beholder. But yes, everything gets more complicated.
But there's also beauty to the chemically pristine universe in the early days.
There is, yeah. I love the desert with its nothingness.
Yeah.
It has so much aesthetics and appeal.
We came from nothing when we made 10. So what about 15.3? What's exciting? A red giant star.
Yeah.
That's another one of your babies.
Yeah.
13.2 billion years old.
So that one isn't quite as iron efficient as the other one. So probably not a second generation star, but easily second, third, fourth, fifth or so. We can't really pin it down, but it's also not super important for us. What is important is that star has a very different chemical composition in the sense that yes, we have all the elements up to iron there, they have sort of normal ratios, which means kind of the same as most other old stars and not too different from the sun, or at least different in quantifiable ways. But it has this huge overload of very heavy elements. And what was so nice about that star in particular was that I could measure the thorium and the uranium abundance. And again, that was the second of its kind. But the uranium abundance was could be more well determined, so we had a better grasp on that. Now, why are thorium and uranium interesting? They are radioactive elements. They decay. Thorium has a half-life of 14 billion years, I believe, and uranium of 4.7, which, to folks on us on Earth is a really long time. But those kind of timelines are really good when you want to explore the early universe. So there are two questions now that kind of come to mind. Where do these elements come from? And what do they tell us, right? And these, as we know, these heavy elements are made in a specific process. It's a neutron capture process, usually referred to as the R process, or rapid neutron capture process. We talked about seed nuclei before, right? So we still don't exactly know where this process can occur. So you have, let's say, a lone iron atom somewhere, and it is in an environment where you have a strong neutron flux, which means there must be lots of neutrons around. And again, when we talk about the site, we can surmise and ponder where that might be the case. But you have this iron atom and you bombard it with neutrons, and you do it incredibly fast. Now, what happens in the process? That iron atom, you collect lots of neutrons, it becomes really big and unstable. So it's a heavy neutron-rich nucleus that wants to decay because it's not stable, it's way too big. And let's say you add only one neutron to it, that would already make it unstable. So it has a characteristic decay time, that's called the beta decay time scale. So it will decay to a stable nucleus. So the neutron will convert to a proton, and that makes it stable. If you bombard lots and lots and lots of neutrons onto that seed nucleus within a time scale of the beta decay, that's how you get to this huge, fat, neutron-rich nucleus that then wants to decay, right? So the rapid process is you have your seed nuclei, they get bombarded, you create these really heavy neutron-rich nuclei. They're heavier than uranium even. The neutron flux stops, and then all these heavy nuclei, they decay. And they make all these stable isotopes that we know of, all the way up to thorium and uranium.
So that's rapid nuclear decay.
Correct. And the whole thing is done within 2 seconds. So just to add to the rapid here, it literally was snapping on my hand. It's all there. In my talks, I have this nice simulation that illustrates, this creation of these heavy nuclei, and I always say this is the only simulation you ever see that's slower than real time. Because in astronomy, we show, this is how a galaxy forms, 13 billion years and 30 seconds, and really short. Right? This is the opposite. Me showing you this, the elements are long made.
So where and when?
So you need the strong neutron flux.
Just the pumping of the
Yes, that's right. And so there are not that many options, right? So where do you find lots of neutrons in the universe? Or neutron stars, right? Neutron stars form in the making of supernovae, with the explosions. Okay, so maybe some of this heavy material gets sort of made in the making of the supernova explosion and gets expelled. Or you have neutron stars, so that, if the neutron star survive, usually that's the leftover of the supernova. If you have two from a binary pair, so stars usually actually show up in pairs, and so it's not too unusual to create a pair of neutron stars that will still orbit each other after both of their progenitor stars have exploded. And those two neutron stars will orbit each other diligently. But as we know now, thanks to LIGO, the Gravitational Wave Observatory, we know already that before, but now it's been measured by LIGO, is that these two neutron stars, they will orbit each other for like forever, but in the process they will lose energy. So that orbit is what we call the orbit decays, and eventually the two neutron stars will merge, and that results in an explosive event that has roughly the energy of a supernova, but the process is completely different. And the cool thing is, when these two neutron stars collide, they produce a gravitational wave signature, because neutron stars are super dense objects. They are like giant atomic nucleuses. So there's a lot of interesting physics happening already. So if you basically form a super neutron star by smashing two into each other, more interesting physics happens, and that means that there's this ripple sent out, into the space, the space-time continuum, basically, what do people say, the ripples of space-time, it's like you drop a rock into water, right? You see the waves coming, so that's exactly what happens when two neutron stars merge, and this is neutron star law, right? It's really violent. You smash two neutron stars, so that are so dense already into each other, and they in 2017, one of these events occurred, and the LIGO and Virgo gravitational wave observatories, they detected that, and then the astronomers pointed their telescopes in that direction, and they indeed observed what we call the electromagnetic counterpart. So there was something seen in the sky that faded over the course of 2 weeks, and that light curve, that light, was exactly what you get when you create all these heavy neutron-rich nuclei in the arc process, and then the neutron flux stops, and then it takes about 2 or 3 weeks for most of them, of these nuclei, to decay to stability. So the astronomers saw in this electromagnetic counterpart the nucleosynthesis of heavy elements occurring. And that's just awesome.
So that's electromagnetic counterpart to the gravitational waves that we detected.
Yeah.
Two neutron stars colliding aggressively, violently to create a super neutron star, and that's where you get all the neutrons and neutron flux somehow, and the whole shebang that happens in 2 seconds. Basically.
So that confirms that one of the sites, for short, is for the arc process to occur, is neutron star merger. Interestingly enough, I have to mention this here, a year prior, in 2016, my former grad student Alex G and I, we discovered a small dwarf galaxy that is currently orbiting the Milky Way, it's called Reticulum 2, that was full of ancient iron-deficient stars that also had a strong signature of these heavy elements, exactly like HE 1523. We weren't looking for that. I actually wanted to prove that they had really low levels of heavy elements, because that's what we have seen in all the other dwarf galaxies. And I was dead set on showing that is yet the case again, and that is the typical signature of early star formations. We already talked about low strontium and barium abundances and the oldest stars, right? This is what we had seen anecdotally in the ancient dwarf galaxies that are surrounding us.
So that's an ancient dwarf galaxy. That dwarf galaxy has a bunch of ancient stars in it.
Yeah. And so now we find Reticulum 2, and it has the stars show the signature of the rapid neutron capture process, the arc process, and we are like, okay, these stars are located in the dwarf galaxy right now. We have environmental information. They are not lost in the galaxy where we don't know where they actually came from. But we know these stars were formed in that galaxy because they're still in it. And that we already deduced from that it must have been a neutron star merger that went off in Reticulum 2 at early time, that polluted the gas from which all our little stars formed.
Can you speak to what a dwarf galaxy is? Can you speak to what this Reticulum 2 dwarf galaxy is that is orbiting the Milky Way galaxy?
Yeah.
It's going to be eaten by it.
It totally is going to be eaten. I can't tell you exactly when. The Milky Way remains surrounded by dozens of small dwarf galaxies. They are collections of stars. Some of them, we call them ultra faint dwarf galaxies because they now only contain, I don't know, a few thousand stars. They are very faint. Uh, yes, because they're fairly close, and we detect actual individual stars in them. So I've observed some of the faintest stars, you possibly observe with current telescopes in these dwarf galaxies because I was like, I need to know what the chemical composition is because there are leftovers from the early universe. They did not get eaten, so they're still in their native surroundings. I got it's like getting the lions in the wild, right? I got to study those and compare to the counterparts that got eaten and are now in the Milky Way. And
So presumably most of those stars, not all of those stars that worked out,
they're all really ancient because actually, as it turns out, if you have a small galaxy, there was a process early on in the universe called reionization that kind of heated up everything. And together with some supernova explosions in an early, shallow, bound system, all these little systems lost the gas. It was sort of blown out, or it simply evaporated, or both, probably both. And so these systems have been unable to continue to form stars since. So it's the best for us stellar archaeologists that you could hope for because it's a whole bunch of stars still sitting there. It's not just one, it's a whole bunch of them still sitting there ever since, and literally nothing has happened to them. They've just been waiting there for.
So from the stellar archaeology perspective, what is like juicier and more interesting? The old stars in the outskirts that have been eaten, or the outskirts of the Milky Way, or the stars in the dwarf galaxies? What's of all the things you love about the world? You said you love stars, so which do you love more?
That's a hard one. I mean, I love them all, of course. They serve different purposes. The stars in the Milky Way, I can get much better data for them because they're brighter, they're closer, so they're brighter, and that tickles my fancy.
And they have been for life.
Yes, and we can get that. And so HE5023, for example, that one is really bright. Only it's a red giant, so it's intrinsically bright and it's fairly close. And so the data I got for that was insanely good, and that yielded this uranium detection and thorium detection. I can never get that kind of data for those galaxies. So that's a big trade-off. But the environmental information that we get along with the basic information about these stars in each dwarf galaxy is really valuable in establishing, these, for example, these site information, right? Because the galaxy is still there, so nothing crazy could have happened. So it's to close that loop. Probably some heavy elements come out of supernovae here and there, but somehow my theory colleagues tell me that the normal supernova just doesn't have enough oomph to really get that R process going and doing it all.
So you need these orbiting supernova.
We need probably the neutron star merger, or we need a special kind of supernova that's maybe extremely massive or heavily rotating or just something else funny, right? To really kind of get that particular process going. But the normal supernovae don't do it, right? So only a little bit comes out. But you could come along and say, why don't you just take 100 supernovae together to build up the wheel, right? But then I come along and say, look, this dwarf galaxy is still intact today. If you would have plugged in 100 supernovae into this little system early on, it would have blown apart. It would have blown apart past 5 supernovae or 10. So that's a really important constraint that we have, that these systems are still alive. Right, so it helps us to pin down where certain processes could have possibly happened, and so it's just a different type of information that we get.
It'd be amazing if we could talk about the observational aspect of this, the tools of observation. So, what telescopes do you use, and what does the data look like? And I think I've read a few interesting stories about the actual process of day-to-day observations, much of probably late nights.
Well, yeah, some of us are doing it all night long. So.
Well, yeah,
Lots of late nights.
Can you explain all night long?
Well, let me start by saying I mostly these days use the Magellan telescopes in Chile. They're a 6.5 meter telescope, which means the mirror diameter is 6.5 meter. That's not the largest that's out there, but it's among the largest. And I use a spectrograph because I'm a spectroscopist. I don't take pictures. And that particular spectrograph is actually unusually efficient, so it kind of makes up for the fact that the mirror isn't as large as, let's say, the 8 meter telescopes from the Europeans or so. So I'm very happy with that.
Efficiency meaning
How many photons get collected sort of per time unit? Because that's always the limiting factor. Um, Prior to the pandemic, we would travel to Chile to do our observations. Um, those telescopes that's the last observatory where people were sort of supposed to travel there and take their own observations. Most other observatories basically have staff there by now who take the observations for you.
so this is directly decide this specifying where to point the telescope and you're sitting there and collecting the data, making sure the data is collected well, and cleaning of the data, and what offloading the data, all that kind of stuff.
Yeah, so it's mostly done for them. Obviously that's super convenient, but it also takes away a central part of what the work of an astronomer is, which is data collection. Right? We don't have an experiment in the basement where we can go day and night or whenever we please and ask a certain question of the apparatus. Right? Let's turn this knob and see what happens. Let's turn that knob and see what happens. No, we only have one experiment, which is the universe, and what we see is what we get. And I think it's so important to take an active role in that. I love going to the observatory. I've taken many students there over the years to teach them and to just show them what it means to be an astronomer, because you go to these remote mountaintops and it's such a magical environment, and you wait there, for the sun to go down, and then you get ready and you look outside, and it's such a serene environment, and it's a little bit out of this world.
You're sitting there until the sun goes down, it's evening, evening, and what does it look like? What are some of the most magical experiences of that process?
Well, when you're on top of a mountain, climbers, I guess, get to see that probably. Otherwise, it's very calm, and the colors are so beautiful, and I always become much calmer when I'm there. Because I'm just there for one purpose only, and that's data collection. I can say no to my emails. I can say no to everything else because I'm observing. So there's literally less distractions because you're just there to do one thing.
And also the emails somehow seem less significant.
Yeah. It's just you can afford to focus on this one thing, and it just kind of does something to you. It's a little hard to describe, but if you then fast forward, maybe I can speak a little bit about that. And I have done a lot of astrophotography there as well. So and I observing faint dwarf galaxy stars. These are like 45 minutes, 55-minute exposures. So you actually have a lot of time. So I would run outside and just lay on the ground under the southern Milky Way. Beautiful, right up, there. And I would just lay there like a snow angel, and just stare up there and just kind of let my thoughts sort of pass through my brain, and just like I'm one of it, right? We talked about this in the beginning. This is when I personally have the feeling that I'm a part of it. I belong here, rather than feeling kind of small. Yes, I'm small, but there are many other small things, and lots of small things make one big whole.
Yeah,
right?
we're part of that big whole.
And
so that's looking at the inner spirals.
Yes. And just this dark sky with the bright stars, and I have described this in my book years ago. if the Milky Way is all bright above you, you don't need a moon or anything. You can walk in the starlight and you will find your way. There are no trees there for safety reasons, but you wouldn't even run into a tree, right? I mean, you can almost see the shadow, from the starlight because it's such a dark side and the stars are so bright. And these are kind of moments that kind of change you a little bit. And
You see the unity of it all.
yeah, and it's just you and nature, and with modern civilization and all of that. And I think we often try a little bit too hard to be removed from, from nature, to be independent of it, and figuring it all out. But at the end of the day, we're just a part of it, and that really helps me to remember that we're one and the same.
Well, that fills me with hope that I tend to think of us humans as in the very early days of whatever the heck we are. So that makes me think thousands, tens of thousands, hundreds of thousands of years from now, that would be whatever we become, will be traveling out there to explore more and more and more.
Yeah.
So what you're doing is the early days of exploration.
Yes, the early seafarers looking at the sky for navigation.
Coming up with different theories of what's on the other side. But it's starting to gain an intuition that the Earth may be round, and then we might be able to navigate all the way around to get to financial benefits of getting spices from India, whatever the reason, whatever the grant funding process is all about. But ultimately, actually, results in a deep understanding of the mystery that's all around us. And, I mean, it's just to travel out there. I mean, to me, the discovery of life in the solar system, I really hope to see that in my lifetime. Some kind of life, bacteria, something, maybe dead, because that means there's life everywhere, and that just the kind of stuff that might be out there. All the different environmental conditions, chemically speaking, that are out there. And it just seems like when you look at Earth, life finds a way to survive, to thrive in whatever conditions. And so maybe that process just kind of humbles you. It's super exciting to know that there is life out there of different forms. And of course, that raises the question of what is life even? We tend to have a very human-centric perspective of what is a living organism and what is intelligence and all this kind of stuff. And all the work in artificial intelligence now is starting to challenge our ideas of what makes human beings special. But I think we're doing that through all kinds of ways, and I think your work is in part doing that as well. The unity you feel as well as we're part of this big mechanism of nature, whatever that is, that's creating all kinds of cool stuff, from the humble, pristine origins to today. So what is, if you could just kind of linger on the process of the data, what does the data look like? And how does the raw data lead to a discovery of an ancient star?
Well, as a spectroscopist, we have to, I guess, talk for a brief moment about what a spectrum is. Everyone, I hope, has seen a rainbow in the sky. That is basically what we're doing. We don't send the starlight through a raindrop that then gets bounced around and splits up the light into the rainbow colors. We do it with a spectrograph, so basically a prism. So we send the starlight through a prism of sorts, and that splits it up, and then we record exactly that. So it's a little 2D picture, actually, of the spectrum. Now, it's not going to look colorful. It's black and white. Different colors have, of course, different energies. That's what we record. More specifically, we record it as wavelengths. So wavelengths and frequency and energy is all the same at the end of the day. We process that little image in the sense that we do a crosscut and then sum up a few columns so that we get all the data that we recorded. And what we see is it's a bit funny to describe just with words, but a wiggly line with lots of dips. So the 2D process spectrum, we call it continuum. So it's just a flat line basically, and then there are dips. So the interesting things are the dips. If you think back of the rainbow, what we actually see in our stars is not just a rainbow, but it would be a rainbow with lots of black lines in it, which means certain little pieces of color have been eaten away by a certain amount. And so we can no longer see it as well or not. Why is that happening? So if we come back to our stars, what we're observing the stellar surface. We can actually never peer with our telescopes inside. We only can go after the surface. And the surface contains, or the surface layer contains different kinds of elements. Every one of those types of atoms, so elements are just different types of atoms, they absorb different photons that are coming from the hot core where the fusion is occurring. And so that means that if you were the observer, with the spectrograph or without, you will see the starlight, but certain frequencies, certain energies of that light will have been absorbed by all the different atoms in the gas. So you see less of them. And so that are the dips. And the strength of the dips tell us which element was it and how much of that element was or is in the star. So we have many, many, many dips. The solar spectrum, for reference, all the dips are overlapping because the abundance of all the elements is so high. It's actually a very complicated spectrum. My spectrum really look like a straight line, and then there's a dip here, and then there's a straight line, and then there's a dip there. The sun doesn't have straight lines. It's just all absorbed in some form or another. But the old stars have so little of all the elements that there are only occasionally these dips that can indicate, okay, that one at that wavelength was iron, and here we have carbon, and there's magnesium and sodium, and there's a little strontium line here. So we have a much easier way to map out this barcode that the spectrum, pretty much is at the end of the day, and to then measure the strength of these, we call it absorption lines, to then calculate with existing codes that mimic the physics of the stellar hemispheres, like how much was absorbed, what kind of elements were present in the stellar hemisphere. And so this is how we get to our abundance measurements, and then all together that gives us the chemical composition and that particular signature in that stuff.
If you ever look at like a raw spectrograph and absorption line, and they're able to see, intuit some interesting non-standard outlier kind of patterns, or does this have to do heavy amount of processing?
We actually process it's fairly straightforward to do our processing. We do it at the telescope, so I often take a shorter exposure first, let's say 10 or 15 minutes. So mostly when I do discovery work, we just take a quick look spectrum, then we process it while we observe the next star. Then we take a quick look. We have what I call the summary plot. It's a collection of little areas in the spectrum that have the key positions, the positions of the key elements in it, and it's kind of like reading the tea leaves. I have stared at so many spectra. I just need to know. I just need to see our summary plot, and I can tell you exactly what the numbers are.
Also to tell if it's
yeah, exactly. And so that's it. Thumbs up, thumbs down. Are you worth my time or not? In most cases, it's not, or it's good enough. We can do a basic analysis, maybe publish this as part of a larger sample, just so the output that we have observed the star and their basic nature. That's an important part to publish as well. I had a run. So now we do remote observing. I do all of this now from my home, from my living room, all night long. I often work with colleagues, so we do it over Zoom, and we still process the data. We look at it, same thing still, and we just found the star that had a very low iron value. And then we decided, okay, that looks interesting. We're just going to keep exposing, so we'll put more data on it on the spot, and we're writing up the paper right now.
How do you know what the point is?
It's not random. There's a lot of work that goes into that. I began my career by trying to answer that question, as in like doing the search process. That's why I called my book that I've written some time ago, "Searching for the Oldest Stars," because searching is one thing; it's very time consuming, and then on top of that, not everyone finds, right? I often don't find, but I keep searching because techniques have established that yes, we can do it if we're just patient enough and keep going, because it's a numbers game, and that's often the case in science. And that's something that's not enough talked about. How tedious it is and how long it takes to get to that one discovery, right? That moves the field further.
And how difficult it is to believe that there's a thing to be discovered.
Yeah, yeah. We have the saying, I learned this from my supervisor. One star is a discovery, two is a sample, and three is a population. So as soon as you found three of roughly the same kind, you're done. But you need to get there.
Probably the first is
yeah, but it kind of remains really hard. But the thing is that at past three, many of us are okay. We solved that problem. We solved it 3 times. We can do it. That's a thing, right? That's a population. 3 iron deficient stars, let's say, right? That's one puzzle piece. Now we can move on to the next thing.
That's an indicator that there's many more.
Yes. So to cut a long story short about the searching, we started early on with what's called low resolution spectroscopy of many stars. So for example, my thesis work almost 20 years ago was piggybacking off a quasar survey that had collected. So quasars are basically giant supermassive black holes that are really far away. So you only see one big bright light point. So it looks like a star, but it's actually just a giant supermassive black hole that outshines its own galaxy. And people have been trying to study those, and they've taken little spectra of all things in the sky, and it turns out, oh, you can fish out the actual stars from that and look for certain signatures that might indicate low metallicity stars, or stars with low abundances. And so it was painstaking work to then take medium resolution spectroscopy to get a little bit more information and to use approximations and to kind of get candidates that we can then eventually take to the big stars like Magellan to get a high resolution spectrum. So we really see the dips of all the individual elements that then give us the final answer is a day over day. These days, with another grad student, I developed a new technique to use images actually of all the stars in the sky taken with very narrow filters. So it's like you're wearing very specific glasses that only let so much light through. And so we can do similar things through having several narrow band filters, what we call it, to fish out things that have no absorption over here, so just the straight line, and then a little dip here, so a little something there. And that has proven fairly successful in recent years.
So looking at broader regions of space.
That's right, because these stars are a little bit like a needle in the haystack, right? There are not that many left over, and certainly the galaxy has plenty of stars in between. We need to comb through all of those to get to the good. So we always start with millions, and then work our way down, and in the end we have like 3 good candidates.
I wonder how those ancient stars feel that they were noticed. They probably know that nobody pays attention.
Right.
No, I'm just kidding.
We're all special, right? So
It's good. It's inspiring. Even if you're the outcast. In your pristine age, you still nevertheless be noticed. I'm hoping you still watch it. Is there something else you could say that's about the challenges of this kind of high precision measurement that you're doing? So this kind of collection of data, trying to kind of pull out the signal from the noise out there.
Well, literally what we're doing in multiple ways, actually. So we're trying to find a needle in the haystack, and then we find something, and then it turns out it's just a little bit too faint to actually get the kind of data quality on it that we would like, or that would be warranted given the potential of the star, right?
So there's always noise. There's always a little bit of noise, and you have to try to say what. How special is this when you're looking at those ultra lines?
Yeah.
How
So the most iron core stars, their iron lines are so tiny that they're literally, almost in the noise. So you get incredibly good data to make detections. And the funny thing is, we're looking for the nothingness of, let's say, the iron lines, but then don't want nothing, because if there's nothing in the spectrum, we can't measure anything. We can only get an upper limit. But we really like to measure it. So we are looking for the last little bit that you could possibly detect. And that's the strong function of the brightness of the star, because the telescopes have the size that they do. that's not going to change for a while. Hopefully eventually it will, but it's going to be at least 10 years out. And so, yes, we're often literally stuck in the noise because we can't make the measurement. So actually the record holder for the most iron per star only has an upper limit. We can't get enough data on it to actually pinpoint a measurement. So then take it to our theory colleagues and say, like, give me this little iron out of your first star. So it's a bit frustrating, but also super exciting at the same time.
let's go to both sides of that spectrum. What's like the most exciting discovery to you personally? Where is there a moment you remember that you saw a piece of data and your heart skipped?
Yeah, of course.
Is it AG 1347?
That was definitely one of those moments. I wasn't actually present at the telescope, but we were sent the data immediately from a colleague, and we just looked at it, and our eyes was really wide. Was like, oh my god, is this really what we think it is? So we had to run some numbers, and it was, and these are magical little moments. The thing is, often we have false positives, and so there's always this kind of period, and often it's I don't know, 10, 15 minutes where you need to make some tests to kind of make a decision. Is this really something I should keep observing now? Is this really as good as I think, or am I being fooled by something? Right? So actually, if you take the spectrum of a white dwarf, a white dwarf is the leftover core of a star like the sun that has gone extinct. And white dwarfs have lost all their outer atmosphere, so it's just the hydrogen helium core. So they look like a metal core star because it's only hydrogen helium left, right? But the hydrogen lines that you can see in the spectrum of our stars and of the white dwarfs are a little bit wider than normal. So you need to have a good eye just to check, does this look a little bit wider than us? Is this a white dwarf who's fooling me here, right? And so it's like this moment, it's like, oh my god.
It's just minutes of nervousness.
Yeah. And sometimes, it's a dud, and sometimes not.
What's been a big for you, remember, heartbreak? Like a painful one. Is it all leading up to the first suspect? Is it all about 1827 again? Just the leading up to it? Has there been like has there been like both research?
That's a good question. I mean, it starts with mundane things, as in like you won your telescope time, you travel there, and the weather is completely cloudy, it rains, and you had 3 nights, which is a lot, and you go home empty-handed. So that's definitely an option. Probably not what you were thinking of, but there is a certain occupational hazard to it.
Which requires resilient patience.
Yeah, and you just gotta learn to live with it. Coming back to Reticulum 2, actually, that little dwarf galaxy, that was a run that we had, and the weather was incredibly bad. And I sent my student there, and I was at home, and he calls me at 2 a.m. and he's like, I think I'm supposed to be sorry. There is this line there, this European line, and it looks like a metal rich star. And I was like, it's cool. We all make mistakes. Send me the data, send me that summary plot. And so I look at it super tired. I can't really tell. It doesn't look wrong, but I can't tell you right now that it's right either. So why don't you go to the next target? He calls me back and on it. Yeah, it's just the same. What am I supposed to do? And then I joke, well, maybe we found an R-process galaxy. Let's go to the next one. And the weather was degrading. And so to cut a long story short, we had to come, so he was observing the right star. It was an R-process galaxy, the first one we had ever discovered, totally unpredicted. We had no idea that this was a thing. I mean, of course we thought that, such a thing might possibly exist because why not, right? Neutron star just happened somewhere. Crazy supernovae probably true, but we were not prepared in that moment to find this thing. And in the end, the weather was getting worse and worse, and we wanted to see how many R-process stars are in this galaxy. So we managed by a hairline to observe the 9 brightest stars, but the data quality was atrocious. Yes, absolutely, because these were really faint stars. And so we were really lucky by making a very tight strategy of getting absolute bare minimum for all the stars, so we could at least take a very crude look. Is it a yay or is it a nay? We couldn't even say yes or no, just to get an idea, because we needed to know. Why was that important? Because we could only observe this system again 9 months later.
So there's always a window of observation.
Yeah, it was setting. This was our chance, and it was going away with the clouds,
That was super high stakes.
But we just made it. Really, it was almost impossible, and it was just. And the thing is, this is such a serendipitous moment. In a serendipitous moment, the enhancement of these heavy elements was so strong that even in this really crappy data, we could still see the enhancement. Right, the absorption was so strong that it stuck out of the noise. If the enhancement wouldn't have been as strong, we would not have been able to say anything because we wouldn't have been able to tell. But because it was so extreme, it lent us a hand. But at the weather and all, we say like, yes, this is it. So that was quite the night.
A lot of this. So that was the first hypothesis galaxy.
Yeah. I didn't sleep all that much.
Do you have hope? Are you excited about James Webb Space Telescope and the other telescopes in the future that increase the resolution and the precision of what can be detected out there?
Absolutely. JWST is fantastic already. I am not planning to use it personally, although I think I'm on 1 or 2 observing proposals actually, because similar to what we already spoke about, we're interested in the same thing. We're just kind of looking at a different sides of the fence, right? I have my own surviving stars, and I concoct these little stories about what the earliest galaxies may have looked like, what the objects were that contributed, energy and elements and all these things. And my JWST colleagues, they try to detect some of these earliest photons from these earliest systems to look at the energetics and other things, what was there, how many, these kinds of things, right? So together we're trying to explore the first billion years, but we do it in very complementary ways. So I'm very excited to see what they can come up with and how that helps me to inform my stories better and more comprehensively.
What do you think is the future of the field of stellar archaeology? How much can we? Maybe what are the limits of our understanding of this first billion years of our universe?
Well, obviously, lots of limitations in the sense that I always say, I have a metaphor star for any of your questions. Because there are so many different kinds out there. And we still find new patterns sometimes, right? And there needs to be an explanation. The question is it ultimately just one 54? Is it two? Is it three, right? Is it a sample of the population? So we haven't concluded that kind of work yet.
So every metaphor star is a kind of data point that you can use to improve the quality of the model and how is the evolution of the early universe.
Yes. And I would say we've made huge progress over the last 20 years. When I joined that field, it was in its infancy, and there was this serendipitous discovery of that first star. And we have filled in the canvas a great deal since then. And this is what I have greatly enjoyed about doing so, because there was so much potential, and it's been down a little bit because of all the progress. It's on the up and coming again because there's so many large spectroscopic surveys in the works now that will just provide a different level of data that we haven't had before. I'm sort of this older generation. I have only very few colleagues. I work in small teams, and I observe every single star myself. That whatever I can, I do myself. I don't generally take other people's data, or at least certainly not in the end stage. I'm not a big data kind of person, although we all headed that way. I certainly use data from the Gaia astrometric satellite for the kinematics, for example. But that's personally a new thing for me to use those big sky surveys that are available. So it's still very sort of hand-grown field, where we do our individual observations. We have enjoyed that a lot, but that's about to change.
So one star at a time.
Yeah.
It is power to that, to build up the tuition of the early universe and looking one star at a time.
Yeah. And this is how you can really drill down on the questions that you have, right? Because you control what data you get. Otherwise, you have the data that you have, right? You get what you get, and you don't get upset. I don't like that. I'm a little bit snobby. I really like to formulate my questions, go to the telescope, and then come what may, I will try to get it.
And also develop intuition that the data can be relied upon and it can't, also different quirks of the data and all that kind of stuff.
Yeah.
Sometimes a lot is lost in the aggregation of the noisy data.
Yeah. And that's always the danger if you have someone else's data that you just don't really understand the limitations, completeness things, how certain things were set up, and you get out what you put in. So I'm really particular about that, and it certainly paid off for me. That's one of the main notions that I try to teach in my classes and to my students, that you need to be able to formulate your question really well, because otherwise you're going to get an answer to a different question, but you won't notice that that the goalpost has shifted in the meantime, right? So your interpretation can only be as good as the question. If you need to change your question, that's cool. Do it. But then, it needs to pair up with your interpretation again. And so really being in the know about every step of what happens, that leads to quality results, I think. That's why I have sometimes little trouble with sort of big data and statistical analysis. Yes, on average, that's true. I'm not debating that. But I'm the kind of person, I like to look at the outliers and not the bulk, like, the special ones. And they just need to be treated in a different way. And there needs to be an acknowledgement of that, different ways for different things.
So big data can look at divorce rates, and perhaps you and I are more interested in the individual love stories.
Yes.
I don't know if it's possible to say, but what do you think is the big discoveries that are waiting? Is it on the different dynamics of the yield? The common narrative, the common story of how some of these metal or stars are formed? Where the discoveries you think will come?
I think the individual discoveries are actually, we've made most of those, certainly through individual stars. Finding yet another second generation star is incredibly important for me, but isn't really going to move the needle. Finding 50 of them or 100 of them, that would move the needle, but that's the order of or two magnitudes up. And new search techniques and new surveys may enable that, but would you still call that a discovery? Right?
But that's just
So-
a scale. Scale.
Yeah, so I think about it more like literally of the puzzle. Let's say you have 1,000-piece puzzle and there's 900 pieces in there. A person like me, I want to get to the last one. I'm not going to leave it. It's like, okay, I see broadly what this is going to look like, right? I'm done now. No, I want to get to the last one. So is the picture globally going to change? No. Are we going to figure out all the details and how it really works? Yes. Right?
So really careful,
Getting
detailed map
into
out
it.
the ancient stars of our universe.
Yeah. Because I think that's what many of us scientists are little bit detailed of that. But I think that's our job too, right? Really kind of make it airtight to really walk away saying, I fully understand this. Not just broadly. We really know now. And so more and more of that is going to happen. And so I think this is probably true across astronomy. These individual 10 sigma discoveries become less and less. If they were easy, we would have made them already, right? Which means we have made many of them. But really filling in the details is the next sort of level of discovery. Maybe we need to find a new word for that. The hopes and expectations that go along with the word discovery so enormous. We may not always be able to live up to that. But it doesn't mean that we're not finding out new things. It's just a different kind of quality because the questions have shifted. You close one door, suddenly there are 10 new open doors that we want to explore and march through. And that's finding these last puzzle pieces here and there that really make it airtight.
And so there's a lot of value, a lot of power and beauty to the discovery in the big picture of our universe and in the details.
Yes,
So both of
we
them.
need both, absolutely.
Perhaps drifting into the philosophical. When you asked about the Big Bang, as we kind of encroach onto it. So your work is kind of taking steps back through time in a weird way. Do you think we'll get to deeper and deeper understand the really, really early days of the Big Bang? And the philosophical question, do you think we'll be able to understand what was before the Big Bang? Or why the Big Bang happened? Do you think about that stuff?
Not the stars. For better or for worse, because stars only probe the time when they were formed, and the Big Bang is shortly before then. I mean, I often talk to my students about the difference between math and physics. Let me give you an example. We talked earlier about 1815-23, and I was happy to share with you that I measured thorium and uranium, but I actually didn't quite close that group. So we did this to try to attempt to calculate an age for these stars, right? But they rely on us knowing how the art process works, how these elements are created, where it happens, and then how those elements get dispersed into the gas and end up in the next generation star. So quite a few question marks. So that's how we got to the age of 13.2 billion years. This is probably not accurate, but this is the best calculation we could do. And the reason why I'm bringing this up is that was actually the average of multiple elemental ratios that each gave a certain age, and then we averaged that because, for better or for worse, this is the best we can do. So some of these numbers said, oh, this star is 15 billion years old, and then others said, oh, this is 10 billion years old. And so I often use that in my class to say, like, what's the good news and what's the bad news here? Some ratios say 15, sometimes 10, right? Is 15 correct? And then I ask them, some people will say something. And so the thing here is that it's an absolutely correct calculation given the mathematical and physical model that we constructed. But does it make sense? No, it doesn't. If we believe the universe is 13.8 billion years old, 15 is ridiculous, yet it is correct. Isn't that interesting?
Correct from mathematics.
Yeah, it is not incorrect because this is what I calculated. Nobody made a mistake. Now, we can question whether that's a good model, but that's a separate issue.
So you're saying physicists are much closer to truth than mathematicians?
It depends. It depends. Sometimes yes and sometimes no, right? So, but our job as physicists is to take a mathematical model, calculate our numbers, and then ask the question, does this make sense? Right? Now, in the case of 15, it doesn't, but we took the average anyway because that was the best we could do, right? So, all right, let's put that aside. Let's apply the same sort of thinking to the Big Bang, right? Math can tell us things that we as physicists cannot grasp because it doesn't make sense to us. Now, in the case of the Big Bang, that's a special case because we don't actually know what's supposed to make sense. And this is where things get interesting. So this is where math will ultimately be the winner because we can no longer say this makes sense or this doesn't make sense because the physics is broken down.
But math breaks down too.
Well, depending on who you ask.
Sure.
This is the current question, right? How much further can we push math, let's say, to the front of the Big Bang, if there is such a thing?
What's the front and the back? What's the front?
Well,
the front is
before the Big Bang.
Oh, before the front. Okay. To clarify,
right?
all the doorways.
Yes. So how far can we let the math go before that stops to make sense? And I don't know what the answer is to that, but it's really cool that because math it's not limited by our physical nature, it can probably go a little bit further than the physics.
Yeah.
Right?
And math can go to more dimensions than 4 dimensions.
Yeah.
Comfortably.
And it's judgment free because it just calculates things on its own. Whereas as physicists, we're so judgment. This makes sense. This doesn't make sense. Right? It doesn't get any worse.
It's such a beautiful day. It's such a. It's so amazing that through this dance, we can explore the origin of the universe. Like, isn't the Big Bang just blow your mind? But this thing is started from a point.
Yeah.
Now we're here.
Yeah.
So hydrogen and helium, and then all the stuff we're studying. I mean, like, this evolution of chemistry created humans. And we're here talking, and there's a lot more to the story. It's amazing.
Yeah.
And this kind of march that you're doing is observing data. Is there? You're looking at old light and old data.
But only a few thousand years.
Just a few thousand.
That's the difference between me and my JWT colleagues. Their objects, that light, has traveled 13 billion years or whatever it was to us, and they're observing that now. My light has only traveled a few thousand years. It's nothing.
So whatever you observe now is what is going on.
Yeah. You stop alive and kicking and having a blast.
1,000 years. Just a few thousand years. It's all it takes. If we can travel to
yeah.
Maybe we can reach out there.
We wouldn't have any planets around us then.
So is that a definitive intuition?
Well, what are planets made of? Elements, right? To take the Earth, of all heavy elements, right? The universe needed to reach a certain stage first to have produced enough of all these elements to actually make it.
So on average,
so that took quite a few billion years.
So they're not going to have a mechanism for forming planets. You could have visitors probably, because the kinematics that are unlikely.
Yeah, I would say so.
So they're interesting in that they reveal the early chemical evolution of the universe.
Yeah.
Not that they could be good vacation spots, but not.
Well, it's not like warm. Just no planet islands to go to chill.
In your book, you highlight the major contributions in the field by many women. Some of these women were not, as you describe it, immediately credited for their discoveries. So for me, from a computer science perspective, the story also tells how the computers Who are these women and what can you just say about the nature of science and humanity?
Discovering things is part of the human nature, right? And so it has happened for the longest time, not just by men, but also by many women. The field of stellar astronomy, which is my field, has particularly benefited from many discoveries made by women. You mentioned the Harvard computers. That's a term used for women who worked about 100 years ago at the Harvard College Observatory, and they were hired for their low wages and willingness to do diligent and patient work to comb through the big data of the day. So the observatory director, they were carrying out large site surveys at the time, and they needed uh, that data needed to be processed and looked at and analyzed. And so many women, or several dozens, one or two dozen women over the years, were were hired to do this work. And in the process, because they were looking at the actual data and they were smart, even though they had often no formal education, they made a lot of discoveries simply by being in tune with what they were doing. So they weren't robots. The term computer would perhaps lead on. So Annie Jump Cannon classified thousands and thousands of spectra and found out that you can, stars have different temperatures and the spectra look according. We still use that classification sequence today. Cecilia Payne-Gaposchkin later on in, I think, 1925 was one of the first women to obtain a PhD in stellar astronomy, and she calculated that the sun is mostly made of hydrogen and helium. That seems normal to many of us these days, but at the time it was thought that celestial objects are made of the same thing as the Earth.
That's a gutsy discovery.
Yeah, it was later termed the most important thesis of humankind or something like that. What a revelation to realize that stars are made of hydrogen and helium, right? And this was exactly the time when people figured out why stars are shining, maybe because of nuclear fusion and that protons and the tunneling effect that leads to the actual fusion. Otherwise, the protons repulse each other, they don't come together. And so, what an incredible time it was back then. And so, stars and nuclear physics are very closely related, and it remains now it's called nuclear astrophysics. And so, many women had many contributions to that. Of course, prior to that, Marie Curie discovered two new elements. Oh, so awesome! Radium and polonium. Lisa Meitner discovered nuclear fission. That is the basis for understanding the R process. This is exactly what happens in the R process. The heavy nuclei, let's say uranium, if you bombard it with a neutron, we talked at length about it, it will decay, it will not decay, it will split into barium and krypton, let's say, so two lighter elements. That's exactly what we observe. I have always a higher abundance of barium than the heavier elements because of this fission cycle that she calculated in 1938 and 1939. So many contributions, and it's just so remarkable. If you just take that body of work, that changed how we do things, how we see the universe, and how we understand things. Has led to so many subsequent discoveries, good ones and bad. Um,
Well, all of it is taken together.
that's progress. It's ultimately, science is what it is. We have to decide what we do with that knowledge, right? We can always use things for good or for bad. That's part of the human endeavor as well.
And also part of the human endeavor and the human natures and issues with corruption and credit assignment and all these kinds of things
Yes.
that make this whole ride so damn interesting about what's right and wrong and about the nature of good and evil.
Yeah.
And that seems to surface itself in all kinds of places all the time.
Yes, yes. Lisa Meitner was nominated for the Nobel Prize 40 times. More than that, even. It's amazing. I mean, she holds the record for that. She never received it.
Yeah, and of course the Nobel Prize has its complexities. One is the credit assignment, but two, even in astronomy, there's assigning credit to a handful of folks when so many more contributed. It was a complicated story also.
Yeah.
Okay, sorry for the romantic question. What do you is the most beautiful idea in astronomy? In stellar astronomy?
Well, so early on, when I was in high school, I was thinking like, okay, what do I want to do when I grow up, right? I knew I wanted to do astronomy, but I was a little bit torn because my interests were definitely stars, stellar astronomy, but also chemistry. I always had a fascination about the elements, so Marie Curie was a big role model. My friend actually produced a beautiful movie about the discovery of the elements. This is a theater play, but digitized, where when I thought I could actually kind of relive this sort of discovery moment that Marie Curie had, it would send shivers down my spine. It was fantastic. I mean, this is the kind of thing that I wanted to experience. But yeah, so nuclear physics and element creation and formation was really interesting to me. Chemistry, the elements, stars, and all of that. And I was like, I don't know if I ever find something that combines all of these things. And then I ended up in Australia, and I met this person, and he was working on all stars. And as I was sitting in his talk, hearing about this for the first time, it kind of it clicked all over my head. I was like, oh my god, it all fell in place because we can use these old stars, study the elements, learn how they're formed. We can get these clean signatures that help us inform the nucleosynthesis processes, and I know, of course, I need to know a lot about stars too. So it's like all together, and that was sort of a moment of magic. And then the fact that I have now done that for 20 years. It's just like I won the lottery. And so, in some sense, it's an ongoing love story for me, if I could say it like that, where I found my stars, my thing, and I'm fortunate enough to be able to keep doing that, and I'm happy to see where it will take me. It's an evolution, as with every relationship. You have to, if you don't march forward, you move backwards. I'm not interested in moving backwards, so I'm letting the field and the discoveries and the findings lead me to, and I'm off to. It's not hard for me to follow sort of my hunches, and sometimes even at the telescope, it's like, let's take a look at this one. I have a good feeling, and then usually something good or not bad pops out at the end, and I really like that I have the freedom to do that I'm allowed to follow my hunches. Too many people, I think, are sort of boxed in with their job or their life. Right? They don't have that kind of freedom. That's really important to me, and I certainly try to make use of that. I also try to teach that to others, to trust them, to learn. You need to learn your things, but then you need to also trust that knowledge, and you have a grasp on it, right? You get out what you put in. And being able to contribute in meaningful ways to our knowledge about our cosmic ancestry, our cosmic history, um, that's a wonderful thing.
And in this way, your personal love story with the stars evolves. What advice, you've already spoken to it a little bit, what advice would you give to young people that are trying to find the same kind of love story in their career?
it seems increasingly hard for folks to find that. Sometimes I feel that young people have all the opportunities these days, and that's wonderful. But it's almost like that leads to some, what's the right word? They're a little bit of tired of too tired to make all the decisions, because at some point you need to put your eggs in a basket, and you need to be okay with that. We can't do all the things, even though we're often told you can be president too, and I think that's really important to convey. But at the end of the day, we can only have sort of one job or one type of profession. I'm not saying you need to be locked in, but it's hard to change 180 degrees, and so lots of people I think are often afraid to really dig in, at least for some time, and get their hands real dirty and really learn from the bottom up on one thing, because they're afraid they're missing out on 99 other things. But life is a little bit missing out on 99 other things, because we only have 24 hours in a day. I have that feeling very often. There's so many things I would like to do, many things I would like to try to be good at. Sometimes I wish I had a different job, because I have other interests too, but I realized, okay, I can only do one thing. So I have no regrets. But this is a general feeling that I think, I would think most of us have. But if it stops you from really digging and drilling down on one thing, to become an expert in one thing, to become really good at one thing that you call your own, man, it just makes it difficult.
And so a fulfilling life is in part likely to be discovered in a single pursuit of a thing, of one thing.
Well, yeah,
or at least for a time.
Yeah, for some time, with your heart and your hands, because I think most people long to own something. We all, I think, want to leave some legacy of some sort, for our children, for humanity, for this planet. And I think it's really important for young people to strive for that and not lose sight or trade that for all the opportunities, because an opportunity is nothing if you don't do anything. You need to do something at the end of the day. So I chat with lots of people about this, and I often start by just saying, hey, tell me what you don't like. Because it's often much easier to
narrow down.
let out what's not on your plate. And then this way we get a little bit closer, and then it's like, why don't you take a risk? You just sign up for something for 3 months.
But that's what it feels like. That's what it feels like. And it is that. It's a risk. Commitment is a risk.
Yeah.
Because you're basically sacrificing all the other possible options. Then I guess you have to trust the magic you notice in that thing.
Yeah.
You notice one thing, stick with it. And then maybe there's something there.
Right. And this moment of kind of feeling it in your entire body and mind that this is the right thing, getting there is probably really hard. But if you don't try, you won't find out.
The hard stuff is the fun stuff. That's also another thing to find out.
And then there's that, yeah.
Wow, it doesn't make sense. You also mentioned that you have taken a little stroll into the artistic representation of yourself. Can you speak to that a little bit?
Yeah. Well, I already just mentioned. Sometimes I wish I had more time to do other things. So I find little sideways, I guess, to pursue things that I like besides astronomy, or at least I try to find connections. And so some years ago, I, again, with the help of my friend who made this Marie movie, she and I wrote a one-woman play where I actually portray Lisa Meitner, who was an Austrian-German nuclear physicist from Germany, so I have the right accent for that. And we wrote this play about this moment of discovery of nuclear fission. Again, this is an absolutely critical piece that explains my work today. And we all stand on the shoulder of giants. She was one of those giants. And in some ways, it's of course a way for me to acknowledge other people's work that has come before me. It's a wonderful way to highlight the contributions by a prominent woman. And the way I do it is it's a 25-minute play in costume where I relive for people the moment of discovery. Then I turn into myself, and then I give a 30-minute presentation on the art process and the creation of heavy elements because the audience can now perfectly understand that, the public audience, given the historic backdrop of this discovery that they just lived through my presentation. And it's a wonderful compliment that almost spans 100 years from one woman to the next, passing on the torch. And when we write up our results in, let's say, magazines like Nature and Science, it's always about the result. On the golden platter, perfectly prepared. The discovery is never described, only ever the result. You asked me beforehand, right? What does it feel to be at the telescope in this moment, right? I'm happy to talk about this, but it's nowhere written ever, and nobody really talks about it. And so having a form of theater, the art, to bring this exciting moment that is what we all want to experience as scientists to a wider audience is so profound and so rewarding. And they all love it because everyone can understand a moment of discovery. I was looking for something and then I found it. It's like you misplaced car keys, right?
Oh, wow.
Yeah. Everyone can
What a
understand.
glorious experience, yeah.
The implications and the findings, that is much harder to understand for anyone. This is where the scientists work truly lies. This is our job. But the moment of discovery is easy and it's beautiful and it needs to be said. And so taking my audience on this journey, what is the peril? What are my worries? And then, here is the moment of discovery. Let me tell you about it. It profoundly transformed me, and here's how it went. Right? It's so good.
The art is making reveals coming up with human science.
Yeah. The problem with science is that people do it.
That's also
Not a
goes,
problem.
that's
That is
also
it.
what makes it beautiful, right?
Yeah.
Humans are fascinating. We're able to come up with these ideas through all the struggle, through all the hardship, through all the hope, through all the search.
And so the art's a great way to portray that and to broadcast that, right? I think this is how the audience really should be interacting with scientists. Much less about the findings, but really more about this yearning for answers, right? I need to find these copies. I need it because I need to go, right? Now. And then, oh God, here it is. Now I can go my merry ways. It's so relatable. We just need to find more and better ways to do that. So I hope to turn this into also a digitized version at some point to again make it more accessible.
I hope so too.
So far, I'm just doing it in person. But
I would love it. I think a lot of people would love to see something you did just that. Let me ask you a big ridiculous question. You look up at the stars. You look up at the early stars. So let me ask the big question that we humans often ask and struggle to answer. What's the meaning of this whole thing? Why are we here?
We talked about, biological evolution requires the chemical evolution for all of this to kind of play out, and carbon played this important role. And, in some sense, we're just a consequence of all of these things being the way they are. Right? So maybe this is just where we are supposed to be, because, the laws of physics sort of work the way they do. And we talk much about the variety of everything really, and certainly from over here to over there, and things in the vicinity of where the sun and the solar system forms, they were the way they were, and life maybe wasn't necessary consequence of that. And in some sense, I like to believe that because then it becomes reproducible and you can find the same argument elsewhere. If it's total chance, right, that makes it harder. And that's not truly satisfying to a scientist.
So it's the consequence of psychological evolution, which is the consequence of biological evolution, which is the consequence of chemical evolution, the consequence of physical evolution, whatever disciplines. It's turtles on top of turtles.
Turtles all the way down, yes. I mean, yeah.
And you have studied some of the most ancient turtles.
Yes.
At the very bottom of the thing.
That's right. They live for quite a while.
Yeah, they do. Well, thank you for your incredible work. Thank you for highlighting both the human side and the deep scientific side. It's just, I'm a huge fan of your work, and thank you for everything you do. Thank you for talking about this. Is awesome.
Of course, it was wonderful. Thank you.
Thanks for listening to this conversation with Eric about. To support this podcast, please check out our sponsors in the description. And now, let me leave you with some words from Douglas Adams in Hitchhiker's Guide to the Galaxy. Far out in the uncharted backwaters of the unfashionable end of the western spiral arm of the galaxy lies a small, unregarded yellow sun. Orbiting this, at a distance of roughly 92 million miles, is an utterly insignificant little blue-green planet whose age-descendant life forms are so amazingly primitive that they still think digital watches are a pretty neat idea. Thank you for listening. I hope to see you next time.
Not reliable sources of evidence because people don't really spend that time getting all the minutiae of someone's face.
It is the most important right that Americans have. It's not a coincidence or an accident that it's named in the First Amendment of the Constitution. Without it, no democratic society can be democratic for long. And I'm an absolutist. That is, I believe that, for example, people say to me, but what about hate speech? Well, hate speech is much more important than love speech. And the reason is, I'm much more interested in knowing whom I should not turn my back on than I am interested in figuring out who loves me.
The following is a conversation with Harvey Silverglade, a legendary free speech advocate, co-founder of FIRE, the Foundation for Individual Rights and Expression, and the author of several books on freedom of speech and criminal justice, including The Shadow University, the portrayal of liberty on America's campuses. Harvey is running to be on the Harvard Board of Overseers this year, the write-in campaign. You have to spell his name correctly, Silverglade. Promising to advocate for free speech and to push for reducing the size of Harvard's administration bureaucracy. Election is over this Tuesday, May 16th, 5 p.m. Eastern. To vote, you have to be Harvard alumni. So if you happen to be one, please vote online. It's a good way to support freedom of speech on Harvard campus. Instructions how to do so are in the description. As a side note, please allow me to say that since there are several controversial conversations coming up, I'm trying to make sure that this podcast is a platform for free discourse where ideas are not censored, explored, if necessary, challenged, in a thoughtful and empathetic way. It's by having such difficult conversations, not by avoiding them, that we can begin to heal divides and to shed lights on the dark parts of human history and human nature. This is the Lex Friedman Podcast. To support it, please check out our sponsors in the description. And now, dear friends, here's Harvey Silverglade. You co-founded the Foundation for Individual Rights and Expression, also known as FIRE, a legendary organization that fights for freedom of speech for all Americans in our courtrooms, on our campuses, and in our culture. So let's start with a big question. What is freedom of speech?
First of all, the organization, when I co-founded it in 1999, was called the Foundation for Individual Rights in Education. It focused on free speech issues on college campuses in academia, and only earlier this year did we decide to expand our reach beyond the campuses, which is why the name, or the acronym, FIRE, remains. It's now the foundation for individual rights and expression.
The E used to be education.
D used to be education, it's now expression. And we basically do a lot of the cases the ACLU used to do. The ACLU now is the progressive organization rather than a civil liberties organization. And we've taken the role of dealing with free speech in the society generally. And now this is a particularly we were prone to censorship. Everybody thinks they're right, and people who disagree with them should not be able to voice their views. It's a very difficult period right now, both on campus and off campus. It's about as intolerant an era as I can remember. I'm going to be 81 May 10th. I was born on Mother's Day 1942. And I can't remember it being this bad. I was born during the McCarthy era.
So that says a lot.
And it sort of reminds me of that.
Well, let's start with that almost a philosophical question, a legal question, a human question. What is this freedom that you care so much about, that you fought for so much? Freedom of speech.
It is the most important right. It's not a coincidence or an accident that it's named in the First Amendment of the Constitution. Without it, no democratic society can be democratic for long. And I'm an absolutist. That is, I believe that, for example, people say to me, but what about hate speech? Well, hate speech is much more important than love speech. And the reason is, I'm much more interested in knowing whom I should not turn my back on than I am interested in figuring out who loves me or who likes me. So hate speech is the most important, in my view. And yet it's banned in schools. It's unbelievable. Kids are not schooled into understanding the glory of the First Amendment. In schools, they're saying that they shouldn't say things that are going to make somebody feel bad. The purpose of speech is to express honest views that people have. So I believe hate speech is as important as love speech, and my view is more important.
So it should be brought to the surface rather than up in the shadows.
Absolutely. Absolutely.
What is the connection between freedom of speech and freedom of thought?
Well, in a free society, thoughts start in the brain and then they come out the mouth. So they're different ends of the same spectrum.
So to you, the censorship of speech eventually leads to a censorship of thought.
Of course, censorship of the mode by which other people know what you're thinking.
So there's some aspect of our society that is the thinking is done collectively, without being able to speak to each other. We cannot do that.
Correct. And out of speech, the theory is that ultimately out of speech comes truth. That isn't necessarily so, but I do think that when there's free speech, better decisions are made because people put their views on the table in a frank, accurate way, and then those views mix together and clash, and out of that usually comes the better decision. Not always, but usually, and more often than not. But if somebody is not allowed to be sit at the table with decision making, then the decision making process is poorer, less robust, less diverse, and ultimately less successful.
Can you elaborate on the idea of free speech absolutism? So, hate speech can be quite painful to quite a large number of people. Does this worry you?
Yeah. Living in a free society requires that you expose yourself to some discomfort or pain. It's maybe emotional pain, it's not physical pain, but it's the price we pay for living in a free society. Every so often we're insulted, we're emotionally hurt. Think of the alternative. All the alternatives are worse. Nobody ever promised us a rose garden. We're lucky to be
in a country that has the First Amendment. It's also it's the most diverse country in the world because of immigration. And my grandparents, my father's side came in from Russia. My mother's side came in from Poland. I'm very happy that my grandparents came in from Russia. I would not want to be in Russia today. I'd probably be sharing a cell with a Wall Street Journal reporter. So I'm thankful that they came in, and